Hello, my dear students. Welcome to BYJU'S exam prep. So, guys, finally we are here for the environmental engineering marathon. So, come on, guys, quickly join the session fast, fast, fast. Good morning, everyone. Good morning, good morning. And I guess you are super energetic for the session because, yes, we'll be covering raw water, wastewater, air pollution, solid waste management, everything in one single go. So let's start the session quickly. But before that, if you don't know about me, you can go through my profile. And guys, you can download the app in which we'll be taking classes each and every day. After that, if you have missed the marathon classes, this is the upcoming schedule of the marathon class. And after today, tomorrow will be a soil mechanics marathon. Apart from that, we are having a scholarship test on 14th of January, flexibility of timing 9 a.m. in the morning to 9 p.m. in the evening. And guys, after that, we are also having All India Open Mega Mock Test going on from 13th of January to 19th of January. You guys can enroll for that as well. And we have launched full syllabus course for 25 and 26, both in English and Hindi language. If you are targeting for upcoming GATE examinations, you guys can start your preparation journey with us. Apart from that, last is you can join my Telegram group for further upcoming classes. And guys, this is the whole thing which I'll be teaching you today. So guys, you can check it out here. Just check it out. This is the whole schedule which I have mentioned to you. Okay, this one. This is the whole syllabus. This one and this one. So what are the things being mentioned? That all the things I'll be covering in today's class. Okay, fine. So this is the first part about raw water and all, and after that we have wastewater, air pollution and solid waste management. So we'll be covering all these things. And now guys, just on the comment section once, are you guys ready? Come on, are you guys ready? Quick, quick, quick. Are you guys ready? Okay. So fine guys, so we'll start with today's session without any delay. Let's be quick. बिल्कुल शुरू करते हैं. चलिए. Okay. So first raw water engineering, then wastewater engineering, then solid waste management and air pollution. Okay. Now when you talk about raw water sample, any sample which you are collecting from natural sources, it is raw in nature. That means you haven't done anything on it and basically it is not subjected to any treatment. Okay, human interference is not there. That is known as raw water. So that process, that from the source you are transporting it to the community. Okay, this whole process which is involved here, this is known as what? Raw water engineering. This is known as what? Raw water engineering. Okay, this is known as raw water engineering. So in this raw water, what are the things you need to do, guys? In these things, what you need to do is first you have to select the source. Ma'am, but how can we decide that which source I have to select? That will depend upon the water demand. That will depend that for how many people, for how much population, what you are doing is you are selecting the water demand. Okay, and based on that, you are selecting the source. So everything we will be covering in raw water engineering. Now, source is decided based on the water demand. Okay, so the technicality is first before deciding the source, you have to select what? You have to select the water demand. Now, talking about water demand, the first thing which comes into action is you have to know some parameters. Like example guys, whenever you do what? Whenever you are just, let us suppose you are going to purchase a rice. You say that you purchase in terms of kgs, quintals or tons. Similarly, if you want to purchase milk, you purchase it in liters and kiloliters. So when I want to say water demand, so which is the unit which I'll take? So here we have different, here you can say parameters which is involved. First is annual draft, which you denoted by V. Now what is this annual draft? See, in case of water, you can call it as demand also, you can call it as draft also. Now what is this annual demand or annual draft? Total water which is required by the whole population in 1 year. So the yearly water requirement is known as annual draft. So total yearly water requirement. Yeah, total water requirement. That is known as annual draft. Total water requirement by whom? By population P for 365 days. So I'll denote it as V. Now annual average daily demand. That means this whole population, instead of 365 days, in 1 day, how much it requires water. So if P population in 365 days require V volume of water, this P population in 1 day will require how much amount of water? V upon 365. And now I'll say I don't want to know that P population requires how much amount of water. I want to know that one person in 1 day requires how much amount of water. So that is known as annual average per capita daily demand. Capita means person. So annual average per person daily demand. So one person 1 day requires how much amount of water? V upon 365 divided by P. So this is the thing which we will be using. Now V is what? The volume which is required yearly. So volume will be in liters. When you have divided by the population, that means you are talking about one person, and 365 means you are talking about, you have divided by 365 means you are talking about 1 day. That means one person 1 day requires how much amount of water? So you denote it by LPCD. What is LPCD? Liters per capita per day. Liters per capita per day. That means one person 1 day requires how much amount of water? That is denoted as LPCD. In the whole water demand, we will be talking in terms of LPCD only. Clear? Now, moving up next is types of water demand. Now, these questions they can ask you in the statement wise. Now, if I talk it about domestic water demand. Domestic water demand varies from 135 LPCD to 225 LPCD. Out of total demands, the major part is of domestic demand, which constitutes to 50 to 60% of the demand. Now, domestic demand, drinking, washing, cooking, everything is included in the domestic demand. Talking about industrial demand, in industrial demand, you have 50 to 450 LPCD. How? It will depend upon the extent of industrialization. If you have big industries, obviously the water requirement will be more. If the industry is in small scale, the water requirement will be less. After that, we have institutional demands like in hospitals, commercial places, schools you can call it. There the demand is comparatively less, that is 20 to 50 LPCD. And the water for public use is 10 to 20 LPCD. Okay, so these are the demands. Public use means you have public gardens is there, then you require for cleaning of roads and all. So these comes under water for public use. Apart from that, there is one more demand which is very, very important, that is fire demand. Of course, fire doesn't take place every day, but still you have to reserve some amount of water so that in case outbreak of fire takes place, that amount of water is being stored. So generally the amount of water required is very less. How much? 1 LPCD. That is 1 liters per capita per day, or you can call it as 1 LPCD is the fire demand. Correct? Now, here if I talk about further, there are various empirical equations which are being given for calculating the fire demand. Now we have various equations. What are they? Kuchling's equations, Freeman's equations, National Board of Underwriters formula, and Buston's formula. Now one more thing is, ma'am, in the examinations, will they mention that if they want to calculate fire demand, which methods to be used? Yes, they will mention it for sure. Okay, so you will use that equation only. Now the first one is Kuchling's formula, which is given to you as 3182 root P. Now here it is very, 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 very important that you have to look at the units. Here you have to substitute the population in thousands. You have to substitute the population in thousands, and the discharge which you will be getting in liters per minute. You will be getting in liters per minute. Now, a patent confusion for you guys is, when you see Freeman's formula, in some books you will find that instead of P by 10, they write P by 5. I have written P by 10, so you will get confused. So, I'll tell you one thing. 1135.5 P by 5 plus 10. This is the, so if it is 1135.5, you will use your 5. If it is 1136, then in the denominator you will use 10. Now ma'am, why there is so much of variation? See, it is an empirical formula, correct? So that is the reason you will face this, you can say ambiguity, because there is a slight change in the number, so there will be change in the denominator. In every equations of the empirical formula, discharge will be in liters per minute and population will be in thousands. Okay, similarly for Freeman's formula and for National Board of Underwriters formula. Now guys, very important, National Board of Underwriters formula, what he has given is valid only when the population is less than or equal to 2 lakhs. Ma'am, but it's not necessary that the population will be always less than 2 lakhs. It can be more than 2 lakhs also. So when the population is greater than 2 lakhs, National Board of Underwriters have not given any formula. They told that you can give a provision of 54,600 liters per minute, and you, in case if second fire breaks up, you can give an additional provision of 9,100 liters per minute to 36,400 liters per minute. So this, if they ask you in statement wise questions, so you should be aware with it. Apart from that, we have last is the Buston's equation, from which also you can calculate what fire demand. Here also population will be in thousands and discharge will be in liters per minute. Now if in case you don't know what is basically population in thousands, if the population is 4 lakhs, okay, so you divide it by 1000, how much it will come? 400. So here you will substitute what? 400. Okay, so you won't substitute 4 lakhs, you will substitute 400. Okay, now the one which they can ask you is, codal provisions one, as per IS code. As per IS code, they don't give you the value in meter cube, liters per minute, nothing. They will give you the value of fire demand in kiloliters. Now, one thing is, here also you will substitute P is population in thousands only. But guys, if you are reading the old books, in that 97 root P was written, but it has been revised. It was prior to 2012, fire demand 97 root P was used in IS code. Right now, the new version of it is 100 root P. So this is the fire demand in kiloliters. Clear? Now, here we have got Kuchling's formula, Freeman's formula, National Board of Underwriters formula, Buston's formula, and we have got the IS code formula. Now comes the next thing is, ma'am, you told us that domestic demand should be this much, industrial demand should be this much, everything you told us. But the question comes when you are designing the basically water treatment plant, when you are designing the pumps, canals, what is the parameter which you will be designing? Reason, example, I'll tell you. Now, if I asked anyone, like if I tell Vamsi will say, if I plot a graph of discharge and time, okay, so obviously let us suppose I'm taking it 6 to 9 a.m., 9 to 12 p.m., 12 to 3 p.m., 3 to 6 p.m. and so on. So my demand will be less, my demand will be more, then it will be less, then it will be more. This is like this. So how can I design? If for one person the demand is changing, like example, like today you are with me, you will be with me for the whole environmental session. So obviously, maybe it's possible that you will be consuming less amount of water, okay, during that period of time. So your demand is varying, and it is varying per minute, it is varying per hour, it is varying per, you can say per day. Okay, it's not constant. So if it is not constant for you, how can you imagine for the entire city of yours it will be constant? You can't say that, right? So now comes the next thing. We want to have a parameter for which we will be designing it. So that parameter is known as maximum daily demand. Now what is this maximum daily demand? Out of the 365 days, there will be one day when the demand of water will be maximum. So out of 365 days, there will be one day when the demand of water will be maximum. Let us suppose from 1st of January to 31st of December, 10th January was the day when the demand of water was maximum. So you will call it as maximum daily demand. Okay, now maximum daily demand is what? It is 1.8 times annual average daily demand. And what is annual average daily demand? That entire population P requires how much amount of water in one day. That is known as annual average daily demand. Now you will say, ma'am, from where this 1.8 comes? This is based on observations. Okay, now 1st of December to 1st of January to 31st of December, 10th January is the day when the demand of water is maximum. Correct? Now, I want to know that what is the hourly maximum demand. Now majority 99.9% people, if I say what is maximum hourly demand, they will say from 1st of January to 31st of December there are 365 days, and in one day there are 24 hours. So out of 365 into 24 hours there will be 1 hour when the demand of water will be maximum. That is wrong. This is not the correct thing. Okay, that is not the correct thing. Okay, so now what you have to do is, it means maximum hourly demand of maximum day means on 10th of January there will be 1 hour. There will be 1 hour when the demand of water will be maximum. That is known as maximum hourly demand of maximum day. So on the maximum day out of 24 hours, there will be 1 hour when the demand of water will be maximum, and that is known as maximum hourly demand of maximum day. Now how can you calculate it? It is 1.5 times average hourly demand of maximum day. Ma'am, from where this 1.5 came? This is based on observation again. Now what is average hourly demand? 1 hour plus 2 hours plus 3 hours. You calculate it for 24 hours demand and divide it by 24. What you said? Average is what? Sum of observations upon number of observations. So average hourly demand of maximum day. This is equal to maximum daily demand by 24. Ma'am, कैसे calculate किया? See, if you want to calculate average, 1 hour, what is the demand? Second hour, what is the demand? Third hour, what is the demand? Fourth hour, what is the demand? You keep on calculating it. Divided by 24. Okay, so MDD divided by 24. What can you write in place of MDD? You can write it as 1.8 into annual average daily demand divided by 24. So what it will become? Annual average daily demand by 24 becomes how much? It will become annual average hourly demand. Ma'am, why you said hourly demand? Because when you divide daily by 24, it becomes hourly. So 2.7 into annual average hourly demand. तो ये formula आ जाता है. This is one of the formula which you can calculate. But what I'll advise you, remember this formula and remember this formula. That is only important. Now, the next thing which comes is fluctuation. Now, what is fluctuation? See, here if this is the average, this is on an average water demand. So, some value is more than the average, some value is less than the average. So, fluctuation is how much is the maximum value with respect to average, or how much is the average value with respect to the minimum. This is known as what? Fluctuation. Correct? Now, here the fluctuation in daily demand, maximum divided by average, 1.8. How much is the fluctuation in hourly demand? Maximum divided by average, 2.7. How much is the variation in hourly factor? 1.5. This is very important, asked in n number of competitive examinations. This becomes very, very, very important. Okay, so kindly remember it. And they can ask you in statement-wise questions as well. Any doubts till here, guys? National Board of 4637 root P 1 minus 0.01 root P. ये यहाँ पे नहीं लगेगा bracket. Correct. ठीक है? Any doubts till here, guys? So we have revised fire demands formula. We have revised maximum daily demand. We have revised maximum hourly demands. Any doubt till here? Come on, guys. Quickly comment. Quick, quick, quick. Any doubts? Super clear? Clear everybody? चलिए. Okay. Now let's start further and keep on sharing with your friends as well. Come on. Next, start further. Now, here is Goodrich's equation. Till now, never ever they have asked questions from Goodrich's equation in the examinations. But you cannot predict, because in the past year you have seen that when they have never asked from any topic, they have asked last year in GATE 2023. So this is the Goodrich's equation which is being used. Now here if you want to calculate percentage fluctuation, remember very important that Goodrich's equation give you percentage fluctuation. So this is denoted by P, which is 180 t to the power minus 0.1. This will give you the value in percentage. This gives you percentage fluctuation. Okay. Now, here percentage fluctuation, that means how much is the maximum value with respect to average or how much is the average value with respect to the minimum. Now, this equation is valid only when t is greater than or equal to 1 day. Ma'am, if t is less than 1 day, not valid. Not at all valid. Clear? Now, when you put t is equal to 1, here it will become 180%. 180% means I told you fluctuation. Fluctuation is maximum by average. So maximum daily demand by average daily demand will become how much? 180%. Correct? When you put t is equal to 7 days in the formula, you will get 148%. So maximum weekly demand divided by average weekly demand is equal to 148%. When you put t is equal to 30 days, you will get maximum monthly demand to average monthly demand is equal to 128%. Now, I'll ask you one question. Tell me whether true or false. As the number of days increases, percent fluctuation decreases. True or false? True or false? As the number of days increases, percent fluctuation decreases. True or false? Quick. Correct? True. You guys can check it out. As you are increasing the number of days, the percentage fluctuation from 180% it has gone to 148%, then 128%. You can put 365 and check it out. The percentage fluctuation will be even lesser. Okay? It's exactly like that. When the sample size increases, the deviation decreases. Correct? Chaliye. Now, you know that I'll draw it. First, you have a source. Okay. From the source, you have pipe. You have here pumps and canals. Pumps and canals. Correct? From pumps and canals, after that, you have a water treatment plant. I'm writing it as TP. This is not an official denotation. Huh? From water treatment plant, you will take it to service reservoir. And from service reservoir, that pani ka tanki which you have it in your society. Okay, that one, not your syntax tank which you have it at your home. I'm not talking about that. Okay. Service reservoir and then to the distribution system. Distribution system. Now what happens here? When you select the source, you design it for 50 years. Ma'am, why we design it for 50 years? Because all the other treatment units are dependent upon the source. So whenever you are selecting the source, you have to basically check it out that it should be able to sustain and deliver you water for the coming 50 years. Okay, after that you have pipe from where you will take it to pumps, canals. This is pipe 1. This is pipe 1 and then here you have pipe 2. Okay, so source is there from where you'll take it on pumps and canals. Pumps and canals you never operate for 24 hours guys. Always remember that. Yes, you call it a overhead tank, correct Prince. Pumps and canals you never design it for 24 hours. Reason is like example. You guys have pumps in your homes. Ever you just operate for 24 hours? No, you say pump jal jayega. You say like that. Okay. So technically pumps will not operate for 24 hours. So neither they are designed for maximum daily demand, neither they are designed for maximum hourly demand. They are designed for the number of hours in which you are using that. Okay. After that you have water treatment plant. In water treatment plant you have various units. They all are also designed for MDD. Service reservoir is neither designed for MDD, neither designed for MHD. It is designed for volume. Which volume? That I will tell you when we will move to the distribution and conveyance system. After that, distribution system is there from which water is supplied to your homes. So that pani ka tanki, that overhead tank, that service reservoir is there. From there, it goes to your home. So that is the distribution system. Everything, either you design it for MDD or you design it for volume. But distribution system, you either design it for MDD plus fire demand or you design it for MHD. Which one is there? because water is available up to 50 years. After that, it will become fully polluted. It is becoming polluted now only. Vamsi, after 50 years, it will become polluted. Then technically, we shouldn't do any treatment only. Because according to your statement, it is fresh. Now, it is not polluted. The water is in the present ground condition. Also, it is polluted only. And that is the reason. See, in the good olden times, as far as your great grandfather's time, it would be considered, there was nothing like this so-called treatment units and so many chambers. Because that time, the quality of water and things were different. Right now, with increasing globalization, population, and due to that, the pollution, now things have changed drastically. So that's why we need to study all of these things, and this is not on pen and paper which we are studying. This is happening practically as well. Okay. Apart from that, if I talk it about here, we will design it for MHD or MDD plus fire demand. Now I'm going to tell you a very important thing. Listen to me very carefully. If a 1 mark statement question comes, and this has permutation combinations has been asked in n number of examinations. Question from this has been asked in your gate also. If they ask you distribution system is designed for, one they have given MHD, one they have given MDD, one they have given fire demand, and last option is, let us suppose this was A, B, C, and this is D. So D option they will say maximum of 8. Then D will be the correct answer if they say like this. Okay. If in the question, now option is like this. None of these. And last one is again maximum of, this is A option, this is B option, this is C. Maximum of A and B. So you will mark D only. But if in the examination, they give you this option, MHD, MDD, fire demand, and the last one is none of these, what you will mark? Now tell me. What you will mark? What you will mark, guys? Very good. We will mark maximum hourly demand. Why? Because obviously, MDD plus fire demand 99% of the cases, guys, listen to me. 99% of the cases when you will do the numericals, MDD plus fire demand will come out to be maximum. But that doesn't mean that you will not calculate MHD in the examination. Check it out in case might be possible they have framed the data in such a manner that MHD comes out to be maximum. Okay, so calculate both. But if options like this comes, then you will mark MHD as the answer. Okay, now one more question. See, MHD and D is some other option. All of the above, none of the above, whatever it is. Chalo. Now answer. What you will take? Now answer. Now what you will answer? Very good, Anwar. Very good. Good morning, Saurabh. Correct. B. Okay. MDT plus fire demand. Clear? Fine. So just you should know that what you are studying, it's not necessary in that same format it will come in the examination. They can change it also. Clear? Fine. So next question is this one. Come on guys, now solve this question. Quick. Population of a city is given 3 lakhs. Water consumption is 335 LPCD. It is asking to calculate fire demand using Kuchling's formula. And capacity of the distribution system as well. First, you should know Kuchling's formula. I am not going to tell you the Kuchling's formula. Come on, be quick. Quick. I'm waiting for your answers. Just 1 minute. Actually, you might be using calculator only right now. So I don't think that it will take time for you. Quick, guys, quick. Okay, you told me in liters per minute. Okay, I got one answer. What about others? Quick. 511. And what about the capacity of the distribution system? Capacity of the distribution system. 18.5. One answer. What about others? Quick, guys, we don't have whole day. We have to complete other chapters as well. Just a minute. Okay. Fine. So let's start without any delay. Being quick. Population of a city is given to you 3 lakhs, that is 3 into 10 raised to power 5. Now it has asked you to calculate Kuchling's formula. Kuchling's formula Q is equal to 3182 root P. This is the formula. 3182. Population in thousands. That means you will substitute here 3 into 10 raised to power 5 divided by 1000. That is, you will substitute 300. What you were getting, you guys said 55113.85 liters per minute. If I want to convert it into MLD, how much it is coming, guys? If I want to convert into MLD, how much it is coming? MLD. Quick. This is technically what? This is fire demand. I want to convert it into MLD. मतलब मुझे क्या करना है? What I have to do? I have to convert minute into days. 1 day is equal to 24 hours into 60 minutes. So I will divide it. I will divide it by 24 into 60. वो चला जाएगा ऊपर. Into 24 into 60. And divide by 10 raised to power 6. So that I get it in MLD. How much it is coming? How much it is coming? Yes, it is hard, but hard things only give you results, right? 5511 24 into 60. Correct. 79.36. Very good, MVS Anwar. 79.36 MLD. At a stretch, you should be able to convert it quickly. Now we need to calculate fire demand, which we have already calculated. Capacity. For that, I need to get MDD and MHD both. I told you, I know 100% maximum chances are there that MDD plus fire demand will come maximum. But then also I'll calculate MHD as well. 1.8 annual average daily demand. P population in 1 day requires how much amount of water? 1 person's require 335. So P population will require how much? How much it is coming? How much it is coming? Tell me directly in MLD only. Tell me directly in MLD only. कितना आ रहा है? 180.9. Okay. Now, MHD. MHD is how much? It is 1.5 times maximum daily demand. 1.5 times 180.9. That's it. How much it will come? 271.35. Distribution system is maximum of MHD plus MDD plus fire demand. So this is 271.35. And what is 180.9? 180.9 plus 79.36. 260.26. Just check it out, guys. I told you that 99% of the time MDD plus fire demand comes out to be maximum. But in this case, what happened, guys? What happened? What happened? MHD came out to be maximum. Got it? So that's why don't be in overconfidence that, oh, MDD plus fire demand will come out to be maximum. I will save my time. I will not calculate MHD. That is wrong. See, I proved you wrong. Now, same question. If you do by Buston's equation, you calculate the fire demand by Buston's equation, you will find MDD plus fire demand will come out to be maximum. Got it? So here for proving your concept that you can be also basically don't think like that always MHD will be less, MDD plus fire demand will be more. That's why I've done this question. Clear everybody? Clear? Buston से यूज करा नहीं Buston's use करोगे actually when you will use Buston's you will get more fire demand value because it is 5663 root P. So you will get more fire demand. More fire demand means more MDD plus fire demand. So if you will use Buston's equation, MDD plus fire demand will come out to be more for sure. Chance ही नहीं है कुछ. Correct? चलिए. Okay. Now we are done with this question. Now, guys, this is one part we have completed. So technically, if you add all the types of fire demand, apart from this, you have thefts and leakages also. You know, some people steal the water also, and sometimes due to leakage of water, there is the losses also. So this also counts to 10 to 15%. So if you talk about the total water, it is 270 LPCD for low income group and it is approximately 335 LPCD for high income group. The only change in low income group and high income group is the domestic water demand. For low income group, you have 135 LPCD. For high income group, you have 225 LPCD. That is very, very common sense. Your low income group will take bath in a bucket of water. High income group will use bathtubs. They will have big lawns, so watering them. They will have various cars, so washing them. They will have dogs, so for cleaning them. So n number of things are there because of which the water demand will be more for high income group. Correct? Chaliye. Any doubts still here, guys? Any doubts still here? Quick. Any doubts still here? Quick, quick, quick. Nothing? Okay. They use shower. No. Shower is UC. Low income group will use bucket. Medium income group will use shower. High income group will use bathtub. Clear, Vamsi? A big bathtub. Okay. Sure. Okay, guys. So now we will start with arithmetic increase method. Now we will forecast the population. Like you forecast whether na अनुमान लगाया जा रहा है. We are forecasting that rainfall will take place and all those things. So arithmetic increase method. What do you mean by arithmetic increase method? This is one of the method for population forecasting. What will happen is we will assume rate of growth of population is constant. It is not mandatory and it will not happen. But for analysis purpose, we will assume rate of growth of population is constant. So now if you want to forecast this, you will use Pn is equal to P naught plus Nx bar. Now Pn is the population which you will have after n decades, okay, for which you want to calculate. Last population as per census. Census means Janganna. You know that after 10 years they come to your home and they will say that, okay, how many people are there, how many are educated, how many are males, how many are females, everything. So the last population as per census, N is the number of decades for which you want to calculate, after which an X bar is the average increase in population. So this is the formula which you use in arithmetic increase method. Okay. Now in this formula, firstly, I'll ask you just one thing. I guess you know already. 1 decade is equal to how many years? 1 decade is equal to how many years? High income group use swimming pools. Every day they can't take bath in swimming pool, na? So bathtub is like easily accessible. Jacuzzi and all. Will you provide PDF? No, I won't. 10 years. Correct. Fine. Now, here, let's look at a question. This is a very good question. And what is this? This question I'll make you solve both by arithmetic also and both by geometric. Because once in the GATE examination, they have asked for arithmetic. Similar question they can ask for geometric. Then you will say, ma'am, we did only for arithmetic. We don't know how to do it for geometric. So, we'll talk about that. Now, see, the present population of a community is 38,000. Okay, this is 38,000 presently. And the water consumption of this 38,000 people is 5,700 meter cube per day. But the design capacity of the plant in which you are doing the treatment, of course, it will be more. It is 7,500 meter cube per day. Now, it is expected that it will rise from 38,000 to 54,000 in next 20 years. So, it will rise in next 20 years. So, it is asking, now, when it is current population, when it is 38,000, from this time, how much time it will take to reach its design capacity? How much time it will take? So, technically, you need to calculate time. So, technically, you need to calculate n. Pn is equal to P naught plus nx bar. You need to calculate n. Now, last population which I know as per the latest record of census is 38,000. Number of decades I need to calculate and x bar is indirectly given to us. How? From 38,000 to 54,000 the population will increase in 20 years. So x bar will become 54,000 minus 38,000 divided by 2. Ma'am, why not 20? Because I will take increase in population per decade. So 20 years means 2 decades. How much it will come, guys? 8,000. Correct? So this will be 8,000. Now, population when it will reach its design capacity means when the population is 38,000, that time the demand of people was 5,700 meter cube per day. What will be the population such that the demand of water becomes 7,500 meter cube per day? Common sense. Now see, if the water right now the demand is 5,700 meter cube per day, that means 10 raised to power 3 liters per day. This is by 38,000 people. That means one person's require how much amount of water? If 38,000 people require 5,700 meter cube per day of water, one person's require how much amount of water? Unitary method. Do it. How much it will come? It will come 150. Just check it out. 150 LPCD. If now vice versa. If one person requires 150 LPCD of water, 7,500 meter cube per day water will be required by how many people? Correct? This will come out to be 40,000. Just check it out. Just check the calculations once. So when you will solve it, you will get here 1.5 years. That is 15 decades. 1.5 decades. That is 15 years. 15 decades में तो फिर तो काम ही खत्म हो जाएगा. 15 years. This will be the one. Correct? So this you should know. Now, this was easy because this has been asked in your previous year. You have done it. But same question I will do it by geometric method. Now, what is geometric method? First of all, you use it for rapidly growing city. Now, it might be possible that in the question, they will not give you to use geometric increase method, uniform increase method, compounding method. Kindly remember all the names because see, if they tell you forecast the population by compounding method and you are like, what is this method? We have heard arithmetic, geometric, incremental, but what is compounding method? Geometric increase method is known as compounding method. Okay, so this is used for rapidly growing city, first of all. Now, here what happens? Here you assume percentage rate of growth of population is constant. So here what you will assume that what is percentage rate of growth of population is constant. That means R is constant. So for here when you will need to forecast the population, it will be Pn. That is 50k not 40k. कहाँ पे 50k है? 50 आया है? 50,000 है? चलो ठीक है. मैंने बोला था ना check the calculations once. 50,000 है. Okay. Fine. Thank you. Okay. So now here rate of growth of population is constant. That is R is constant. So when you will forecast the population here, Pn is equal to P naught 1 plus R to the power n. Now very important, 2-3 things, just remember this. If here you are substituting R, you will substitute it in decimal. And here if you are substituting, this will be, if you are substituting in percentage, this will be divided by 100. So if you are seeing in books this formula, you have to put it in decimal. If you are using this formula, you have to substitute R in percentage. So that's it, simple. Now guys, one more important thing, if they want to twist the question for 2 marks, what they can do is, they can tell you, like they will ask you to forecast the population using compounding method. First, calculate percentage rate of growth using arithmetic mean method, and you will be confused. One question, 2 methods it is asking. Firstly, it is telling you to forecast the population using compounding method, that is geometric increase method. So you will use this formula. Secondly, it is telling you to calculate percentage rate of growth using arithmetic mean method. Technically, he is telling you to calculate R using arithmetic mean method. Remember, arithmetic increase method and arithmetic mean method are different. Ma'am, how is it different? Arithmetic increase method is a method of population forecasting, while arithmetic mean method is a method to calculate R. So just understand the difference. Don't get confused in the examination. This will be equal to R1 plus R2 dash dash Rn by n. So how many decades, you know the data, you will divide by that much amount of decades. Okay, R1, R2 dash dash Rn. I'll tell you what is R1, R2 also, don't worry. Now, the one more thing is geometric mean method. R1, R2, Rn to the power 1 by n. Ma'am, here also n is there. Here also n is there. Both n are same? No, beta. This n is for number of decades. Very important. And this n is for number of rates. That is the difference. Very important. So one is for number of decades, another one is for number of rates. Now how to do is that I will tell you. But just a minute, I'll tell you one more thing. Guys, if in the question they don't mention you that from which formula calculate percentage rate of growth, without any second thought, use geometric mean method. Ma'am, how can you say that we have to use this? Because this is being specified in the code. So if they have not mentioned you what to use in calculating percentage rate of growth, you will use geometric mean method. Correct? Rather than using arithmetic mean method. However, practically when you will go into the field, you will see that they use arithmetic mean method because it gives more value of population forecasting. So whosoever is the engineer, he wants to be on the safer side. And that is the reason what they do, they use arithmetic mean method. But in the examination, if nothing is mentioned, you will go for geometric mean method. Clear? So this is known as geometric mean method, and the R. And here if you want to calculate the population forecasting, that is uniform increase method or compounding method. Now, same question I will do it for geometric increase method because they can ask you geometrically also. Here they have said assume an arithmetic rate of population growth. So they will tell you assume a geometric rate of population growth and everything else will be same. So how will you do? This question, Vamsi, it was telling that 38,000 people in one day requires 5,700 meter cube per day of water. But the plant for which, obviously when they are supplying water, so we have to treat that water. So the plant has a design capacity of 7,500 meter cube per day. It has been found that the coming 20 years, the population will increase to 54,000. So tell us that if we start from now, present existing condition, at what time the plant will reach to its design capacity, that is 7,500 meter cube per day. So first I need to calculate the population. Obviously population will increase, then only it will reach to its design capacity of 7,500 meter cube per day. So first I calculated the population. Okay, and with the help of which I calculated what? I calculated the number of decades. Now same question if I need to do it by geometric increase method. How will I do it? Formula is Pn P0 plus 1 by R by 100. See, don't play with the concepts. Concept will remain same. If one person's require 150 LPCD, 7,500 meter cube per day of water will be required by 50,000 people. So 50,000 will remain as it is. Here it was 38,000, right? 38,000 will remain as it is. Okay. 1 plus 100. You need to calculate N and you need to calculate R. One equation, two unknowns, you cannot calculate. Check it out. They have given this data that 38,000 to 54,000, it will change in 20 years. So check it out. Pn is equal to P naught 1 plus R by 100 N. From 38,000 to 54,000. 54,000, 38,000 in how many years? Got 0. In the coming 20 years. That is 2 decades. From here you will calculate R in percent, substitute here. That's it. Everything else remains same. Only the formula changed and only to calculate R changed. And definitely they can ask you this in geometric rate of growth. Clear? If consecutive 3 data is given, then how we can calculate? I haven't come to saturation population, so let me go to first logistic curve. That time I'll take your doubt. Okay? Clear, Vamsi? Clear, everybody? Divya, Sophie, Prince, Sahil, Dharmendra, everybody, Yogesh, MVS. Clear? Quick, quick, quick. Is it clear? Yes or no? Clear? Okay. Fine. Next question. Next method. 19.2%. You told also. Okay, fine. 19.2%. Substitute it here. You will get it also. Correct. Okay. Now, incremental increase method. Incremental increase method, this is a moderate value. It will give you more value as compared to geometric increase method, and it will give you more method. Geometric increase method gives you the highest value of population forecasting. That's why it is used for rapidly growing city, or you can say it is used for young cities. Arithmetic increase method is used for old cities. So it gives you a very lesser value of population forecasting. Incremental gives you moderate value. Lesser than geometric increase method, more than arithmetic method. What is the formula? Pn is equal to P naught plus nx bar plus n plus 1 by 2 y bar. P naught is the last population which you know as per census. Pn is the population which you want. N is the number of decades. X bar is the average increase in population. And in that increase, what has increase taken place? Average increase in population. And Y bar is incremental increase in population. Correct? This is the formula. Now, one question has been asked long back, means I guess when you were born also or not, they have asked. Okay. So, in that they have asked question from incremental increase method. Till now, they have not asked from geometric method. So, we are hoping maybe in the coming years they can ask from, or this year only they may ask from geometric increase method. But they have asked question from incremental increase method already in the previous years. Now, next one is decrease rate of growth method. Now here I give you the best example. See, decrease rate of growth method. See, population will increase. For sure the population will increase. Ma'am, but COVID came, population decrease. That is once in 100 years, guys. It doesn't happen often. Once in 100 years any epidemic hits, that time you will get that basically the population decreases. Otherwise, you know that the population will always increase for sure. Okay, we are the ones we will reproduce, then our kids. So definitely it is going to happen. Population will shoot for sure. Okay, now population is shooting, but the rate at which it is shooting is decreasing. Best example is, let us suppose, example. Initially I used to eat 2 chapatis. Then my diet increased. I started to eat 4 chapatis. Then my diet further increased. I started to eat 5 chapatis. From 2 to 4, what is my percentage diet increase of chapatis? 50%. 4 minus 2 divided by 2, 50%. From 4 chapatis to 5 chapatis, my diet is increasing. But the percentage, 5 minus 4 by 4, how much it will come? 1 by 4 into 100. 25%. Correct? Is my diet increasing? Yes. but the percentage rate is decreasing. It has reduced from 50 to 25%. Although my diet is increasing, from 2 chapatis I started to eat 4 chapatis, from 4 chapatis I started to eat 5 chapatis. My diet is increasing, but the percentage at which my diet is increasing is decreasing. Got the logic? So that is what happens in decreased rate of growth method. The population is increasing, but the percentage rate at which the population is increasing is decreasing. Correct? So now here we have question for this. Now guys, I always say to students that this method kindly don't go through the formula. Formula is very lengthy. See, arithmetic definitely go through the formula, geometric increase go through the formula, incremental go through the formula. In civil, we have so many formulas to remember. Kindly don't use formula for decreased growth rate method. It becomes very, you can say, troublesome for you because you have to remember each and everything. So go through the basic concepts, you will understand it. Now, from 1960 to 1990, population is given to you. They are asking you how much will be the population in 2020. How much will be the population in 2020? So how will you calculate it, guys? How will you calculate it? Simple common sense, and you will solve this question. Chalo, I'll make this for you guys. Be ready with your calculator. 1960, 70, 80, 90. What is the population? 55,500. 63,700. 500. Okay, year is given to you, population is given to you. Now, first you will check it out. First you will check it out how much increase in population has taken place. How will you do it? How will you do it, guys? Anybody? कैसे करोगे? How will you do it? मुझे year दिया है. I have been given the population. See, in the previous case, like I'll tell you, if in the question, let us suppose they have given last data of 1990, 5 lakh is the population, and they're asking you for 2030, what will be the population? How many is the number of decades different, guys? How many is the number of decades difference? First tell me. 1990 to 2030, how much is the decade? 1990 to 2000, 2000 to 2010, 2020, 2030. 40 years, that is 4 decades. You will just write 2030, whatever, 5 lakhs plus 4 decades and whatever is the X bar you are getting. Correct? 4 decades, Vamsi. Correct? On all the formulas, you do like this. Whether geometric, whether arithmetic, whether it is incremental, whether it is logistic. Only mark my words, I'm telling you the exception things. Like it happens in chemistry, things comes from exceptions, so here also. In decreased growth rate method, if it is asking also to calculate for 2030, you make sure that you calculate. Now here it is asking 2020. You make sure that first you have to calculate for 2000, then 2010, and then you will calculate for 2020. Then you will say, ma'am, if it is asking for 2050, then 2000, 2010, 2020, 2030, 2040, and then you will get for 2050. For sure. It will be like that. Clear? So if it is telling you to calculate for 2020, it is deliberately mandatory whether you use formula, whether you use anything. You have to calculate for 2000, 2010 as well. Clear? Understood? So first we have to calculate for 2000, 2010, and then we will be able to calculate for 2020. Here you cannot skip the steps in between. So mark this. This is very, very important for you. Now the next increase in population, and this one will be percentage decrease in population. Okay. How much is the increase in population? Come on guys, quickly tell me. 67,500 minus 55,500. Okay. Increase in percentage population. So let's calculate in one hand only. See, percentage increase 55,500. How much it is coming? Quick. Tell me in percentage only. into 100 कर देती हूँ. 14.77. Second one, calculate half of the students and third one. Mayank, you calculate the third one. Prince, Divya and all calculate the second one. And along with Mayank, some others calculate for the second one. Come on. Quick. $11.93. And what one this one is? Last one, 11.50. Fine. Now, how much is decrease taking place? From 14.77, it is going to 11.93. So, how much is the decrease taking place, guys? And from 11.93, it is going to 11.50. How much is the decrease taking place? Solve it. This much is the decrease taking place. Correct? Now, how much is the average decrease taking place? That is R bar. How much is the average decrease taking place? 2.84. Now, if you remember this now, you don't need to remember the formula. What you did? You calculated how much is the percentage increase in population and how much is the decrease in that increase. So, what that I have done? I said now that chapati's case, my diet is increasing, but my percentage increase in diet was decreasing. Exactly same thing here. So, you will calculate R bar 2.84, 3 divided by 2. That is 1.635%. 1.635%. But ma'am, you did all these things. I need to calculate the population forecasting. How will I calculate? You calculated all these things. Now listen to me very carefully. In 2000, 11.50% should be the increase in population. Correct? But you see that the increase in percentage population is decreasing. That means in 2000, the population percentage will further decrease. Correct? So minus 1.635. From where you got this 1.635? By taking the average from here. Calculate and tell me how much it is coming. Calculate and tell me how much it is coming. Quickly. .865%. Correct? So, the population in 2000 will be how much? Population in 2000 will be whatever is there in 1990, it will be there, plus 9.865% of 79,500. This will be the population in 2000 basically. 2000. 79500 into 87342.675. Is this coming for you guys also? Population will increase, Saurabh. This will be the population in 2000. Now, in 2010, whatever is the population percentage in 2000, it will further decrease. How much? Minus 1.635. How much it will come? So you have to proceed till like this. You cannot, you can say you cannot do any shortcut. You have to go like this. So again, this you will get minus 1.635. So 9.865 minus 1.635. That is, you will get 8.23%. So population in, it is striking over my head or what? ऊपर चला जाएगा मेरे head से. चलो. Okay. Population in 2010 will be whatever population you are having in 2000 plus 8.23% of population in 2000. Come on. So you have to proceed by step, otherwise you will not be able to solve. So come on, proceed in step by step. Quick, quick, quick. और कोई option ही नहीं है. You have to proceed in step by step. 2000, then again for 2020. So 87342.675 into 1 plus 8.23 divided by 100. So from here you will get 94530,977. ठीक है? This you will get it. Correct. Last one I told you, it will be 8.23 minus 1.635. Ma'am, if it have asked for 2030, you have calculated for 2000, 2010, 2020 also? Yes. There is no other option. Even you go by formulas, you have to do this thing only. So 8.23 minus 1.635. So this will be 6.595%. So population in 2020 will be population in 2010 plus 6.595% of population in 2010. Correct? This is the formula. This you have to use it. Come on, answer it how much it is coming. I haven't calculated 100,765.28. Anwar ne bata diya, so this will be the answer. If he is telling is this correct. Okay. ये कविता के नाम से कौन फेक आईडी आ गया है भाई? कम से कम ओरिजिनल नाम से आते. Okay. So guys, understood this decreasing growth rate method? Understood this decreasing growth rate method? Clear हुआ? Come on, come on. Is it clear? So अगर आ गया एग्जाम में, see now एक मैं misconception, let me clear you. Initially you used to think that virtual calculator it can't ask you highly calculative questions, but they have break the stereotypes last year when they asked a big questions from area velocity method in hydrology. So you don't think that highly, you can say large method they can't ask you in GATE. Of course they can. Remember that. Okay, now simple graphical method, very easy. Basically this is not, you can say, accurate method for population forecasting. What they do is they just you have to plot time in years for the data which you know in x-axis, abscissa, and population in thousands on y-axis. So when you plot this, what will happen is, till here let us suppose you know the data. After this, you will extend the curve. But ma'am, it is not necessary now. I will extend like this, or Prince will extend like this, or let us suppose Mayank will extend like this. Okay, so anything can happen. Anything can happen. Correct? So yes, you are correct. Somebody can extend it like this. Somebody can extend it like this. So it depends upon the intelligence and experience of the designer. That's correct. Okay, so you will extend this curve till here. Let us suppose you want to forecast the population for 2011. So you will extend this like this. Okay, then from here, because you are doing it in graph paper, you will draw a line parallel to y-axis. It will intersect the graph here. Okay, this curve, and from this point you will draw a line parallel to x-axis. So here you will get the value as 80,000. Correct? You will get the population in 80,000. So this will be the design population which you will be getting. So this is a tentative method. You can say it is just depending upon the intelligence and skill of the designer, nothing else. So this is not very much reliable. Clear? Arithmetic regression method means decreased rate. No. It doesn't mean the decreasing rate method. Decreased growth rate method is different. Okay? Chaliye. Next. Comparative graphical method. This is a good method as compared to that of simple graphical method. What will happen here? Now city A at various times you know the plotting, the various populations. But you don't know from 1980, 1990 or 2000 you don't know the population. Now we will take those cities. Now let us suppose I am making a new Raipur. So what I will take those cities which have developed in a similar pattern as that of New Raipur. Example, I will take the data of New Bhopal. I will take the data of New Chandigarh. I will take the data of Navi Mumbai. I will take the data of New Delhi. So all those places which have developed in a similar fashion as that of New Raipur, I will take their data. Their data I know. New Raipur's data I don't know for the upcoming years. So what I will do is, Like example, 1970, what was the population of New Raipur? Similar population was there for 1930 for city B. Similar population was there in 1925 for city C, and similar population was there in 1935 for city D, and similar population was there approximately for city E in 1920. So what you do is, if you want to calculate, let us suppose for New Raipur, which is city A, you will just take the population of all the other 4 cities and divide it by 4 and plot it. Okay, similarly, you will for 1990, if you want to calculate, just take the average of these 4 and plot it. And again, if you want to get it for 2000, extend the curve, draw a line parallel, you can do that. But here, basic thing is you take the average. So whenever you want to calculate, let us suppose you want to calculate in 1990. So take the average of the population in 1950, 1945, 1955, 1940. Whatever the population was there in these 4 cities in these years, take their population, divide it by 4, you will get the population of city A. So this is more realistic, more practical, and here you are not depending upon the intelligence and skills of the designer, which way you were doing it in the case of simple graphical method. Clear? So this was your comparative graphical method. This one is a very good method which you use it, master plan or zoning method. You guys can check out the master plan. You can Google it and you can check out the master plan of your city as well. Here what happens, whenever this, you can say whenever a city is being constructed, government tells that this is for, this is private buildings. Okay, this is public one. This is for government offices purpose. Everything is divided. This is commercial area. This is industrial area. Everything is divided. Now example, here they have told that the residential area density will be 250 kilometer square. Okay, here they have told that the industrial area will be 150 kilometer square. They have told commercial area will be 100 kilometer square. Okay, now let us suppose if they have told that 10 people live in 1 kilometer square area. Okay, here if let us suppose 20 people live in 1 kilometer square area, and here 7 people live in per kilometer square area. So you can calculate the population. If 10 people live in 1 kilometer square area, how much people will be there in 250 kilometers? If 20 people are in 1 kilometer square area, how much will be there in 150? If 7 are there in 1 kilometer square area, how much will be there in 100? This will give you the total population. Correct? So this is the master plan or zoning method which you use it. This is a good method right now. Whatever coming new smart cities are being developed, they are developed on this master plan and zoning method. So they are not arithmetic geometric, we are using master plan and zoning. Here? Now, arithmetic method को ही बोलते हैं. Arithmetic method को ही बोलते हैं, first वाले को. Clear, Venkatesh? First method is only what you call it as. Last method of population forecasting and last water demand, last topic of water demand, that is logistic curve method. Now this you can use only when T2 is twice of T1. If T2 is not twice of T1, you cannot do this. And here it is very important that all calculations are done from base year. Are done from base year. Example. I'll tell you, you tell me whether it is valid or not. 1950, 1970 is, here the population is P0, here the population is P1, here the population is P2. Logistic curve is valid or not? Yes, they can ask you formula based things from logistic curve. Logistic curve is valid or not? Logistic curve method is valid or not? Come on guys. T2 should be twice of T1. I'll write it as, I'll write this time as T0, this time as T1 and this time as T2. Now tell me, logistic curve method is valid or not? Some people will say that yes, it is valid because they will say 1950 to 1970, it is 20 years, that is 2 decades. 1970 to 2010, it is 4 decades. So yes, T2 is twice of T1. So logistic curve is valid. No. I told you, all calculations are done from base year. All calculations will be done from 1950. Correct? Correct. Not valid. From 1950 to 1970, the population is how much? 2 decades. From 1950 to 2010, the population is 6 decades. all calculations will be done with respect to 1950. So here T2 is thrice of T1. You cannot use logistic curve. Now, example, same thing. If 1950, 1970, 1999, P0, P1, P2. Now logistic curve is valid. How? 1950 to 1970, 2 decades. 1970 to 1990, 2 decades. But I will not take from 1970, I will take from 1950. So 1950 to 1990, 4 decades. So see, T2 is twice of T1. Now you can use all the formulas of logistic curve method. Otherwise, you cannot. Now, somebody was asking that time, is she there? If you are there, then I'll answer that. Consecutive decay, something you were asking, kindly post it. Now I will answer your doubt. Whatever you were saying. That time we were not dealing logistic curve method, so I was not telling you. Because I can't distract the other students, right? So now anybody was having doubt that time, if she is or he or she is there, can ask me right now. Now, at T0, the population is P0. At T1, the population is P1. At T2, the population is P2. Now, P saturated means the maximum population which a city can accommodate. In India, we have already gone very far as compared to saturation population. Okay, in one people, if it is 1 BHK, 4 people to live, you will see that in some places 8 people are living. So, we have already exceeded more than saturation population. But yeah, for numerical purpose, we should know. So, the maximum population which a city can accommodate, that is known as saturation population. Now, how can you calculate? So, the formula for calculating saturation population is 2 P0 P1 P2 minus P1 square, P0 plus P2, P0 P2 minus P1 square. Kindly remember this if they ask you in the examination. So, you should remember this saturation population. At time T0, whatever is the population is known as P0. Time T1, the population is known as P1. Time T2, the population is known as P2. Now, here it is very important to know that this is saturation population. Whenever you want to forecast the population, P is equal to PS 1 plus M e to the power nt. Now, PS you have already calculated. M is a constant which is saturation population minus initial population divided by initial population. So, this is M. N, you substitute this in number of decades. Now, here, let us suppose from 1950 to 1970 it is telling. Okay, so here you will substitute, like example I'll tell you. 1950 data is given to you. 1970 data is given to you, 1990 it is given. First is to check whether logistic curve is valid or not. Then it is asking you in 2010. For calculating in 2010, here from 1950 to 1970, how much is the decades? 2. So here you will substitute 2. Okay, here you will substitute 2. Remember that. And if it is asking for 2010, can anybody tell me what you will substitute in place of T? Can anybody tell me? Here n is not number of decades. So they have given you the value of n. What is t? T is for how many time you want to calculate. Can anybody tell me? This is very important. From 1950 to 1960, 1970, 1980, 1990, 2000, 2010. Here you will substitute 6. All calculations from base year. This is the thing which you make mistake. Here also T1 you will substitute in number of decades. And here also T you will substitute in number of decades. Very good, Saurabh, Saugata, Dinesh, Divya, Anwar, MVS. Good. Now, if consecutive 3 decades data is given, then how can we calculate saturation population? Their logistic curve method will not be valid. Or it will be valid. Batao. Pehle to ye batao that whether it will be valid or not. Consecutive 3 decades means 1950, example, 1960, 1970. First tell me whether it will be valid or not. 1950 to this, 1 decade. 1950 to 1970, 2 decades. T2 is twice of T1. Valid. Valid. Dinesh, valid. Check it out. 1950 to 1960, 1 decade. 1950 to 1970, 2 decades. T2 is twice of T1. It is valid. Kindly substitute whatever formula is there. Kahan gayi? Who was asking that? Somik. See. P0, P1, P2, whatever. Obviously, you said now how we will calculate saturation population. So, this is the formula for saturation population. You haven't given me the data. So, whatever value you have it for 3 consecutive decades population, substitute it here, you will get the saturation population. So, you asked me how to calculate. You will calculate with the help of this formula. Clear? Decides in decimals or not? Vishal, could you elaborate? I'm not able to understand what you're saying. Clear, everybody else? So first you have to check it out. So guys, with this we have completed the first chapter. Finally, it took 1 hour 20 minutes, but next chapter we will complete in 1 hour. That's a big, we'll complete in 1 hour. Okay, enjoyed? You guys also drink water, hydrate yourself. Okay. So now we are going to the second chapter, very important quality parameters of water. And tomorrow you are going to have Geotech Marathon. And guys, let's start with the ones. So we have completed the first chapter, done and dusted. Correct. Now we will talk about the second chapter, physical water quality parameters, chemical water quality parameters and biological quality parameters. You have to be with me till night, till the time it is not covered. जब तक खत्म करेंगे नहीं तब तक छोड़ेंगे नहीं, याद रखना. Okay, so now let's start. Let's start, guys. T-twist. Yes, Somik, I told you na. If it is not the logistic curve is not at all valid, that is the prerequisite. Like if you want to do, let us suppose if you want to go for PhD, you need to have a postgraduate degree. It is very mandatory. Otherwise कुछ और डिग्री होनी चाहिए. उसके बिना कैसे आप बीटेक के बाद सीधे PhD नहीं कर सकते, अदर देन डुअल डिग्री प्रोग्राम होगा. मैंडेटरी है ना, क्लास 2 से पहले क्लास 1 पढ़ना ही पड़ेगा. Mandatory condition. So here also, if you want to apply logistic curve, T2 should be equal to twice of T1. Correct? Yes, it is possible. Yes, it is possible, Vishal. You can take it. डायरेक्ट पीएचडी वो डुअल डिग्री प्रोग्राम्स वगैरह होते हैं, या आपकी बहुत ही मतलब फॉरेन से कुछ कंडीशंस करके आओ तो, नहीं तो 1 के बाद तो 2 ही पढ़ते हो ना, कि 3 पढ़ते हो. Until and unless you are an exceptionally good child. बट यहाँ पे वो भी वर्क नहीं करेगा. चलिए, now we'll talk about quality parameters of water. We will check the quality of water. Why we need to check the quality of water? Because obviously for doing the treatment, first we should know what is the desirable quality and what is the undesirable quality. If undesirable quality is there, you need to remove them and you need to add desirable quality of water. Now, exactly like if you have a fever, so doctor advise you so many tests to check it out. Or firstly, doctor will check it out. You will say its fever is there, but then also doctor will say, nurse, just check it out how much fever she is having. Based on that, your fever you are having, he or she will give you the prescription. Correct? So how is the treatment to be given when you are not ill? That will depend upon the extent of disease or extent of fever or anything which is there. So similarly, how much treatment is to be given to the water, that will depend upon the quality of the water. So you have physical quality, chemical quality, biological qualities. So first we will talk about what? First we will talk about the physical water quality. Physical is which you can touch, feel, see. That is known as physical. So first physical which you will talk it about is suspended solids. Now, of course, if I'll give you a water and in that solids are suspended, will you drink that water? Of course not. Because a psychological impact is there. It is not looking good. That means this water is not good. Okay, although water will be taste good, but since you have seen particles on that, you have that psychological impact in your brain. Correct? Next thing, if I talk it about, generally from where does the suspended solids comes? So now, if I talk it about, suspended solids comes from organic matter, or like it comes from inorganic matter, like sand silt can be there, or organic matter can be there. Ma'am, what is the difference between organic and inorganic? In organic, predominantly carbon is there. In inorganic, carbon is not there. Now, in organic, carbon is predominantly there. There are exceptions because see, it's partly chemistry. So yeah, exceptions is there. Sometimes a compound is organic in nature, but it doesn't have carbon. So yeah, you can say that obviously exceptions are there. Okay, so now if I talk to you the general formula of organic matter, this is the formula. A moles of carbon, B moles of hydrogen, C moles of oxygen, D moles of nitrogen, E moles of sulfur and F moles of phosphorus. This is the general formula of organic matter. Clear? Now, if you want to calculate organic matter, there are various methods which we will check it out later. This is the organic matter. Now you will say, ma'am, they are further divided. Yes, there are biodegradable organic matter, there are non-biodegradable organic matter. Biodegradable organic matter can be easily decomposed. Microorganisms will attack, it will easily decompose. Non-biodegradable organic matter, which will not be easily decomposed by the action of microorganisms, or they will take time for decomposition. Okay, so from where does suspended solids comes? It can come from organic matter, plants are there, algae is there, you have glucose is there. These are organic in nature. Okay, or it can come from sand, silt particles as well. So if suspended solids is there in water, you need to remove them. Okay, and I told you, if suspended solids is there, psychological impact is there that this water is not good for drinking. Correct. Now comes the question that how can you do the measurement of suspended solids? So what you will take, now understand this very importantly, the whole procedure. Before I start the procedure, हिंदी में भी बोल दीजिए. कौन है हिंदी वाला? भाई साहब, मुझे लगता है कि nobody is having problem in English, right? अब पता नहीं कहाँ से आ जाते हैं क्लास में डिस्टर्ब करने के लिए और फ्लो को खराब करने के लिए. Nobody is having any problem, right? Come on, एक बार बता दो भाई. Just tell once. Nobody is having any problem. तो मैं ऐसी कोई फॉरेन इंग्लिश तो यूज नहीं कर रही हूँ जिसको शायद समझ में ना आए. ठीक है, मतलब बहुत ही ज्यादा फ्रेंच स्पेनिश नहीं बोल रही हूँ, इंग्लिश ही बोल रही हूँ, वो भी नॉर्मल वाली, लो लेवल की. तो चलिए अब स्टार्ट करते हैं. अब बीच में डिस्टर्ब नहीं करना ऐसे लोग. No, I will not provide any PDF. You have to be here and study with me. That's it. Okay, now. बता तो दिया. Okay, now. Guys, very carefully understand the procedure. Because in the examination, they will not tell you that this is the procedure for suspended solids. You have to apply your brain. Okay, they will not tell you that this is for suspended solids, this is the procedure. You check it out. If you don't believe me, check out the previous year's question paper. They will tell you the procedure, they added this, they do, this came out. But they will not tell you that this is the procedure for suspended solids. You have to apply your brain. So that is the reason, understand the procedure, it is very important. Okay, now listen to me. See, actually total solids is there, which is the summation of suspended solids plus dissolved solids. Correct? Now, you took 1 liter of the sample. Now, obviously, in that suspended solids will be there and dissolved solids will be there. Both will be there. Okay, so you pass it through a filter paper. In some questions, they may give you the weight of filter paper. In some, they will not. So, what will happen? Dissolved solids will go into the beaker. Suspended solids will be retained. Okay. This suspended solids will have some water in it. Ma'am, how can you say some water is there in it? Guys, everybody have made tea in their life, or they might have seen people making tea. So when they pour it through the sieve, from the spoon, you press it like this so the tea comes out. Then also the tea comes out. Although tea leaves are there in the sieve, but you press it with the spoon, what happens? Tea comes out. Correct? Exactly like this will happen here. That means water will also be there along with suspended solids. So you will heat it at 104 degrees Celsius for 24 hours. So the water will vaporize and you will get only suspended solids. You will measure the weight of suspended solids. This technique, because you are measuring the weight, is known as gravimetric technique. So you will measure the weight, you will get the weight in mg. This weight is present in how much sample of water? You have taken 1 liter sample. So if they ask you the concentration, so concentration of suspended solids will be mg per liter. This will be the concentration of suspended solids. Clear? So they will not tell you that this is suspended solids. A 1 liter sample of water was taken, or they don't take even 1 liter, they take 200 ml. And they pass it through the filter paper, and after heating it came out to be so much. Identify the amount of concentration of suspended solids. So you should know that this whole procedure is for suspended solids. Got it? And let us suppose when you pass it through the filter paper, the dissolved solids came. So when you heat it at 104 degrees Celsius for 24 hours, you will get from here dissolved solids. Okay, ma'am, dissolved solids I can get it like this, suspended solids I can get it like this, but I don't want to get suspended solids and dissolved solids. Rather, I want to get how much is total solids. Then nothing. Just take this sample because they've asked question from total solids also. This total solids is there in 1 liter. Okay, this total solids is there in 1 liter. Take this 1 liter sample and just heat it for 104 degrees Celsius for 24 hours directly. So because since you are taking total solids, you don't need to pass it through the filter paper, nothing you have to do. Take this 1 liter of total solids in this 104 degrees Celsius, water will vaporize, you will get the value of total solids in mg per liter. Correct? So they have asked questions from this one. They have asked question from this one. So if they're just taking the sample, they haven't mentioned that whether they are passing through the filter paper and all, because they have asked question from this topic. They have taken the sample and they have heated it. Okay, that means they have given you total solids. If they have taken the sample, passed it through the filter paper, and then from the filter paper they are heating it, that means they are talking about suspended solids. Okay, so this they will not tell you. You have to understand it. Clear? 104 degrees Celsius for 24 hours. Yes, temperature role is there because this temperature is made sure so that all the water converts into vapor and vaporizes. So temperature is important. Like when you bake the cake, Akash, temperature is important. At this degree Fahrenheit, you should bake the cake. Ambient temperature for fluffy cakes. So similarly here, I don't want any moisture. I just want the solids. So that's why temperature. Clear everybody? Okay. Now guys, what happens in suspended solids? One more thing is there. In suspended solids, one more thing is there. That here I will have further bifurcations also. Like one bifurcation I told you. What I told you, one bifurcation is that total solids is the summation of suspended solids and dissolved solids. Correct? Now, total solids is the summation of suspended solids and dissolved solids. But total solids can be organic in nature also and inorganic in nature also. Now, this question also they have asked in the examination. Now kindly guys remember, this is very important. Organic solids, there is other name also, Paryayavachi, that is synonyms also you need to remember. Organic solids is also known as volatile solids. Inorganic solids is known as non-volatile solids. You call it as fixed solids as well. Clear? Now, because in the question it is not necessary they will use inorganic, they can use the word fixed also, they can use the word non-volatile also. Okay, now what happens guys? Now what happens is, you will say, ma'am, I want to know how much is the organic solids present. Now, how much is the organic solids present? Listen to me very carefully. Organic solids have a property, if you heat them at a very high temperature, from liquid they directly convert into vapor state. Okay, but liquid नहीं है, वो solid है. So basically liquid में वो present है. In liquid, that is in water, these organic solids are present. So the property of organic solids is that if you heat them directly from the solid phase, they will convert into vapor state. Exactly like camphor, you know that, right? Kapoor. So you call it as sublimations there. But here, basically that organic solids will directly convert it into vapor state. So what happens when you have total solids? When you put it in a furnace, and from where you calculated total solids? By just heating the sample. No brain, just take that sample, heat it. You will get total solids. Total solids which are there, when you put it in a muffle furnace, from 600 to 650 degrees Celsius. Imagine how much great temperature is. For 1 to 3 hours, what will happen? Organic solids will vaporize. And what will remain? Fixed solids or inorganic solids will remain. Total solids, you already know. Fixed solids, you have measured the weight. So total solids minus fixed solids will give you organic solids. So if in the examination they ask you volatile solids or they ask you organic solids, just measure total solids and divide it by the inorganic solids or fixed solids, you will get the organic solids. Clear? This is the thing. If they ask you, no, in organic solids can also be suspended or it can be dissolved. So if they'll ask you, no, I want to calculate suspended organic solids. I want to calculate suspended organic solids. Then what you do is you will calculate suspended solids, which you have already calculated. Take that suspended solids, put it in a muffle furnace. What will happen? Organic suspended solids will vaporize. What will be left? Inorganic suspended solids. Just measure the weight, subtract it from suspended solids. You will get suspended organic solids. Clear? Similarly, you can do for dissolved solids as well. So this is the procedure. However, till now they have asked questions from this topic 3 times, and they have asked from this logic 1, and they have asked from this logic. Okay, so they have asked from these 2 things. Any doubt till here, guys? Any doubt till here? What I should repeat? पहला चैप्टर पूरा करा दिया. Now Kalyan, tell me what I have to repeat. What specific thing? Tell me now what I have to repeat. Everybody else, it is clear. Divya, Akash, Prince, MVS, clear? Sophia. Suspended organic solids. See, this suspended solids I have already measured, beta. Kalyan, I have measured this. I will take this suspended solids, okay, and I will put it in a muffle furnace. How much time? 600, 650 degrees Celsius temperature, 1 to 3 hours. What will happen is, organic suspended solids will vaporize. What will left? Inorganic suspended solids. Which has vaporized, I can't measure it. But which is left, I can measure it. So suspended solids, I already know. Inorganic suspended solids, I will measure it. So suspended minus inorganic suspended will give me organic suspended. Clear? Because this is the property of organic solids that when you supply a high temperature to them, they vaporizes. That is the reason. That is the property of it, and that is the reason it will vaporize. Clear? Okay. Muffle furnace is a special. See, if you are giving 600 to 650 degrees Celsius, imagine 100 degrees Celsius is the boiling point, 600 to 650 degrees Celsius. So for that, a special type of furnace should be there, which can bear such high temperature. That's why the name is there, muffle furnace. Okay. Inorganic solids difficult to remove in comparison. Inorganic solids are sand silt particles, beta. Usko to remove करने में ज़्यादा दिमाग ही नहीं है. They will not vaporize. They will settle down. They will settle down under the action of it. You will remove them. Non-biodegradable organic matter is difficult to remove. Okay, if you ask me. Chaliye. Now we'll talk about turbidity. No, muffle furnace is the furnace which is used here. If you can develop anyone, that is also good. Now, next type of treatment which you give, not treatment, a parameter is turbidity. Turbidity in water is due to suspended solids. There is a quantitative relationship not there. There is a qualitative relationship. Qualitative matlab zyada kam, more less. More is the suspended solids, more is the turbidity. Less is the suspended solids, less is the turbidity. But if you say, ma'am, if suspended solids is 5 mg per liter, turbidity will also be 5 mg per liter. No. There is a different method for measuring turbidity as compared to that of suspended solids. If suspended solids is more, turbidity will be more. But otherwise, if you talk in terms of value, no. You have different values. Ma'am, permissible limit, according to the code has not given any permissible limit for suspended solids. Got it? So there is no limit of suspended solids. Got it? A Bureau of Indian Standards and other agencies have given, but if you talk about government, that IS 10500/2012, that is the, if you can download it and check it out, this is the code for quality parameters of water. In that, there has been no unit given for suspended solids, though no limit has been given for it. Okay. Now, when I was talking about turbidity, what is turbidity? Firstly, turbidity is due to the presence of suspended solids. But what it is the extent to which light is either scattered or absorbed by the water sample. That is known as turbidity. Now, if I talk about turbidity, light scattered or absorbed. How the light is scattered or absorbed? Because suspended solids are there, because of which either light will be scattered or it will be absorbed. But I want to measure the turbidity of water. How can I measure it? So there are different ways by which I can measure the turbidity of water. First method is turbidity rod. This is a field method. Out of all the methods, only one method is field method, that is turbidity rod. Here eye mark, tape, everything is there. A nickel ring is there here and a platinum needle is there, 1 mm long and 1 mm dia, 25 mm long, and this is the aluminium rod. This small bifurcations, what is the rod made of, what is the needle made of, what is the thickness, this has been asked in many of your JEE papers also. Okay, now what you do, this needle is there. The water which you want to test it, you just insert it. You keep on inserting it and checking it out whether this needle is visible to you. The moment you keep on inserting it and the needle becomes invisible, you will check out the reading and you will tell that this so and so much is the turbidity of water. Now you will say, just a minute ma'am, rod gives you the value in meters, right? It is the height and you are telling me that it will give you the turbidity in mg per liter. How is it possible? I understood you inserted the needle and you just keep on just penetrating it till the time the water, the needle becomes invisible. And so you tell that so and so is the turbidity of water. But the question comes that it should give me the height now. It should give me the depth. How is it giving me the turbidity value? Example. Here I have calibrated two things. I have related two parameters. Like technically it should give you the height, but it is giving you turbidity because I have done the calibration. I have related two different parameters. Example, if the height is, let us suppose if the penetration is 5 centimeter. So the turbidity will be 11 mg per liter. So technically this is arbitrary value. Technically I should get in the rod 5 centimeter. Okay, but I'm getting 5 centimeter or 50 mm. But I'm getting the turbidity value. Why? Because the time when I was making this rod, I have done the calibration. But ma'am, how can you do? Example, when I sneeze for one time, it's for sure that I'm getting a 100-degree fever. When I sneeze for 2 times, I'm getting 102-degree fever. How can you say that? Because over the past 10 years, whenever I used to get sneezing one time, I used to check the thermometer. I used to get 100 Fahrenheit of fever. And when I used to sneeze for 2 times, I used to get 102-degree fevers. So that was based on my studies. Okay. But here I calibrated it. Example, I added 2 milligram of silica. I took 1 liter of distilled water. Okay, let us suppose I have taken here 11 now. So 11. I took 11 milligram of silica in the form of silica oxide in 1 liter of distilled water. Today my writing is doctors. Do not say anything. Distilled water. Okay. It was a pure water. I added 11. I measured 11 milligram of silica and I added it. So this time the turbidity will be how much? 11 mg per liter. You can call it as 11 ppm or you can call it as 11 STU. What is STU? Silica turbidity unit. And now in this water I will penetrate the turbidity rod. And let us suppose at 5 centimeter I was not able to see the needle. So in place of 5 centimeter I will write 11 mg per liter. I made the sample, I did the experiment and I calibrated it. Similarly, I will make n number of combinations and in that whole rod, I will put the values. Okay, so I did the calibration of two unknown things. Now, in the examinations, if they give you mg per liter, ppm and STU and they ask you that which one is the accurate measurement, you will say STU. Although ppm, mg per liter, STU, they all are same. But the principle involved in calculating was of silica. That's why you will write STU. Clear everybody? Clear? So this was turbidity rod. Now after this we have one more, Jackson's turbidity meter. Exactly also that is also same. Nothing is there. You just take a beaker, you have a measuring glass and you have a candle here. Okay, now what you will do is you will burn the candle and you keep on pouring the water. The candle flame should be visible. The moment you are pouring the water and the candle flame is not visible to you, that point you will get the turbidity. So exactly same. In that needle was become invisible. Here candle flame becomes invisible. So you will get what? You will get the turbidity. Clear? This you don't use because see, if more than 5 mg per liter turbidity is there, you can easily, it is visible by naked eye. And Jackson's turbidity meter is giving you turbidity. Jackson's turbidity meter is giving you turbidity more than 25 units. So for drinking water, you don't use it. For natural water bodies and all, you can use it. Clear? So this is Jackson's turbidity meter, which is there. Don't use it here for drinking water supply. Clear? And one more thing. If one thing you will answer me. If here more amount of turbidity rod is penetrated, turbidity will be less or more? More amount of turbidity rod is penetrated. Larger the penetration, turbidity will be more or less. सेंटीमीटर कहाँ लिखा है मैंने? ppm लिखा है. Very good, Divya. Very good summary. See, if more amount of whether it be water, more depth of water, or whether it be a more, you can say, rod penetrating. That means the turbidity is less. That's why it is penetrating more, and still you are able to see the needle. If the turbidity would have been more, then the penetration would have been less. Correct. More penetration, very good. More penetration, less. Or more is the length of light or path traveled. So lesser will be the turbidity. Correct? Okay. Same goes for Jackson's. Now talking about Bailey's turbidity meter and nephelometers. Firstly, they are based on color matching technique. Initially, Bailey's turbidity meter was based on color matching technique. You have an electric bulb. Okay, you have a reflector here. You have two glass. One is the test sample in which you need to find the turbidity, and one is the standard sample in which you made the turbidity. See, when you will make, you know what will be the turbidity. So standard sample, I will not repeat every time. Standard sample is that sample in which you will make the turbidity. Correct? Now, what you will do is you will switch on the bulb, and here you have plotted this, basically you have kept in front a vertical blue cobalt glass plate. So what will happen is when you will on this electric bulb, the light will be going scattered, and I have told, let us suppose I have told Divya that Divya, keep your eye here in this position, and you have to see in standard sample and in test sample, light should be there. Okay, same color of light should be scattered. So she is just holding like this eyes and she is checking it out. If the intensity of blue color light, because you have played a vertical blue cobalt glass plate and our eyes are sensitive to blue colors. Okay. So if the intensity of blue color in standard sample and test sample comes out to be same. So whatever is the turbidity in standard sample, that much will be the turbidity in test sample. Standard sample, you made it, so you already know the turbidity. So standard sample turbidity and test sample turbidity will be same. Correct? But one thing which will come into action is that it's not necessary na ki standard sample and test sample will have same turbidity. If let us suppose intensity of blue color light scattered in both of them is not same, you can say. So you will change the standard sample. How many times we have to change it? Keep on changing it till the time you get same intensity of scattered light in standard sample and test sample. Now I'll ask you one question. Let us suppose in standard sample, you made the turbidity of 4 mg per liter. In test sample, if we would have measured, actually the turbidity is 3.8 mg per liter. Intensity of light is scattered in both of them. Will you be able to distinguish? Yes or no? I'll be back in a minute. Just tell me. Will you be able to distinguish by yourself the intensity of light 4 mg and 3.8 mg? Quickly. No. No. Right? So you will not measure, and that was the drawback. See, I told Divya that and she will say, no ma'am, both the intensities are coming same in both the samples, but actually not, right? You're not getting the same intensity in both the samples. In one it is 4 and one it is 3.8. So that was the drawback. So that's where we move towards photometers. Now what is this photometers? Photometers is a semiconductor device, and which is whenever light is moved, basically pass on this, it produces current. So photometer is a semiconductor device which produces current when light is incident on it. Now I'll show it to you. Wait. Okay, photometers. Now, as the light will be incident on it, quickly it will produce current. Ma'am, how current is produced? Current is produced due to what, guys? It is produced due to, it is produced due to flow of, it is produced due to flow of electrons. So when light is incident on it, excitement of electrons will take place. And that is the reason what will happen? Current will be produced. Just let me add a slide so that I can draw it for you guys. Fine. Done. Now see. One is the test sample. This is standard. This is SS is not for suspended solids. This is for standard sample. This is not an official denotation, huh? And this is for test sample. That's what I'm telling, na? Standard sample. Now in both of them, we will put photometers behind the sample. Here it will be a bulb. Okay. Now what will happen is you will pass light path to both of them. You know, some, because obviously in both of them solids are there, because standard sample is what I made it. So obviously solids will be there. Test sample in which solids are there, which I want to know how much solids is there. So some light will be scattered and some light will be absorbed. The light which gets absorbed will fall on the photometer. Photometer, excitement of electrons will take place, current will be produced. If the current which is produced in test sample and standard sample is same, so whatsoever is the turbidity of standard sample, that much will be the turbidity of test sample. The current is being produced due to the excitement of electrons. Here you match the current. So the technique which is used is current matching technique. Initially you were using color matching technique, which was not that appropriate. Now you use color matching technique you were using, which was not appropriate, not accurate. So now you measure the current, which is further accurate. Ma'am, if the current produced is not same, change the standard sample. Keep on changing it till you get same amount of current in both standard sample and test sample. Since here you measure the absorbed light, Bailey's turbidity meter is based on absorption principle. Now, similar funda is there. Example. Only difference is, here let us suppose standard sample is there, here let us suppose test sample is there. Instead of placing the photometers behind, you place it at 90 degree. This is photometer and there is one more photometer. You are placing it at 90 degree. Again same thing, light will go. Now here what will happen, some light will be scattered, some light will be absorbed. So now the photometers will measure scattered light, and that too only those scattered light which are falling at 90 degree. If again the current produced in standard sample and test sample is same, whatsoever is the turbidity of standard sample, that much will be the turbidity of test sample. If not, change the sample. Okay. So here when you place it at 90 degree, you call it as nephelometers. When you place it behind the sample, you call it as Bailey's turbidity meter. Nephelometer is also based on current matching technique, but one more thing is there. Here when you are making standard sample, okay, when you are measuring standard sample, and first you are making standard sample, here you don't use silica dioxide. Let us suppose if I am using 2 milligram of formazine. When you put 2 milligram of formazine in 1 liter of distilled water, you call it as 2 FTU or you call it as 2 NTU. Formazine turbidity unit, or you call it as nephelometric turbidity unit. That means it will, that water sample will produce same turbidity if 2 mg of formazine in 1 liter of distilled water is added. If the current produced is same, that means test sample will also have the turbidity of 2 NTU or 2 FTU. That is the meaning. Ma'am, initially we were using silica dioxide. Why we are using formazine now? Because it gives more good results as compared to silica dioxide. Okay, one question has been asked in your gate: NTU, FTU, mg per liter, ppm. Which one is the appropriate, guys? Which one is the appropriate? Come on, guys, which one is appropriate? The answer is, this is your previous year gate question, FTU. But ma'am, you told NTU and FTU are same, and technically NTU, FTU, mg per liter, ppm all are same. Yes, same. But the principle involved in making the standard sample is of FTU. Okay, and that is the reason FTU is the most appropriate. Correct? Now, if you talk about the limits, you have two limits, acceptable limit and cause for rejection limit. Acceptable limit, if I talk it about, you have one NTU. Acceptable limit under normal conditions. Now, very big misconception which people have. I don't know specifically why they think like this. They think that 1 mg per liter or 1 NTU turbidity should be there. Nah, beta. Up to 1 NTU turbidity should be there. That means when 1 milligram of formazine in 1 liter of distilled water is being there. So up to that much turbidity should be there. If it is 0.9, 0.8, 0.7, that is also okay. Now, let us suppose you are using the water when there is no alternate source available, nothing is available. In that case, you can exceed up to 5 NTU. Otherwise, it is 1 NTU only. Okay, so cause for rejection limit is, that is also not 5. Up to 5. That it means it can be 4 also, it can be 3 also, it can be 2 also. That is the meaning of it. Clear? It means same type, like if I put 5 milligram of formazine in 1 liter of distilled water, how much turbidity is there? Exactly up to that turbidity is allowed in the water. That is the meaning of it. Clear? Now is it clear? Bailey's, nephelometers, everything clear? Clear everybody? I'm just waiting. Should we do more if more than one options are correct? What should we do if more than one options are correct? Then it will be an MCQ. They will frame it like this so that one or more than one options is correct. Okay, here it is will be FTU. And this question has been asked in assistant professor, lecturer, many exams, that mg per liter, ppm, FTU, NTU is the most common one. Now, guys, if you are asking for break, however, I am very much happy that you haven't asked. But if you are asking for break, after this chapter, we'll take a break. Okay? Means first let us complete quality parameters of water, and after that we will take a break. Right? So at least we should complete 2 chapters and then 2 chapters after this. Is it okay, right? Everything are equal. NTU, ppm, NTU, ppm, FTU, and this one. ppm, mg per liter, all are equal. But if you ask me that which one is more appropriate, I will say that FTU, because the principle involved in making the standard sample was formazine. Na? That is the reason. Okay. Direct lunch break. Chalo, theek hai fir. I don't have any problem. But in between, I will have to drink electrol. Because that's it. Otherwise, I don't have any problem. Fine. Let's start. Color. Color is also something which you can see it. It is visible to you. Now, just remember this thing. This they can ask you in statement wise. True color. There are 2 types of color. True color and apparent color. True color in water. This is due to dissolved solids. Okay. Apparent color is due to total solids. Total solids means it can be due to dissolved solids also and suspended solids also. So, color in water. From where does the color will come in water? Due to dissolved solids or due to dissolved and suspended solids. Now, example, if I give you a water which is black in color, will you drink? Yes or no? Will you drink? Yes or no? Now, don't let me open my mouth. That Prince understood what I'm trying to say. If it is a soft drink, you will drink. Why? I'm giving you black water. You are not drinking it. But what Prince is saying, you will drink it. Why? Because you know that taste. You have seen it before. It is in your mind. But whenever you're coming and you're seeing that a colored water is there, generally you hesitate. Because you have that psychological impact. Okay, you have that psychological impact that it is not looking good. Again, okay. And if color is there, color can be due to many reasons. Trusted color, ये देखो इसको जरा. Trusted color, बहुत very good. Okay, so here if you are having if you are having color, so color in water, a psychological impact is there. See, if color is there, it can lead to carcinogenic compounds, it can react with phenol. There are so many impacts of it is there. Okay, so the question comes, how can you measure color? Obviously there should be an equipment for measuring it. So the equipment which is there, that is known as tintometers. This has been asked in Match the Following. Tintometer is the equipment by which you measure the color, and the tube which you use, that is known as Nessler tubes. So you will have two tubes. Again, one is the standard sample. See, standard is always the one which you will prepare. So here SS is not suspended solids, this is standard sample, and TS is the test sample. Example, when I add 2 milligram of platinum in the form of chloroplatinate ion, in 1 liter of distilled water, you call it as 2 TCU, 2 true color unit. TCU means true color unit. You add it, and if you see that the color produced in both the samples is same, in standard sample and in test sample, the color produced is same, you will say whatever is the color in standard sample, that much will be the color in the test sample. If you put 4 TCU and you see that the color produced in both of them is same, you will say test sample also have 4 TCU as the color. But the problem is, this platinum in the form of chloroplatinate ion gives only yellowish color. Ma'am, but it's not necessary that in water you will have only yellowish color. Of course, it will not necessary. So nowadays we have a technique that is known as spectrophotometer technique. Now we have the advanced version of it, that is spectrophotometer technique. So that will give me the various colors measurement as well. This one platinum in the form of chloroplatinate ion, this will give me generally yellowish tincture of the color shades, but not the other colors. So we will have spectrophotometer techniques. Now acceptable limit up to 5 TCU. That means when you add 5 milligram of platinum in the form of chloroplatinate ion in 1 liter of distilled water, how much color is produced? Up to that much color is allowed in the water. In case when there is no alternate source available, that time you can extend it up to 15 TCU. Got it? This is the meaning of color. Clear? Any doubt till here? Color 1? Clear? You people drink orange color also, yellow color also, pink color also. I don't know what else colors are there in the market. So don't tell me that you are not the one who don't drink different colors. Nowadays you have reddish pink, orange pink colors also. So coloring things. Okay. Now taste and odor, from which question has been asked. Taste and odor are two different parameters, but over the time we have realized that whatsoever gives you taste, they gives you odor as well. When your mother cooks food and you get the taste, you automatically visualize something good is cooking, and you start to feel the taste as well. So like taste and odor are related. Now if you want to measure the taste and odor, so first of all the measurement is done by dilution technique. Now listen to it here, because this will be used in wastewater also. It was not Jaljeera, by the way. Last year marathon, it was not Jaljeera, it was sand and silt particles, first of all. Okay. Now you just make fun. Jaljeera Rita, and that was Sunday ka Funda video also I have shown you about turbidity. This 1 liter of water is there. In this, you have added 9 liter of distilled water. Distilled water means pure water. 1 liter of test sample was there, in which you added 9 liter of pure water or distilled water, whatever you want to call it. So you will get 10 liters of water. Now in this, test sample is also there and the pure water is also there. So you will call it as diluted sample. Exactly like in diluted, the amount of water is more. Exactly like if you remember in your chemistry, you have it. Remember. That concentrated H2SO4 which is kept near to the faculty, and you go and just put a drop and all from your glass rod into your test tube, and many people would have burned their skin and clothes also. You might have done your, like, I'm making you nostalgic in your old 11th and 12th standard, right? And dilute is the one which you are just using as if you have to take a bath on it without any fear H2SO4 putting it in the test tubes. Because you know maximum in this is a water only. So if it falls on your hand also, you will not have any impact in maximum cases. Concentrated, even if a single drop goes, it will burn your skin for sure. Correct? So here exactly same thing. Diluted, you have put more amount of water in it. So here if they ask you what is dilution factor, in short, you call it as DF. That is final volume of diluted sample initial volume of test sample. Example, in this case, how much it will be? Final volume is 10 liters and initial volume of test sample is 1 liter. So here the dilution factor is 10. That means you have diluted the sample 10 times. Clear? That is the meaning of it. Now, what is threshold odor number? It will give you the intensity of taste and odor. Let us suppose the raw water sample was A. In this, you keep on adding you keep on adding basically distilled water till the time no taste and odor comes. So that is known as, that will be giving you the threshold odor number. In the short, you write it as A plus B by A. Now what is A? A is the volume of raw water sample. And B will be the volume of distilled water. Okay. Now, keep on adding it till the time you don't get any taste. But ma'am, this is for 1 liters, 2 liters. Now, how we will do it practically? So practically, when you go it into to measure it for large million liters of water, you do it by the equipment which is known as osmoscope. Now, what is osmoscope and all? Now, I'll tell you. Wait. I'll add one more slide. Okay. Now see. Listen to it very carefully. Try to understand in one go. कहाँ गया pen? I'm doing with free hands, so not even a single straight line is there. So understand my feelings, not the lines. Huh? A is volume of raw water sample. Ma'am, this always A will be the volume of raw water sample. Yes, beta. B will be the volume of distilled water which you are adding, and A plus B should be always 200 ml. Ma'am, who told you? This is as per code. So it's not me or you who have decided it. It's as per the code. Okay. Now what will happen? First, what I did was, I'll take 20 ml. 20 ml raw water I'm adding. How much distilled water should I add so that it becomes 200 ml? How much distilled water should I add? $180 ml. Can you tell me how much will be the dilution factor? 200 by 20. 10. Correct? Now what will happen? 180 I will add 10 is final volume divided by the initial volume of test sample. Now out of you, Sahil, Sogata, Divya, Samre, Prince, Jeetu, Vignesh, Sophie, Bhaskar and one more. एक और नाम ऊपर से ले लेती हूँ, Vinay. 10 people I will call you that come. Okay, you come. And everybody, there is an equipment by which, see, obviously I won't tell you to taste it. You will say, ma'am, you want us to die. So obviously I won't make you to taste it. So 10 people I will call it out. And there will be an osmoscope which will be there. And I'll tell each one of you to basically smell it. So you have to put your nose near to it and you need to smell it. Okay. Out of the 10 names which I have taken, even a single person says that, ma'am, smell is coming. I have to change it. Ma'am, who told you to take 10 only? Because in the code it have written 10 sets of noses. 10 sets of noses means 10 people will be there and who will be smelling it. If even a single person says that smell is coming, change the dilution. That means you need to add more amount of water. So let us suppose I'm just taking here 10 ml. So here I need to add 190 ml. So now the dilution factor will become how much? 200 by 10. Again, I will tell you to, I'll call these 10 people and tell you to smell it. If everybody says that no ma'am, no smell is coming, so I will do the treatment proportionate to this. Got it? And the equipment which is used for measuring or basically smelling it, that is known as osmoscope. Is it clear? That is known as osmoscope. So 10 sets of noses are there. 10 sets of noses are there which will be doing what? Which will be smelling the water. Which will be smelling the water. Clear everybody? Clear? So this one is for taste and odor. Now talking about acceptable limit and cause for rejection limit. Generally you say 1 TON is the acceptable limit and 3 TON is the cause for rejection limit. But if you check out the code, that is IS 10500-2012, they have written what? Agreeable. Means nahi hona chahiye. Agreeable. See, if you are thirsty also and I'm giving you a water and that smell is coming, you'll be like, it's okay ma'am. No, I'm not feeling that much thirsty. It's okay. Until and unless from 10 days you haven't drank water, in that case you will drink anything. That is an exceptional case. But otherwise, under normal conditions, you will not allow any type of taste and odor. Correct? So this is taste and odor. Last physical parameter is temperature. If I put your hand in a hot water, of course you will feel that sensation. Okay, so yes, temperature will affect the chemical and biological activity. Generally, when you increase the temperature by 10 degrees Celsius, the biological activities doubles. We say that 10 to 20 degree, 25 degrees Celsius is the temperature which we want. And generally, we want that temperature should be in this range for proper functioning. Correct? So this is temperature, and now we will move to chemical water quality parameters. Chemical water quality parameters in this dissolved solids we will start. Till here, any doubts? First tell me, otherwise we will move towards further. Any doubts? Okay, now. Chemical water quality parameters, already I told you about dissolved solids, how to measure it. When you pour it through the suspended solids filter paper, whatever is there is dissolved solids. You burn it at 104 degrees Celsius, 24 hours, you will get dissolved solids. Now, there is one more approximate method which you should know, that is measuring the electrical conductivity. Now, listen to me very carefully. Cations are positively charged ions. Anions are negatively charged ions. Cathode is positive. Anode is negative. Okay. Now, when the water sample in which you want to measure the dissolved solids will be poured into this, electrodes and all are there. In the water, positive ions will be there, negative ions will also be there. So these positive ions will go and deposit on the negatively charged electrode. This negative ions will go and deposit on the positively charged electrode. During the movement, potential will be there. So technically you are not measuring the dissolved solids, you are measuring the potential, and that potential is calibrated to dissolved solids. So technically you are measuring the electrical resistivity, or you can say conductivity. So you measured the electrical conductivity in micromole per centimeter and multiply by 0.65, you will get total dissolved solids. Now first doubt you will have, ma'am, why you have specified the temperature? Because as the temperature rises, the electrical conductivity will change. Ma'am, why you have put this 0.65? 0.65 is a factor which is based on observation. Why? Because total dissolved solids is same. Okay, even if you're changing the temperature, total dissolved solids is same. But the electrical conductivity will not be the same, na? Because as you change the temperature, electrical conductivity will change. And if the electrical conductivity will change, you will get the wrong value of total dissolved solids. Technically, in 1 liter, whether you keep it at 25 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, the dissolved solid should be the same. But electrical conductivity is not the same. And that is the reason you have to specify first the temperature and multiply by the factor. So that at any temperature you take, the factor will change such that you get the same value of total dissolved solids. Okay, but this is an approximate method. Ma'am, why? If I'll explain you with the help of Venn diagrams, it measures only the ions. It measures only the ions. Now, all ions are dissolved solids, but not all dissolved solids are ions. So, this is the measurement which is done by the electrical conductivity. Only ionic form is being measured. So, if you say that is it measuring the whole dissolved solids? No, it is not. That is why it is an approximate. Got it? Clear, everybody? Okay. Now, next we will talk about pH. pH is minus log base 10 of hydrogen ion concentration in moles per liter. Now, if pH is more, that means alkalinity will be more, or basically not alkalinity, you call it here basicity. Basicity will be more. If pH is less, you will have acidity more. So, corrosion will be there if pH is less. And if pH is more, that means hydroxides will be more. If hydroxide is more, let us suppose aluminium is there and in water hydroxide is there, it will form aluminium hydroxide. If iron is there, it will form ferric hydroxide. So what will happen? They will deposit in the pipeline. So if a pipeline is there, they will deposit in the pipeline. And if they get deposit in the pipeline, what will happen? Instead of this much area, now the area available is less. So I will say that the discharge carrying capacity will decrease. Discharge carrying capacity of pipeline will decrease. Correct? Now similarly, if you want to calculate POH, this will be minus log base 10 OH minus, and here also OH minus hydroxyl ion concentration will be in moles per liter. You know pH 1 to 7, basically 0 to 7 it is acidic, 7 to 14 it is basic. Now two important relationships which you should know is pH plus POH is equal to 40 and H plus into OH minus is equal to 10 raised to power minus 14. You will solve any questions which has been asked. Now listen to me, very, very important, because question from this topic has been asked. If they say hydrogen ion concentration is varying linearly, okay, and one thing they can say hydrogen ion concentration is varying parabolically. Let us suppose at time is equal to 0, hydrogen ion concentration is H plus naught. At t is equal to 24 hours, hydrogen ion concentration is H plus naught 24. And it is telling you hydrogen ion concentration is varying linearly. This word is written. That means H plus ion mean will be at 0th hour at 24 hour divided by 2. If it is telling it is varying parabolically, ये सही लिखा है? This one is the one. Parabolically. In the question in GATE, they have already asked for linear. Now they can ask for parabolic as well. So that's why I've told you for parabolic as well. Clear? Now, till here any doubts, guys? I'm just teaching, I'm asking you also. Is it clear? Is it clear? Haan ya na? Say yes or no. You are not there in front of me, so I have to ask you, right? Okay. Now we will solve one question for seeing how much it is clear to you. Now let us suppose if the pH is 9.25. Calculate how much is OH minus ion. This question I personally like it because here multiple concepts get clear. Now come on, answer this. I'll give you 4 options. You have to answer out of that and you have to be logically correct also. Don't, because it is a PYQ question, you should be not that you should just copy paste the answer and you should tell me. Okay. Moles per liter. I'm waiting for your answers, everybody. If in the question they write like this, millimoles per liter, don't think that they have made a typing mistake of just putting one more m. They literally mean it as millimoles per liter. Okay. Now it is 10 raised to power minus 4.75. Now I want the answer from this. This one question clears multiple concepts. H plus means hydrogen ion concentration. 0 I have written for 0th hour, 24 I have written and when you measured it after 24 hours. Okay. Okay. एक बार मैं B answer is wrong. Those who have said, now just wait for a minute. Parabolic is, let us suppose there was one question they have written. I've just told you the gist because this is a PYQ question. A sample of water was there. At 0 hour you measured it. It came out to be so and so pH. So with the help of pH you calculated H plus hydrogen ion concentration at 0 hour. After 24 hours the pH value got changed and it came out to be so and so. So after 24 hours you again measured hydrogen ion concentration. Calculate if the hydrogen ion concentration is varying parabolically, calculate the mean pH. They will answer like this. So for calculating the mean pH, here you should know the mean H plus. Got it, Saugata? So if in the question it is telling you it is varying parabolically. So this is the formula which you will use. Ma'am, from where does this formula came? This is not a empirical formula. By using area under the curves, you can derive this formula as well. Okay. So when till now they have asked linear. So it was linear is first and second divided by 2. But if they ask you parabolic, at 0 hour minus 2 by 3 at 0 hour minus 24th hour, what was the hydrogen ion concentration? Is it clear? Is it clear now, Saugata, and everybody else also? Okay. Now this question is the one. C, which is the answer. Now let me check it out. pH is given to you. Now what you did is, first thing which you have applied is pH plus POH is equal to 14. So POH will become how much? 14 minus 9.25. So I guess you got it from here 4.75 moles per liter. So from here you know POH is minus log base 10 OH minus ion. So from here OH minus ion was 10 raised to power minus 4.75 moles per liter. Okay, in the question also written, you are like, hooray, I got the correct answer. No, it is not written that. What it is written is millimoles. That means technically they have written it 10 raised to power minus 3. They have written this. Is it coming same? No. So this is wrong. This is wrong. Now you are left with two options. Okay, now you are left with two options. Now you know what? Now you know what? That this is in moles per liter. Molarity means number of moles present in 1 liter of the solution. Number of moles means given weight upon molecular weight per liter. Correct? Now, molarity they have given to me as 10 raised to power minus 4.75. I will multiply by molecular weight so that I can get given weight. Ma'am, why given weight? Because see, in the question they have given mg. So given weight. Oxygen is 16, hydrogen is 1. That is 17. It is in grams. 17 into 10 raised to power minus 4.75 grams per liter. Grams, if I want to convert it into milligrams, what I can do is, I can multiply by 10 raised to power 3. So it will become milligrams. So when you will solve it, you will get 0.302 mg per liter. So not all questions of pH are simple. You will get these type of questions as well. Clear everybody? Clear? So this is pH. I have made you solve question as well. Now, how can you forget alkalinity? Alkalinity, ability of water to neutralize acid. Ability of water to neutralize acid. पानी की ability कि वो acid को neutralize कर दे. But the question comes that how will water get that capability to neutralize acid? Basically, there will be ions in the water which will be capable of neutralizing hydronium ions. Now, what are those ions? Obviously, if it is neutralizing a positively charged ion, so obviously the alkalinity will be due to negatively charged ions. Correct. So there are n number of negatively charged ions which will neutralize the hydrogen ions, or you call it as hydronium ions. Now here you will say that alkalinity in water is due to carbonate ion. If it is there, you call it as carbonate alkalinity. If it is there due to bicarbonate ion, you call it as bicarbonate alkalinity. If it is due to hydroxyl ion, you call it as hydroxyl alkalinity, but you generally call it as caustic alkalinity. So now, if apart from that, ammonium ion is there, biborate ion is there, phosphate ion, there's n number of ions are there, but you don't consider them. Now, a very important thing, listen to me. Although I have taught you carbonate, bicarbonate, hydroxyl. Okay. Till now, never ever they have given in the question minor ions which imparts in alkalinity. If in the question in future, means let us suppose in this coming examination, they give you minor alkalinity, biborate or HPO42 minor, anything if they give you, okay, alkalinity. And if they haven't mentioned in the examination that neglect the minor ion concentration, you have to consider it. Because once they have done it for hardness, generally we always say that calcium, magnesium imparts hardness, calcium, magnesium impart hardness, but in that question they give an aluminium also. So similarly, I'm telling you carbonate, bicarbonate, caustic does that. But if in the question other type of alkalinity comes, and they haven't mentioned it, that ignore it, nothing they have mentioned, you have to take it. And specifically if it is an NAT question. Okay, so till now never ever they have asked, but in future if they do so, you should be prepared for it. Now, for all practical purposes, you ignore it, but for GATE, if they're giving you and they're telling you not to consider it, then don't consider it. Otherwise, you have to consider it. Okay, and don't worry, in GATE they tell you each and everything, so you don't have to say that ma'am they haven't told and all those things. They mention each and everything, so don't worry about it. Now, how do you measure alkalinity? I told you, see, bicarbonate is there, carbonate is there, caustic is there. Now just, I'll ask you one thing and then I'll tell you the concept of equivalent rate. Can you add dollar and rupees together? Can you add $3 and 30 rupees together? Yes or no? Just tell me this much. Yes or no? Can you add dollar and rupees together? Yes or no? Quick, quick, quick. No. You will say, ma'am, either convert dollar into rupees or rupees into dollar. Correct? You will say me this only, that if you want to add dollar and rupees, so either convert dollar into rupees or rupees into dollar and add it. Correct? Similarly here, HCO3 minus concentration, CO32 minus concentration, OH minus ions concentration, I cannot add it directly. I need to convert them into a common parameter. Correct? So now when I have to convert it into a common parameter, what I have to do is, I will take that parameter as calcium carbonate. And there are so many compounds. Why only calcium carbonate? No logic. Its molecular weight is 100. That is the logic. Easy for calculation. That's why you are taking it as 100. Okay. Now what you do is, there is one thing. You just remember this all throughout the environment, because this is very, 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 very important. How to make in 1 unit? Convert dollar into rupees or rupees into dollar. That one. Okay. Now, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. Okay, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. Now, next question comes, what do you mean by this gram equivalents? Okay, number of gram equivalents. See, if you will do the conversion each and time, either if you will convert bicarbonate into carbonates, carbonates into bicarbonates, this takes a lots of time. So we take calcium carbonate, that all the conversions will be based on calcium carbonate. Example, I can tell you one more thing. Guys, you have gone to the railway stations and all, you will see that whenever you pass through a train, that new, you can say city comes, that station comes, they write it there with that yellow color in that concrete block, with black it is written so and so station, samudra tal se upar, from mean sea level. Okay, every station all over India go, you will see that they write it as MSL. Why mean sea level? They could take any other datum point so that we can make it constant. Okay, datum can vary, you can take any datum, that doesn't harm you, but the thing is to make it common for everybody. Okay, we make like this. Got that? So that is the thing which is happening here. Now, here we will talk about, similarly here I want to make common. If HCO3 minus is there, CO32 minus is there, OH minus is there, ammonium ion comes, biborate comes, bisilicate comes, any ions comes, I will measure in terms of calcium carbonate. Okay. Now, number of gram equivalents kya hota? What is number of gram equivalents? This is given weight divided by equivalent weight. Now, what is equivalent weight? Equivalent weight is molecular weight divided by valency. What is valency? That is the combining power of an element. Example, if sodium chloride is there, this you already know, but for my satisfaction, I'm telling you. Sodium chloride, the atomic number is 11, that is 281. And here in chloride, the outermost electron is 7. So if sodium gives 1 electron and chlorine takes 1 electron, both of them will achieve the octet. So sodium is giving 1 electron and chlorine is taking 1 electron. Correct? So the valency will be how much? 1. So here the valency is 1. So here valency means the combining power of an element. So if you want to calculate gram equivalents, that is equal to given weight upon equivalent weight. This is the thing, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. That means 1 gram equivalent of bicarbonate is equal to 1 gram equivalent of carbonate is equal to 1 gram equivalent of OH minus. All over the universe it is valid. 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. Ma'am, how can you say this? Can you say this? You remember this N1V1 is equal to N2V2? In your 11th, 12th chemistry you have studied it. N is what? Normality. Number of gram equivalents present in 1 liter of the solution. Correct? And this volume is also in liters. This is for first one. Here also N2 is normality. Number of gram equivalents in 1 liter of the solution. And this volume is also there. Liters and liters will get cancelled out. Gram equivalents of 1 is equal to gram equivalents of 2. Hence I prove it also. So from here I can say 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. Got it? किसका वैलेंसी 2 होगा? भाई वैलेंसी 1 होगा सोडियम क्लोराइड का. कौन सी दुनिया में जी रहे हो? सोडियम एक ही देगा, आउटर मोस्ट देता है ताकि ऑक्टेट अचीव कर ले. और 1 + 1 नहीं, उसने एक दिया, उसी ने वो तो एक लिया ना, दोनों ने एक एक थोड़ी ना अलग अलग दिए. वैलेंसी 1 होगा. ओके, now what you will do is, whatever HCO3 minus is given to you, you will take that value, okay, divided by the equivalent weight. This will give you the equivalent weight of HCO3 minus. Now, this much will be the equivalent weight of calcium carbonate also. By the logic, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So, how much gram equivalents? This is the gram equivalents of HCO3 minus. So, this will be the gram equivalents of calcium carbonate as well, by the logic which I told you. Now, you will say, ma'am, I want to get it in mg per liter. I want to get it in grams per liter. I don't want this equivalent. So, if you want to get it in mg per liter and all, just multiply by the equivalent weight of calcium carbonate. That's it. This will give you the value in mg per liter or grams per liter. Now, very, very important, guys. Listen to me. Some cases in the examination, they have said milli-equivalents per liter. They have written like this, milli-equivalents per liter. What do you mean by this? Listen to me. Like, let us suppose for bicarbonate, they have given to you in milli-equivalents per liter. That means concentration of bicarbonate in mg per liter divided by the equivalent weight of bicarbonate. This is the meaning of it. Got it? That means they have directly given you this value. This means milliequivalents per liter. Always remember this is important. So if they have directly given you milliequivalents per liter, just multiply by the equivalent weight of calcium carbonate. Clear? Clear everybody? Clear everybody? Yes or no? Quick, quick, quick. Clear? Okay. Now, acceptable limit, as I told you, up to 200 mg per liter as calcium carbonate is acceptable. In case when no alternate source is available, up to 600 mg per liter you can allow. Okay. Now, next, if I'm coming to hardness, but before that, I'll tell you one more thing. If you talk about alkalinity, if in the question they have given only bicarbonate ion and they haven't given other things, don't take. Carbonate not mentioned, don't take. Hydroxyl not mentioned, don't take. If they're telling you to take, now see, initially I'll tell you one more important thing. The question has been asked in GATE 2022. See, if you see the past 20-25 years papers, that time there were some things which you need to assume. Now, let us suppose in that question H plus was there. Okay. Other compounds like calcium, magnesium and all were there, and it was only HCO3 minus mentioned. Now you will say that, ma'am, you told to take only bicarbonate ion concentration. But in the question, if pH is given, let us suppose not even H plus is given, pH is given. So from pH I can calculate POH. From POH I can get OH minus. So should I take OH minus or not? Because that is a matter of ambiguity. Because bicarbonate is there, but it's not hydroxyl is there. Indirectly it is there. You can calculate it. So in the question they will mention you whether to take the impact of it or whether not to take the impact. Okay, so they will tell you whether to take the impact of it, neglect the concentration of H plus ions. If they will say, that means you have to neglect it. And if it is not, that means you have to consider. Clear? So this you have to make sure. One more thing. There is a concept known as negative alkalinity. Now, technically, if you'll ask me, there is nothing like negative alkalinity. That is a hypothetical concept. Example. Let us suppose in water, you have 10 units of alkalinity. Okay. And in that, 3 units of H plus ions was present. So, what you will say? Out of 10 units, 3 units will neutralize with H plus ion and 7 units of alkalinity will be left? No, you will directly say that the alkalinity of water is 7 units. Okay, example. So now what you did was you did 10 minus 7 to calculate. This 7 was due to H plus ions. So you say that the one which doesn't impart alkalinity in water, it imparts negative alkalinity. So this is that negative alkalinity. Clear? This is the thing which you should know. Okay. Now let's talk about hardness. Important hardness for us. 2020-21. They have asked questions regarding color from hardness. Now hardness is in water. Now this is very, 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 very important. I keep on saying to students, I don't know in which zone they are. Mark my words, at least till your GATE examinations. Hardness in water is not due to calcium and magnesium. Hardness in water is due to multivalent cations. Multivalent cations. Mark my words, open your ears, listen to me. Multivalent means valency more than 1. Cations means positively charged ions. Okay. So now, listen to me very carefully. Hardness in water is due to multivalent cations. Those ions whose valency is more than 1. Okay, I'm talking about those. Now, it has been found that practically calcium and magnesium are the predominant one. But it doesn't mean that aluminium or other ions will not impart hardness. They will impart hardness. Correct? So always remember that. Until and unless it is telling you to neglect other ions, you will then only you will neglect, otherwise you won't. Okay, so hardness in water is due to multivalent cations. However, calcium and magnesium are the ones which predominate. Now, here you have two types of hardness. Temporary hardness, this you already know, and carbonate hardness. Short, we call it CH. Other hardness is permanent hardness, or you call it as non-carbonate hardness. Now, temporary hardness is the one which is due to carbonates and bicarbonates of multivalent cations. Of multivalent cations. Okay, like calcium bicarbonate, magnesium bicarbonate, calcium, magnesium carbonate. These are temporary hardness. Why? See, again hardness is due to multivalent cation only. But in the suffix, prefix is pehle, suffix is baad mein. In the suffix, if carbonate and bicarbonate is there, you will call it as temporary hardness. If in the suffix you have chlorides, sulfates or nitrates, you will call it as permanent hardness. Why this name permanent and this one is given to you? Why this name like permanent and temporary is given to you? Because temporary is something which can be removed easily by the boiling, or you can add lime, it will be removed. If you talk about permanent, if you just boil it or heat it or add lime, it will not be removed. You have to use zeolite method, special techniques you have to apply for the removal of hardness. Okay, that's why it is permanent in nature. While temporary, just boil the sample, it will be removed. Got it? So that is temporary hardness. Now, here you should know this. Here reactions are also given. You heat it, it will be removed, or you add lime, it will be removed. Now, the one thing is non-carbonate hardness, you cannot calculate directly. So what you do is, total hardness is carbonate hardness plus non-carbonate hardness. Carbonate hardness, there is no formula for this. You will calculate total hardness and you will calculate alkalinity. Whatever is minimum, it will become total hardness. From here, you will get non-carbonate hardness as total hardness minus carbonate hardness. Clear? This is the formula which you will be using. Got it? Soda lime method will also not give you 100% removal, but lime soda method, soda lime, we call it as lime soda method. They removes permanent hardness, but the efficiency is not 100%. While demineralization process, zeolite process, they remove 100% of the hardness. Correct? And now if you talk it about, here also you express in terms of calcium carbonate, because otherwise for conversion it becomes difficult. So whatever is the concentration of calcium in mg per liter, you will divide it by the equivalent weight of it. Similarly, whatever is the concentration of magnesium in mg per liter, you will divide it by the equivalent weight of it, multiply by the equivalent weight of calcium carbonate, you will get the hardness. Okay, you will get the hardness. Clear? साफ नहीं दिख रहा है? मुझे तो साफ दिख रहा है. Everybody is seeing it clearly now? Fine. So this is the hardness which is there. Now, यहाँ तक, is it visible properly? बीच में आके, is it visible properly, right, Divya? Chalo. Now, if you talk about the limits, acceptable limit, cause for rejection limit, exactly same as like you had it for alkalinity. Exactly same like you had it for alkalinity. Same. Now, we'll talk about the hardness measurement. Now, listen to me. 2 minutes it is there. This is the burette color change. They have already asked. Let us suppose this is 100 ml burette. Here you have added here the titrant. Titrant is a chemical which reacts with unknown parameters present in the water sample. This is the water sample in which I need to find hardness. Let us suppose I need to find calcium, magnesium. Before starting the experiment, I will add EBT, which is iriochrome black tea. The moment I add EBT in water, I haven't started the experiment, it becomes wine red. So the color of wine, you might have seen it. So wine red color. In chemistry, we enhance the color by saying all these things. So wine red. Okay. Now in this, what you will do is, now you will open the knob and you will do what? You will do what? EDTA will start to fall into this water sample. Just mix it like this. Essay. Stir it. No, not even stir it. Just mix it like this when it is falling out. So that whatever EDTA is coming, it is getting completely mixed. Now what will happen is, eventually this complex of EBT and calcium magnesium will break and EDTA calcium magnesium will come. So the color of wine red starts to break and this is colorless in nature while EBT is blue black in color. So technically the color changes from wine red to blue black because EBT is separate now. So in water you will get this blue black color. The moment you get this blue black color, you will switch off, basically you will turn off the knob of the burette and you will check it out how much volume of EDTA is being used. Let us suppose the reading is 100 minus V. That means V ml of titrant is used. V ml of titrant is used. Got it? So how much equivalents of titrant is used, that much alkalinity will be there. So you will get that much amount of hardness will be there. So you will get the hardness, gram equivalents of hardness, multiply with the equivalent weight of calcium carbonate, you will directly get the answer. So this is the manner in which you will calculate the hardness in the laboratory. The titrant which you use, it is EDTA, ethylene diamine tetraacetic acid. The indicators which you use, that is EBT, that is ideochrome black tea. Clear? Clear everybody? Now, I'll do one question for you guys, so that will be better. Clear ho gaya na? Chalo. Let's do one question, simple questions. Let's do and calculate the hardness. Sodium 30 mg per liter. Calcium I will take it as 60 mg per liter. Magnesium I will take it as 36 mg per liter. Okay. They are asking you to calculate total hardness and non-carbonate hardness. Come on guys, quickly. Let's sum it up. Calculate the total hardness and this one hardness. Tick, 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 tick. Quick. Calculate. How much is clear? Let's check it out. See, I told you, when you want to calculate total hardness, you will see only calcium and magnesium. Why? Because first you will check it out who others multivalent cations is present. Other multivalent cations is present? No. Only calcium and magnesium is present. So 60 mg per liter is for calcium divided by equivalent weight of calcium. Equivalent weight is molecular weight by valency. Molecular weight of calcium is 40. Valency is 2. Plus equivalent weight of magnesium 36. Here equivalent weight 24 is the molecular weight, valency is 2. So 24 divided by 2 is 12 into 50. Because equivalent weight of calcium carbonate is 50, molecular weight 100, valency 2. So from here if you calculate, you will get the value of total hardness in mg per liter as calcium carbonate. How much you are getting? How much you are getting the total hardness? Come on guys, calculate. 300 you are getting. Total hardness you are telling me? Okay. Similarly, for calculating carbonate hardness, I need alkalinity. Alkalinity here is due to only bicarbonate, which is given to me as how much? 61. And bicarbonate is also how much? ये तो 1 mg आ रहा है क्या इससे तो? कैसे? तो 61 हो जाएगा. तो 1 mg per liter alkalinity आ जाएगा. टिक. So this will be 61 into 50. So alkalinity will be 50 mg per liter as calcium carbonate. Okay. So minimum of total hardness and alkalinity. What is their carbonate hardness? So carbonate hardness becomes 50. Total hardness is 300. So 300 minus 50 is 250. So 250 will be the answer. Got it? For non-carbonate hardness. Acceptable limit, cause for rejection limit, already told to you. Okay. Now the one is chloride content. Chloride, if you ask me, present in water is very less. If it is present in more amount, that means that water is polluted. Polluted due to what? Polluted due to industrial sewage, polluted due to industrial sewage, or it is basically polluted due to any sort of industrial waste or sewage. Okay, now how can you determine that? This has been asked in many examinations. The titrant which you use, that is silver nitrate. Chalo. So let's talk it about. AgNO3. This is the water sample in which you want to find chloride. Now see, before starting the experiment, you will add K2CrO4. You will add K2Cr2O4. You haven't started the experiment, right? Huh? You added it. Nothing happened. It remained as it is color. Now here you have AgNO3, silver nitrate. Now what will happen? You will open the knob. AgNO3 will start to come. AgNO3 will start to come. It will react with chloride. And this you might have done it in your first year also. The whole water become color whitish, white. The exact whole water becomes white precipitate. After that means the whole chloride is exhausted. Exhausted means what, ma'am? It has reacted with silver nitrate. Now, even if a single drop of nitrate falls onto the water, chloride is not there. Now, this silver nitrate will react with K2CrO4 and it will form Ag2CrO4. So, you will see, imagine in that white you are seeing patches of red. So, immediately if it happens, you will close the knob and you will measure how much volume of titrant is used. Initially here it is 100, here it is 100 minus V. So V ml of titrant is used. So how much gram equivalents of silver nitrate used? That much gram equivalents of chloride is present. And if you want to remove this equivalent, multiply by the equivalent weight of chloride. Okay. So it is like in that white precipitate, when you see reddish brown dot, you will close it. Now you can ask me one thing, ma'am, K2CrO4 was initially also present now. So why first AgNO3 reacted with chloride and afterwards it reacted with K2CrO4? It should have reacted before also. Affinity, attraction. Okay, पहला जो सबसे अच्छा उससे ज्यादा attraction होगा. उसके बाद second option से थोड़ा कम attraction. फिर next option से थोड़ा कम attraction. Correct? So it's like based on attractive reactivity series. AgNO3 will first react with chloride. Okay, after when chloride is gone, चली गई वो, तो उसके बाद जो next आएगी उससे react करेगा. So next is what? K2CrO4. So it will react with that. Clear? So this is the thing. Talking about the limits, up to 200 mg per liter is allowed. In case when no alternate source is available, you can exceed up to 1000 mg per liter. धोखा क्या, बेचारा react कर रहा है अपने हिसाब से. अब आपको भी बोलेंगे प्रिंस तो पहले तो हीरोइन ही पसंद आएगी ना, फिर बाद में नॉर्मल लड़की. तो ये चीज बेचारा सिल्वर नाइट्रेट कर रहा है, तो प्रॉब्लम क्या हो रही है? ठीक है, चलो क्लियर. नाउ टॉकिंग अबाउट नाइट्रोजन कंटेंट. ये नाइट्रोजन ही और फ्लोराइड ही बचा ना, फिर बायोलॉजिकल. ओके, nitrogen, if I talk it about, of course, if it is there, like chloride, if it is present in excess, it indicates presence of organic matter. Similarly, if nitrogen is present, it will indicate the presence of organic matter. If free ammonia is there, it indicates that past pollution has happened. And if organic ammonia is there, it will tell you that decomposition अभी start नहीं हुआ है. Nitrite is decomposition is going on right now. And nitrate is when complete decomposition of organic matter has happened. Now this is not the correct units right now. I have written it so that I can cancel it out. This was the old units. Guys, IS 105-2012 में amendments हुए, changes हुए. So now they haven't given free ammonia and organic ammonia. Organic ammonia you also call it as albuminoid nitrogen. Okay, so now they haven't given separate units for both of them. Instead, they have written total ammonia. Total ammonia, they means that it is free ammonia plus organic ammonia. Can anybody tell me the updated value? Come on. Nitrite, already the decomposition is going on. So decomposition is going on. That means microorganisms is there. Because of course, who will do the decomposition of organic matter? Microorganisms. So nitrite is nil. You cannot allow any nitrate. Nitrate, when you feel like sneezing and you don't sneeze, na? Correct, Shravan. So total, nowadays you don't use this limit now that they have given you total. Guys, if in the examination comes, don't write the old value. It has been amended. Rather than giving you the individual values, now they have given you the total value of it. Kindly remember this. Okay, that's why I've written it here. Nitrite, because decomposition is going on, nil. Nitrate, if I talk it about, here the decomposition has been completed. Complete decomposition of organic matter. Up to 45 mg per liter you will allow. But if it is more than 45 mg per liter, it will lead to methhemoglobomania, that is blue baby disease, that is blue baby syndrome. So if infants or pregnant ladies consume it, what will happen? They have certain enzymes which will convert this nitrate to nitrite. And nitrite is dangerous because nitrite will react with hemoglobin in your body and it will make the color of the blood as blue. That's why you call it as blue baby disease. Call it blue baby syndrome. आपको कुछ नहीं होगा. This is for infants. Got that? चलिए. Okay, now fluoride content. Fluoride is a very tricky person, just like girls. अब सब लड़के खुश हो जाएंगे, है ना? 1 to 1.5. ज़्यादा 1.5 से then also there is a problem. Less than 1, then also there is a problem. Up to 1 mg per liter, good. Good, helps in preventing dental cavities. Prevent dental cavities. मतलब पर जरूरत भी है फ्लोराइड की, ना हो तो भी दिक्कत और ज्यादा हो तो भी दिक्कत. ठीक है? So need of fluoride is thereby. If it is not there, then also it is a problem, and if it is present in more amount, then also there is a problem. Prevents dental cavities and helps in permanent growth of teeth. Okay, so that's why you have seen that when infants are there and all, particularly for them, fluoridized toothpaste is there. Even when you guys also use fluoridized toothpaste. The reason is your teeth needs fluoride. Okay, that is the reason. If you check out this one, ingredients, the composition of the toothpaste. Some toothpaste they have mentioned, some are fluoride free. Some there is fluoridized toothpaste. Generally, who have cavities, doctor advise them to use fluoridized toothpaste. Okay, because it helps in permanent, हमारे लिए तो permanent growth of teeth for infants. For us, for preventing dental cavities. Helps in permanent growth of teeth. Then, if it is more than 1.5 mg per liter, it will lead to fluorosis. It will lead to fluorosis. Basically, the brown precipitate will deposit, decolorization of teeth will occur. So that is 1.5 mg per liter, it will lead to fluorosis. And if it is more than 5 mg per liter, it will lead to deformation of bones. जिसको आप बोल देते हो bone fluorosis. उसका रीजन है why deformation of bones, because calcium की जगह magnesium deposit हो जाता है. Instead of calcium phosphate in your body, fluoride will be there. Okay, and that is the reason this deformation will happen. So up to 5 mg per liter से ज़्यादा if it is there, it will lead to deformation of bones, and that disease is known as bone fluorosis. Got it? Correct, Dr. Strange. Okay. Now, acceptable limit, I told you, up to 1 mg per liter. Cause for rejection limit, 1.5 mg per liter. Any doubt still here? Now, we will move towards the last topic of biological water quality parameter, that is NPN. Come on, quick. Prince, Ogata, Shravan, Anwar, anybody? Okay. Now what you will do, this is very important. Practically this test is obsoleted, but if you check out the previous year's question papers, you will see sometimes consecutively they have asked questions from MPN, sometimes alternate years they have asked questions from MPN. They have asked questions from MPN in 2021 also, they have asked it in 2022 also. Okay, so just check it out. This is important. Now, MPN is most probable number. You call it as, this is a multiple tube fermentation test also. Now, what happens here is basically you take different test tubes. Now, but But different test tubes you take, but the capacity is 10 ml only. So ma'am, different test tubes I'm taking, but the capacity is 10 ml, what you are trying to say. Now listen to me very carefully. See, you are taking different test tubes. The capacity is 10 ml, but in that the test sample value is different. Now let me add a slide so that I can draw it and tell you. Just a minute, just a sec. Now listen to me very carefully, guys. This is damn important. Okay. We are taking multiple tubes. Okay. This is one tube. This is one tube. I'm taking 5 tubes. Huh? 3, 4, 5. Each and everybody has 10 ml capacity. In first, if I'm adding 10 ml as the test sample, means whole 10 ml I'm adding test sample. In this, I'm adding 1 ml test sample. That means 9 ml will be pure water. Here I'm adding 0.1 ml test sample, 9.9 ml will be pure water. Here I'm adding 0.01 ml test sample, so 9.99 ml will be pure water. Here I'm adding 0.001 ml test sample, so 9.999 ml will be pure water. Correct? Now what will happen is you will say, ma'am, how will you will distinguish? In everything we will having what? If everything what you are having 10 ml is the amount. So guys, whenever you have gone for blood test, every other person's blood test also they collect in that same volume of the test tubes, or you can say that basic small test tubes are there, in that they collect it, correct? But then how they distinguish that it is my blood sample, or is it Divya's blood sample, or Prince's blood sample, or Anwar's blood sample? You might have checked that they put a sticker in which they write your name and all. Okay, so that they can bifurcate, because everybody's color of the blood is same, red only. Intensity of color may change, but it is red only. Similarly here, every have the same capacity. Now how can you check it out? How can you label it? I'll put it here 10, here 1, here 0.1, here 0.01, here 0.001. It means that the total volume is 10 ml only. Here this means 1 ml test sample will be there. Here 0.1 ml test sample will be there. Here 0.01 ml test sample will be there. Here 0.001 ml test sample. This is the meaning of it. Got it? So for distinguish it, you do like this. Now listen to me. In the first step, now code has told that you will take five sets of each, 5 tubes of 0.01, 5 tubes of 0.001 ml, and so on. In the first step, you will add lactose broth. Now what is this lactose broth? Listen to me. Generally, in the laboratory, we don't test for pathogens. We test for coliforms. Why? Testing of pathogens is expensive, tedious, and time consuming. So instead of testing for pathogens, we test for coliforms, because which is very easy as compared to testing of pathogens, and presence or absence of coliforms indicate presence or absence of pathogens. Okay, so instead of day to day when you are testing the water, you will test for the presence of coliforms. Now you will say, ma'am, but in this water coliforms will be also present and pathogens will be also present, right? Of course, correct. But you will supply water only to the coliforms. The one which you will supply, basically not water, you can say nutrient, a food. You will supply food only to the coliforms. So who will get food? He will survive. Who will not get food? He'll die. So here you will take the sample and you will put lactose broth. This is the food for coliforms. So they will reproduce and they will liberate gases. If the gas is liberated, that test is positive. That means coliform is present. Ma'am, if no gas is produced, that means that test is in that test tubes, coliforms are not present. After 24 to 48 hours, you check it out whether gas is produced, and if it is not produced, you further incubate it for 24 hours. Ma'am, if then also the gas is not produced, leave it. In that test tube, coliforms are not present. Okay, after that, in the tubes in which coliforms were present, in which gases were there, you will take out that and you will add lactose green bile broth. This lactose green bile broth will be the second step which you do it. And if the gases are being released again, that means in those test tubes, what was there? Coliform was present. You will count the number of tubes. Let us suppose in 5 tubes, in 3 you were getting gases. Here in 4 you were getting gases. Here 2 you were getting gases. Here 1 you were getting gases. Here you will getting no gases in any of the test tubes. So you will count it out. Okay, but ma'am, counting the gases, how it will give me MPN number? Now listen to me, it is very, 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 very important. Code said that you will take the sets. Sets like, I will take one set of 10 ml, 1 ml, 0.1 ml. Next set I will take of 1 ml, 0.1 ml, 0.01 ml. Next set I will take of 0.1 ml, 0.01 ml, 0.001 ml. Now, why you are moving in sequence? Why can't you take 10.1, 0.001? Because code told that adjacent, it should not be more than 10 times the dilution. Check it out. 10 divided by 1, 10. 1 divided by 0.1, it is 10. So the difference should not be more than 10 times. Who told this? Code told this. Now listen to me, very important. If here you are getting all the tubes positive, like here you were getting 3, 4, 2. 3, 4, 2. Then you were getting 4, 2, 1. Okay, and here you were getting 2, 1, 0. Code told that if in all the sets you are getting positive results, like here you are getting negative results also, like let me take it this also as positive so that once I can explain you one logic. Code told that if in all the tubes you are getting positive result, you will select that set whose dilution is minimum. You will select that test whose dilution is minimum. गलत, बहुत गलत. मैक्सिमम, दैट मीन्स जिसमें ज्यादा पानी ऐड है. डाइजर पानी ऐड किस में है? सेट 1 और सेट 3. इन विच मोर अमाउंट ऑफ वाटर इज देयर? सेट 1, सेट 3, सेट 2. Come on guys. If in all the sets you are getting positive result, code told to take that value in which the dilution is maximum. सबसे ज्यादा पानी किस में डाला है? Set 3 में डाला है. So you will take set 3, that is 2, 1, 2. Example, 2, 1, 2 जो टेबल होता है for MPN standard table is 10 ml, 1 ml, 0.1 ml. The standard table which is given officially, that is for 10 ml, 1 ml, 0.1 ml. So the standard table 212, let us suppose it is coming 40. So you will write MPN as 40, which will be wrong. Why? Why? Because the table is given for 10, 1.1 ml. The set which you selected is 0.1, 0.01, 0.001 ml. So as compared to 10 ml, 0.1 ml is how many times diluted? 100 times diluted. So you will multiply by 100. So you will get it here how much? 4,000. Got it. Ma'am, out of this 3, if in 2 test tubes, 2 sets you were getting 0, you will select the set in which all the tubes are positive. Correct? You will select the test in which all the tubes are positive. Now check it out. Check it out. In this question, this is a question, negative people and negative test. We don't want. So here, we don't want to look at that right now. So in 1 ml, 4 tubes were positive. In 0.1 ml, 3 test tubes were positive. In 0.01 ml, 1 test tubes was positive. It is asking you to calculate what? MPN. Now see, the positive combination is 431. In the question, they have given the MPN value as table 33. Now in the options also you will get 33, but it will be wrong. Why? Because the test you conducted was on 1.1 and 0.01 ml. And the table is given is for 10, 1.1 ml. So as compared to 1 ml, 0.1 ml, 0.01 ml, how many times dilution is there, guys? 10 divided by 1 or 1 divided by 0.1 or 0.1 divided by 0.01. Do it anything. You will find 10 times diluted. So multiply by 10. Clear? Clear, everybody? So this completes your, and I'll give you one more thing. Now you will save 10 1.1. This is arbitrary I'm taking. Which set I will select? Set 1, 2, 3. Which set I will select? What again I have to tell Sophie? Thank you, Shreya Jain. Which set I will select? 1. Because in both of this question has been, there was one answer 11 into 10 raised to power 4 something, your BYJU'S. So that was based on this logic. They have given 2 sets. Okay, so you will select set 1. Correct? Okay. Now, Sophie, this question actually 431 positive test results corresponding to an MPN was given 33. Okay, but the test was conducted on 1 ml, 0.1 ml and 0.01 ml sample, and the table is given for 10 ml, 1 ml and 0.1 ml. So how many times it is diluted? The sample which you chose as compared to the standard sample, how many times it is diluted? 10 times. How I checked it out? I divided 10 by 1 or corresponding I divided 1 by 0.1 and then checked it out, it is 10 times diluted. So here you will multiply by 10. That is what I said. Okay. Now, fine. So guys, with this all sets having 0. That one also. Okay. Set 1, 10 ml, 1 ml, 0.1, 1 ml, 0.1 ml, 0.01. Set 2. Today what has happened to this? 0.1 ml, 0.01 ml, 320, 204, 042. Correct. Yes, I will make it that one. Now this one guys. If all 3 sets are given to you, in this all you are getting 0, in which all you are getting 0. So what will happen is, here first of all you have to check out in which set you are getting second dilution as positive. You are getting second dilution as positive. Okay, Abhinav sir is there. Yes guys, tomorrow I was to show you this slide. First let me complete this chapter. Tomorrow sir will be taking Geotech Marathon at 10 a.m. So be present there tomorrow as well. And good afternoon sir. Now, guys, these 3 sets are given to you, and in this, all the sets you are getting what? You are getting 1, 0. That means no results were produced, no gases was being produced. So first you will check it out in which second dilution is positive. It is positive second dilution. This one, this one, this one. Here it is 0. Neglected. So, ma'am, but set 1 also second dilution positive. Set 3 also second dilution positive. So now what you will do is, you will select that set in which dilution is minimum. Initially when all were positive, you selected that set in which dilution was maximum. Here, when you are getting 0 in all the sets, first you will check it out in which one second dilution is positive. If there are more than one sets in which dilution is positive, you will select that set in which dilution is minimum. In which one it is minimum? First. Correct. Got it? So corresponding to 320, you will get the MPN. Got it? Fine. So with this, we have completed the biological water quality parameters, and sir will be taking tomorrow Geotech Marathon for you guys. And now we will be starting with the 3rd chapter, that is treatment of water. So done and dusted, this one completed, this one completed. And now we will move towards treatment of raw water. Shall we? कोड ने बोला है सेकेंड डाइल्यूशन वाला रीजन मैंने आई हैवंट टोल्ड यू दिस इज रिटन इन द कोड आई एम टेलिंग यू व्हाट कोड हैज सेड clear shall we start it why we select second dilution but that what I'm telling you na that it's not me who have selected this is as per the code has told this. So maximum, minimum, everything, it's not me who has told this. This is as per the code. Codal provisions है. Clear? Okay. 5 minutes break लोगे कि फिर lunch break ही लोगे? You guys told that at 2 p.m. you will take break. After this chapter, lunch break. If table is not present, then we use Thomas equation. 2 p.m. ना अभी पढ़ लें यार मेरे को पोल करते नहीं आता this chapter will take a lot of amount of time because sedimentation, filtration, disinfection and I have to solve questions also. ये देखो ये क्वेश्चंस भी हैं MSQ क्वेश्चंस आई हैव केप्ट हियर देन आई हैव क्वेश्चंस में टाइम लगेगा फिल्ट्रेशन भी है फिर फिल्ट्रेशन में भी क्वेश्चंस है फिर डिसइंफेक्शन में भी क्वेश्चंस है दिस चैप्टर विल टेक नॉट मोर देन 1.5 2 hours 1.5 hours दिस विल टेक क्या करना है ठीक है Okay, what I can do is we shall do it till 2 p.m. After that, we जितना भी complete होता है till that how much is completed. After that, we will take a break. Whatever you say. What you say, Sophie? Everybody, let's do it till 2 p.m. After that, we'll take a break of half an hour. Or you want break now? Is it okay, Sophie? Everybody? 2 p.m. तक करते then 2 p.m. to 2:30 we'll take a break. अपने मम्मा के साथ हो तो then tell to make food for you guys. हाँ चलो let's see. Okay, it's 1:15. Let's take a target that at least sedimentation will complete. Let's take it out. Okay, so now we have checked the quality of water and based on that we will do the treatment. So treatment, these are the procedures. This is the chronology which we will follow it step by step, one by one you have to do it. Okay, so first we will go for screening. Screening is done for the removal of large suspended solids or you can say large floating matter. So the debris and all whatever is floating, for the removal of that what we will go for screening for removal of large suspended solids. Okay, now this screening you will see it in wastewater also. Both are same, only difference is here in raw water you have 2 types of screens, in wastewater you will have 3 types of screens. Screenings, you have 2 types here. You have coarse screens and fine screens. Okay. Now, what are coarse screens? Basically, you will see these are like this. They have 20 to 25 mm is the dia and the spacing between the two diameter bars is maintained 25 to 100 mm. Okay, generally you place these bars at an inclination. The reason for placing these bars at an inclination so that more area is available so that the suspended solids large floating matters can deposit. But you know, whenever there is a relative motion between two things, what comes into action? Friction comes into action. So when the water is passing through the screens, what will happen is the water will be offered resistance by these bars. These bars will not allow the water to move. Because of that, water has to lose energy. So there will be head loss. So the formula for head loss is given by K by 2G V square minus U square, where V is the velocity which is passing through the screens and u is the velocity present above the screen, which you call it as velocity of approach also. K is a constant which depends upon the material of the screen, and if nothing is given, you will take k by 2g as 0.0729. So V is the velocity through the screens, U is the velocity of approach by which you can calculate head loss. Till now in GATE, they haven't asked any formula from these questions, but they can ask you because it is there in your syllabus. Talking about the inclination, generally they are placed at 3.6 vertical is to 1 horizontal. And this is the manner in which you can calculate the head loss. Correct? Now, if you talk about core screens, generally we prefer core screens as compared to fine screens. Fine screens is basically in the form of wire mesh, like this. I ask people that which we should prefer. You will say fine screens. Maximum students every time they say fine screens because they will say, ma'am, even finer impurities will be trapped. So fine screens are better, but they are not. Why? Because if maximum impurities are trapped, maximum clogging will take place. If maximum clogging take place, frequent cleaning is needed to be done. So that is the reason we prefer core screens. But you will say, ma'am, but finer impurities are getting trapped now. So after screening, moreover, I am not giving you the water to drink also. We have n number of more procedures which will take care of the removal of fine suspended solids. So you don't have to worry. But in the first step only we are cleaning it. So a lot of labor and work is being done. So that is not desirable. So that is the reason what will happen is we don't use fine screens. Operational cost, choking conditions, a lot of things will be there. So we avoid fine screens. Rather we go for core screens. Okay. Apart from that, next step which comes. So first we have done removal of large floating matters. In the next step we talk about aeration. Aeration. Now this question has been asked in your this one also. ISRO 7th January. Aeration question has been asked this year also. Okay. So what do you think? They have asked questions from these topics also. So if you talk about aeration, what will happen is aeration, you basically bring that water which is to be treated in intimate contact with oxygen. Correct? In water, what is there? Color causing things are there like iron, manganese. In water, gases are also present like H2S and CO2. So what will happen? By aeration, you are bringing in contact water with oxygen. So whatever like Fe2 plus is there, it will form ferric. You know, two valencies are there. One is ferrous and another one is ferric. Okay, so ferric hydroxide, it will form precipitate. Similarly, manganese oxide, it will form precipitate. So you can remove and water, you will pass it further. H2S, when it will react with water, it will form H2SO4. Similarly, carbon dioxide, when it will react, it will form H2CO3. So they will be also removed from the water. Correct? So iron, manganese, H2S, CO2, they will be removed from the water. So whether it is dissolved minerals or whether it is dissolved gases, both are removed. Now one more question which is asked is aeration. If you want to remove minerals and all, if you want to remove iron and manganese, what you do? First aeration and after that sedimentation. Because first they will react and they form precipitate and then you need to remove them also. No? So sedimentation will do that. Got it? So this is the thing. Now how do? How we will bring water in intimate contact with oxygen? Firstly, you will do spray nozzle method. Now what you do in spray nozzle, just check it out. This is spray nozzle method. It's like the concept is you fire it multiple layers. Like you have done it in your this one also guys. Decrease the acidity of water. So see, at the end we want the pH to be 6.5 to 8.5. Before that there will be large number of procedures in which your pH will be getting fluctuated. Okay, so increase acidity, basicity, that will at the end after disinfection it should be in the range of 6.5 to 8.5. So now we are not bothering about pH. Clear? Box G. Okay. Now in spray nozzle what will happen? It will go into multiple number of layers. Now actually what happens is, what is happening guys, this you have done it at your home also. When your parents tell you to water the plants and all, you just cover half of the area. So what you see that it goes into water goes into multiple number of layers. What happens when your just ejecting into multiple number of layers, you are increasing more tendency of the oxygen to come in contact with the water. And this is what, see, it is breaking into number of layers. So you're increasing the tendency. Correct? Efficiency, carbon dioxide and all 99% up to that it can remove, but pressure and all is required. For that requires money. Money is not there. So we don't go for spray nozzle. For a particular community you can apply, but for lakhs of people, populations you can't. Okay, so this is spray nozzle method. This is the one which we use in our case of treatment. If you particularly visit any treatment plant, the one which you will see is this one, cascade aeration. Here generally concrete steps are there. See, 1, 2, 3, 3 to 3.5 steps are there. 3 to 3.5 steps are there on both the sides. So what will happen? Water will flow. Like when the water is flowing, see, again, you are increasing the opportunity of contact of the atmospheric oxygen to come in contact with water. So the one which we use is this one. Why? Nothing to do, just create a concrete steps, that's it. No energy, no power, nothing. They'll function. So easy, simple, economical. We use cascade aeration. Apart from that, you have diffused air system also. Now what is this diffused air system? Just exactly like our aquarium. See, from the nozzles, the oxygen will come out. Bubbles, exactly like you would have seen it in your aquariums. Okay, from the bottom, the oxygen is coming out dissolved in water. So this oxygen which you supplied it will react with water and carry out the removal of dissolved minerals and gases. Correct? But this is again expensive. You can do it for a certain small populations, but you cannot do it for a large area or large number of people. Correct? So this is what? This is your diffused air method. Correct? Last one is your tray towers method. What you do, here multiple number of trays are there. Like they are arranged in series. Multiple number of trays are there through which the water will pass. Now what happens? When it is passing, it will spread into number of layers. Spread into number of layers. So what will happen? The tendency to come in contact will increase. Got it? And this is known as tray tower method. Multiple number of trays are arranged, but the drawback is the area requirement is very high, and that is the reason you don't use it, because the area requirement for this installation of trays is very high. Correct? So you don't use it. So these are the 4 methods. This is spray nozzle method. This is cascade aeration method. This is diffused air method, and this one is tray tower method, which is used for the removal. Correct? Which you can use it. Fine. Now, talking about the types of sedimentation tank. Now, this is important because if you see the PYQs questions are flooded with sedimentation tank questions. Now, first type is generally you broadly divide it into 2 categories, quiescent type, and the second one is continuous flow type. Quiescent type, you call it as fixed type also, you call it as fill and draw type also. What do you do? Nothing. Bring the water, make it at rest. What will happen? Here, the whole hero in sedimentation tank is specific gravity. The whole hero in the sedimentation tank is specific gravity. That means water, whatever suspended solids are there, they will settle under the action of their own weight. So what will happen is, factors which affect rate of sedimentation is first is the amount, or you can say turbulence. If the turbulence will be more, efficiency of sedimentation tank will be more or less. Efficiency will be more or less. The best method is spray nozzle if you talk about the atmospheric oxygen to be used, and if you are doing artificial treatment, then you have diffused air method. Diffused air is only the artificial, others one are natural method. मैंने क्या बोला था? If turbulence is more, turbulence more बोला था कि less बोला था? देखो भुला दिया इसने मुझे बॉक्स में. Again, if turbulence is more, efficiency of sedimentation tank will be less, and vice versa. Why? If turbulence is more, that means water is moving in a haphazard manner here and there. That means suspended solids are not able to settle. Because if you want anything to settle, you should reduce the velocity so that solid will settle down under the action of gravity. So if turbulence is more, what will happen? The suspended solids will not be able to settle. So the efficiency of the sedimentation tank will decrease. If you have zero turbulence, the water is at rest. Quickly, the solids will deposit. Correct. So that is that type of tank in which you make the turbulence zero is known as quiescent type tank, fixed type tank, or fill and draw type tank. Ma'am, why fill and draw type tank? You're filling the water. 24 hours you're not touching the water. Okay, so detention time is 24 hours. Some people write it as TD or some people write it like this. Anything you can use. That means the time for which the water remains in the tank. 24 hours you are not touching the water. Water in that suspended solids will settle. After 24 hours you will supply that water to the next treatment unit. Okay, but ma'am, whatever solids have deposited, you need to clean them, na? Yes. So generally the cleaning period is 6 to 12 hours. Okay, you design these sedimentation tanks for maximum daily demand, which is 1.8 times the annual average daily demand, and the next thing is minimum 2 tanks. See, generally I'll ask you. Okay, first let me ask you, minimum how many tanks are required for quiescent type? Minimum how many tanks are required? Now see how many people are confused. नहीं आएगा इसका कोई रिकॉर्डेड वीडियोस, ये सेक्शन को प्राइवेट कर दिया जाएगा जैसे ही क्लास खत्म होगी वैसे। तो अटेंड तो लाइव ही करना पड़ेगा बिकॉज दिस वीडियो विल बिकम प्राइवेट एज सून एज द क्लास एंड। आई नो 3 वाला भी बोल दिया क्यों मिनिमम पूछा है, मिनिमम 2 tanks will be required ना। why? Because in one tank if cleaning is happening in other treatment should happen, so 2 tanks are required. If I ask you total number of tanks required in this quiescent type, then you will say 3 because 2 operational and 1 standby in case if any failure happens. Got it? So total is 3 and minimum is 2. No, in 2 you will not add standby because common sense, in one when water is being put for purification, in others it should be able to supply it na. And in one cleaning will happen, then at that time 6 to 12 hours you will not supply water to the people because cleaning is happening for 6 to 12 hours. So there should be another treatment unit who should be functioning na. So that's why minimum 2. Total 3 because 1 standby is there. Got that? अरे बताओ भाई विकास भैया, इसका रिकॉर्डेड नहीं आएगा तो आप अभी लाइव पढ़ लीजिए, ठीक है? चलिए, okay. So everybody clear regarding quiescent type, fixed type, fill and draw type? You made the turbulence 0. You brought the water at rest. Got it? You allowed the water to stay in the tank for 24 hours. Next type is continuous flow type tank, or in this continuous flow type tank, you don't make the turbulence at 0. But what you do is you allow the flow of water to take place but with a reduced velocity. So technically 2 things will be taking place here. The particle will be moving further. The particle will be settling down. The particle will be moving further, settling down. Moving further, settling down. So this will be going on. Now, while designing this continuous flow type tank, there is certain assumptions which you have to take. See, in sedimentation tank, there are different zones. First, inlet zone from where the water will come. Outlet zone from where the water will go. And here in between, you have 2 zones. One is settling zone, where the particles will settle, and the other one is sludge zone. Now, if you will ask me that, ma'am, what is the meaning of sludge? So, beta, sludge is the mixture of water and liquid waste. Ma'am, sewage is also a mixture of water and liquid waste. Sludge is also a mixture of water and liquid waste. Then, what is the difference between the two? In sludge, the percentage of solid is more. Got it? So that is why it is known as sludge. Now, this particle, if you want to remove this particle, so if this particles reaches the bottom of the zone, okay, bottom of settling zone, or you call it as top of sludge zone, we will assume that particle is removed. This is the assumption, that if that particle reaches the bottom of the settling zone or the top of sludge zone, we will assume that that particle is removed. Second thing, if let us suppose, example arbitrary itna bada hoga nahi, depth of the tank is 10 meter. Okay, and let us suppose 6 mm particle is there, and which is present in 200 mg per liter is the concentration. So you will assume that this 200 mg per liter is present uniformly around 10 meter. That means in every 1 meter you will get 20 mg per liter as the concentration. Every 1 meter 6 mm particles is 20 mg per liter. Every 1 mm 6 mm particle is 20 mg per liter. So the concentration is same at every 1 meter. It will practically, if I'll ask you, will it be there? You will say, no ma'am, it is not possible. Yes, but this is the assumption. If you will not take the assumptions, you will not practically able to calculate it. That's why assumptions are taken to simplify our calculations. Got it? So the concentration of particles at the vertical cross section at inlet is same. Clear? Both the assumptions is clear? हर मीटर पर आपको mg per liter का concentration same मिलेगा. Clear? हाँ या ना? Yes or no? चलिए. Now, coming to the formula, because derivation is not important. Now, I said that I will reduce the amount of flow. I will reduce the turbulence. Now, the size of the particle which is there, it can be laminar, it can be basically the flow which is taking place, it can be laminar, it can be transitional, it can be turbulent. If the water flows in layers, okay, and there is no momentum transfer taking place, particles are there and no momentum transfer is taking place, you call this flow as laminar. In laminar flow, the dia is less than equal to 0.1 mm. In turbulent flow, water is moving in a haphazard manner and momentum transfer takes place. In transitional flow, it is in between laminar and turbulent flow, and here the dia is varying from 0.1 mm to 1 mm. Correct? In laminar flow, the settling velocity is given by d square by 80 nu gs minus 1 into g. This is the formula. D is the dia of the particle, mu is the kinematic viscosity, gs is the specific gravity. But in case if in the examination they will tell you that consider the impact of temperature and answer, so the formula which you will take will be 418 gs minus 1 d square 3t plus 70 by 100. Here the dia you will substitute in mm, temperature will be in degrees Celsius, and settling velocity will be in mm per second. This is an empirical formula, so yes, you have to take care of the units. Now, if you talk about transitional formula, here, same formula is there, just one difference, exactly copy paste, just only one difference is there, that here you will substitute the dia in mm. Exactly same, but here d square was there, here d is there. Other than that, everything is copy paste. Okay, after this, everything is copy paste. Kuch nahi karna, nothing you have to do it. Okay, turbulent flow settling velocity is given by 1.8 root over gd gs minus 1. So these are the formulas. Out of this, if you will ask me, ma'am, in which formulas questions are being asked? Only this one. Only this formula questions are being asked. Correct? So till now they haven't asked from others, but they have asked from this one only. Fine. So these are the formulas. It's 3.3. We need break. Just this one question I'll make you solve, and after that I will give you break. Okay, Vinay? Just this one question shall I solve? After this I'll give you break. Is it okay? Is it okay? Chalo. Fine. But for teaching you this, I just need 5 minutes for concepts, more to tell you, and after this we'll do it. Okay, now just we'll complete coagulation aided sedimentation afterwards. Right now we are doing just plain sedimentation. Okay. Now one thing is, I told you the settling velocity. Now there are 10 mm particle, 8 mm particle, 7 mm particle. Like 10 mm particle is there, 8 mm particle. Hmm. Just check it out that addition of it is coming 1000. Add करने से 1000 आ रहा है क्या? Just check it out that first. Is it coming 1000? Is it coming 1000? जल्दी. ठीक. Now you will answer me. If I'm telling you, Divya, Prince, Rahul, Vignesh, Vinay, Sahil, everybody, that I want to design a sedimentation tank in such a manner that if 1000 mg per liter of suspended solid goes, then maximum 500 mg per liter should come. Even if it is coming less than that, it's okay. But more than 500 mg per liter should not be coming. So which particle should I choose? Can you tell me which particle should I choose? I'm taking an example of sedimentation tank and settling velocity. Wait. First I have to explain you velocity overflow rate. Then one question I'll solve all the things. Have made MSQ also. Very good. Very good. Divya, Shravan, very good. You will select 6 mm. Why? Because if you design for 6 mm, 200 will be removed, 100 will be removed, 100. 500 mg is removed. But you said that ma'am, minimum 500 na, even maximum 500 na, even lesser than that. Yes. So if you design, now listen to me very carefully. Based on this logic, questions have been already been asked. Okay, so listen to me very carefully. Questions have been asked in 2020 and all from these topics. Okay, the concept only they have asked, and it was a very easiest question. 10 seconds and you'll solve that question. Check it out in your PYQs. If you design for 6 mm, 200 mg per liter will be removed, 100 mg per liter will be removed, 500 mg per liter will be removed. 6 mm is the design size of the particle. This is the design size of particle. Correct? So, if any particle is larger than the design size of the particle, it will be 100% removed. If any particle is smaller than the design size of the particle, it will be partially removed. So this will be, so even you will be getting lesser than 500 mg per liter. Why? Because out of 1000, this 500 will be completely removed, and the remaining 500, out of that also, how much that you can't tell just by seeing it. But partial removal will take place. Partially removed. So the particle for which you are designing the tank is known as design size of the particle, or one more name is there, concerned size of the particle. If you want to calculate the velocity of the concerned size of particle, now listen to me very important, that this formula which I tell you, V naught, this is Q by BL, this is valid, this is the surface overflow rate, and this formula is valid only for the velocity of concerned size of particle. If you think that this formula you can apply for 4 mm, 3 mm, 8 mm, 10 mm, no, you can't. Ma'am, but if you want to know the velocity for that particles, how can you calculate? Go for laminar flow, go for any other. Okay, but you can use these settling velocities formula. But this formula is valid only for the velocity of the concerned size of particle. Remember this. This is very important. And if you want to calculate like 4 mm particle, how much it is removed. So percentage removal is given to you the settling velocity of the particle by the equations divided by the velocity overflow rate into 100. This is the percentage removal. The settling velocity divided by velocity overflow rate into 100. This is the percentage removal. Got it? Now, last one more thing I'll tell you, and then we'll move towards one numerical, and then you can go for break. If this is a particle, it has two velocity. This is the sludge zone. This is the settling zone. This is the length. This is, I'm taking longitudinal section. This is the depth. Okay. Now the particle will be settling also, moving also. Settling also, moving also. So Vs is the settling velocity of water and Vf is the flow velocity. Or some people write it as Vh also. It's upon you whatever denotation you want to add. So what is happening? Particle is settling also, moving also. Whatever is the velocity of water, that will be the velocity of particle also, because the particle is there inside the water. So if you want that 100% the particle should settle, based on this logic, question in ESE conventional gate has been asked. If you want to 100% remove, that means detention time will be same. So what you can write? Distance. Speed is equal to distance by time. Time is equal to distance by speed. Distance is h. Speed is Vs. Similarly, if you take horizontal distance, distance is L and velocity is Vf. Both the time is same because the time for which the water remains in the tank will be same. So h upon Vs is equal to L upon Vf. So from here, whatever they ask you, you can calculate. They ask you Vf, Vs, anything they ask you, you can calculate it from. Got it? Now one more thing. If they ask you to calculate Vf, okay, discharge is equal to area into velocity. So you will say velocity will be discharged by area. But the question comes which area? When you calculated overflow rate, this time the area was plan area or you call it as surface area. But here which area will be there? Remember, we always take that area which is perpendicular to the flow of velocity. So here if this is the Vf taking place, perpendicular to this, the area which will be there will be B into H. That is the cross-sectional area. So B into H. Cross-sectional area. Got it? Q upon BH, that is cross-sectional area. So if they ask you anything, this is one equation for 100% removal of particles. Got it? So now one question and then coagulated aided sedimentation, we'll do it in the after break. Now, flow rate is the settling basin is there. Flow rate is given to you 0.6 meter cube per second. Now, who was asking na that ma'am give the example Ratnadeep, not just Ratnadeep Rajkumar ji. Just check it out. Discharge is given to you. Length is 20 meters. Height is 3 meters. Width is 6 meter. Now, 60% of the particles that have a settling velocity of 0.0034 meter per second will be removed. Is it true or not? How can you calculate? How can you calculate? First, you know that ma'am percentage removal is equal to Vs by V naught into 100. So they have given you the settling velocity, that is Vs, and they have given you the percentage, that means they have given you efficiency. So first we need to calculate V naught and check it out that whether it is true or not. V naught is what? Q by BL. Come on guys, calculate Q by BL fast. 0.6 divided by 20 into 6. How much it is coming? So check it out. They have said that the settling velocity is 0.0034. V naught is 5 into 10 raised to power minus 3 into 100. Is it coming 60%? %68% it is coming. तो मेरा भी तो वही आ रहा था 68% it is coming. Who was telling it is true? Mine it is coming 68%. So first one is false. Now, if the length is 15 meter, then removal efficiency of particle whose settling velocity is 0.003 is 45%. अब देखो, length change हुआ, velocity over flow rate will change, yes or no? If length is changing, velocity over flow rate will change, yes or no? Yes or no? Velocity over flow rate will change, yes or no? Yes or no? Yes. Why? BL. So first you need to calculate velocity over flow rate. Calculate. 6.66 into 10 raised to power minus 3. Correct. Now again you will calculate what? Percentage removal. कितना आएगा? 0.003 बोला था ना 0.003 6.66 into 10 raised to power minus 3. How much it is coming? 51%. तो मैं check करती हूँ. 9/20 45% आ रहा है यार. सौरभ चेकआउट करो 45% आ रहा है. B is correct. A was false. तो ये सेम ही क्वेश्चन था, इसमें 75% दिया. Now, last statement that is given. Surface overflow rate depends upon the width and length of tank. Yes, inversely proportional. So, true. So, B and D are true. Correct? Clear? ठीक, चलो बस ये लास्ट चीज. फिर मैं यहां से कोगुलेशन एडेड सेडिमेंटेशन से वी विल स्टार्ट आफ्टर द ब्रेक. दिस इज द लास्ट थिंग वील डू. वर्टिकल फ्लो टाइप टैंक बिफोर द ब्रेक. आफ्टर दैट वी हैव टू डू एलम एंड ऑल क्वेश्चंस आल्सो नो. So vertical flow type tank, if I talk it about, see, in the case of continuous flow type tank, you were getting that the resultant is linear, right? Here you will get that the resultant is coming parabolic in nature. Why? Because the velocity of flow keeps on changing. It is more here, but it is changing, right? It is moving away, so the velocity of flow changes. That's why if it asks you in the statement-wise questions, in vertical flow type tank, you will get this resultant as parabolic in nature. And in the case of horizontal flow type tank, you were getting it as linear. Got it? So now this will move. Here the water will be coming through the perforations, and here the water will get spread out. So whatever suspended particles are there, they will settle down under the action of gravity. Now here just one thing you need to know, that is the volume. Volume is given by d square 0.785 h plus 0.011 d. They have asked logic of this question last year. Last year they have asked in conventional. Yes, conventional. Last year they have asked in conventional. So either they will ask you to calculate the height or dia. Volume, they will just make you to work extra hard. They will not give you the volume in the question. So they will give you discharge and detention time. So multiply discharge into detention time, you will get the volume. Correct? So this is the formula for calculating volume. D square is equal to 0.785 h plus 0.011 t. Clear? So this is the formula. Okay. So with this we have completed. Now we will talk about coagulation aided sedimentation. So break. Break, guys. Yes. I don't think that now you will study. Of course, you badly need break. Correct? So we have done screening, aeration, plane sedimentation. Now from there we will start it at. Acha, tell me. No. Radial flow is moving along the radius, moving in various directions along the radius. अभी मैं आपको बता दूंगी वो. At what time we'll come back? Just tell me the time. Just tell me the time. At what time you will come back? Just tell me the time and then go. Now it's 1:55. Tell me how much break you want. I am continuously teaching for 4 hours. Just check my jaws. 2:30. Okay. चलो, एक सेकेंड. Before going, you have to promise each and everybody that you will be back sharp at 2:30 PM. मैं बता रही हूँ, मैं रिकॉर्डिंग अलाउ ही नहीं करूंगी. मैंने तो उसको प्राइवेट कर देना है. मैं मेहनत कर रही हूँ और तुम बड़े आराम से रिकॉर्डिंग देखो. ऐसा नहीं हो सकता. Promise and then go. I want commitment. Come on. Promise and go. I want commitment. And girls are good at giving commitments. Check it out. Promise चाहिए, श्योर, गारंटी, डेफिनेटली, 100%, 90%, ना. आई नीड कमिटमेंट एज ऑलवेज. चलो, जितने लोग नहीं आएंगे ना सबको ब्लॉक करूंगी. ओके, fine guys, so we'll see you at 2:30 p.m. I'm good at time and I hope you will be also good in time, so we'll see you that time. Okay, 2:30. Okay guys, see, अब इसके बाद जो ब्रेक मिलेगा ना वो वेस्ट वाटर कैरेक्टरिस्टिक्स वी विल कंप्लीट इट. सो डिस्ट्रीब्यूशन तो छोटा है. डिस्ट्रीब्यूशन, फर्स्ट ट्रीटमेंट, देन डिस्ट्रीब्यूशन, देन वेस्ट वाटर कैरेक्टरिस्टिक्स. ठीक है, चलो. अच्छा, ये राहुल जी भी आए, राहुल गांधी जी भी आए. चलिए, नमस्कार. ओके. Okay, Vamsi, thank you so much. I know Divya, Vamsi will be there and hopefully Prince also. Prince Hoga. The 4-5 people I know, if this whole, even anything happens, they will be there. Okay, guys, we'll see you at 2:30 p.m. Relax, take a power nap of 10 minutes, but come at 2:30 p.m. Okay, thank you everyone. Let's meet at 2:30. Good afternoon. Ready? Okay. Okay. Good afternoon. Good afternoon, everyone. Good afternoon. So, am I audible, visible, right? Am I audible, visible? Yeah, ready after a nap. I didn't got time to take a nap also. Good afternoon. Fine. Okay. So guys, shall we start now? We have to start from coagulation aided sedimentation, and now till the time we don't cover wastewater characteristics, no break, huh? Because after that we have to start treatment of sewage, then no, design of sewage, disposal of sewage effluent, then sewage. Okay. So after till wastewater characteristic, at least minimum, you will not ask for any break. Okay. So now we'll start further. Now the class has resumed. So let's start. Nobody is having any doubts till now, right? Nobody is having any doubts. Quick. Otherwise, then I'll proceed. Okay. Fine. So now let's start further. Now, what happened was, let us suppose I wanted uh, total dissolved solids up to 500 mg per liter is acceptable. Cost for rejection limit is 2000 mg per liter. Okay, example I'm taking. I'm taking any solid, let us suppose any solids are there, which is 1500 mg per liter, and the one which has to come out is 200 mg per liter. This is desirable. So can you tell me the percentage efficiency? How much should be the efficiency of the sedimentation time? 1500 minus 200, that is 1300 divided by 1500 into 100. How much is the percentage efficiency coming? 13 by 15 into 100. How much is the percentage efficiency coming, guys? 86.66%. Okay, now it's okay. You can go for plain sedimentation. But if I say that I want it, that it should be the amount of solids which is coming is 1500 mg per liter, and the amount I want is, let us suppose, 50 mg per liter. So what is the percentage efficiency? 1450 divided by 1500 into 100. So what is the percentage of efficiency which is coming now? 96.66%. Now tell me, is it possible to practically get this much of efficiency from a sedimentation treatment plant? I'm not asking about the ideal one where you used to get 100% efficiency. Is it possible to get this much of efficiency? Is it possible? No. So if you think that plain sedimentation tank will help you out, so for sure it is not going to do this. So whenever, now you can say, no ma'am, how do you decide whether I want to go for plain sedimentation or I want to go for, just a minute. Excuse me. So how I decide whether I have to go for plain sedimentation or I have to go for coagulation aided sedimentation? You can decide based on how much water is coming. How much water is coming from where you will decide? From the quality parameters of water. How much water you want, that will be as per codal provisions. Okay, so based on that, you have to decide whether you will go for plain sedimentation or you will go for coagulation aided sedimentation. Now, always remember coagulation plus flocculation plus sedimentation. After coagulation, flocculation is must. After flocculation, sedimentation is first. This is the chronology which has to be followed. CFS, coagulation, flocculation, sedimentation. Nothing can you can shift it up and down. Okay, this is the process you have to follow. Now, what happens? Let's talk it about. First, let us talk about coagulation. In coagulation, what you do is you mix any chemical which you call it as coagulant. Now, what does this coagulant does? The chemical which you mix it. See, the question comes, why these suspended solids are not settling? Why I'm just providing, I'm reducing the turbulence to 0, I'm reducing the velocity to 0, but why the particles are not settling? The particles are not settling because the particles are stable in nature. If you want that particles to settle, you need to add chemical. That chemical is termed as coagulant. Now, ma'am, what will happen if you add that chemical? That chemical performs two functions. These particles were not settling because they were stable. So the coagulant which you will add, it will first destabilize those particles. The moment they are destabilized, so what will happen? You will take it to the flocculation, so where slow mixing will be done and these particles come in contact with each other. Now the particles have become bigger in size and now in the sedimentation tank they will settle. So coagulation, flocculation, sedimentation. In coagulation, you will do mixing of the chemicals, but first you will add coagulant, that is chemical. That chemical performs two functions, destabilization of the colloidal particles and second is the agglomeration of the colloidal particles. Now what are the chemicals which you will use? There are n number of chemicals which you use. The one which is most common and which has been asked in your examination is filter alum, or you call it as alum, or you can call it as hydrated aluminium sulfate. You call it as hydrated aluminium sulfate. Now, what happens here? This is the formula. See, I basically goes through this formula. Quickly you are able to solve questions. Now see, aluminium sulfate is there. It reacts with calcium bicarbonate. Now, one thing. Ma'am, is it necessary for it to react with calcium bicarbonate? Yes. Yes. Why? If calcium bicarbonate is not present, alum will not at all function. It will not at all function only. So if you want alum to react, it is very mandatory that calcium bicarbonate is there. That means technically bicarbonate alkalinity should be there. If bicarbonate alkalinity is not there, alum will not at all function. Alum will not at all function. Now what you do is, alum will react with calcium bicarbonate alkalinity. It will form aluminium hydroxide, which is the gelatinous white precipitate, and this is what you call it as floc. It forms calcium sulfate, which is a permanent hardness. It forms carbon dioxide, which causes corrosion of pipes, and it forms water. Now, if I give you a question, addition of filter alum in water leads to the formation of floc. True or false? Leads to the formation of floc. True or false? Leads to the generation of permanent hardness and leads to the liberation of carbon dioxide, or you can say corrosion of pipelines. So, all three are true. All three are true. And you can check it out from these reactions. You can check it out from it forms floc, it forms calcium sulfate, which is permanent hardness, and it liberates carbon dioxide. Correct? Now, if you go by unitary method, like first calcium bicarbonate you cannot get directly in water. For getting calcium carbonate, you need to add calcium bicarbonate, you need to add calcium carbonate. Calcium carbonate plus carbon dioxide gives calcium bicarbonate. Okay, so if you want 3 moles of calcium bicarbonate, you need 3 moles of calcium carbonate. You know A is equal to B, B is equal to C, so A is equal to C. Exactly same logic. Filter alum requires calcium bicarbonate requires calcium carbonate. That means filter alum requires calcium carbonate because calcium bicarbonate is common in between. So if you calculate here, this comes out to be 666. 666, this is the molecular weight. So 666 grams of filter alum requires 300 grams of calcium carbonate. So 1 mg per liter will require how much? 0.45 mg. If you remember this, trust me guys, you will be able to solve easily any questions within a fraction of seconds. Similarly, now it is not necessary that calcium carbonate will be present in water directly. So if you want to have calcium carbonate and if it is not present in water directly, you need to add quicklime. What is quicklime? That is calcium oxide. So calcium oxide when reacts, this will be H2O. Calcium oxide when react with carbon dioxide, it leads to the formation of calcium carbonate. It leads to the formation of calcium carbonate. Correct? So again, 1 mole of calcium carbonate means 100 grams require 56 grams of calcium oxide. So 1 mg per liter will require how much? 0.56 mg per liter of calcium oxide. So such things have been asked. Based on this two concept, question has been asked in your GATE common data question. However, they have not asked questions from this topic. Okay. However, they have not asked questions from flock, calcium sulfate and carbon dioxide, but they can ask you again same thing. 1 mole needs to 3 moles of calcium sulfate. So 1 mg will lead to how much? You can remember this. Okay. Or you can do it yourself in the examination as well. But these two are very, very important which you should know. Clear? Now, let us solve one question. I'll give you arbitrary data question. I'll give you. Let's solve that question and check it out that how to proceed. Because I told you this is an easy manner in which you can do it. Now, I'll give you just one question by myself only. Example, let us suppose 10 ml water is there. Okay. And the alum dosage which is required is 18 mg per liter. Okay. Already 6 mg per liter of alkalinity as calcium carbonate is present. Calcium carbonate is present. First question it is asking you calculate the total alkalinity required. Total alkalinity required in kg per day. If it is asking total, means you don't subtract -6 and all, which you guys make the mistake. Okay, now see. Total alkalinity required as calcium carbonate. Okay, now see. 1 mg per liter of filter alum requires 0.45 mg per liter of alkalinity as calcium carbonate. Now see, in one line you will be able to solve. So 18 mg of alum will require how much alkalinity? Come on guys. If 1 mg requires 0.45 mg per liter as calcium carbonate, 18 mg per liter will require how much alkalinity? 8.1 mg per liter. Correct? So it is asking if in 1 liter 8.1 mg is there, in 10 mld how much will be there? So 10 into 10 raised to power 6 liters per day into 8.1 mg per liter. Convert mg into kg. How much it has come? How much it is coming? Solve it and tell me how much it is coming. Eight 881 kg per day. This is the requirement. Correct? How you got this? If you know this, you were able to solve the first part of the question. Now, let us suppose quantity of second part is quantity of quicklime required. Required in a year. Okay? If efficiency or if quicklime added is 85% pure. That means 15% is other foreign material which is added. Now here you know for quicklime is added for calcium carbonate. You checked it out that you required 8.1 mg per liter. That means when you add 18 mg in 1 liter filter alum, simultaneously you require 8.1 mg per liter of calcium carbonate. In water 6 mg is already present. So additional how much you require? Additional alkalinity as calcium carbonate. How much is required? It is required as 8.1 minus 6. That is 6, 7, 8. 2.1 mg per liter as calcium carbonate. Now calcium carbonate you can't add directly. You need calcium oxide. So just now I told you 1 mg per liter of calcium carbonate requires 0.56 mg per liter of calcium oxide. So how much is there? 2.1 mg per liter of calcium carbonate will require how much calcium oxide? So 2.1 into 0.56. It will require 1.176 mg per liter of calcium oxide. Okay. Now, if the calcium oxide would have been 100% pure, I would have added this much. But it is only 85% pure. So, I need to add more amount of calcium oxide. That is 1.176, 0.85. So, why I divided? Because I want more amount of calcium oxide to be added. Why? Because the calcium oxide which is added is not 100% pure. Divide by 0.85. That is, it will come out to be 1.3835 mg per liter. Now it is asking you yearly. Mg per liter. First of all, how much liter of water is there? 10 mld. That is 10 into 10 raised to power 6 liters. Convert mg into kg, 10 raised to power minus 6 kg. And then talking about one day, this much is required. So for 365 days, how much will be required? That's it. Minus 6 will get cancelled out. 10 into 365. This will come out to be 5049.88 kg. In a year. Correct? मेरा क्यों एक ज़्यादा आ गया? 1.3835 into 10 into 365. 5049 ही आ रहा है. Just check it out. Divya, I think you forgot to multiply 10 or what? You forgot to multiply 10, I guess. Clear? So I told you now, if you remember this two equations, you will be able to solve it. Correct? Okay. Now, guys, you had your breakfast, lunch, and then also now the voice is not coming from your side. मैंने एक 10 raised to power ये 6 और minus 6 कट जाएगा. कहाँ गया? Plus 6 minus 6 1.3835 था into 10 into 365. 50498. Veera Babu, Divya, just kindly check the calculations once. चलो, ठीक है? चलिए. Now, guys, one more thing is happening. When you are adding alum, similarly you can add ferrous sulfate, or you can add, you can just chlorinate it, you will get chlorinated copperas. You can add sodium aluminate. They are also the ones, ferrous sulfate, if you talk it about, or chlorinated copperas, they are cheaper than alum, but still we use alum in our treatment units. Sodium aluminate is costly, so whenever boilers and all, whenever you have to use water for boilers, there you will go for sodium aluminate, because there you don't want any hardness. So generally you want very less hardness, and you don't want in water other coagulants, suspended solid should be present. So there you use sodium aluminate. However, in Indian subcontinent, generally for treatment we go for alum. Correct? Now, here generally you will say that, ma'am, if you want to mix the chemical, will you just throw it into the water, the chemical? Excuse me. And they will mix automatically? No. Actually, there were baffle walls also. There were baffle walls around and N type, round and N type. So water used to go splash it out and try to get mixed. Splash it out and try to get mixed. But what happens? The efficiency doesn't used to come more. Okay, when you were using baffle walls, that means you naturally constructed structure so that whenever you add chemical, it will mix on its own. So you were just happening, what proper mixing was not taking place. Okay. Instead, then what you did is you applied impeller, you gave power so that when that impeller was rotating, the paddles were rotating. What was happened? Proper mixing of the chemicals took place. So with the use of mechanical mixers, what you saw, that proper mixing of the chemical took place. So what you did it here, from here you fed the coagulant here. Now what will happen? And here the raw water will be coming. Now you added the chemical. Now generally you can add the chemical in powdered form and in solution form also. Generally we prefer solution form. Generally, like if I tell you, I'll give you sugar. Okay. And I'll tell you to make a drink for me. Okay. Make a healthy drink for me. And if I'll give you sugar syrup, in which case proper mixing in water takes place in a lesser amount of time. Of course, when sugar syrup is there. So generally the coagulant which we use, that is preferable in liquid form. Okay. In solution form. So what will happen is when this coagulant chemical will come, okay, when this coagulant chemical will come and this raw water is coming, this shaft will, here a motor is there and the shaft is there. So now the proper movement will take place, and this takes place at a very fast rate, rapid mixing. Ma'am, for how much amount of time? 1 minute, not more than that. Okay, so it is rotated at a very fast speed so that proper mixing of the chemicals takes place. And that is the reason you call it as fast mixing. I told you the reason, right? I told you the reason. So that quickly quickly the chemical gets mixed in water. I told you, just take a glass of water and I'm giving you sugar in the form of crystals, and I'm giving you sugar syrup, and I'll give you same amount of time to make them dissolve. Sugar syrup will dissolve in lesser amount of time uniformly in water as compared to that of the crystals. So that is the reason. Got it? Now what is happening? You are doing what? You are supplying power. So now comes how much power you need to supply. So the amount of power which you need to supply is G square mu V. Now here maximum students have a doubt and they make mistake here is volume. This is volume, which you guys take it as velocity. This is the volume of the tank. Don't get confused. Okay, V is the volume here. Mu is the dynamic viscosity and G is the mean temporal velocity gradient. So basically what it happens is, this is the mean temporal velocity gradient. That is, it will give you mean temporal velocity gradient. It will tell you that how much difference in velocity has taken place. How much difference in velocity has taken place with respect to distance. So technically the unit of it is second inverse. So relative, like this is one particle, this is one particle. This particle is moving with velocity v1, this particle is moving with velocity v2, and the distance between them is x. So mean temporal velocity gradient is the difference in velocities between the two particles to the distance between them. This is known as mean temporal velocity gradient. It tells you about the intensity of mixing. More is G, more is the intensity of mixing. So if they will ask you to calculate power or mean temporal velocity gradient, you will use this formula for calculating. Any doubt? Now, here coagulation is always a fast mixing because you want that chemical to be mixed fastly and that too in a lesser amount of time. The moment that chemical is mixed, it will carry out the destabilization. The particles are destabilized. Now you want that the particles which are destabilized, they should come in contact with each other. So now you will go for flocculation. What is flocculation? It is slow mixing. So here also you will have what? You will have this shafts will be there, pedals will be there, but here you will induce slow mixing, slowly, slightly and slightly, so that all the particles which have destabilized, they come in contact with each other and they become bigger in size. And what will happen if they'll bigger in size? If they will become bigger in size, they will settle down in the sedimentation tank. Okay, so first you will mix the chemical. Then you want them that they should come in contact with each other. Then you want them, they should settle under the action of its own weight. So coagulation, then flocculation, then sedimentation. Correct? So this is the thing which will be happening. So inlet from mixing basin, it will get mixed. After that, you want that the particles should come in contact with each other, and after that you will take it to the sedimentation tank. Here also the formula for power is same, G square mu V. Correct? Now, power, you can write it as force into velocity. Can you? G square mu V. Volume, you can write it as discharge into detention time. Of course, you can write it. Now, the force which is acting here is the drag force. So, you can write it as half CD rho A V square. And this is one more V. So, here it will become VQ. Now, a very important thing, ma'am, this capital V was volume. This small v is velocity. Now, what will happen is, small v. Now, in the question, they haven't ever asked this, but they can do this. See, this is technically VR. Remember this. This is very important. Now, if they want to ask you concepts, they can ask you this thing. This is resultant velocity, which is velocity of pedal minus velocity of water. Okay. In vertical plane, basically right now, the velocity of water in maximum cases which they have asked questions, they have taken it as 0. But it is not necessary. If in the question they are giving you the velocity of water, then this is the resultant velocity which you will calculate. But right now, since VW becomes 0, you write it as VP is the velocity of paddle. But if any question comes in examinations and they say velocity of water also they give, then you have to mention it. Got it? So this is G square mu discharge into detention time. Now whatever they are asking you in the question, you can calculate. They are asking you G, you can calculate. They are asking you discharge, you can calculate. Anything you can calculate it from here. Now one more thing. Sometimes in the question, they will not give you area also. They will give you the width of the paddle, they will give you the length of the paddle, and they will give you the number of paddles. So that time the area will be number of paddles into width of paddle into length of paddle. Got it? So you need to substitute it. So what they will give you, what to use, that will depend upon in the question paper what questions comes. Clear? But I have told you, if they are not giving you area directly, you will calculate like this. If they are giving you VW, then here instead of VR, you have to substitute VP, you have to substitute VR. Got it? That is the thing you have to do. Fine. So this is about flocculation. Any doubt? Now, one more thing. If area A, which one, madam? Area of this paddle. Area of this paddle. Iska area. This area. Got it? Now, one more thing which they have already asked question. If you want, if the temporal mean velocity gradient is more, okay, intensity of mixing is fast, but the time is less. Can you tell me which type of flock is formed? Can you tell me which type of flock is formed? Come on guys, ये तो पढ़ा होगा. They've asked you already. Come on. Dense flock. Always remember, if G is more, you will get dense flock. If G is less, you will get very good, Divya. Dense flock, small in size. And if G is less, you will get, if G is less, what you will get? You will get what? Light flocks, large in size. And this they have already asked you. Correct? So if intensity of mixing is more, the denseness will be more. If intensity of mixing is less, the flock formed will be light. That is the thing which you have to do it. Clear? That is the thing which you have to do it. Now, next coming further, light and large. Correct. Now, next coming further is filtration. Next coming further is filtration. Now, what is filtration? What is filtration? What is filtration? Filtration is carried out. This is a treatment unit. Here you do what? Here you do what? Here you perform various functions. First function which you perform is what? First function which you perform is the removal of fine suspended solids. Second, if filtration is there, what will happen is fine suspended solids is removed. After that, you get removal of dissolved solids as well. Okay, you get the removal of dissolved solids as well. Okay, if filtration is there, even the suspended solids, dissolved solids, and even color is also removed. So can you see that filtration in itself acts as the complete treatment unit? What if we want that? I'll tell you, just wait. If you talk about filtration, so filtration in itself acts as a complete treatment unit. Why? Fine suspended solids are also removed, dissolved solids is also removed, color is also removed. So in it itself acts as a complete treatment unit. Okay. Now if I talk further that how can I remove filtration? Basically, how can I remove fine suspended solid, dissolved solid? So I can do it with the help of filtration. Now filtration can happen when you add here the units which you have it here is filters. So the components which you have it here is filters. Now what does this filters happen? These treatment units known as filters will be the one which will be carrying out the process of removal of fine solids, dissolved solids, colors and all. Now what you will do here, you have two types of filters. One is gravity filter and the other one is pressure filter. So in gravity filters, what will happen? The water will move under the action of its own weight. While in pressure filters, what will happen? You will apply the pressure so that the treatment can take place. So in gravity filters, see, whenever there is a relative motion between two things, friction will come into action. So when generally the filter media which we use is sand. Ma'am, why sand? You can use any other also, but make sure it has a high compressive strength, high durability, high resistance. So if whatever material you are choosing, it is able to fulfill all of that, bingo, you can use that. Okay, generally we use sand as the filter media. You can use sand as the filter media. So now comes the question that gravity filters, water will be moving under the action of its own weight, right? Now, why it is moving, ma'am? Because in the filter media, the water will be moving. Okay, the filter media will not allow the water to move. It will not allow the water to move, but water has to move. So water will lose its energy. Since water loses its energy, okay, water is losing its energy. So here, how will the water get energy to be lost? Due to the action of its own weight. So such type of filters, you call it as gravity filters. Such type of filters, you call it as gravity filters. That means water will move under the action of its own weight, and that's where the name came out to be as gravity filters. Now in gravity filters, you have slow sand gravity filters and you have rapid sand gravity filters. Why the name slow and rapid is given? Because in slow sand, water will be moving same. In both of them, water will be moving under the action of its own weight. But the rate of filtration is less in the case of slow sand, while it is more in the case of rapid sand. And that is the reason the name slow sand gravity filter and rapid sand gravity filter is being given. Correct? Now, we will be I'll be teaching you that basically what are the various mechanisms by which the removal of fine suspended solids, dissolved solids and colors and all take place. So there are four mechanisms: mechanical straining, sedimentation, biological changes, electrolytic changes. Now, while explaining you, I'll be telling you one by one. But it's not that first mechanical straining will happen, sedimentation. All the things will happen simultaneously. But since I'm explaining you, I'll go one by one. Okay. Now coming first is mechanical straining. Now, what happens in mechanical straining? Now listen to me very carefully. These particles. Now sand will be obviously smaller in size, but it will not be visible on the screen. That's why I'm drawing it bigger. Now what will happen? The water will come. Now when the water is coming, the water is coming. Okay. In this water, suspended solids are there. Some will be finer and some will be bigger in size. Correct? So now once you know that water passes through the interconnecting voids. Water will pass through the interconnecting voids. So whatever particles are bigger in size, will it be able to pass through the interconnecting voids? Of course not. So what will happen to these particles? They will be settling on the top. Because they are not able to pass. The particles which are bigger than the voids of the sand particles, they will not be able to pass. So they will settle on the top. Correct? They will settle on the top. Now, even if finer impurities are coming in from the water, they will also settle. So basically, they will form a matte layer. Why? Because in water, you have n permutation and combinations of suspended solids which is present. So what will happen is basically the finer impurities will not be able to pass through the voids. First of all, finer impurities will not be able to pass, or coarser impurities will not be able to pass. Finer impurities or coarser impurities will not be able to pass through these voids. Those particles in water which are in size more than the voids of the water, more than the voids of the sand particles, will not be able to pass. And since they will not be able to pass, they will settle at the top. They are settling at the top and they will form a matte layer. So what you will do? You will mechanically remove the top layer. So that is termed as mechanical straining. That is termed as mechanical straining. So whatever fine suspended particles are there, you remove them with the help of mechanical straining. Now sedimentation tank. Just check it out. This is a tank. Okay. Now you will tell me it behaves like a continuous flow type tank or it behaves like a quiescent type tank. Check it out. The particles are there. Particles are there. Now the particles will settle under the action of its own weight. That is the process of sedimentation. Is it a quiescent type tank or continuous flow type tank? Come on guys, quickly. Quiescent type. See, it is a tank. The water is stable here. So it will be acting like a quiescent type tank. Only one person said it correctly. That is Anwar. Okay, it will behave like a quiescent type tank. That is here the turbulence will be 0. Okay, so it is behaving like a quiescent type tank. Behaving like a quiescent type tank. So what will happen? Whatever particles are there, specific gravity will act and they will settle down under the action of its own weight. Again, fine suspended solids are removed. Mechanical straining, sedimentation. Here what will happen? Fine suspended solids will be removed. Okay. Now, biological changes. Biological changes, if I talk it about, what you check it out here, what I check it out here, in biological changes, I will remove the organic matter. Here, biological changes, I will remove the organic matter and microorganisms. How? Now, this is important. This is important. Now, check it out. Check. Yeah. I can't read your comments. Just a minute. Where are your comments? Okay. Now, Rajik, I guess you are reading it. तुम्हारा पीछे चल रहा है बहुत. पहले का आंसर अभी दे रहे हो आप. Okay. Biological changes, if I talk it about, what you will see is here. Before filtration, organic matter was there, microorganisms was there. Okay, before filtration, organic matter was there, microorganisms was there. Okay, so that means microorganisms was already carrying out the decomposition of organic matter. Organic matter has already been getting decomposed initially. So what will happen when this filter media is there, when organic matter comes, because obviously suspended solids are there, that means what? Organic matter is there. When organic matter comes, that means microorganisms are also there. And microorganisms are carrying out the decomposition. That means here they will form a sticky deposit. And in this deposit, what will be happening? Microorganisms will be there, organic matter will be there, and microorganisms will be carrying out the decomposition of organic matter. So, ma'am, when organic matter will be decomposed, they will die. So, yes, even the dead cell mass of the organic matter is present here. And, ma'am, if microorganisms will not get enough food, then what will happen? First, the more dominant microorganisms will eat a less dominant microorganisms, and then if he doesn't get food, the microorganisms will utilize carbon from its own body. That means it will carry out endogenous respiration. Correct? So here biological changes will be there. So here what will happen is, here the layer will be formed which is known as smut stack. Some people call it as smooth stack also. So this smut stack layer will be formed. Which will be doing what? Which will be carrying out the removal of organic matter and microorganisms. So here what was happening? Here one more thing was happening, removal of organic matter and microorganisms. That's why it is said that filtration in itself acts like a complete treatment unit. Okay, last one is electrolytic changes. Very simple. See, the water which is coming, it is having a positive charge, negative charge. Okay, the sand also has positive charge and negative charge. The sand particles also have positive charge and negative charge. So when this water passes through the filter media, you don't know that what amount of neutralization takes place. Like this, I will call it as A plus and B minus. So here it is having sand particles is also having positive charge, negative charge. Water is also having positive charge, negative charge. You don't know that how and what neutralization takes place, but it is sure that whatever water comes out, whatever water comes out in that dissolved solids present is very less. And that is due to this electrolytic changes. This positive and negative, they have neutralized themselves, and because of that reason, now what is happening? You are getting more removal of dissolved solids, and the remaining dissolved solids is less. So that is electrolytic changes. Got it? Yeah, dirty skin layer. So these are the four, you can say, mechanisms by which treatment takes place in the filters. Clear till here? Clear? Okay. Now this is slow sand gravity filters. Like quickly understand this. Here, firstly, you have how much is the depth of sand. That much should be the depth of the water which is there. Secondly, if I talk it about here, you have gravel. Secondly, you have placed gravel at the back of it, okay, so that it can support the sand. Only function of gravel in slow sand filter is to support the weight of the sand. Now, here you will have a walls from which the water will come from the sedimentation tank into the SSF, slow sand gravity filters. Remember, it is very, very important and prerequisite that water from coagulation aided sedimentation should not come. Either you bring the raw water or either you bring water from plain sedimentation. But don't you dare to bring the water from coagulation aided sedimentation. SSF will not perform up to its efficiency. Okay, so it is very, very mandatory that you should know that whatever water you are bringing here, either you should bring the raw water or you should bring the plain sedimentation water. Coagulation aided sedimentation water is strictly prohibited. Okay, now I'll tell you the reason also. See, actually here you place finer layers, even finer as compared to the rapid sand gravity filters. In rapid sand gravity filters, the sand particles are relatively coarser as compared to slow sand gravity filters. Okay, and what happens in the case of slow sand gravity filters, if you use the coagulation water, it has chemicals, so it has much bigger solids. So that is the reason, and it will interfere with the functioning. So generally you don't go for coagulation aided sedimentation problem. Yes, aluminum hydroxide flocks will create a problem, and plus here you need to do cleaning rapidly, and there will be n number of functional problems which will be taking place. Now, here what you do, an inlet chamber will be there, how much from where the water will go, which is to be filtered. Now, this is, let us suppose 90 centimeter of water is to be filtered. Depth of the sand is also 90 centimeter. Whatever is the depth of sand, that much water you will allow it above it. You have gravel to support the sand, or you have drain pipes. Generally, you can see these drain pipes. Technically, they are placed inclined. And there are multiple drain pipes, which you can see it inside the screens. So, from this multiple drain pipes, there will be perforations from which the water come into the main drain. So, this is the main drain. So, this you can see it. And this is the main drain from which the water comes out. After that, here what you will have is, here you will check out the water which comes out. Now, either you can take it to the disinfection unit or you can supply it to the reservoir. Now, why don't we do disinfection? Generally, from slow sand filters, bacterial removal efficiency is 99% and all. So, it gives you a very high efficiency. Now, here what will happen as the water goes to the chambers near to the sand, mechanical straining, then sedimentation, biological changes, everything will take place as I told you. The water which comes out will be taken. Now, over the time what you will see, initially the head loss will be less. Over the time, the head loss will keep on increasing. Now, there comes the question that why it will increase. See, initially when water was coming through the sand was offering resistance. Water lost its energy, so the remaining energy was less. In the water, particles are also there, which is to be removed. Now, water along with the particles, now eventually over the time, the particles will be sticking on the sand media. So, initially only sand media was offering resistance. Now, sand plus the particle both are offering resistance. So, now water has to lose more amount of energy. So, the head loss will increase. If the head loss becomes 0.7 to 0.8 times the depth of filter media, what you need to do? You need to do the cleaning. Ma'am, how do we do the cleaning? Generally, top 15 to 30 centimeter sand, we place it of finer layer. In that also, we will just remove 1.5 to 3 centimeter layer of sand from the top. Ma'am, why only 1.5 to 3 centimeter? Because maximum impurities are trapped only in that layer. Okay, after that racks, you have it like this. You have racks from which you will remove. You will just take basically sand. You will do with the help of racks so that impurities are set free. Okay, and after that, so first for cleaning, you will use racks and you will remove top 1.5 to 3 centimeter layer of sand. After that, you will again start the filter, but you don't use the water for 24 to 48 hours. Why? Can anybody tell me that why don't you use it? Why don't we use it? Because smart stack layer is removed. So we have to give time for the smart stack layer to get formed. Okay, and that is the reason for the coming 24 to 48 hours you don't use it. Correct? Okay. Now, coming further, coming further in slow sand filters, backwashing doesn't take place. It takes place in rapid sand filters. Okay. So here you will see 98 to 99% bacterial removal efficiency takes place. Only drawback is rate of filtration is less. And one more drawback is area required is more. Now, minimum how many tanks are required? Minimum how many tanks are required? अभी मैं आई नहीं हूँ यार वो rapid sand problems. I don't know that why you guys interrupt in between for the things which I haven't taught. Negative head will come when I'll be teaching you rapid sand filter. Right now I'm teaching you slow sand filter. Two. Minimum number of tanks required is 1. Because the frequency of cleaning is 1 to 3 months. Total number of tanks required is 2. 1 for standby. Minimum number of tanks required is 1. Okay, minimum number of tanks required is 1 here and total number of tanks required is 2. Because generally in 1 to 3 months, just once you do the cleaning. Okay, so maybe possible in the whole 12 months, hardly 3 to 4 times you have to do the cleaning. Got it? So that is the reason. Okay, now this is just for your purpose. I'll give you an example for explaining this. If the example... Okay. Okay. If 800 meters square is the area. Okay. 800 meters square is the area. How much will be 800 meters square is the area? How much number of filters will you adopt? You will say 5 filters. Okay. Can you tell me the area of each filter? Can you tell me the area of each filter? Quick. Can you tell me the area of each filter? Quick, quick, quick. मुझे पता था ये करोगे किसी ने भी सही नहीं बोला क्या 40 कहाँ से आया मुझे समझ में भी नहीं आ रहा अभी तो 200 guys out of 5 filters 4 are working, 1 is standby. So why you are taking the area of the standby? Area of each filter will be 800 by 4. करेक्ट आपने किया 800 by 5 तो ये कितना आया था इसका 800 by 5 किया था तो कितना आया था 800 by 5 this comes out to be 160 ठीक है and here you did it it come out to be 200 meters square. So 160 is wrong. Why? Because you are considering the operation standby filters also, which is wrong. You have to consider only the operational filters. You have to consider only the operational filters. Correct? So that is the reason. Just make it short. Now what are the things who was saying it? चलो पहले clear कर देती हूँ. Possible negative head. कहाँ लिखा है? Positive negative head कहाँ लिखा है? मैं भी तो पढ़ूं. ये पॉसिबल नेगेटिव हेड. यार ये वाला नेगेटिव हेड की बात करो. देखो. See, you know, with time the head loss will decrease. With time the head loss will decrease. Increase. With time head loss will decrease or increase. With time head loss will increase or decrease. हेड लॉस बढ़ेगा कम होगा. बढ़ेगा कम होगा. Increase. Okay, it will increase. Now you want concentrate water, but what is happening? The head loss is increasing. So first you will measure it. How much head loss is decreasing? Decrease कर रहा है, negative हो रहा है. ठीक है. Now you have this adjustable telescopic tube. As the head loss will increase, you will basically lower this adjustable telescopic tube. This is adjustable, so that from here you get constant rate of water. Let us suppose you need to get water as 30 liters per second. Example. Okay, so what you do is you will adjust this, you pull it down, this adjustable telescopic tube, so that at constant rate you are getting water. How will you know that the head loss is increasing? By measuring the head. Okay, got it? So this is adjustable. What is the use of this adjustable telescopic tube? So that you lower it down and you get the water at a constant rate. That is the use of this adjustable telescopic tube. ठीक है, तो बता दिया. चलो. Now एक चीज जो एक छूट गई थी, somebody was asking, उसको complete कर देती हूँ. Somebody was asking what she said. आगे करना पड़ रहा है. Somebody was said about G and T ना. कुछ तो बोला था. क्या बोला था? कमेंट्स में ऊपर जाना पड़ेगा. Kalyan, what if we want large and dense flock? Then you will go for tapered flocculation. What is tapered flocculation? If you want large and dense flock, you will go for tapered flocculation. That means power is in your hands. You are supplying the power. So initially you will supply, you will keep the detention time less, such as G is more, TD is less. And afterwards in one tank only what you do, in one tank only what you will do, initially you will provide more G and less TD by keeping the water for a lesser amount of time. Okay, after that you will decrease the power, decrease the intensity of mixing and keep it for a larger amount of time. So this is tapered flocculation. You are tapering the power supply. So at the end what you said na, that you want what? You want dense flock and large in size, you will get it. Dense and large flock. Got it? And this is known as tapered flocculation. Clear, Kalyan? So you were asking that, na? So this is the one. So that type of flocculation is known as tapered flocculation. Chalo. Slow sand gravity filters, now rapid sand gravity filters. This is visible, right? This is visible. Rapid sand gravity filter. This is visible, right? दो ही बार use कर लेना. 2 times. Just taper is twice depending. Now how can I say that? That will depend upon the quantity of water which you are treating. 10 mld, 20 mld. Now you will say, ma'am, what is the length and width and depth of the tank you will use? So that will depend upon the quantity of water which you are treating. Now how can I say that randomly? Got it? I can tell you that you can alter the power supply. But how many times, that will depend upon the quantity of water which is coming, the amount of coagulant which you are mixing. That depends upon many factors. There is no hard and fast. Sometimes you make me feel. Okay, now check it out. Okay, so here you bring water from coagulation aided sedimentation. First of all, okay, here generally you don't use raw water or plain sedimentation. You can use it, there's no issue. But generally we use coagulation aided sedimentation. Here nothing is strictly prohibited. You can use them, but generally we use coagulation aided sedimentation water. Now what happens? Here are walls 1, 2, 3, 4, 5, 6. 6 walls are there. This is 5. This is 6. 1, 2, 3, 4. Correct? Now let's check it out. Firstly, you will open valve 1 and valve 4. The water from the inlet chamber will come here. Here, if you talk it about, sand will be relatively inferior quality as compared to that of slow sand filter. The size will be comparatively more as compared to that of the slow sand filter. And here, gravels will be there. Now what will happen? The water will come. The water will pass through the sand particles. Exactly same. Mechanical straining, sedimentation, biological changes, electrolytic changes will take place. After that, the water will pass through the gravels. From the gravels, lateral drains, from the lateral drains to main drains to filtered water will go to disinfection. In RSF, that is rapid sand filter, it is very mandatory that you pass it to the disinfection unit. It is very important. Okay, now after this, what you will do, it is going on. Here you have head loss indicator. If head loss becomes excessive in nature, that means now cleaning has to be done. Here, if you think that just remove the top layers of sand will help you, it will not. Reason is here, the impurities have penetrated even deeper. So just removing top 1.5 to 3 centimeter layer of sand will not be sufficient. So here we don't remove any layer of sand. Rather, what you do is you do backwashing. Is backwashing done only in slow sand, rapid sand filter and not in slow sand filter? Yes. Now what you will do, you will provide air compressor in case when desired height is not available for storing the water, in that air compressor is required. It is not mandatory that every time air compressor needs to be there. So whatever wash water storage tank is there for cleaning, we will supply water and we will put an air compressor. So what will happen? This water will be lifted up. Okay, from downwards it is lifted up. When this water goes from backward direction, what will happen? The impurities will set free. Okay, the filter media, the depth will rise, impurities will be set free, and here troughs are there. Here the troughs are there. Troughs like this are there. So from here, the water along with impurities will collect to the wash water trough. There will be an inlet chamber from where it will go to second valve and it will go to the wash water gutter. So initially you have first and fourth valve open. After that you have which valves open? 2, 5 and 6 valves open during the time of cleaning. So first it went to wash water gutter. First it went to this wash water troughs. After that, from valve number 2, it went to wash water gutter. Okay. After backwashing is done, generally you give slight time, 15-20 minutes for maturation so that smart stack layer is formed. And this is one of the reasons. See, there in slow sand filter, you were giving 24 to 48 hours for the development of smart stack layer. Here you are giving hardly 15-20 minutes for the development of smart stack layer. And more is the thickness of smart stack layer, more is the efficiency of removal of organic matter and microorganisms. So here you are not giving that much time. So relatively the efficiency for removal of microorganisms and all will be less. Since it will be less, that is the reason it is mandatory to have to take the water to disinfection unit. Clear? Now, the next thing which comes into action is done. You have cleaned the filter. Then what you will do is you will close it. Now you will open valve 1, but you will not start filtration. Now you will open valve 1 and you will open valve 3. You will close all the valves. Water will come. Again, still also some impurities are there. It's not necessary that all the impurities have gone to this wash water trough. So you will open the valve 1, they will do the clear, they will again straining and all, everything will happen. And then instead of going to the filtered outlet, it will again go to the wash water gutter. Now the filtration is taking place from top to bottom only, from sand to gravel, gravel to lateral drain to main drain. But rather than going for the outlet to disinfection, it goes to the wash water gutter. So that if any impurities are there, they will also, they will also what? They will also removed. After this is being done, then you will do what? Again start the filtration. So this is the whole procedure of rapid sand filter. Clear? This is the whole procedure of rapid sand filter. Now you know when this filtration will happen, head loss will be there. But we have found that the head loss of unexpanded bed and head loss of expanded bed is same. Can you tell me the reason why head loss of unexpanded bed and expanded bed is same? No. I'll tell you the reason for that. First tell me what I have asked. Head loss of unexpanded bed and head loss of expanded bed will be same. Why? Can you tell me the reason? If it is asked in MSQ statement wise, at least you should know. Come on. Because buoyant weight of the particles is not changing. Buoyant weight of the particles is not changing. Clear? That is the reason head loss of unexpanded bed and head loss of expanded bed will be same. So D 1 minus 1, G minus 1, Unexpanded. D is the depth of the filter media, N is the porosity, G is the specific gravity. Of unexpanded bed, D dash is for expanded depth, N dash is expanded porosity, specific gravity of the sand will remain same. They both are same. Head loss is same because the weight, जो buoyant weight है particle का, जो upthrust लग रहा है वो तो same ही रहेगा ना. That will not change. So here the head loss will not change. Correct. A darling Gaikwad. Correct. Okay. Now this questions related to this has been asked. Now, what Anwar is saying that, ma'am, it's obvious that when you are backwashing it, so the sand particles will be set free and the impurities will travel. Okay, so the sand particles may also travel. So, Anwar, the backwash velocity, okay, whatever backwash velocity is there and the settling velocity of the sand particles, we keep a check on both of them, first of all. Okay, so backwash velocity should be less than the settling velocity of the particle. First thing. Second thing, when you are doing backwashing, minimum, if D is the, if D is the depth of your filter media, minimum that wash water trough should be above D by 2. So that only water along with impurities can travel and sand will not travel. Okay, so your doubts I think is clear. So two things regarding one, the velocity, and the other thing is wash water troughs is placed at a depth minimum D by 2 so that only the water along with impurities goes but sand doesn't. Clear? Okay. Now one more thing. If you want to calculate the expanded porosity, that will be equal to backwash velocity upon settling velocity to the power 0.22. This is the expanded porosity which you take. Okay, this is empirical in nature, so you need to remember this. Fine. Now, let's solve this question. One more thing, guys. One more thing before I proceed. Generally, first of all, the rate of filtration of rapid sand filter is 30 to 60 times more as compared to slow sand filter. In slow sand filter, you require hardly 0.2 to 0.6% of filtered water. In rapid sand filter, you require 2 to 5% minimum of filtered water for backwashing. Why? Because when you clean it with clear water, right? When you clean your room, you clean it, when you do mopping, you do it with clear water, na? So when you're cleaning the filter, you will do for clear water. Now, example, if I need 100 liters of water for supplying it to the people, but out of this 5 liters you are taking for cleaning, so the water supplied to the people will be 95 liters. Will the demand of people be satisfied? Yes or no? Will the demand of peoples be satisfied? No. So that is the reason what you have to do is how much water you will filter plus the amount which is required for backwashing. Both you have to treat it. So the amount of water which is to be supplied to the people plus the water which is to be used for backwashing, both has to be taken care. Okay, because this question will be taking about that. If in the question, like in GATE, they have asked maximum questions in which if they don't give you backwash, how much water is used, don't take. If they don't give you backwash time, don't take. You don't assume yourself anything. Remember, everything, whatever will be given in the question, you have to take that. Okay. The size of particle matter for rapid and slow sand filter, which size you are talking about? The water in that, the impurity size or the size of the filter media? Just clarify that first. Now, a rapid sand filter is provided within an area so as to treat water for 2,75,000 people. Demand is given to you as 200 LPCD. Rate of filtration is given to you as 15 meter per hour. First is determine the number of filters for treating water with one standby. Come on. Answer. Determine the number of filters with one standby. Come on guys, quick. With one standby. Number of filters with one standby. Number of filters निकालना, पहले ये पता करो, number of filters निकालना, पहले ये पता करो, what is the quantity of water to be treated. See, अब एक चीज और, इसमें आप बताओगे, read the question properly. in this question, is anywhere they have mentioned that we have to design for MDD, maximum daily demand? Measure है, mention किया है? Come on, quick guys, we have many chapters. मेंशन किया है कहीं पर भी एमडीडी के लिए करना है? नहीं. कहीं पे लिखा है डिजाइन पानी का, डिजाइन वाटर डिमांड, नथिंग. नहीं. अगर गेट में, इन गेट, if they don't write MDD, you will not take MDD. Generally they say the design size, design, they say like that. Okay, so that time only you take, otherwise you will not take. अभी मैं यहाँ पे लिख देती हूँ design for MDD, just for your reference purpose. But अगर नहीं दिया होता, you won't have considered it. Fine. Now what is MDD? 1 point, हाँ, conventional आता, just put a note and write it down. That is different thing. 1.8 annual average daily demand. One person is required 200 liters. So 2,75,000 people will require how much? How much it will require? जल्दी करो. (99 into 10 raised to power 6 liters per day). This much water is required, but 5% of this water is also required for cleaning, for backwashing. So the quantity of water required will be how much? Quantity required will be how much? 99 mld plus 5% of 99 mld. How much it will come? 99 into 1.05. This will come out to be 103.95 mld. This is the quantity of water to be filtered. Correct? Now, I have to calculate the area. Total area if I talk it about. See, discharge is given to me 103.95 into 10 raised to power 6 liters per day. Okay, rate of filtration is given to me 15 meter per hour. Liters if you convert it into meter cube, 10 raised to power minus 3. Now, day what I will write? 24. 1 day is equal to 24 hours because nowhere they have given the time for backwashing. दिया है? तो अब मैं 23 लिखूंगी, 23.5 लिखूं. Shall I write 23 or shall I write 23.5? दिया है backwashing का. लास्ट लाइन देख लो, हर चीजें लास्ट लाइन में इंपॉर्टेंट दी रहती है. 30 minutes. That is, now here instead of 24 hours, what you will write? 23.5. ठीक है? So from here you will get the area in meter square. How much you will get? How much you will get? 103.95 into 1000. (294.89 meter square). Correct? Now, the number of filters, इतना ही आ रहा है ना? How, this much you are getting now? So, the number of filters which I require will be how much? 294.89. Area of one filter is given 10 into 4, that is 40. How much it is coming? Divide by 40. 7.37. So 7.37, that means 8 filters you require. But in the question deliberately they have mentioned that 1 filters for standby. मैंने पढ़ा था कहीं तो लिखा था with 1 standby. So if till here also they ask you, that means how many filters you require, guys? Total number of filters required is how much? 9. Correct, friends. Okay. तो क्या क्या पूछा था इसमें मुझसे? Determine the number of filters and compute head loss भी पूछा है. Head loss. Okay. Head loss, either you can use D1 minus 1, G minus 1 or expanded one you can use. Both will give you the same head loss. Now depth is given to you. The depth of the filter bed is, initial one is 0.6 meter. Porosity given है question में. Porosity bed की given है 0.5. Specific gravity given है 2.5 minus 1. Solve it. How much you are getting head loss? Solve me and tell me how much you are getting head loss. 0.6 मीटर. एक क्वेश्चन आया था गेट में, क्वेश्चन आया था हेड लॉस निकालना, कुछ तो नहीं. हाँ, there was one question which is asked in your previous year. In that expanded depth, bed depth was निकालना था, कुछ ऐसी. मैं बता देती हूँ before we move towards disinfection. I'll tell you the procedure. You can solve it if you haven't done it. This is expanded porosity. In that question, it has asked you to calculate the expanded depth. So it was d 1 minus n upon 1 minus n dash. Correct? Now, here in that question, d was given, n was given, n dash was not given. So n dash निकालने के लिए backwash velocity upon settling velocity to the power 0.22. So only thing you need to do that in that question, बस आपको ये formula and this formula you should know. You will solve it. Okay. Make sure that both the backwash velocity and settling velocity should be in the same unit. Okay. Both should be in the same unit. So substitute it. You will get expanded porosity. Substitute it here. You will get the expanded depth of the filter. That was the question which was asked in your gate. 0.45 मीटर है तो 0.6. दिव्या कैलकुलेशन मिस्टेक क्यों हो रही है बेटा आज? Why you are making mistakes in calculations? Okay. Clear? Is it clear everybody? चलो. Last topic of treatment, that is disinfection. अब 4 बजे से पहले we have to complete disinfection. हाँ कि ना, क्लियर है ना? ओके. चलो, खाना खा लिया, फिर अब तो मुंह से और आवाज नहीं निकल रही. अब तुम लोग मांगना ब्रेक. Had your dinner, had your lunch and still no voice. Time to break through and time to the head loss. I'll give clarity. First let me complete this. बीच में बोलूंगी, बाकी मेरे बच्चों को डिस्टर्ब हो जाएगा. डिस्प्लेसमेंट एफिशिएंसी का टॉपिक की बात कर रहे हो आप. Now, disinfection. Now, disinfection is carried out. It is the process for removal of disease-causing microorganisms, which you call it as pathogens. Pathogens, if you want to remove pathogens, are those microorganisms which are disease-causing. So, for the removal of pathogens, that is disease-causing microorganisms, you do disinfection. And disinfection is done by the disinfectants. Now, just tell me one thing. Is it possible that you can remove only those types of microorganisms which are disease causing? Is it possible? Is it possible, guys? Anwar, chao, mudho karao. No. Technically, we do sterilization and on that process, disinfection takes place. So technically we do sterilization, but on that process disinfection takes place. Correct? So here what happens? Here what is happening? Sterilization. Technically we remove all types of microorganisms. So in that process disinfection happens. Now what you can do? Simply you can boil it. Generally in at home what you do it whenever somebody fell sick, you give them boiled water so that you assume that the pathogens have been killed out. Okay. Next what you do is pathogens is killed out. Even you go for UV ray treatment. Okay, generally in swimming pools and all, you go for UV ray treatment. But whenever you are selecting any disinfectant, for the process of disinfection, you need two things. First, kills existing microorganisms, the present one which is there, and takes care of future recontamination. In future, if the water is polluted, in that case, you have to take care of it. Two things are being required. So now, first it is killing the boiling or you do UV ray treatment. They will kill the existing microorganisms, but they will not take care of future recontamination. Similarly, one more thing is you can do ozone treatment. In India, subcontinent, we don't go for ozone. Only in Chandigarh, ozone treatment is done. Otherwise, we don't. Now, ozone, what happens? Here, this nascent oxygen is there. This is highly reactive and highly unstable. The thing which is very reactive is definitely unstable in nature for sure. So, this nascent oxygen will kill all the existing microorganisms and it will go. Highly reactive, highly unstable, but it will not take care of future recontamination. That means if in future the water is polluted, it will not take care of it. Clear? So ozone does this function. Similarly, you can go for copper, silver and all, but they are toxic elements. That's why you don't use it. You can use acids and alkalis, but for acids, the pH is less than 3. For alkalis, the pH is greater than 11. See, disinfection is the last treatment. After this, you don't give any treatment to water. Okay, so make sure whatever the treatment you give, the pH should be in the range of 6.5 to 8.5, because after this you will not get any turn to increase or decrease the pH. So this is the last treatment. Okay, now out of all the ones we go for chlorine, because chlorine will do both the functions, kill existing microorganisms and take care of future recontamination. Now check it out. Chlorine, when react with water, it forms hypochlorous acid. This is highly reactive, 80 times more powerful as compared to hypochlorite ion. Now, ma'am, if pH is less than 5, chlorine will not function at all. It will remain as molecular chlorine only. Okay, so hypochlorous acid. Hypochlorous acid, when pH is greater than 8, it will form hypochlorite ion. When pH is less than 7, it will be hypochlorous acid only. So you can say pH less than 5, it will be what? Chlorine only. pH 5 to 7, it will be hypochlorous acid. pH 7 to 8, it will be hypochlorite ion. pH greater than, this will be hypochlorite ion and hypochlorous acid. And pH greater than 8, it will be only hypochlorite ion. So HOCl is so reactive. The moment it will form, it will kill all the existing microorganisms. It will kill all the existing microorganisms. So one thing is done, killing all the existing microorganisms. But ma'am, you told to take care of future recontamination. Yes, the chlorine which will be there, it will react with ammonia and it will form monochloroamine. That time the pH should be greater than 7.5. If pH is from 5 to 6.5, it will form dichloramine. If pH is less than 4.4, it will form trichloramine. If you talk about the efficiency of dichloramine is more as compared to monochloramine and as compared to trichloramine. So here if you talk it about, the one thing, this is the component which is responsible for future recontamination. So if in future, if recontamination take place, this dichloramine will take care of it. Got it? So present existing will be by HOCl and future recontamination will take care by dichloramine. Got it? Clear? So that is the reason we use chlorine. Already written to you. Now, one more thing, after this, generally we use this chlorine only in Indian subcontinent, we go for this. Out of this, if I want to calculate the disinfection efficiency, so this you can get it by Chick's law. What is Chick's law? It is number of microorganisms at any time t. First of all, it follows first order kinetics. See, at t is equal to 0, if number of microorganisms is n naught. And at t is equal to t, the number of microorganisms is nt. So what will happen? Number of microorganisms at any time t is equal to n naught e to the power minus kt. And if it is asking you how much percentage removal of microorganisms has taken place, initial minus final divided by initial into 100. This is the. Got it? Sure. Now, let's do this question. Let's do with this question. An influent at a flow rate of 2670 meter cube per day from a sewage treatment plant, usko disinfect karna hai. Already they have given you this relation they have given you. That means K they have already given to you. It is asking you the volume to achieve 98% kill of microorganisms. Technically it is asking you volume. That means it is asking you discharge into time. Discharge is given to in the question, time is not given. So you have to just calculate the time. How much will be the time? Nt is equal to n naught e to the power minus 0.145 t. Now how much? 98% killing. If 98% of the microorganisms are being killed, how much is the microorganisms remaining? If 98% is killed, how much is remaining? 2%? Take log on both the sides. Tell me the value, guys. Log e basic. Come on, tell me the value quickly. Minute में आएगा. Ma'am, how you know it will come in minute? Because here they have already given that t is in minute. Come on, calculate and tell me fast. Divya, Saurabh, Prince, everybody. Quick. 26.97 minutes. Saurabh, calculation mistake. 26.97 minute. Now 1 day is equal to 24 hours, 1 hour is equal to 60 minutes. So that minutes and minutes cancel. Now come on, tell me the volume. Come on, tell me the volume. $50? $50 it is coming? 50.0244. ठीक है, अगर asking in integer then 50 meter cube. Correct. चलो. So with this, guys, come tomorrow soil mechanics marathon, as I've already said, and now we have completed one more chapter, that is disinfection. This completed, this completed. One more small things I have to tell you. Like they have not asked this, but dose of chlorine. Dosage of chlorine is how much? How much? Dosage means applied chlorine is demand of chlorine plus residual chlorine. Demand whatever is there plus residual chlorine. This is the dosage of chlorine. Correct? So how much is the demand plus how much is the residual? Correct? कुछ खा लीजिए. Oh my God, thank you for asking, Yogesh. किसी ने तो पूछा but मैंने खा लिया. Thank you for asking. Clear? तो कभी भी पूछे residual chlorine. Generally, when you do, I'll tell you quickly. Plain chlorination is when the water is comparatively pure, turbidity वगैरह बहुत कम है, turbidity is very less, just supply, no need for any treatment, just chlorine, supply it to the people. If let us suppose the water is highly turbid, highly polluted, then you need to do chlorination 2 times. That chlorination, firstly, pre-chlorination you do it. Pre-chlorination is always followed by post-chlorination. So first pre-chlorination will be there, and then pre-chlorination will be there, and post-chlorination is the last treatment which you give. Generally, at the last, after filtration, we give the disinfection. So that is post-chlorination. Very important. Pre-chlorination is always followed by post-chlorination. Vice versa is not true. Post के लिए pre होना जरूरी नहीं है, but pre के लिए post होना जरूरी है. If pre-chlorination is there, then post-chlorination has to be there. When post-chlorination is there, it is not mandatory that pre-chlorination is there. ठीक है. After that, what happens? Double chlorination. When you do pre and post-chlorination both, 2 times chlorination, you call it as double chlorination. Super chlorination in case of epidemic like COVID time and all. Generally, or let us suppose in a place when jaundice and all has been spread a lot, basically to a lot of people. In that, deliberately you add more amount of chlorine. Ma'am, how much more? 5 to 15 mg per liter. Such that after a contact period of 10 minutes, 1 to 2 mg per liter should remain residual. That is super chlorination. And ma'am, if chlorine is in excess and we don't require, do dechlorination. Okay, there are n number of elements, n number of compounds which will remove the excess chlorine. So do dechlorination. Okay, and residual, how much we keep for residual? And they will tell you. They say, Anwar, you will say that how much food should remain. How much food I should make, that how much should remain. I'll tell you, make whatever food you want such that out of 2 people's stomach, the food should remain. So similarly, any amount of chlorine dose you apply it, make sure that after a contact period of 10 minutes, 0.2 mg per liter should remain. That is the dose which you provide. Clear? Clear? आ गया समझ? So dose is demand plus residual. Chalo. Now shall we start with the chapter, last chapter for completing the raw water treatment? Shall we start? Shall we start last chapter? Chalo. For this one, अब इतना सारा बच्चा है यार. चलो. Distribution and conveyance system. Okay. Let's start. Distribution and conveyance system. मैं बहुत देर से बैठी हूँ, मैं थोड़ा खड़ी हो जाती हूँ. रुको. I'll remove. मैं हेड से छुप तो नहीं रहा. Okay. Fine. So now let's start. आज भी 10 बजेगा? नहीं यार, 10 नहीं बजेगा. कल 10 बजा था क्या अनवर? आज नहीं बजेगा. मैं बजने ही नहीं दूंगी 10 को, मैं उससे पहले ही करूंगी. चलो. Okay. Now we will talk about the layout of distribution network. Now we will talk about the layout of distribution networks. Here we will have अलग-अलग तरीके से, by different ways you will be supplying water to your homes. Dead end system is there, grid iron system is there, radial system is there, ring system is there. Networks. Method of distribution. अब distribute कैसे करते हैं? By gravitational system. Like you have seen that service reservoir, पानी का टंकी, overhead tank. From there water will move to your homes under the action of its own weight. That is by gravitational system, water will move under the action of its own weight. Pumping system is, let us suppose the service reservoir is there, but water has to be supplied to a higher elevation, that is on the hillside. So what we will do, we need to do pumping. Okay, we need to do pumping. Correct? So you have to do pumping. With the help of pumps, you will take the water to the higher side. Now, the ones you will say, ma'am, which we more often used, that is combined gravitational and pumping. So what will happen here in this combined gravitational and pumping? From the treatment plant, you will pump the water and supply it to the service reservoir. From the service reservoir, the water will move under the action of gravity and will be supplied to your homes. So that is what is combined gravitational and pumping system. Okay. Now, how the layout is being taken care of? This is dead end system. No need to apply your brain in this system. Main pipe is running. Okay. Then you have here sub-main pipe is there and branch pipe is there. Main pipe, take the connection to your homes. You also want connection, take the connection, go to your homes. This is the thing which happens. So no brain you need to apply, nothing you need to do. Main pipe is there. These are valves. I'll tell you about this later also, but just small thing I'll tell you right now. That gate valves are used to regulate the flow of water. Correct? Now here don't apply any brain. Bas main pipe, from there pipes are there. Sub-main pipes are there and lesser number of valves are required. Sub-main pipes, branch pipes, supplying it to your homes, go. So here large number of dead ends are there. So water gets accumulated. And if water gets accumulated, you know diseases and all take place, stagnated water, all those things will take place. Okay. Apart from that, what will happen if, let us suppose in this place, outbreak of fire takes place. You don't have any other way through which you can supply water. And let us suppose if in this place the pipeline has become faulty because of which water cannot be supplied, you don't have any mechanism by which you can supply water here. You can divert the water from any other direction and you can supply it here. So that is the drawback. Advantage, simple, easy, no skilled supervision, lesser number of valves required. That's it. But this has been old systems and all you used to do it. Since it is expanding like trees, you call it as tree system as well. So dead end system is also known as tree system. Next one is this one. Can you tell me what is the system? Grid iron system. There is one more name of it is reticulation system. This has been asked in assistant professor examination. Reticulation system is also known as, that is grid iron system. Okay. Now what happens here? Main pipe is running in the center and the sub main pipes is running around the main pipe. Okay, now these submain pipes are there, and then from submain pipes you have lateral pipes, and from lateral pipes it will be supplied to your homes. Now you will say, ma'am, this is so complicated. Yes. And see how many number of valves are required. Each and every place. Here check it out how many number of valves required. And check out the number of valves required here. So less the number of valves are required in the case of grid iron system, or more as compared to dead end system. Costly, and moreover, you cannot use it anytime you want. You need to have a proper layout of that planned city. This you cannot use it for a city which is not planned. This you use it for a, like Chandigarh is the first planned city of India, and there you will find this grid iron system. So this is the system which you will apply only for planned cities. Got it? So these are this. So now all the drawbacks of dead end system will be eliminated here. See? There is no dead ends, so no water will be stagnated. Now, if in this place you are not getting water, so from here, if let us suppose the supply was coming, you will divert it from this side, you will divert it from this side. So in case of failure of pumps, in case of outbreak of fire, you can get the water. There is no issue for that. Correct? So that is one of the things which you can take care of. Now, next one is here. This one is your dead end I have told you, grid iron I have told you. Now this one is your ring system. You call it as circular also. Exactly like grid iron, only changes in the previous one main pipe was running around the center. Okay, in this main pipe is running around the outer periphery. It is running around the outer periphery. Check. Outer periphery. This is the main pipe. This is the main pipe which is running around. Clear? So now from main pipes, sub-main pipes, and exactly same. More number of cut-off walls, but no dead end. So all the advantages you have of grid iron, similar is for this one. Okay? So if you want in case of outbreak of fire, you can divert the water. Exactly, you can do each and everything. Now, the last one is your radial system. Radial system, now if they tell you that if an area is there which has large number of radial roads emerging from the center, identify the layout of distribution network. What will you apply? You will go for radial system. So when large number of radial roads is coming, in that case you will go for radial system. What you do is, you will place that pani ka tanki, distribution reservoir or service reservoir at the center. Okay, and from this the water will be supplied to the various, because obviously the pipeline is in the same direction as the direction of your roads. So from here you will supply it to all the radial roads. See here, second distribution reservoir, third distribution reservoir. So everywhere you will be supplying it. Got it? But this is costly. Sasta nahi hai. This is costly. Got it? So where there are large number of radial roads emerging from a point, you will go for radial system. Clear? So these are the 4 types of layout of distribution networks. Any doubts? Any doubts? ये टेबल नीचे हो गया, मेरी हाइट बहुत ऊपर हो रही है. क्लियर हुआ? Is it clear? मेरी चेयर लानी पड़ेगी. Is it clear? Yes or no? तुम लोग सो रहे हो क्या? चलो, सो रहे हो कि नो मैम, कि क्लियर के लिए नो मैम? चलो. Okay, now we will calculate. You remember I told you in service reservoir, right in the first chapter, neither we design it for MDD, neither we design it for MHD. We design it for volume. So 3 types of things are there. First is balancing storage or equalizing storage. Second is breakdown storage. Third is fire storage. Fire storage, I have already told you, Kuchling's formula, Freeman's, National Board of Underwriters, Bustons, and as per IS code. So that topic we have already discussed. Breakdown storage, generally we take it around 25% of the total storage capacity, or we take it in terms of average hourly supply. Balancing storage or equalizing storage is being asked. That is, what happens? See, this is time. Now, this is the supply is constant. Okay. But my demand varies. Sometimes my demand will be more than the supply. Sometimes my demand will be less than the supply. My demand is fluctuating, but the supply is constant. So how much water should be supplied to you such that your variable demand can be balanced? That is known as balancing storage. So to balance the variable demand against constant rate of water supply, that is known as balancing storage. So what you do, see here, you will take this ordinate as A and you will take this ordinate as B. So here what is happening? Demand is more, supply is less. So here demand is more, supply is less. So what will happen? Depletion will happen or accumulation will happen? Demand is more, supply is less. Depletion will happen or accumulation will happen? Depletion will happen. Very good Anwar, very good Shravan. Depletion will happen. Depletion. But I will take the maximum value mod because otherwise positive and negative will get cancelled out. That means demand will be more and supply will be less. So CD is for cumulative demand and CS is for cumulative supply. So maximum depletion will be cumulative demand minus cumulative supply. And here supply is more, demand is less. So here maximum accumulation. Supply will be more, demand will be less. Clear? So the balancing storage will be how much is the depletion plus how much is the accumulation. Mod. Otherwise positive and negative will cancel out. Clear? Now if you want to detect leak, see if it is sand and all and in the pipes if you see in everywhere it is dry but some places you are getting wetness, obviously you will see that this place leakage is taking place. Sounding rods are there by which what you can see, you can hear the sound of water. Okay, so with that also you can know that whether leakage is taking place or not by plotting hydraulic gradient line. So you plot the graph and if kink comes, you just plot it and if anywhere kink comes, drop comes, that means leakage is taking place. Or you can use waste detecting meters and with the help of which also you can calculate, you can detect the leakage. So right now in everywhere in India also due to the smart city concept, we are going towards underground distribution pipes. So in that cases, when you're using underground distribution pipes, time to time inspection has to be taken care that whether leakage is happening or wrong. Okay, so if leakage is happening, you need to just rectify it, change it, repair it. So that is the reason by these ways you can check it out if leakage is taking place in the underground distribution pipes. Got it? Now, the last and the important thing, important for GATE ESC, because in GATE also they can ask in match the following or in statement wise or in MSQs questions. And in the case of this one, other examinations also it has become very important. Now listen to me. Pipe appearances. Appearances is essentials. Like if you talk it about for boys, some things will be very essentials. For girls, where some things will be essentials, like your earrings, your clothing, your sandals. These are essentials for you. Okay, for your maintenance, for your maintenance and all you require. Similarly, if you want efficient flow to take place through the pipe, some essential things are required. Okay, so if you talk it about, first thing is sluice wall or gate wall or cutoff wall. All three means the same, so kindly remember it. Now listen to me. They can ask you in statement wise also, huh? किसको repeat करूं? Okay, पहले breakdown storage को. See, breakdown storage, what happens when let us suppose failure of pumps takes place. Emergency happens. Okay, you require water for that conditions. Let us suppose the amount of water which was coming from the treatment plant to the distribution reservoir, that a big fault came. Now water will not be coming, but water has to be supplied for you guys. So for those reasons, the water has to be stored. That is known as breakdown storage. So generally 25% of the total storage capacity of the reservoir, this much amount of water you keep it for breakdown storage. Got it? Now is it clear? किसने पूछा था? और मैं ये भी लिख देती हूँ 25% और 1.5 to 2 times average hourly supply. This is the amount you keep for breakdown storage. क्लियर छे? कहाँ चला गया? किसने पूछा था? गुड इवनिंग अभिषेक. क्लियर प्रकाश खान? चलिए. फाइन. अब इसको ध्यान से सुनना, लिसन टू इट केयरफुली. इट इज 5-7 मिनट्स टॉपिक मैक्सिमम, कंप्लीट हो जाएगा. नाउ लिसन टू मी. गेट में कितने आएंगे वो तो पता नहीं अमितेश, बट इतना तुम मुझसे रिटर्न में ले लो. 2021 से 2023, that is from the time this MSQ has been introduced, not even a single year is there that questions from environment MSQ is been asked. हर साल पूछा गया है. Every year they have asked MSQ from environment. From any subject they ask or not. But from 2021 till 2020, from the time this MSQ has been introduced, 3 years, all the years they have asked MSQs from environment. Got it? Now let's check it out. Here, if you talk it about gate valve. Now, gate valve is generally placed at the summit point. You call it as cutoff valve. You call it as sluice valve also. What is the function? It will regulate the flow of water. Now, what happens when you want to do the cleaning of the pipes? You need to stop the flow of water. When you stop the flow of water, water hammer pressure comes into action. And for basically protecting the pipe from that, you need to do what? You need to have gate valve. Now, the next question comes, ma'am, why the gate valve is placed on the top? See, generally, if you take this as datum, so this as datum, so the datum head will be more and the pressure will be less on the summit points. Okay, or summit means topmost point, crest point. So at top points, the pressure is less. If the pressure is less, they can use comparatively cheaper material. If large pressure is there, of course, they have to use a very high quality of material, and high quality comes with expense. Okay, so the logic is you place them at the summit point, so the pressure will be less, so the materials they can use it of relatively cheaper quantity because they don't have to overcome a large amount of resistance. Correct. So that is the that is the reason you place them at the summit points, so that the amount of pressure to be resisted by them is less. And what is the function of gate valve? That is to regulate the flow of water. Okay. Now what you can do is you will regulate the flow of water. One thing which you are doing it. Now what will happen is ma'am, but in gate valve you have provided at the summit point so that less pressure will be there. So you can provide any material. No, it's not that you can provide any material, used cast iron or any those things which will have decent resistance. Okay, you can go for that. You don't want a very high resistance because that much pressure will not be coming on the top. But still, you should provide a durable quality of material. Now, air valve. Technically, they write air valve, but let me tell you, there are two types of air valve. Can anybody tell me the name first? Just tell me the names, then I'll tell you. Can anybody tell me the name of air valves? Quick. Two types of air valves are there, I've already taught you. Come on, guys. ये वीडियो प्राइवेट तो नहीं होगा मैम आफ्टर क्लास. सोचा तो मैंने है कि प्राइवेट कर दूंगी. किसी को नहीं पता. इनलेट आउटलेट. चलो. Air release valve on the upstream. Now they can ask you this. Air release valve is placed on the upstream side of gate valve. Air inlet valve is placed on the downstream side of gate valve. पता तो होना चाहिए placement. You should know the placement of it. So air release valve is placed on the upstream side and air inlet valve is placed on the downstream side. Now what happens is, now listen to me very carefully. 2 minutes concept है, ध्यान से सुनना. Listen to it carefully. Yeah. देखो. You design pipe to resist the pressure of water. You never design it for air. Okay. Now, if along with the pressure of water, if the pressure of air comes, and this pressure, the total pressure exceeds the designed pressure, what will happen? Can you tell me what will happen? What will happen? The pressure of air and is also coming with the pressure of water and it exceeds the design pressure, a predetermined value. What will happen, guys? Quick, थोड़ा सा तो दिमाग लगा दो. प्रेशर बढ़ रहा है, क्या होगा? Pressure is increasing, what will happen? किसी का भी आंसर नहीं आया भाई। प्रेशर अगर ज्यादा लगाया क्या हो, बैलून में फूक मार रहे हो, यू आर जस्ट पुटिंग एयर इन द बैलून, इफ इट एक्सीड्स द कैपेसिटी व्हाट विल हैपन? ब्रेक, ब्लो आउट। फेलियर तो होगा बट कौन सा फेलियर होगा? 5 फट जाएगा। फटने को क्या बोलते हैं? फटने को क्या बोलते हैं इंग्लिश में? वेलोसिटी कम, जो भी सब बोल दिया, फटने को क्या बोलते हैं? फट जाएगा, हाँ इसने बोला सही, श्रवण ने, बर्स्टिंग फेलियर विल टेक प्लेस, बर्स्टिंग फेलियर, ये वर्ड सुनना था। So if the pressure is becoming more than the predetermined pressure, bursting failure will take place. And if you don't want this bursting to take place, that is the reason you have installed this air release valve. So what will happen if the pressure exceeds? Automatic valve होता है, ठीक है, ऑटोमेटिक इन नेचर है, इट विल ओपन, इफ सेट करके रख दिया आपने, यू हैव सेट इट आउट, सो इफ इट exerts more pressure, that valve will open automatically, the excess air will release, and after that the valve will close. So it is automatic in nature. Now similarly, listen to me, this also you will answer, I will sit, I will not answer at all. Now here it is air inlet valve. Now let us suppose you have stopped the flow of water, gate valve से आपने stop कर दिया. Now पीछे से पानी उसको पुश कर रहा था, from the back water was pushing the front water to move. Now from the back no energy is coming. Okay, now how the water will move? How the water will move? Energy नहीं दी आपने, you have closed the gate wall, now the water is not coming, how the water will move and what type of failure can take place? Both the answers I want. Come on guys. कोई एनर्जी नहीं मिल रही है, नो मोमेंटम, नथिंग इज देयर, हाउ इट विल मूव? बताती हूँ, पता नहीं होगा. नो एनर्जी, नो मोमेंटम, नेगेटिव प्रेशर विल डेवलप. नेगेटिव प्रेशर, एनर्जी नहीं मिल रही है. In this case, if you don't compensate this negative pressure, cracking of the pipe will take place. So in air release case, bursting failure was taking place. In air inlet valve, if you don't provide it, cracking failure will take place. Basically crushing बोल सकते हो आप इसको, will take place. Why? Because negative head will be developing. Okay, so what will happen if such conditions, if you close the gate valve, automatically this air inlet valve will open and it will allow the atmospheric air to go into the pipe. Okay, such that it will compensate it, make the negative pressure at 0 and that valve will close automatically. So here first case bursting failure and here it is crushing failure. Clear? Understood? Bursting and crushing. So here for air, now they can ask you, air release valve is provided to prevent bursting failure. True. Air inlet valve is installed to reduce crushing failure. True. Air release valve is placed on the upstream side of the gate valve. True. Air inlet valve is placed on the downstream side of the gate valve. True. Correct? So they can ask you anything regarding it. Blow valve, drain valve or scour valve, generally you place it on the downstream side. This is manually operated. This is not at all mechanically operated, because whenever you need to do the cleaning, what you will do, you will stop the flow of water, open this valve so that the water, instead of going in the forward direction, it goes here and you remove the impurities. Okay, so you call it as blow off, drain valve or scour valve. Clear? Last is one more, check valve. You call it as non-returning valve. Generally what happens, guys, whenever like you switch off the pump, what happens? The water tries to move in the backward direction. Correct? So in that cases, you don't want, otherwise it can damage the pump. Generally the water is flowing through the pump, but when you stop the pump, what will happen? The water will try to move in the backward direction. So you don't want the water to move in the backward direction, otherwise it can cause failure of the pumps. So that is the reason you install this check valves on both on the upside and downstream side, so that it does not cause the damage to the pumps. So, and also it allows unidirectional flow of water. It will not allow backward flow of water. So, for that reasons, you install check valve. So, these are the most important valves which I have told you. Any doubts? Any doubts? Suction of water from tank, but that priming and all. Clear? चलो यहाँ पे मैं लिख भी देती हूँ आपके लिए bursting, यहाँ पे crushing. Clear? ऐसे में तो पायलट like butterfly valve is there, globe valve is there. Like if you talk about butterfly valve, if you talk about globe valve, they also their function is same, that they will regulate the flow of water as it is done by gate valve. But the difference is their mechanism is different. काम same ही है, काम same है, that will regulate the flow of water, but the function is different. Basically working is different. Function same है, working is different. Clear? अब किसी को कोई भी डाउट है? विद दिस वी कंप्लीट रॉ वाटर. एनी डाउट? तो मैं लिख देती हूँ. नाउ वी आर स्टार्टिंग विथ वेस्ट वाटर. एनी डाउट स्टिल हियर? एनी डाउट? किसी को कोई डाउट? चलो फिर. नाउ वी विल स्टार्ट विथ वेस्ट वाटर क्विकली. एक बार मैं टेलीग्राम पे भी डाल देती हूँ. कम ऑन. अब आएगा बीओडी टीएचओडी. दिस ईयर मतलब दुनिया में कुछ भी हो जाए, द थिंग विच दे विल आस्क यू एवरी टाइम इज बीओडी सीओडी. पिछले साल भी पूछ लिया था आफ्टरनून सेशन में. सो दे विल बी आस्किंग यू बीओडी सीओडी फॉर श्योर. ओके, दे विल बी आस्किंग यू बीओडी सीओडी फॉर श्योर. तो वो पूछेंगे ही, चाहे कुछ भी हो जाए. नाउ आई हैव शेयर्ड इट. नाउ लेट्स स्टार्ट. Okay, now let's start. ASP activated sludge process. वो तो हाँ, फोर एक तो activated sludge process, एक BOD. They will ask for sure. Or and this time from the last 5 years, if you check the pattern, they have started to ask, means every year without any delay or without any forgetness, they ask every year one more thing, and that is what solid waste management air pollution. They will ask you types of primary air pollutants and secondary air pollutants, but it is sure that they will ask you for sure. So now let's check it out. Let's check it out. Wastewater treatment मैंने check कर दिया है. And now let's talk it. Hardness इतना मतलब हर साल नहीं पूछा है, but activated sludge process, BOD, and solid waste management and air pollution. Initially, a sedimentation tank, that D square upon 18 new formula, almost every year they were asking, and filtration, either of them two, or MPN alternate years or sometimes regular years. Now they have moved towards solid waste management, air pollution. चलो, this कितना अच्छा लगता है ना, ये completed this. Now we are left with wastewater characteristics. Now we will talk about wastewater characteristics quickly. First of all, sewage or wastewater. हालांकि there is slight difference between them, but you call it them same. What is sewage? Sewage is a mixture of water and liquid waste, which is depending upon domestical activities, industrial activities, it is being generated. Generally in the sewage, 99.9% is water and 0.1% is solid. Okay, 99.1% is water and 0.1% is solid, even lesser than that. Now, domestic sewage, if it is generated due to domestic activities, you call it as domestic sewage. If it is generated due to industrial activities, you call it as industrial sewage. And if, see, from whatever rainfall is taking place, in rainfall, the water infiltrates, evaporates, interception, this depression storage, out of all of them, after that, whatever water which flows on the surface, that is known as drainage or runoff. That is known as drainage or runoff. Now, listen to me very carefully. In domestic sewage and industrial sewage, generally the solids which are there are organic in nature. In drainage and runoff, the solids which are there are sand silt particles. So, they are inorganic in nature. Okay. And domestic plus industrial sewage, you call it as sanitary sewage. Okay. Now, moving further, sewers are conduit or pipes which will carry the sewage from one point to another. That is known as sewers. Sewerage system is the bringing them, distribution, collection, conveyance, everything, the whole processes which you adopt, that is known as what? Sewerage system. So sewers are pipe which will carry the sewage from one place to another, and sewerage system is basically you convey the pipe, distribute the take the sewers to the distribution system, basically to the water treatment plant. Everything will be done by the distribution by the sewerage system. Correct? Conveyance, transportation, disposal, everything. And that system is known as sewerage system. Now here you have different types of sewerage system. First you have separate one. You know obviously that the sewage systems right now are placed below the ground level. Okay, if the water pipes moves like this, that means raw water treated, it's supplied to you. This is water pipe. So going to your homes, you will convert it, you will drink that water, it will be converted into wastewater. That wastewater will be going here. So generally, when you have two different pipes, okay, when you have two different pipes, one pipe is for the drainage runoff and one pipe when you have it for sanitary sewage. When you have two different pipes, okay, that time you call it as separate system, because you have provided two different pipes, okay, drainage and sanitary sewage. Ma'am, why you have provided two different pipes? What is the logic for this? I'll tell you. See, in drainage sand silt particles are there, in sanitary sewage organic particles are there, and organic particles without treatment you can't dispose it. Ma'am, why? If we'll dispose it, what will happen? See, wherever organic matter will be there, microorganisms will attack. If you dispose it without treatment, if you will dispose it on the land, microorganisms will come, and if microorganisms will come, they will start to utilize oxygen from the atmosphere. If you dispose this sewage on river without treatment, microorganisms will go into the river. It will use the dissolved oxygen for the rivers. For aquatic animals, there will be no oxygen left. So that is the reason sanitary sewage organic in nature, drainage inorganic. So drainage water, if you will not take it on the treatment, it's okay, and it will save your money also, because if drainage plus sanitary sewage is coming, you have to install a bigger treatment plant, bigger treatment units. But now if drainage water simply gives sedimentation and treatment and all, and dispose it, because in that majority inorganic particles are there. But sanitary sewage you have to give n number of treatments. So that is the reason in separate system the burden on the treatment units reduces. Now if I talk about combined system. Ground level is there. Water pipe. Here you just provide only one pipe. Drainage plus sanitary sewage, you will provide only one pipe. So the dia will be more or less in comparison to the combined separate system. Obviously more, because your drainage water is also coming and sanitary water is also coming. So it will be more. Generally drainage water is 20 to 30 times more as compared to sanitary sewage. 20 to 30 times more as compared to sanitary sewage. Getting it? 20 to 30 times. Imagine. So how much bigger dia pipe is required. And you know what? Every time you design it and every time it fails. Fails in a sense, guys, if you are having combined sewerage system in your locality, and if during rainy season, if you are able to see the sewage flowing on your streets, that means it is the failure of the engineer. Because rainwater is something which you cannot predict. Yeah, you are just taking the data, designing it, but that is still something which you cannot predict. So that's why I'm telling you design combined sewer, but still it fails, and that failure, when you can see that litter and shit spreading on the roads, and it is flowing on the roads. So that combined sewerage system. See, technically for having entire basically proper drainage pipe and proper sanitary sewage, it's not practically possible, because water in your rooftops and all, that is also rainwater only. Water in your courtyards, verandas is also what, drainage water only. But it is not possible for the pipeline to collect all the water from your homes also. So what they do is instead of that, what they do, we go for partially separate system. Partially separate system is whatever water is there in the rooftop of your houses and all those things, we will allow it to mix in the domestic sewer. We will allow it to mix it in the domestic sewer. That means we will allow them to mix it in the sanitary sewage. All other water which is flowing on the roads and streets, that we will take out in the that we will take out in the drainage. So what you did in the partially separate system, what you did in the partially separate system, what you did, two things you did. First, whatever water is there in your verandas, courtyards and all those rooftops and all, you allowed it to mix with the sanitary sewage. And the remaining water which is flowing on the roads and all, they will flow into the drainage pipe. So that is known as partially separate system, because completely you haven't taken all the water and provided into the drainage pipe. Got it? So that is what partially separate. In India, if you will ask me, ma'am, which is the one which we majorly use, combined. Everyone have their own disadvantages and advantages. See, in separate system, you need to have two different pipes. So excavation and all has to be done accordingly. Combined pipe, one pipe is only there. In congested areas, you cannot go for separate system. But in combined system, the burden on the treatment units will be more. So both of them have their own advantages and disadvantages. Got it? Okay. Now, see this combined sewer. Houses, industrial water, everything, even drainage water is coming. Clear? Now we will move towards the quality parameters. Now, whatever we studied, suspended solids, turbidity, everything which we have studied, copy paste here also it is valid. Copy paste here also it is valid. So you guys didn't have doubt there, yes? You guys didn't have any doubt there? Yes or no, guys? In the previous case, I have already taught you suspended solid, dissolved solids. So I guess you don't have any doubts there. Yeah? Yes or no? I'm asking you just once. No doubt there, right? Okay. Now just one thing I'll tell you. In the case of solids, what I have studied, suspended solids, dissolved solids. Yes, everybody, we have studied only two types of solids, suspended solids, dissolved solids. Here you will study four types of solids. Settlable solids, suspended solids, colloidal solids and dissolved solids. So settlable solids, suspended solids, colloidal solids and dissolved solids. Four types of solids are there. Now, if you will ask me suspended solids, how I have to measure, I have told you. Dissolved solids, how to measure, I have told you. Settlable solids, here, there is a cone. This has been asked in your other examination. The cone which is used for the measurement of settlable solids is Himhoff cone. This is again a calibrated cone is there. So what you will do is, you will bring the sewage for which you want to calculate the settlable solid, pour the sewage in this Himhoff cone, leave it for a certain duration of time. After that, just measure how much suspended solids have settled. So you will be able to see the suspended solids settling at the bottom. Just check it out how much is the concentration of them. So this is known as settlable solids. So for calculation or for computing settlable solids, the cone which is being used, that is known as Himhoff cone. Clear? Now, settlable solid size is greater than 10 micrometer. Suspended solid size is greater than 1 micrometer. Colloidal solids, it is 1 to 10 raised to power minus 3 micrometer. And dissolved solid size is less than 10 raised to power minus 3 micrometer. So, if they ask you in match the following, I have told you. Now, talking about the color of sewage. Color, again, if fresh sewage is there, that is yellow. And you can say light brown. And if the color, okay, just one thing I'll ask you. Fresh sewage is dash in nature. Fresh sewage is dash in. Very good, Anwar. Fresh sewage is alkaline in nature. 2 hours, 1 hour, that depends. Fresh sewage is dash in nature. It is slightly alkaline in nature. After that, whatever oxygen is there, it will be used. So what will be the color of the sewage? What will be the color of the sewage? Initially, you told me, afterwards, what will be the color of the sewage? What will be the color of the sewage? This has been asked. What you said? Yellow, light brown when it is fresh sewage. That is alkaline in nature. Black, dark brown when it is acidic, or the one more thing is there, septic in nature. Because all the oxygen has been used, and that's why now anaerobic decomposition. So black, dark brown. Correct. Now this is the color. After this, taste and odor तो हम करते नहीं है. Temperature तो वही 10 to 25 degree Celsius. Settleable solids by hem of cold. चलो. अब आते हैं तीन major, that is dissolved oxygen, chemical oxygen demand, theoretical oxygen demand. Okay. Now dissolved oxygen. Now guys, अब ये important है, इसलिए इसको ध्यान से सुनना. Dissolved oxygen. How much amount of oxygen is present? That is known as dissolved oxygen, which is present in the water. Dissolved form, how much oxygen is present. Now, if deficiency of oxygen is there, how can you calculate it? But before that, there is a terminology which you need to know, deosaturated. This is the official denotion, that means saturation dissolved oxygen. What is deosaturated? The maximum quantity of water which can be dissolved in water at a given temperature. Let us suppose generally at 20 degrees Celsius, deosaturated is 9.2 mg per liter. It means 9.2 mg per liter is the maximum quantity of water which can be dissolved, maximum quantity of oxygen which can be dissolved in water. Ma'am, cannot be more than 9.2? No. At 20 degrees Celsius, dissolved oxygen cannot be more than 9.2. Okay, ma'am, and if it is not more than 9.2, what it means? Basically, if it is not more than 9.2, it is 9.2. It means that in that water, no organic matter is there. That water is fully saturated with oxygen. But if you get the deficiency, how you will calculate the deficiency? I'll call it as DT. It should be deosaturated. But let us suppose you measured and it came out to be some value. So how much it should be there minus how much it is there at any time t. When you will subtract that, you will get the deficiency. More the deficiency means more the organic matter. Ma'am, how can you say that? Because if the deficiency is more, organic matter will be more. Because if the organic matter will be more microorganisms will be there. And if more microorganisms will be there, they'll be using more amount of oxygen for carrying out the decomposition. Got it? So that is the reason it is direct. Deficiency is directly proportional to the organic matter. More the organic matter, more the deficiency. Got it? Clear? Now, how can you measure it? How can you measure it? Anybody? If you want to measure the dissolved oxygen present at any time t, you can go for Winkler's method. ये Winkler's method बताना है मुझे. I have to teach you this Winkler's method, or you know, so that I can skip. Winkler's method I have to teach you, or shall I skip? जल्दी बता दो. Yes लिख दिया, किस चीज के लिए लिखा है? No, I have to tell you. सब पढ़ाओगे मेरे से. छोड़ना मत मुझे आज. और फिर अनवर बोलेगा आज तो 10 बजेगा. है ना? चलो. Winkler's method. What you do is here. अब रुको, एक स्लाइड ऐड करने दो मुझे. First let me add a slide. चलो ठीक है. अब मैम टीच इन शॉर्ट हैंड, शॉर्ट में ही टीच करूंगी. लॉन्ग में तो करने लगी तो इसमें 1 घंटा लग जाएगा. ठीक है. एक मिनट, मुझे कमेंट्स नहीं दिख रहे यार. एक मिनट, जस्ट अ मिनट. एक मिनट में स्विच ऑफ बस कर लो. Fine. Now listen to me. सबसे पहले you take a water sample. In that put alkaline magnesium sulfate. What do you mean by alkaline magnesium sulfate? नहीं, magnesium sulfate तो वही put करोगे. Alkaline potassium iodide. Alkaline potassium iodide means आप उसमें NaOH you will add it. OH is there, that means caustic alkalinity is there. So you will put water sample, in that you will add magnesium sulfate and you will add alkaline potassium iodide. If you react, you have taken a water sample. In this case, we will take wastewater sample. This experiment is valid for both raw water and wastewater. You took a water sample, added magnesium sulfate, added alkaline potassium iodide, and if here you get MnOH twice, this is a precipitate. What color is this precipitate, guys? This is white precipitate. That means no dissolved oxygen is present in water. Khatam ho gaya sab. Why, ma'am? How can you say that no dissolved oxygen is present? Here manganese is +2, -2 is for sulfate. Here also manganese is +2, oxygen hydroxide is -2. Okay, so here also the oxidation state is +2. Here also the oxidation state is +2. So here the case 1 becomes dissolved oxygen is absent. Generally, when you reach the books, they write it dissolved oxygen absent first only. So you will think, how come they know that dissolved oxygen is absent? They don't know initially. First, they do the experiment. If they find that white precipitate is there, they say that dissolved oxygen is absent. Now, if you do the same experiment again, and here you will get MnO2. Now see, here it is +2, here it is +2. Why this oxidation state has increased? Because dissolved oxygen was present. So case 2 is dissolved oxygen present. Dissolved oxygen present. Now how can you calculate this dissolved oxygen? I want to know how much oxygen is present at any time t. Now here I'll go to the gram equivalent concept. Now what I will do is, I'll take this MnO2, this I minus will be there again, and I will take H2SO4. Ma'am, why H2SO4? So that it will accelerate the process. It will accelerate the process. Now it will form an iodide complex, I3 minus. That is I2 minus I2 plus I minus. This is what an iodide complex is there. ठीक है. अब इसको मैं पहले ऐसे लिख देती हूँ. 1 मिनट. Shit, यार. 1 मिनट. काम बढ़िया. White precipitate. This you might have done it in your college also, first year. Chemistry रहता है ना common, that year. Now when dissolved oxygen is present, water sample plus manganese sulfate plus NaOH plus Ki, if this forms MnO2. This is generally a color also, this is reddish brown in color. Reddish brown in color. Now I want to say, you said that dissolved oxygen is present. Now I want to find that how much is the dissolved oxygen. First I confirmed that dissolved oxygen is present. Now we will ask that how much dissolved oxygen is present. So what we will do is MnO2, you will add H2SO4 and here iodide is there. What complex will it form, guys? What complex it will form? It will form I2 plus I1 and this will form iodide complex. This will form iodide complex. पर ये सब क्यों निकाल रहे हैं? Why we are calculating this? I want to calculate the dissolved oxygen. How will I calculate? And this is yellow in color. Yellow in color. कैसे निकालूं मैं? अभी तक मुझे समझ ही नहीं आ रहा कि मैं कैसे निकालूं. क्या करूं? I calculated MnO2. MnO2 से मैंने iodide complex बताया. Now what I will do? What I will do, guys? ध्यान से सुनना. एक लाइन का काम बचा. Here I will add starch. I will add this sample is there. I will add starch. मैंने star put कर दिया. It will become blue colored complex solution. Blue colored complex solution. इसको मैंने this I will titrate. Can anybody tell me the chemical for titration? Divya, Prince, anybody? किससे टाइट्रेट करेंगे? किससे टाइट्रेट करेंगे? वेरी वेरी इंपॉर्टेंट एंड वेरी फेमस क्वेश्चन. डिसॉल्व्ड ऑक्सीजन वी यूज sodium thiosulfate Na2S2O3. Okay, so iodide complex is there. Put starch, it will become blue colored complex solution. Titrate with sodium thiosulfate. Now what will happen? You have put sodium thiosulfate here and this blue colored complex solution. Now what will happen? This blue colored complex solution in this sodium thiosulfate is keep on adding. The moment it becomes, correct Divya Prince, the moment it becomes what? The moment it becomes colorless, you will just close it, close the knob, and here if it was 100, here it is 100 minus V. So that means V ml of titrant is used. See, how much gram equivalents of thiosulfate used? That much gram equivalent of I3 minus will be there. That much gram equivalent of I2 will be there. That much gram equivalent of oxygen is there. Ma'am, how can you say this? By the logic, remember 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So by that logic, I can say gram equivalent of sodium thiosulfate used is equal to gram equivalent of I3 minus is equal to gram equivalents of oxygen. And if you want to get the value of oxygen, just multiply by the equivalent weight of oxygen. Equivalent and equivalent will get cancelled out. Okay, so this is the manner, this is the Winkler's method by which you can calculate the dissolved oxygen. Is it clear, everybody? Is it clear? Now is it clear? Sophia, Divya, Prince, everybody clear? Chal. Next, coming to बायोकेमिकल ऑक्सीजन डिमांड से पहले मैं शॉर्ट में आपको केमिकल ऑक्सीजन डिमांड भी बता देती हूँ. केमिकल ऑक्सीजन डिमांड इज द अमाउंट ऑफ ऑक्सीजन रिक्वायर्ड फॉर द डिकम्पोजिशन ऑफ बोथ बायोडिग्रेडेबल ऑर्गेनिक मैटर plus non-biodegradable organic matter. Now you will say that, ma'am, you only told us at the starting of the class when you were teaching us quality parameters of water that non-biodegradable cannot be easily decomposed, and you are telling me how much amount of oxygen is required. How can we calculate? Guys, hold on. We are using chemical here. If you depend on microorganisms, there are less chances that they will carry out the decomposition of non-biodegradable water, organic matter, because it will take time. You are using chemical, right? So it is easy when you use chemical. Okay. See, I can't read your comments. I nahi raha yaar ye niche. Okay. Now what you do is, ध्यान से सुनना इसको. We will take water sample, wastewater sample basically. In this, we add K2Cr2O7. Sulfuric acid to accelerate. Now since you are adding K2Cr2O7, you know how much you are adding. Let us suppose 8 gram equivalents. After reaction, the K2Cr2O7 which is left is B gram equivalents, which you don't know how much is left, but you will calculate that. Okay, you have to calculate that. It will remain. Ma'am, if it doesn't remain, add more K2Cr2O7. Okay, if K2Cr2O7 after reaction is not remaining, then add more K2Cr2O7 initially. Clear? Now, how much K2Cr2O7 is remaining? How can I calculate? I want to know this B value. How can I calculate B? Why? Ma'am, why you want B value? Because how much oxygen is used? Gram equivalents of oxygen used is equal to gram equivalents of K2Cr2O7 used. And how much K2Cr2O7 is used? A minus B. See, A I added, so I know A. B I don't know because it was remaining. So how can I do that? I need to calculate B. How will I calculate B? Can anybody tell me how will I calculate B? B बचा हुआ है मेरा. How will I calculate B? In this, I will add an indicator. B आया. I don't know how much it is B. A famous indicator is there which is added only in the case of CO2, COD, Ferroin indicator. Now, can you tell me the name of the titrant? Again, famous titrant. Come on, guys. Tell me the name of the titrant, famous titrant which you use. Famous. Famous titrant is there which you use. Very famous. बहुत ज़्यादा नाम है इसका भाई. Very good, Kalyan Reddy. Very good. Potassium dichromate का chemical था. The indicator is ferroin. The thing which you need to calculate is K2Cr2O7. You titrate it with, this is blue-green sample. After ferroin, it will become blue-green sample. So you titrate it with ferrous ammonium sulfate. Ferrous ammonium sulfate. Again, वही कहानी. Ferrous ammonium sulfate will go, and you keep on pouring ferrous ammonium sulfate till this blue-green sample becomes red-brown color. Till that time. It becomes, you will switch it off, you will check it out how much titrate of ferrous ammonium sulfate used. So gram equivalents of ferrous ammonium sulfate used. That much is the gram equivalents of K2Cr2O7 present. So this will give me B. Now you got B, substitute it here, you will get the oxygen. That is the simple thing. Got it? Clear? Clear? सब बोल दो KMNO4, K2CrO4, say everything now. Clear? Okay. Now one more thing is there. Generally you don't call it COD. You call it as dichromate demand. Because K2Cr2O7 is such a powerful oxidizing agent that along with carrying out the decomposition of organic matter, it also carries out the decomposition of inorganic matter. So technically it is giving you both the oxygen. It is giving you the oxygen requirement for the decomposition of organic matter plus the oxygen requirement for the decomposition of inorganic matter. So that's why you don't call it COD, because in COD I was talking only about organic demand, but here it is telling me COD also plus inorganic. So that's why you call it as dichromate demand, or you call it as dichromate oxygen. Clear? Chalo. Now let's move further to BOD, the most important BOD, biochemical oxygen demand. What is biochemical oxygen demand? The amount of oxygen required by aerobic microorganisms for carrying out the decomposition of biodegradable organic matter, that is termed as what? BOD. Correct? Now if you talk about BOD, generally the standard BOD, अब यहाँ पर we don't talk only about non-biodegradable organic matter. It is not at all required. पानी नहीं बचा यार. Okay, so it is not at all required only. We are talking only about biodegradable organic matter. So the amount of oxygen required by microorganisms for carrying out the decomposition of biodegradable organic matter. Now just answer one thing. Who requires oxygen? Aerobic microorganisms or anaerobic microorganisms? Who requires oxygen? Aerobic. Correct. So when you say biochemical oxygen demand, this is the amount of oxygen required by aerobic microorganisms. For what? For carrying out the decomposition. Decomposition of whom? Biodegradable organic matter. That is known as BOD. Now here you have two ways of calculating BOD. First, the laboratory method, and second one is the formula method. Now what you do is, let us suppose first a raw water was there. Okay, you measured the dissolved oxygen. For calculating BOD, now we are going to the very important parts. Facultative ne generally aerobic. Definitions as per definition Shrikant, aerobic. For calculating BOD, three things should be there. Organic matter, microorganisms, oxygen. If any of the thing is missing, you need to add it. Now, if first we will take the sample, we will measure the dissolved oxygen. We will keep it at 5 days at 20 degrees Celsius, which is the standard BOD, and we will measure dissolved oxygen final. If it is not coming 0, so you will say BOD 5 days at 20 degrees Celsius will be DO final minus DO initial minus DO final. Here do you have added any water? No. So case 1, this is when no dilution is done. Till now in the examinations, never ever they have asked this first case. In the history of the GATE, never ever they have asked this first case. Correct? Now case 2. Let us suppose this water you took it, you did the experiment and dissolved oxygen final came out to be 0. Your test is invalid. Why? You calculated after 5 days, you checked it out, dissolved oxygen final is coming 0. But it is not necessary. It is not necessary na, that on the 5th day only dissolved oxygen is exhausted. Ma'am, how can I calculate dissolved oxygen? I already told you Winkler's method. So at any time you want to calculate how much dissolved oxygen is present, you can go for Winkler's method. Correct? Now dissolved oxygen is there. You have incubated for 5 days at 20 degrees Celsius. After 5 days you are checking it out. You are getting dissolved oxygen final as 0. Correct? You took it out after 5 days and you are finding dissolved oxygen 0. But it might be possible on the very first day only it is exhausted, or the second day only it is exhausted. So in this case, it will not give you accurate result. So now what means an oxygen is exhausted? That means oxygen is not there. So you will add oxygen. Ma'am, how can I add oxygen? You can add oxygen by adding distilled water. Distilled water is that water which is fully saturated with oxygen. So this is the volume of the sewage and this is the DO of sewage. This is the volume of water, distilled water. In that only distilled water should be there. No organic matter, nothing should be there. Otherwise, you will get wrong reading. And this is the DO of the water. So here what you will get? You will get DO initial mix. Because now you have mixed the water. So volume of sewage, DO of sewage plus volume of water, DO of water upon volume of sewage plus volume of water. This is DO mix. After that, you will put it at 5 days at 20 degrees Celsius and you will get whatever is the DO, you will get DO final mix. But this is the DO of the mix now. I want the DO, I want the BOD of the test sample. How can I calculate? If I am saying DO mix minus initial minus DO final mix, so this is giving me the DO, BOD, or for any days if you are incubating, it is giving me for the mixed sample. I want for the raw sample, the test sample. So what I will do it, I will multiply by the dilution factor. Okay? So now, dilution factor. What is dilution factor? Dilution factor is, I have already told you this in threshold order number. Volume of sewage plus volume of water divided by volume of sewage. Or if X% solution you take, अगर 2% बोल दिया, 2% solution is diluted. दिमाग मत लगाओ, 100 upon X%. Volume of sewage, if let us suppose, example, how does it came? If it is telling 2% solution is diluted, that means volume of sewage is 2 ml, volume of water is 98 ml. Calculate, you will get 100 by X%. So why to waste time? Directly apply 100 by X%. Okay, now you will see, ma'am, if microorganisms is also missing, then you will do seeding. So from other plant, you will bring the microorganisms and put it. That is known as seeding. Correct? So this is one way which you do it. Next is by using the technique, that is exactly like you did it for Chick's law. Here this also follows first order kinetics. At t is equal to 0, the amount of BOD which is present is LT. You can write it as BOD ultimate also, L naught, or you can write it as BOD ultimate also. Eventually, over the time, microorganisms will carry out the decomposition, so organic matter will reduce, so BOD will reduce. So at any time t, the amount of BOD which is there, that is LT, or you call it as BODT. Now, if you want to calculate BOD at time t and t degrees Celsius, it is given by this formula. Similarly, you can use the KD, this one. K and KD both are deoxygenation rate constant. This is base E, this is base 10. If you look out the past 5 to 7 years of paper, they have already given you what? They have already given you deoxygenation, when to use base E, when to use base 10. Before that paper, if you see, they don't used to mention it, but right now don't worry, they will tell you that whatever K which they are giving, you have to use it for base E or whether you have to use it for base 10. Okay, now here if I talk it about, let's talk a question. Ma'am, for dilution 300 by Vs can be used. 300 ml is the capacity of the BOD bottle, but don't remember like that. It will be risky. Come on, solve this. Come on. 5 days BOD is given to you, K is given to you, this is base E. Now you have to calculate BOD 8. The temperature they have changed it. So if there is asking you BOD 8, that means firstly it is asking you consumed BOD. This will be how much? L naught ultimate BOD 1 minus e to the power minus k at 15 degrees Celsius into T. Now here you don't know ultimate BOD also, you don't know K also. So if you want to calculate K, now here they haven't mentioned temperature coefficient. What you will take? क्या लोगे? कुछ तो बताओ यार, सब क्वेश्चन मैं सॉल्व कर रही हूँ. किसी का भी रिप्लाई है? चलो यहाँ पे थीटा जब 20 डिग्री सेल्सियस से कम होता है तब आप लेते हो 1.056. गलत, गलत. Generally here we take 1.056. They will mention you in that question. Theta is temperature coefficient. K20 given है 0.23, 1.056, 15 minus 20. How much it is coming? How much it is coming? Solve. 1.047. जब टेम्परेचर 20 डिग्री सेल्सियस से ज्यादा होता है दैट टाइम वी टेक इट. इसीलिए क्वेश्चन करवा रही हूँ. 0.175 आ रहा है per day. So this will be 0.175. Ultimate BOD, you need to calculate. 5 days BOD they have given to you in the question. So calculate the ultimate BOD. Ultimate BOD तो calculate करना पड़ेगा भाई. Five days. What is ultimate BOD coming? 150 upon 1 minus e to the power minus 0.23 into 5. This is coming 219.5. Substitute 219.5. Tell me BOD 8 value. BOD 8 बता दो. $165.37. This will be the answer. Got it? .175 धोखे से लिख दिया क्या? चलो. Okay. Now population equivalent. Why this concept came? The patent example which I give you. See, let us suppose 1 crore. सबका आ गया ना वो. See, 1 crore is the treatment cost of 1 month in a city whose population is 10 lakhs. Okay, 10 lakhs. So can you tell me how much per person gives money in a month for treatment of sewage? कितना पैसा दे रहा है एक पर्सन? इसको 10 लाख की जगह 1 लाख कर दूं क्या? चलो पहले बताओ कितना दे रहा है. How much money it is giving? 1 करोड़ पैसा लग रहा है. 1 करोड़ मतलब कितना होता है? 10⁻⁷ और 1 लाख लोग हैं. 1 लाख तो अरे यार 10 ही ले लेती हूँ, थोड़ा सस्ता पड़ेगा ना. फिर तुम लोग को लगेगा यार 100 रुपए लग रहे हैं. 10 lakhs मीन्स 10 into 10⁵ कितना हो जाएगा? 10 rupees पर पर्सन पर मंथ. तो इफ इन योर होम 4 people are there, you give 40 rupees per month. Correct? But what about the industries? From them who will take the money, because they are generating effluents, but उसको लोगों के हिसाब से how will you calculate in terms of people? So that is why this word population equivalent came. Like example, if the population equivalent is coming 2025, it means that industry is generating pollutants equivalent to 2025 people. So 2025 into 10, that means he has to give 2025 rupees. Correct? So how will you get this 2025? You will take the BOD of the industrial sewage and you will divide by the BOD produced by per person per day domestic basis. If nothing is given in the question, you will take 80 gram per capita per day. This is the BOD which is produced by per person per day. Otherwise, whatever they give you in the question, just take that. Okay, so the BOD of the industrial sewage divided by the BOD produced by per person per day. This is the population equivalent. Got it? Clear? Chalo. Last one is relative stability. Relative stability basically tells you कि how much amount of oxygen, किसी को पता है, how much amount of oxygen is available, whether in molecular bonded, whether it freely available, divided by how much oxygen is required for the decomposition of first stage BOD, or you call it as carbonaceous BOD. ये ग्राफ आपको पता होगा, ये अब इसके ऊपर भी क्वेश्चन आएंगे. गेट 2022 या 2020, हाँ 2022 they have asked question from this. This is known as first stage BOD. You call it as carbonaceous BOD also. This is known as second stage BOD, which you call it as nitrogenous BOD. First stage BOD is the amount of oxygen required for the decomposition of carbonaceous organic matter. Second stage BOD is the amount of oxygen required for the decomposition of nitrogenous organic matter. फर्स्ट स्टेज बीओडी के लिए कौन यूज किया जाता है? हेट्रोट्रॉप्स. दे यूटिलाइजेस हेट्रोट्रॉप्स व्हिच यूटिलाइजेस ऑर्गेनिक कार्बन, व्हाइल इन सेकंड स्टेज यू यूज ऑटोट्रॉप्स व्हिच यूटिलाइजेस इनऑर्गेनिक कार्बन. इनऑर्गेनिक कार्बन इज लाइक कार्बन डाइऑक्साइड. फ्रॉम हियर टू जस्ट टेक आउट कार्बन, एक्स्ट्रा एनर्जी इज रिक्वायर्ड. व्हाई? बिकॉज फर्स्ट यू नीड टू ब्रेक द बॉन्ड and then you will require. That's why autotrophs takes time. In that moment, heterotrophs has done its decomposition and it has gone. Okay, so this one, relative stability is amount of oxygen required as molecular bonded available, as molecular bonded freely available, to the amount of oxygen required for first stage decomposition or first stage BOD. So there are two formulas I'm writing. Tell me whether it is correct or not. T 20 degrees Celsius and T 37 degrees Celsius are time required in days for the decolorization of methylene blue colored solution when incubated at 20 degrees Celsius and 37 degrees Celsius respectively. This is true or false? Come on. सही है? And this is the T is the time required in days. Now, time required in days for decolorization of methylene blue colored solution. Generally, methylene blue colored solution, when you place in it, if methylene blue color decolorizes, that means anaerobic conditions has come. So, if the sample decolorizes is less than 4 days, that means that the sample is unstable. Why? Because sooner the decolorization takes place, sooner the anaerobic conditions comes. Sooner the anaerobic condition comes, that means the stability is affected and the sample has become unstable. So if the time for decolorization of methylene blue colored solution is less than 4 days, it is termed as unstable. Got it? So this is your relative stability. Clear everybody? So with this, we have completed one more chapter and now we'll start with design of sewers. Any doubts? Any doubts? Start करूं design of sewers? Design of sewers कर लेते, छोटा ही है, ज़्यादा बड़ा नहीं है. Then treatment of sewage, फिर disposal है, फिर treatment of sewage है, फिर solid waste management. ये अनवर की बात सच ना हो जाए आज. 10 नहीं बचना चाहिए, चाहे कुछ भी हो जाए. Okay, it's 5, right? Shall we start? Okay, just give me 2 minutes. I'll be back in 2 minutes. So just you guys can also come just in 2 minutes. I'm just coming in a minute, not more than. that is used when 10 is there. What you are saying ना अनवर, उसके लिए ना जब अपन जो अभी ले रहे थे उसमें बेस ई के लिए ले रहे थे. So that I was telling जब बेस 10. Okay, क्या बोल दिया मैंने? THOD and TOC. चलो वो भी बता देती हूँ. इजी था करके छोड़ दिया था, बट चलो ठीक है. THOD is theoretical oxygen demand. This is on pen and paper you are doing it. You are assuming complete decomposition of organic matter is taking place. Example C6H12O6. In this, when you add oxygen, carbon dioxide plus water. So like 1 mole of glucose requires 6 moles of oxygen. So whatever will be given to you in the question, 180 mg per liter, 200 mg per liter, how much oxygen it will require. So you assume complete decomposition, when in practical will not happen also. But since you are assuming it to be complete, you will find that theoretical oxygen demand is greater than chemical oxygen demand, which is greater than BOD ultimate. This is a patent relation. For all calculation purposes, you assume that theoretical oxygen demand and chemical oxygen demand are same, but in actual they are not. If non-biodegradable organic matter is absent, in that case COD and BOD ultimate will be same. BOD ultimate will be greater than 5 days BOD, that is obviously. And now what is TOC? Like similar thing, 1 mole of glucose has 6 moles of carbon in it, because I told you organic means carbon. So 1 mole of glucose has 6 moles of carbon in it. So 100 mg per liter of glucose will have how much carbon? So that you report it in terms of total organic carbon. Clear? Now is it clear? Who was telling this? It was rare. Shravan Kodari, is it clear? चलो बस बहुत सारा काम बचा अभी हमारे पास. 5 8:30 तक तो मैक्सिमम कंप्लीट करना है. किसी को नींद तो नहीं आ रही ना? चलो, दिव्या, प्रिंस, श्रवण, अनवर, सोफिया, एवरीबॉडी इज देयर, राइट? चलो चले, let's start it now. Design of sewers. These are household sewers. Sewers are basically, these are conduits or pipes which will carry the sewage to the treatment plant. Now we have different types of sewers. First, there are household sewers. From various household sewers, the sewerage will go to the lateral sewers. From various lateral sewers, it will go to the branch sewer. From various branch sewer, it will go to the main sewer. MA, it is written everywhere, that is manhole. From various main sewers, it will go to the outfall sewer. There is two function of outfall sewer. Firstly, it carries the sewage to the sewage treatment plant, and from the sewage treatment plant, the treated sewage it carries for disposal. So two function is performed by the outfall sewer. Carries the sewage to the sewage treatment plant, and from the sewage treatment plant it carries for disposal. So two functions are being followed by this outfall sewer. Now, whatever sewer which you are having it in your homes, that household sewer you will be installing. Government is not responsible for that. From your household sewer, when it joins the lateral sewer, then it is the responsibility. Of the government. They will take care of treating all those things. But household sewers, whenever you construct your home, it's your responsibility. Correct? Now, here, when you design the sewers, obviously, if you check it out, here the amount of peak will not be same at every time for every sewer. Of course, when you are drinking water or when the highest amount of water will be supplied to you, exactly same time the amount of water peak will be higher in lateral sewer? Of course not. You will be having higher amount of water that will be converted into waste water, then it will go into the sewer, and then the amount of peak will be more in lateral sewer. So you will see that when it is more in lateral sewer, it will not be more in branch sewer. When it is more in branch sewer, it will not be more in main sewer, because it will take time. Got it? Now, if the dia, generally we never fill the sewage to full depth. यहाँ पे बना ही हुआ था already. We never fill it for full depth because you know generally in the sewers, the sewage undergoes anaerobic decomposition. And anaerobic decomposition releases acids, alcohols and gases. And gases like methane is released, which is known for its explosive tendency. Okay, so we give space for the accumulation of these gases. So we never fill it full. Now, If the dia is less than 400 mm, you fill it partially, the depth of water to the full depth. If it is 400 to 900 mm, if the dia of the sieve, you fill it 66.67% full. If the dia is more than 900 mm, you fill it 75%. Okay, still you will not fill it completely because you will give space for the accumulation of gases. Now, coming further, that if you want to calculate fluctuation, this is a 1 marks question. If they want, they can ask you. Generally, I tell to students whenever they are preparing for ESE as well, if in the question they haven't mentioned, they tell you design a sieve, okay, but they haven't mentioned whether it is a lateral sieve, branch sieve, main sieve or outfall sieve. Assume it to be a branch sieve. Assume it to be a branch sieve. Okay, so it is 18 plus root P upon 4 plus root P. This is a direct formula, and P is the population in thousands. P is the population in thousands. So this is the formula. Fluctuation is how much is the maximum value with respect to the average. That is fluctuation. Now let's talk about the self-cleansing velocity. What happens in sewers? Suspended solids will get deposited, and if you don't remove them, they will settle here, and the amount of depth available for the water to pass will reduce. So the discharge carrying capacity will reduce. Correct? So we need to make sure that self-cleansing velocity in sewer should be there, so that the sewer clean itself on its own. Okay. So now there are two formulas. One is based on Chase's equation. This is the, now if in the question they ask you to calculate a self-cleansing velocity using Chase's equation, then you will use this equation for calculating self-cleansing velocity. If in the question they gave you to calculate self-cleansing velocity by Manning's equation, you will use this equation. Okay, what is this? Root over 8 GD GS minus 1 K upon F. Now what is G? G is acceleration due to gravity. K is a constant, obviously, which is the solid's present depends on that. F is a friction factor. Manning's R is hydraulic radius. dP is the size of the particle. Clear? This is 4 root. Clear? So this is the formula for Manning's equation. This is the formula for Chase's equation. Now, if let us suppose they haven't asked this question, but if they ask you, they will give you some data and they'll ask you whether silting will take place or not. If whatever flow velocity you have calculated, it is less than the self-cleansing velocity. That means flow is taking place even at a lesser rate as compared to the self-cleansing velocity. Silting will occur. So if they give you in statement wise, they ask you, or in numericals, they ask you. So for that reason. dP is the particle size. So dP particle size के लिए लिखा है. That is in subscript. Particle size. Clear? Then what will happen? Silting. Deposition of solids will occur. Silting will occur means what? Deposition of solids will occur. Correct? These two formula. Now guys, for calculating, अब इसका derivation बिल्कुल important है. You should know these formula. So when this is the capital D dia and this is flowing, partial flow is taking place, and this is the center, and this will be alpha. So if they are asking you ratio of the depth which is there to the full depth, it will be half 1 minus cos alpha by 2. If they are asking you the ratio of the area, it will be alpha by 360 minus sin alpha by 2 pi. If it is asking you ratio of the wetted perimeter flowing depth D to the ratio of the perimeter flowing full flow, that is alpha by 360. And if they ask you the hydraulic radius of partial flow to full flow, that is alpha by 360 minus sin alpha by 2 pi divided by alpha by 360. So this will be the ratio. So these you should remember it. And now if they ask you, let us suppose for discharge, then I don't think you should remember it. Why? Because that is area by velocity upon capital V. Okay. So that is simple. You can calculate it. So which are important, I have told you to remember that. Clear? Now this you should remember it because once they have asked question. Now let's do a question for this. For a sewer of dia 300 mm, depth of flow is 0.3 times the full depth. That means how much is the depth of flow, guys? 90 mm. Now, if you are ensuring equal degree of self-cleansing capacity, अब इसको मुझे एक चीज और पहले पढ़ाने दो. equal degree of self cleansing capacity. This I have asked in pre-class, and 99% students have answered it wrong. I've asked this in MSQ question and 99% students have answered it wrong. First of all, if you calculate the shear stress, see, obviously there will be frictional force which will be acting, so it will impart shear stress. So if you want to calculate the shear stress which is experienced by the sea weight, this is given by gamma RS. Gamma is the unit weight, R is the hydraulic radius, S is the slope. Ma'am, is this an average shear stress or the maximum shear stress? This is average shear stress. Now, if one sewer is there which is flowing with full depth or any depth, other sewer is there which is flowing at small depth, and if both have same degree of self-cleansing velocity, then how much shear stress is there in this capital, let us suppose you call it as capital tau, this will also have same shear stress. So the shear stress experienced by both of them will be same. Got it? Now if you check it out, this will be basically gamma R capital S, and this I will take it as gamma of sewage. We'll assume that both of them same sewage is there. So approximately they are equal to gamma W unit weight of water. Generally the unit weight of sewage is slightly more. For water it is 1, it will be 1.0 to 1.03. So you will cancel it. You will get RS is equal to small rs. So you can write it as R by small r is equal to small s by capital S. Correct? So this formula holds true if both two sewers have same degree of self-cleansing velocity. That time you use this formula. Okay? Clear? चलो अब मैं इसका एक velocity का भी formula बता देती हूँ. I don't think you need to remember. If you have the basic logic, you will able to do it. Like velocity of that partial one, velocity of the full one. 1 by n, तो इसका capital N. Velocity is given by, you know, the 1 by n r to the power 2 by 3 s to the power half. So this will become small r by capital R to the power 2 by 3, small s to capital S to the power 1 by 2. Okay, so from here, instead of small s by capital S, what you can put? कैपिटल आर बाय स्मॉल आर पुट कर सकते हो, या इसको ऐसे लिख लो आर बाय स्मॉल आर टू द पावर -1/2. उल्टा कर दो ना, माइनस कर दिया. सो फ्रॉम हियर द वन रिलेशन 2/3 - 1/2, हाउ मच इट विल कम? 2/3 - 1/2 कितना आएगा? 2/3 - 1/2 हाउ मच इट विल कम? 2/3 - 1/2 एलसीएम होगा 6, 4 - 3 1/6. A very important result. अगर मैंने Manning's roughness coefficient same ले लिया, then it will be 1/6. If the Manning's roughness coefficient in both of them is not same, then this will be the one. Correct? Got it? Now solve question. अब solve करो question. पहले पूछा required grade, slope बताओ. पहले पूछा slope, calculate the slope. Come on. 1 by 1 क्विकली. पहले पूछा कैलकुलेट स्लोप. स्लोप तो सेम ही रहेगा ना भाई, एक सीवर है, अब उसको तुम आधा फ्लो कराओ और फुल फ्लो कराओ, दैट सीवर. सो स्लोप यू हैव टू लेट एट सेम कंडीशन ओनली. सो इसमें वेलोसिटी इज गिवन टू मी, फुल फ्लो वेलोसिटी इज गिवन 1 by n r to the power 2 by 3 s to the power half. Full flow velocity is 0.9. Manning's roughness coefficient 0.03. Hydraulic radius. Full flow condition, you know it is d by 4, wetted area by wetted perimeter, r is a by p, wetted area is pi by 4 d square, wetted perimeter is 2 pi r or pi d, that is d by 4. So d by 4, that means how much? 0.3 by 4, 2 by 3. Calculate the slope from here. चलो calculate the slope from here guys. अब मैं नहीं calculate करूंगी, अभी तो इसमें बहुत सारी conditions MSQ बना के पूछ लेगा ये. Calculate the slope and tell me. Correct. Jaldi. 0.023. Divya said 0.023. What about others? 0.023. चलो स्लोप इज 0.023. रिक्वायर्ड ग्रेड मिल गया. नाउ अब बहुत तगड़ा. Velocity assuming roughness coefficient n is equal to 0.03. This is asking the velocity when it is flowing at 90 mm. Small v पूछ रहा है. कैसे निकालोगे? How will you calculate? It is asking you small v guys. It is asking you small v. कैसे calculate करोगे? अब भी बताया मैंने. क्या बोला था? On a grade ensuring equal degree of self cleansing. Now अभी बताया मैंने formula एक. Small v by capital V. Small v by capital V is equal to small r by capital R to the power 1 by 6. N तो एक ही दिया तो n will be same. Now capital R you will calculate d by 4, that is 300 by 4. How will you calculate small r? अब देखो अब फंसोगे. अब एक ही क्वेश्चन में सब कुछ आ गया. Multiple concepts in one single question. See, velocity is given to you full flow 0.9. Small r by capital R नहीं दिया है. अब देखो small r and capital R. अभी आपको एक फॉर्मूला बताया था. This is alpha by 360 minus sin alpha by 2 pi upon alpha by 360. ये क्या था? Wetted area to wetted perimeter. So alpha by 360 minus sin alpha by 2 pi divided by alpha by 360. Okay. Now here what is given to you? 0.3 times full depth. That means small d by capital D is given to you how much? 0.3. You know इसका फॉर्मूला होता है हाफ 1 माइनस कॉस अल्फा बाय 2. कैलकुलेट अल्फा फ्रॉम हियर, सब्सटीट्यूट हियर. बस इतना सा काम है. कैलकुलेट अल्फा फ्रॉम हियर, सब्सटीट्यूट हियर और फिर यहाँ पे सब्सटीट्यूट कर दो. यू विल गेट द वेलोसिटी. टेढ़ा क्वेश्चन है, दिमाग लगाना पड़ेगा इन द एग्जामिनेशन. यू हैव टू अप्लाई योर ब्रेन. इजीली यू विल नॉट गेट. कम ऑन, कैलकुलेट अल्फा. हाउ मच इज द अल्फा कमिंग? हाँ वेरी गुड. डी बाय इससे बोला करेक्ट. हाउ मच इज अल्फा कमिंग? Come on, calculate Prince, Sophia, everybody. Calculate alpha and tell me, quick. One 132.84. 132.84. अब इसको यहाँ पे पुट करते टाइम रेड उसमें पढ़ लेना. चलो सब्सटीट्यूट इट हियर एंड टेल मी स्मॉल आर बाय कैपिटल आर. टेल मी व्हाट इज स्मॉल आर बाय कैपिटल आर. फटाफट. स्मॉल आर बाय कैपिटल आर. पॉइंट 683. और किसी का? पॉइंट 683 पक्का है? अगर बोल रहे हो मेरे पास आंसर नहीं है. 0.683 1 by 6. From here you will get the velocity. Come on, solve it. You will get the velocity from here. Point 683 to the power 1 by 6 into 0.9. चलो बस कैलकुलेट करके वेलोसिटी बता दो. दैट्स इट. 132.84 the velocity. Point 8445 meter per second. Correct? Fine. चलिए चलो. Now last one concept, that is hydraulically equivalent section. अभी तो और भी बचा है थोड़ा. Hydraulic equivalent section. You call two sections are hydraulically equivalent if the slope of both of them is same. Slope is same and discharge is same. So two sections are said to be hydraulically equivalent if the discharge flowing through them is same and they both are having the same, if they are laid at the same slope. So if they ask you to calculate hydraulically equivalent of square and circle, so what you can do is area into velocity of square, area into velocity of circle, both will be same. Slope will get cancelled out, only change will be in the hydraulic radius and area. Substitute it, you will get this. Okay, in exam, if you have time, you can solve it. Otherwise, remember this. This they have asked in other competitive examinations. Like, if they'll ask like this, they will give you a value. I'll tell you how the questions are asked. If a sewer of dia D is hydraulically equivalent to a square of side B, then what should be the dia of the sewer to be provided if the sewer and square are hydraulically equivalent? So 1.1 into B, they will give you the value of B. So they can ask you like this. Got it? Same discharge, slope, correct. Slope is same, running full. Correct, absolutely correct. Now, next coming further is designing of sewerage system. First of all, it is important to check it out that whether in the question they will give you that the population P is there and it is generating. Sometimes they will tell you that the water supply is per person water requirement is LPCD. They will give you the water supply or the water requirement. If they will give you the water requirement, you will do 80% because we assume that whatever water is supplied, 80% of it is converted into wastewater. If in the question they have given you sewerage supply, then you will not do 0.8% because they have already done 0.8 or whatever percent and they have given you the value. Then generally when you can do it for combined sewer, you multiply by 3 because 3 is the fluctuation which is taken into account. So multiply by 3. So this will give you the value of the sanitary sewage, you can say. Now, obviously, if you design combined sewers, you will have to consider sanitary sewage plus drainage. So, drainage, there are many equations, like one is 1 by 36K PCA, which you do. Catchment area, you substitute here in hectares. And PC is the critical rainfall intensity, which you substitute it in centimeter per hour. If in the question they are giving you the value of PC directly, well and good. But maximum times they don't give you the value of critical rainfall intensity directly. Critical rainfall intensity depends upon time of concentration. What is time of concentration? It is the time taken by the molecule from the farthest point to reach to the outlet. That is known as what? Time of concentration. How much time is taken by the molecule from the farthest point to reach to the outlet? That is known as what? Time of concentration. If they are giving you time of concentration and if the time of concentration is from 5 to 20 minutes, okay, that time, this is the critical rainfall 75 TC plus 10, correct? And if the critical rainfall intensity it is coming out to be greater than 20 minutes, that time of concentration, then it will be given as 100 TC plus 20. Got it? So anything you can use depending on that. Clear? You can use this one, you can use this one, anything. Depending upon whatever time of concentration they have given to you in the question. Last drop, time of concentration. So the total discharge will be what? Q of sanitary sewage plus QP. And if they ask you to calculate the dia, discharge is equal to area into velocity, pi by 4 d square into area. This will be the total discharge, QS plus QP. From here, you can calculate the dia. These are the questions which they ask. Is it clear, everybody? हाँ, एक चलो और किसी का कोई डाउट तो नहीं है ना. चलो, one thing more is there that this question has been asked in GATE. जैसे 30% area runoff coefficient, case runoff coefficient ना is A1, A2 area runoff coefficient is A2, A3 area runoff coefficient is K3. So here you will calculate equivalent runoff coefficient K1 A1 plus K2 A2 plus K3 A3 upon A1 plus A2 plus A3. If they give you like this, you will calculate equivalent runoff coefficient like this. Clear? नहीं है ज्यादा, नहीं है डिजाइनर. 1 by 36 KPC. एक बार K से रिलेटेड क्वेश्चन पूछा गया है, सेल्फ क्लेंजिंग वेलोसिटी से पूछ ले तो अच्छा है, बाकी उतना नहीं पूछा गया. चलो, with this we have completed design of sewers, soil mechanics, marathon tomorrow for you guys at 10 AM and now we have completed. ये तो हम लोग ने पूरा कंप्लीट कर लिया, ये and this we have completed. अभी क्या कंप्लीट किया? डिजाइन ऑफ सीवर्स we have completed. Any doubts still here? Chalo. Shall we start disposal? डिस्पोजल कर लेते हैं, डिस्पोजल कर लेते हैं. ट्रीटमेंट से मैं आपको फिर से ब्रेक दे दूंगी. क्या बोलते हो? इज इट ओके? डिस्पोजल कंप्लीट कर लेते हैं, फिर ट्रीटमेंट ऑफ सीवेज, एयर पोल्यूशन, सॉलिड वेस्ट मैनेजमेंट एक साथ कर लेंगे, है ना? तो हो जाएगा. 10 नहीं बजाऊंगी मैं बहुत कम ब्रेक्स दूंगी एंड आई विल मेक श्योर दैट. ठीक है, ओके, लेट्स स्टार्ट. Now, obviously, the sewage which has to be treated, it has to be disposed. But technically, first we study disposal and we study treatment. Why? Because government, as per codal provisions, it has been told that if you are disposing it in rivers, what should be the value? If you are disposing it in the sea, what should be the values? So they have given the provisions for that. So now if you want to do the disposal, you can do it by dilution, that means in water, or you can dispose it on land. If you're doing it on disposal by dilution, you can do it either on rivers, either you can do it on lakes and ponds, or either you can do it on seas and oceans. Now, if you do by disposal by dilution, there are some things which you have to follow. First of all is whatever water in which you are disposing it, in that dissolved oxygen should be present in higher concentration. Already if dissolved oxygen is less, you will put, because you never treat sewage 100%, remember that. There will be some organic matter remaining. So you won't treat the sewage 100% and you will dispose it. Okay, so make sure that whenever you're disposing it on the river or in any diluting water, so make sure that it has sufficient and high quantity of dissolved oxygen in it. And that water should not be used like for ships and all to move. So that diluting water should not be used for navigation purpose. And the outfall sewer, I told you there are two functions of outfall sewer. First, it takes to the treatment plant, and from the treatment plant, it takes it to the disposal. So the outfall sewer or the treatment plant, basically outfall sewer of the city, is basically situated to some natural water, so that sewer directly takes it from the treatment plant to that rivers. Okay. Otherwise, if you have to construct a large sewer, then there will be a cost of transportation as well. Now, sewage, if it is comparatively fresh, it should be comparatively fresh. That means 4 hours it should be old, and it shouldn't have any and it shouldn't have any organic matter in floating form, and solids should be there which are settleable in nature. So if these prerequisites are being satisfied by the sewage, then you can go for what? Disposal by dilution. So these are the prerequisites which is required. Now disposal by dilution, which can be done by any method. Generally the disposal we do in rivers. Now what happens, why we are doing out disposal, gardening one and all, that I'll tell you when disposal on land is there. Okay. Now, when you do disposal by dilution in rivers, what will happen? When you will dispose the effluents on the river has a property that is of self-purification. That means it will clean itself on its own due to various phenomena. These are the physical forces, and this one, oxidation reduction, is the chemical force. Okay. Now, what is this? What is this? First, let us try to understand. Now, dilution and dispersion is technically not a method of cleaning. It's just like when that, let us suppose if 5 mg of suspended solids is present in 1 liters of water, and you added 9 liters of water. Now it becomes 10 liters. So initially that 5 mg was present in 1 liters of water, and now it is present in 10 liters of water. So initially the concentration was 5 mg per liter. Now the concentration is 0.5 mg per liter. So suspended solids is same. Only the concentration is changed. So dilution and dispersion is technically not a method of disposal, but you are reducing the potential hazard, you can say. Sunlight. Now what happens? Obviously river is open to the atmosphere, so sunlight will come, and now algae will be present here. So algae will make food under the action of photosynthesis and liberate oxygen. This oxygen will be used by aerobic microorganisms for carrying out the decomposition. So yeah, organic matter is being removed under the action of sunlight. Now sedimentation. You will say, ma'am, you told that for sedimentation turbulence should be 0 or very less. In rivers, is the turbulence 0? I'll say no. Is the turbulence very less? I'll say no. That's why For same functioning, in the length of sedimentation tank is required in meters for the settlement of particles. Since the turbulence is not zero and since turbulence is there in the rivers, you require more length of water in kilometers. That why for same function to perform in rivers, it take kilometers for the sedimentation of the suspended solids. So whatever solids are there, they will settle down under the action of its own weight, and this will happen on its own, that is by the action of sedimentation. So these are physical forces which will be happening. Now, the one is oxidation and reduction. What will be happening? Like obviously oxygen will be coming from the atmosphere, and meanwhile the decomposition will be carried out by the microorganisms for the organic matter. So simultaneously oxidation will be also taking place by the chemical action, and reduction will also be taking place. So these are known as chemical forces. All these things happen simultaneously. While teaching, I am telling you one by one, but in actual all of it happens simultaneously. Now, which treatment I have to give, that will depend upon the dilution factor. Now, initially, let me tell you, basically this was used by Royal Commission. Royal Commission was the one who gave this values. So he told when the dilution factor 150 is greater than 500, no treatment is required. If you have tested the sewage and it is, let us suppose the sewage is generated from your homes and it is coming, and I've checked it out that the dilution factor is 500 se zyada, more than 500, dispose it directly. No need to do any treatment. If it is 300 to 500, plain sedimentation, make sure that the suspended solids is less than 150 mm. If the dilution factor is 150 to 300, sedimentation, coagulation aided sedimentation need to be done. If it is less than 150, complete treatment, aeration, screening, sedimentation, filtration, everything you have to do to make sure that the BOD which comes out is 20 ppm and the suspended solids is less than 30 ppm. So check it out before disposal that the BOD which is coming out should be less than 20 ppm and the suspended solid should be less than 30 ppm. Now, if you want to calculate the dilution factor, see, it's not possible that you can measure the volume of the river. That's because you will say, ma'am, initially you took volume of sewage plus volume of river upon volume of sewage. Why here not you are taking volume? Why you are taking discharge here? Because it is practically not possible that I can measure the volume of the river. So I measure volume per unit time. Volume per unit time is what? Discharge. So discharge of sewage plus discharge of river divided by discharge of sewage. This is known as dilution factor. Correct? So you will check it out and based on that you will decide that which degree of treatment is to be given. Okay? Now, after this, the next important thing is what are the various zones of pollutions you have it in river. Now, initially, if this is a river flowing and this is a point, this is the upstream side of river and this is the downstream side of river. So let us suppose this is point P where you are disposing the sewage. So when you dispose the sewage at point P, on the downstream side of it, various phenomena takes place. Let's talk it about one by one. This is DO saturated. This is DO minimum. Now, what will happen is initially the water is clear water. The moment you dispose the sewage, on the downstream side, the DO will reduce suddenly. Why it will reduce? Because oxygen is being used. Why it is being used? And who uses it? It is being used by microorganisms. To be precise, aerobic microorganisms. Why? For carrying out the decomposition of organic matter. So in this region, what will happen? Algae will die. Fishes will be there in zone 1. The water will become slightly dark. And how will you know? Here decomposition of organic matter has been started by aerobic microorganisms. They have started to consume the oxygen which is present in the river. So the dissolved oxygen is decreasing here. When it goes to DO minimum, first stage is over. DO minimum generally it is 4 mg per liter. For the survival of fishes it is required, and DO minimum is generally taken to be 4 ppm. Now, zone 2 is zone of active decomposition. It is more critical. What will happen? The water will become very dark. You know, even the fishes which were alive in the first stage, they will also die. Algae already died, fishes will die. Now here, even it is possible that the DO level can reach to 0. Okay, when significant amount of decomposition of organic matter has taken place, now organic matter has been decomposed, now microorganisms will not have food, they will kill themselves on their own and go endogenous respiration. So now the oxygen which is there in water will not be used, so the level of dissolved oxygen will increase. Again, zone 2 is completed when the dissolved oxygen again reaches to DO minimum. Now in the third stage, since the organic matter is being decomposed, the DO level goes on increasing. But at no time DO level at stage 3 will be equal to DO saturated. Remember this, they can ask you in statement wise. DO third stage में कभी भी DO saturated के equal नहीं होगा. And that is why this is known as zone of recovery. The dissolved oxygen is getting recovered. Fishes and algae will again come in stage 3. And in stage 4, what will happen? It will again come to clear water. So the DO will again reach to clear water. So 4 zones you have: zone of degradation, zone of active decomposition, zone of recovery, zone of clear water. So here these 4 zones are there. In the first zone, fishes will be alive, algae will die. In the second zone, fishes and algae both will die. In third zone, fishes and algae will reappear. And in the fourth zone, you will see the water will again reach to DO saturated. Clear everybody? Clear everybody? Clear हुआ? चलो. So everything is written for you guys. लिख दिया यहाँ पर. Now, the next question comes that how the level is basically, how can you say that the DO level is increasing? How can you say that the DO level is increasing? Because initially more oxygen was being used. So see, reoxygenation was less, deoxygenation was more. See, KD was more than KR. More oxygen was being used and less oxygen was coming. So here what is happening? Deoxygenation was more and reoxygenation was less. So KD was more than KR. In the second stage, what happened was, in the second stage, initially more oxygen was being used and less oxygen was there. So it's like this. After a specified, you can say a larger quantity of organic matter have been decomposed, this reoxygenation curves increases. So this is KD and this one is KR. So if you take the resultant, it will becomes like this, a sack curve. So you call it as oxygen sack curve also. And the maximum deficit corresponding to it is known as critical DO deficit. Now the important things which is being asked, let's talk about it. Firstly, they will ask you, now let us suppose Sophia tells me that, ma'am, I want to calculate the deficiency after 5 days. Means after 5 days, what will be the deficiency? So this equation is given by Streeter-Phelps. Streeter-Phelps equation is KD is deoxygenation rate constant, KR is reoxygenation rate constant, D naught is initial DO deficit. What is initial DO deficit? This is DO saturated, whatever is the saturation dissolved oxygen at particular temperature minus DO mix. Mix is when you are disposing the sewage in water. Now you see, now in the question, very important. They will say it is sewage, they will write, they will say it is river, they will write river, but you have to apply your brain, it is now no more a river. Because in that river, even sewage is there. So technically, it is the discharge of sewage plus discharge of river. So DO mix is QR, DOR plus QS, discharge of sewage, DO of sewage upon discharge of river plus discharge of sewage. So you will minus it, you will get initial DO deficit. Correct? Similarly, you can calculate BOD mix, temperature mix, anything you can calculate. Now, critical time. Critical time is that time when you will get critical DO deficit. For calculating critical DO deficit, because critical DO deficit will occur when just maxima and minima concept, dt by dt, del by del t of del t, del by dt of del t becomes 0. So when you will differentiate it, you will get the value of critical time, that is 1 upon kr minus kd. This is a very big equation. I personally don't advise you to remember this equation. Rather, I tell you to remember this equation. F is self-purification constant, or you can take it as factor, which is Kr by Kd. Kindly remember this one. Kindly remember this one. And in this equation, if you substitute the value of T as Tc, then you will get the dissolved oxygen deficit as Dc. So don't waste your time in calculating or differentiating. Remember this formula. So the formulas which I have marked it with double stars, that are the formulas which are important for you. So kindly remember those formulas only. That's it. This formula, initial DO deficit, deficiency after T days, and if they ask you critical DO, because already they have asked it in the examination. So it's not that they haven't asked ever in the examination. Critical time and critical DO deficit. So these formula, the critical DO deficit means that the amount of maximum deficiency of oxygen, that is known as critical DO deficit, and the time corresponding to it is known as critical time. Clear? So this formula. Two formulas are there for calculating critical DO deficit, this one and this one. Now you will see, ma'am, which one to use. If in the question there is nothing related to critical time is given and it is not required to calculate critical time and waste your time, that time you can use this formula for calculating critical DO deficit. From here also you will get critical DO deficit. Got it? So this is the one thing which you can use it. Okay. Now let's solve question. चलो पहले इसको solve करते हैं. ये तो आप खुद भी सॉल्व कर सकते हो, कंबाइंड डिस्चार्ज बीओडी, पर अभी चलो पहले ये वाला क्वेश्चन सॉल्व करते हैं. दिस इज अ गुड क्वेश्चन. इसके बाद हमारे पास क्या बचा? ये तो लास्ट है. चलो चलो लास्ट है भाई. इसके बाद हम लोग फिर नेक्स्ट ब्रेक है. ब्रेक, कम ऑन, ब्रेक इज देयर आफ्टर दिस. What you have to calculate for the critical system, find location. Location means you have to find the distance, L. Okay. Discharge of sewage is given to you as 125 meter cube per second. Discharge of river is given to you 1600 meter cube per second. DO saturated is given to you as 9.2 mg per liter. Velocity of river is given to you as 0.12 meter per second. 5 days BOD is given to you. F is given to you 4. Oxygenation rate constant is given 0.11 per day. It is asking you to calculate the distance. How will you calculate? Come on guys, how will you calculate the distance? L पूछा, L. Location पूछा, distance पूछा. अब distance क्या होता है भाई? Velocity into time. Question में कुछ दिया है, velocity भी नहीं दिया है. Neither velocity is given, neither time is given. कैसे calculate करोगे? How will you calculate? Come on guys. Velocity भी नहीं दिया है. Come on. कैसे कैलकुलेट करोगे? वेलोसिटी दिया है क्वेश्चन में, दिया है रिवर का वेलोसिटी 0.12 मीटर पर सेकेंड. टाइम नहीं दिया है, टाइम निकालना है. हाउ विल यू कैलकुलेट द टाइम? निकालो भाई क्रिटिकल टाइम. क्रिटिकल टाइम TC is equal to 1 upon KD F minus 1 log base 10 F log base 10 1 minus F minus 1 DO naught by L. चलो मेरा तो उधर ही जा रहा है. सेल्फ प्यूरिफिकेशन कांस्टेंट फॉर्म. अब चलो फटाफट कैलकुलेटर यूज करो, अब इतना काम खुद करना. 1 minus 4 minus 1 is 3. L भी निकालना, F भी निकालना, अभी खत्म ही नहीं हो रहा है ये. चलो DO naught is, that is DO naught is इनिशियल DO डेफिशिएंट, जो कि होता है DO सैचुरेटेड माइनस DO मिक्स. DO saturated is given to us in the question. How much? 9.2 mg per liter. DO mix you have to calculate, which is discharge of sewage, DO of sewage plus discharge of river, DO of river upon discharge of sewage plus discharge of river. So 125 discharge of sewage तो बता दिया था मैंने. DO of sewage कितना लिखा था मैंने? DO of sewage कहाँ गया? Discharge of sewage is given, BOD of sewage is given 300. Okay. Discharge of river 1600. DO of इसका कितना था? एक मिनट. ये तो BOD है ना, ये DO थोड़ी ना. डिस्चार्ज ऑफ सीवेज कहीं भी मेंशन नहीं है क्वेश्चन में. BOD दिया सीवेज का, डिस्चार्ज नहीं मेंशन है. If nothing is mentioned, you will take it as 0. Discharge of sewage is 0 because nothing is mentioned. Okay, so excuse me, this whole will become 0. 1600 into discharge of river. River is fully saturated, so it is how much? 9.2 divided by 125 plus 1600. How much it comes? $8.533 subtracted from 9.2. 0.67 mg per liter. ठीक, एक चीज मिली 0.67. L is remaining. What is L? What is L? L क्या होता है? अल्टीमेट फर्स्ट स्टेज BOD. लेंथ नहीं है ये. L is ultimate first stage BOD. In the question what is given, ultimate BOD is 1.5 times BOD 5 days of the mixture. 5 days of the mixture. Now you have to calculate 5 days BOD mix. So BOD 5 days mix. Discharge of sewage, BOD of sewage, plus discharge of river, BOD of river, upon discharge of sewage plus discharge of river. अब BOD of river, see, अब यहाँ पे multiple concept is used. If the river is fully saturated, means in that organic matter is not there. If organic matter is not there, there is no BOD. So here BOD of river will be 0. Good question, because two concepts. पहले तो DO sewage 0, and if it is DO saturated, the BOD saturated means what? No microorganisms because no organic matter. So here discharge of sewage is how much? 125. BOD 5 days of sewage is 300 divided by 125 plus 1600. This will come out to be 125 into 300 divided by 125 plus 1600. Chalo, this will come out to be 21.74 mg per liter. अब इसमें 21.74 27.17 आ रहा है 27.173. चलो क्रिटिकल टाइम कैलकुलेट कर लो. जस्ट यू नीड टू कैलकुलेट क्रिटिकल टाइम. कम ऑन गाइस, कैलकुलेट क्रिटिकल टाइम. क्रिटिकल टाइम अब बस कैलकुलेट कर दो. इतना सारा मैंने कैलकुलेट किया, अब क्रिटिकल टाइम कैलकुलेट कर दो. एक क्वेश्चन इसके बाद और फिर आपको ब्रेक दे दूंगी मैं. मेरे को तो लग रहा है अभी 6 बज रहे हैं ना. ठीक है, चलो. Come on. What is the critical time coming? $27.173 and small bracket into 4. This will come out to be how much? Just a minute, once more. This one come out to be 27.173. तो वो आ रहा है, मैं critical time पूछ रही थी. I was asking critical time. मेरा आ रहा है 1.723 days. Check it out. Critical time. So velocity is coming 0.12 meter per second and this is 1.723 days. 1 day is equal to how many seconds? 86400. So what will happen is 0.12 into 1.723 into 86400. So this will come out to be 17864.064 meter. That means it will come out to be 178.64 17.864 kilometer. This will be the answer. एक क्वेश्चन हुआ. क्रिटिकल टाइम आई हैव कैलकुलेट 1.723 आ रहा है मेरा. अनवर चेक करना. ओके, अप्रोक्सीमेटली. चलो ठीक है, डिस्टेंस निकालिए. इट हैज आस्क्ड यू टू कैलकुलेट वैल्यू ऑफ क्रिटिकल DO डेफिशिएंट आल्सो, क्रिटिकल ऑक्सीजन डेफिशिएंट आल्सो. मैं यहाँ पे कैलकुलेट कर दूं. L by F 10 raised to power minus KD TC. L अल्टीमेट फर्स्ट स्टेज BOD ऑलरेडी कैलकुलेट किया था 27.173. 27.173. सेल्फ प्यूरिफिकेशन कांस्टेंट कितना था? 4 था ना. 4 4 10 raised to power minus KD, that is minus 0.11, and critical time came out to be how much? 1.723. देखो 10 के ऊपर E के ऊपर there is no unit, so this is D and this is 1.723. Calculate आखिरी, you will get the critical DO deficient. These are the values which I am getting. Clear, man? Clear? Correct. Now guys, with this we have completed this chapter. This question आप homework कर सकते हो. Combined discharge, BOD, DOD, temperature. ये बहुत simple है. So you just take the screenshot of it and this is homework question. Easy है. Very easy. Correct? So you can do this question. Chalo. Now you want a break? We started from 2:30, 3:30, 4:30, 5:30. अच्छा अभी तो 3.5 hours ही हुए हैं. Break guys? Yes or no? चलो हमारा डिस्पोजल भी हो गया. हाँ डिस्पोजल आई जस्ट टेल यू फ्यू थिंग्स. डिस्पोजल ऑन दिस वन कहाँ गया. Disposal on basically we don't do disposals in the case of this one land. अगर आप करते हो तो do two cases are there, effluent farming and sewage farming. So that depends that for what reason you are doing it. You are doing it for effluent farming or when you are doing it for sewage farming. पहले अब लिखते तो ये भी तो छूट गया था. ठीक है. Effluent farming main concern है कि आप उसको dispose करो. In sewage farming it is important that growth of crops is required. ओके सो दैट इज द थिंग. इसमें एक टर्म होता है आपके लिए होता है यहाँ पर सीवेज सिकनेस. What happens if continuously on the same patch of land you keep on disposing the sewage, so the voids of the soil gets clogged, because of which now the sewage cannot percolate and they just form a pile on the top surface and this is termed as sewage sickness. Okay, this is termed as sewage sickness. Now one more thing, now the other type of dilution which I said you, that disposal in sea by dilution. Nowadays you don't do disposal by dilution in sea because first of all you know that sea has less dissolved oxygen because it has more concentration of salt. Now if you talk it about when you dispose the sewage in the seas, first of all you have to dispose it only on low tides. You have to take it 3 to 5 meters below and you have to take it away from the shore. Okay, and basically what will happen is when you dispose the solids, sewage solids will react with the dissolved matter of seawater and they will form sludge. So imagine sludge bank will be formed near to the sea and rotten smell H2S you get. That is also one of the three. Now, so that is the reason 3 to 5 meters below, away from the 1.5 to 2 kilometers away from the shore, that is costly, and that too you have to dispose it in low tide conditions. You technically nowadays disposal in sea is obsolete, you don't use it. Apart from that, you had one more thing, that was disposal in lakes. Basically, disposal in lakes also we generally don't prefer. Reason is phosphorus is the main constituent which is responsible for it. Here actually the growth of algae takes place, and if the growth of algae takes place, more the growth of algae, more is the productivity of the lake, and lesser is the case you can use it for disposal, because eventually it will convert into marshy land. दलदल बन जाता है तो वो lake खराब हो चुका है, अब वो कोई काम का नहीं होता. It is of no use. Now if I talk about it also, like example, algae is there. Algae gives oxygen. This oxygen will be used by microorganisms for carrying out the decomposition of organic matter. Correct? इस कुछ लिखा था क्या? Okay. ठीक है. For carrying out the decomposition of organic matter, they use it. Now, while decomposition of organic matter takes place, they will release carbonates, nitrates, sulfates. You know, aerobic decomposition releases stable products and which are unobjectionable in nature. That means they will not produce any foul gases. These are used as nutrient for algae and these are used by fishes as well. Okay, so now if more nutrient you will give, algae will grow more. Okay, so that is the thing which will happen. So based on that, we have different layers. Now different, you can say lakes. But before that, I have to tell you one thing. There are various, you can say, layers which exist. One is epilimnion. The other one is metalimnion. And the last one is hypolimnion. See, metalimnion is the layer where basically what is happening during the onset of summers, you can see that the sunlight is able to penetrate. So in those places where sunlight is able to penetrate, oxygen will be there and aerobic conditions will remain. So that is known as epilimnion layer. Hypolimnion layer is that layer where like in summers and all, the water will not, the sunlight will not penetrate to the downside. Okay, up to a greater depth. So here in this zone, the availability of sunlight is restricted and this zone is known as hypolimnion. Here anaerobic conditions persist. And the steep gradient from epilimnion to hypolimnion, that is known as metalimnion, or you call it as thermocline. Now, when you talk about lakes, because questions from this topic has been asked in your GATE examination. Oligotrophic lake, least productivity. Least productivity means algae is very less, almost negligible. If algae is not there, sunlight will be able to penetrate even to the hypolimnion layer. So you will see that even you can see what is there inside the lake also. Sufficient availability of oxygen is there, and you call it as aerobic lakes. Generally in sceneries and all you have seen, or in discovery channels, you find it in Antarctica. In India you won't find it in maximum cases. अब कहीं पर मिल जाएगा तो अलग बात है. Mesotropic lakes, algae will be there. So intermediate productivity level will be there. Deficiency will be there. Slight deficiency of oxygen will be there, but still you will call it as aerobic lakes. After this, eutrophic lakes, high level of productivity means growth of algae will be more. So here sunlight will penetrate only to the epilimnion layer. Okay, and here what will happen? Deficiency of oxygen will be there. So you will call it as anaerobic lake. Senescent lakes की तो बात ही मत करो. Everywhere algae, this will be marshy land. Daldal ban chuka hai. Daldal. Practically it is converted into marshy land, a highest productive level which is there in the senescent lakes. Correct? Now, last is eutrophication. What is eutrophication? See, what happens if you continuously keep on disposing the sewage into lakes? What will happen is phosphorus will be there. Generally, phosphorus comes from the detergents and from the agricultural runoff because it is there in the fertilizers. Now, what will happen? Algae will grow, and everywhere it is growing in the lakes. So, the depth of water is becoming shallower in nature. Okay, so it will become shallow cell. Everywhere you will see greenish deposit. So higher productivity of lake because higher growth is taking place. Algal bloom will occur, and this process is known as eutrophication. Okay, now if you want to avoid this process, you don't want algae to grow. How can you regulate the growth of algae? You can avoid it by adding copper sulfate or calcium hydroxide. Okay, and not only removing it, don't allow further growth of algae. How cannot you allow further growth of algae? By cutting down, by not allowing the sewage to flow into the lakes. Because when sewage will not come, nutrients will not come. When nutrients will not come, algae will not grow. Okay, so just add it copper sulfate or calcium hydroxide so that algae doesn't grow, and apart from that, restrict the entry of nutrients. That means don't allow this. Restrict the entry of nutrients means what? Don't allow the sewage to come. Got it? Clear? So this is eutrophication और मैंने पूरा पढ़ा दिया. Clear? चलो अब हमारा बचा है treatment of sewage, air pollution and solid waste management. 3 topics are remaining. So start कर दूं अभी. Soil mechanics marathon tomorrow guys for you. Sewage treatment start करूं कि थोड़ा wait कर लूं? अच्छा एक काम करती हूँ, skimming टाइम तक पढ़ा देती हूँ. From trickling filter we will start it after break. What do you say? ये तो पढ़ ही चुका already. Screens we have already studied guys. Here actually only difference is there. Noise pollution gate में नहीं है. कब का हट गया? Shall I start? Divya, Anwar, Sophia. I'll teach you till ये skimming tank तक. So ये trickling filter and all I'll teach you with your fresh mind. Correct? Chalo. Screening already I have told you it is used for the removal of large floating matter, suspended solids. In the case of raw water, you are having 2 types of screens. Coarse screens, fine screens. Here you will have 3 types of screens: coarse screens, fine screens and medium screens. When the spacing, just check it out. When the spacing between the bars is 50 mm or more, you call it as coarse screens. When the spacing is 6 to 40 mm and the inclination angle is 50 to 60 degree, generally 30 to 60, 50 to 60, then you call it as medium screens. When the spacing is, see, this is mesh size, 1.5 mm to 3 mm, you will call it as fine screens. And this is the formula which I have already told you. V is the velocity through the screen. U is the velocity of approach. Got it? And K by 2G, if nothing is given, 0.0729. Correct? Now this we have already studied. Coming to commutators and macrometers. Technically, they are not a method of treatment. They just convert heavier solids into finer solids by cutting, tearing action. They will just convert a heavier solids into smaller solids. That is the function of commutators and macrometers. Okay. Now, if I talk about the next thing which comes into action is grit chamber. Now, the next thing which comes into action is grit chamber. Now, what is the function of grit chamber? What is the function of grit chamber? Is the removal of inorganic suspended solids. So, if you want to carry out the removal of inorganic suspended solids, you have grit chamber. Now, when you design, this is like a sedimentation tank only, but you keep it for a very less time. And question from this topic has been asked in your gate. So, you keep it for a lesser time. Ma'am, less means how much? About 1 minute. Now, your velocity, you have to be very, very careful. If you keep the velocity very high, inorganic particles will not settle. If you keep the velocity very low, even organic matters will settle. And the solids which settle in inorganic grit chamber, no, you don't treat them. You just directly dispose them. So if organic solids will settle, then there will be a problem. Got it? So that is the reason you have to select the velocity in such a way, you have to design it that only inorganic solids should settle and organic solids should move to the primary sedimentation tank. Now, for grit chambers, generally the velocity you keep it as 0.15 to 0.3 meter per second. I told you, you keep the water in here for 30 to 60 seconds, and depth you keep it 1 to 1.8 meters. And generally for safety purpose, you provide a freeboard of 0.3 meter. Got it? Apart from that, generally at inlet and outlet, the turbulence is there. So generally you increase the length by 25 to 30%. You do that. And if in the question it is asking you to calculate the velocity, which till now they haven't asked by using the formula. But in future, if they ask you to calculate the velocity in grit chamber, it is transitional in nature. So the formula for transitional velocity is this one. 4 by 3 gs minus 1 gd upon cd. Gs is specific gravity, small g is acceleration due to gravity, cd is coefficient of drag, and cd value, if it is giving you in the question directly, it's well and good. Otherwise, you can calculate like this. What is Re, ma'am? Re is Reynolds number, which is the ratio of inertia force to viscous force, that is rho Vd by mu. This is the formula for calculating. Till now, not asked from this formula in the examinations. If they do it in future, I have told you about it. Got it? So this was regarding grit chamber. Grit chamber is used for the removal of inorganic suspended solids. Now talking about skimming tank. Skimming tank is used for the removal of oil and greasy particles. If oil and greasy particles are there, they will not allow proper decomposition of organic matter. So what you do is compressed air, you blow it from the top, from the bottom, so that oil or grease already they have a lesser density. जो lesser होता, they will obviously, if you pour oil on water, you will see it is floating on the surface. So what you do is you put compressed air from the bottom so that grease and oil will move towards the top, and just like आप दूध में से मलाई निकालते हो ना, skimmed milk, वैसे you will remove this oil and grease from the top. So that is why this is known as skimming tank. If worst case they ask you the area required for skimming tank, it is given by this formula 0.00622 QVR, where Q is the how much flow is taking place in the sewage, and VR is the rising velocity of greasy material, the velocity with which the greasy material rise, that is known as VR, that is the rising velocity. So this is skimming tank. Correct? Now we will move towards trickling filter, which is a biological treatment. So how much time you need break, let me know, so that we'll move. See, trickling filter is there, then activated sludge processes, the question is there, oxidation pond, activated sludge process, and then sludge digestion. And then we will move towards air pollution. Septic tank, hemorrhage tank is there. चलो बहुत सारा है यार, अभी भी छूटा नहीं है. 15 minutes? Everybody, 15 minutes is okay? So we'll meet at 6:30 p.m. ठीक है. अच्छा फिर हम लोग सीधे पूरा सॉलिड वेस्ट मैनेजमेंट तक कंप्लीट करेंगे गाइस. वी विल कंप्लीट टिल सॉलिड वेस्ट मैनेजमेंट, देन नो मोर ब्रेक. If you want break, take it now. Otherwise, I will stop after solid waste management. अब पूरा complete करना, 10 बजे तक नहीं खींचेंगे यार. What do you say? 6:30 okay? Fine. 6:30. Hello everyone. So we are back, and this time let's complete. Good evening. Yeah, we'll start again. Guys, just wanted to tell you, if you don't know, that we have a quiz also related to today's class. So just one second. Okay, so this is the scanning code for the quiz. So guys, you can just scan it and you guys can attend the quiz as well. Okay, so the quiz related to today's class is there in the app. You will get it. PDF कुछ नहीं मिलेगा, यहीं पे लाइव पढ़ना पड़ेगा. कोई PDF नहीं मिलेगा. Hello Sophie, Divya, Anwar, Shubham. Good evening everybody. Okay. शैल वी स्टार्ट. अब एक टारगेट लेते हैं कि 9:30 तक मैक्सिमम कंप्लीट कर देंगे. 3 आवर्स है एंड दैट्स इट. क्या बोलते हो? व्हाट डू यू गाइस सेज? बाय 9:30 वील कंप्लीट इट मैक्सिमम. लेट्स ट्राई. गुड बाय. ओके, सो लेट्स टेक दिस अ टारगेट एंड लेट्स ट्राई. देखते हैं, टारगेट तो लेना ही चाहिए. सो लेट्स सी हाउ मच वी आर एबल टू कंप्लीट. ओके, चलिए. Okay, so now before telling you about this, I just want to tell you about two types of mechanism. One is, बताओ जरा, 9:30 और 10 होता है क्या? 10 is different and 9:30 is different. उससे पहले तो बोला मैंने. Maybe 11 also. अब क्या करूं मैं? खत्म ही नहीं हो रहा है. Okay, I'll try. I wish I try and it gets completed by 8:30 ppm. तो उड़ा के लेके जाऊं क्या? बताओ. शुभम and this who is there? अनवर. उड़ा के लेके जाऊं. ये होता बहुत जल्दी जल्दी पढ़ा दूं, फिर तो मैंने अभी 1 घंटे में कंप्लीट कर देना है. You want that to happen? That I should skip the parts? No, right? So that's why. Fine. Now I'll talk about two types of mechanism. One is suspended growth mechanism, one is attached growth mechanism. In suspended growth mechanism, what happens in water? Organic matter and microorganisms both are suspended in water. Microorganisms will search for organic matter and carry out its decomposition. So that is known as suspended. Means what? Organic matter and microorganisms both are suspended. While in the case of attached growth mechanism, what will happen? You will give a medium for the attachment of microorganisms, and then the decomposition of organic matter will be carried out by microorganisms, and this you call it as attached growth mechanism. So suspended growth mechanism is there. Microorganisms and organic matter are suspended. While in attached growth mechanism, what will happen is you will provide a medium for the attachment of biomass, that is microorganisms. Whenever I say biomass, it means microorganisms only. Okay, for the attachment of biomass, and then the decomposition of organic matter will be carried out. Now we'll talk about trickling filter, which is first of all aerobic. That means first is we will be carrying out aerobic. That means it will be taking place in the presence of oxygen. So it will be open to the atmosphere. You are not providing artificially air with the help of aeration tanks and all. It is open to the atmosphere. Secondly, here you will provide a medium for the attachment of biomass. That is why you call it as attached growth process. Now what you do, a feed pipe is there. A feed pipe is there with the help of which you will feed the sewage into the trickling filter. Here you have provided nozzles. Okay, you have provided nozzles. So from where the sewage will spread into this filter media. Filter media is provided by you. Now initially when the plant is being brought into treatment, okay, basically it is just came into operation and the sewage is brought into treatment. So for initially 2 weeks you will not carry out any you can say filtration process. No, you will not carry out any treatment process. Why? Because first you will give the time for the attachment of microorganisms in the filter media. So initially 2 weeks, that is 14 days, you give time for the this biomass microorganisms to get attached to the filter media. Okay, now I'll take one particle. This is the filter media and the different color I'll take for biomass. And generally the thickness of it is maximum, it varies up to 1 to 2 mm. So this is the thickness of biomass. This is the thickness of biomass. Now, eventually after 2 weeks, the plant is ready for operation and you can use it. Means you can start the treatment of sewage. Okay, because main function of biological treatment is you need to carry out the removal of dissolved organic matter. You need to carry out the removal of dissolved organic matter. So what happened? First 2 weeks you gave the time for the development of biomass layer. After that you start with the treatment. Now the water which is coming in that, what is there? In that organic matter is there and microorganisms is there. Microorganisms is already, they have formed a layer also. But the sewage which is coming in that organic matter is also there and microorganisms is also there. Now, this organic matter and microorganisms, it is there. Particularly, predominantly the sewage which comes in that organic matter is present in abundant quantity. Which organic matter? Dissolved organic matter. So this organic matter will come in contact with the biomass layer in which organic matter is there and the decomposition of organic matter will be carried out. They will be decomposed, so their dead bodies will also be here. Now the thickness keeps on increasing. So what will happen here? 0.1 to 0.2 mm, here oxygen will be available. 0.1, 0.2 mm, here oxygen will be available. But as you go near to the filter media deficiency, whatever, this is the filter media, here whatever layer is there, here deficiency of oxygen is there. Why? Because oxygen is available only to the top surface and it is not able to penetrate here. Okay, to this portion, supply of oxygen is not there. Whatever food is coming, that is also available for the upper layer. It is not penetrating here. So what will happen here? The microorganisms which are there near to the filter media, they will not get food. They will not get food. So first, more dominant one will eat the less dominant microorganisms. After that, they will just consume carbon from their own body. So that is termed as endogenous respirations. So the microorganisms will die. So here they are not sticky. So what will happen here? The bond will try to get loosened out because their dead bodies are there. So now they are not holded to the filter media. So what will happen now? The bond starts from here only, close to here, like this portion. Bond will start from here only, this portion. But whatever microorganisms are there, they have died. So what will happen? Now the bond has what? The bond is just wearing out. And because of that, if water comes, the high turbulence will be created and this whole biomass layer will be carried to the SST, that is secondary sedimentation tank. And this process is known as slogging. What is slogging? The process of removal of biomass layer is termed as slogging. The process of removal of biomass layer is termed as slogging. Now this happens, it goes on. In some filter media, biomass layer is getting formed. In some filter media, it is getting removed. So it is a process which goes on continuously. When it is getting removed, when it is getting formed. So it is a continuous process which is happening, which is termed as slogging. Okay, so the whatever filtered water which comes out from the trickling filter will have lesser concentration of dissolved BOD. Basically BOD, the value will be less because maximum amount of BOD or maximum amount of organic matter, to be precise, dissolved organic matter has been treated by the microorganisms. Clear? Now, if you will ask me that, ma'am, this disposal, basically the distribution which you do of this wastewater, how you do it? You have broader sense, you have two methods. One is rotary distribution system and another one is spray nozzle method. Generally the one which we prefer is rotary distribution system because here the sewage is fresh. While in nozzle distribution system, actually you spray for 3-5 minutes, then you just wait. Then you spray it for 3-5 minutes, then you wait. So that is known as spray nozzle method. Here, comparatively, the sewage is stale. While in rotary distribution system, you just continuously supply the sewage. So the sewage here is comparatively fresh. Now, if I talk it about, you have different types of trickling filter. One is standard rate trickling filter and one is high rate trickling filter. The difference between standard rate and high rate is high rate trickling filter, same decomposition will be carried out, but that in lesser time. So that is why it is termed as high rate trickling filter. Okay, now here what is happening? See, these are the denotions which I take. If you want, you can change the denotion, that is up to you. Okay, now SI is the BOD which is going into primary sedimentation tank. Technically, the function of primary sedimentation tank is the removal of suspended solids. But there is an added advantage that along with the removal of suspended solids, 20 to 30% it carries out the removal of dissolved solids as well. So the BOD which comes out is S0. This BOD goes into trickling filter and the BOD which comes out is S, and obviously S will be less than S0 because a significant removal of organic matter has been taken up by microorganisms in the trickling filter. Now you will take this in SST. See, if you ask me the truth, in SST also BOD removal takes place. But we assume that no BOD removals takes place in SST. So whatever effluent is here, whatever is the BOD here, that will be the BOD and you will dispose it. Either you give a tertiary treatment or you directly dispose it in the reverse lakes wherever you want to, depending upon the value of effluent which is coming. Now here, if you want to calculate the efficiency of trickling filter, that is given by influent minus effluent divided by influent into 100. This is the efficiency. One more formula for efficiency is given as 100 upon 1 plus 0.0044 U by, सिर्फ U ले लेती हूँ उसको मैं तो यहाँ पे. U. Now what is this U? U is organic loading rate, that is kg per day per hectare meter. I'll take it write this. Some people write it as U by V also, that is up to you. I just take as U only. In some books you will find they write U by V, in some books they write Y. Denotions can vary. You should understand what it is talking about. Now how much organic matter is going? If in 1 liter S0 is the organic matter going, in Q0 how much organic matter will go? Q into S0. And the total volume is V. So this you have to substitute it in kg per day and this volume you have to substitute it in hectare meter. So this is the formula. If they ask you, if you will say, ma'am, I don't want to substitute the volume in hectare meter, rather I want to substitute it in cubic meter. So you can use this one. Cancel out this and here you can use 1 plus 0.44 U. So when you are using this, here whatever is the organic loading rate, that is kg per day per cubic meter. This is the organic loading rate. Got it? So you can use this one also, you can use this one also depending upon the volume, whether you are taking in hectare meter or you are taking in cubic meter. You can use any of them. Now, if you want to increase the decomposition rate, what you can do is, you can do what? You can do recirculation. So a part of the sludge from SST, you will take it and you will recirculate back. This is known as QR. So here now the discharge will get Q0 plus QR. Since here you are doing it recirculation once, you will call it as what? First stage, or basically first stage high rate trickling filter. Why? Because here what you are doing it, you are just recirculating once. Other than that, procedure, everything remains same. Only what you have done, a part of the discharge you are recirculating back into the trickling filter for increase. See, if more microorganisms will be there, in lesser time the decomposition will take place. So whatsoever microorganisms settled in SST, you just took a part of it and recirculated back, so that in lesser time more amount of organic matter can be decomposed. That is the reason. So you call it as high rate trickling filter. Ma'am, is the formula same for high rate and standard rate? Exactly same, only one difference is there. U by F. U is again here, if you talk it about kg per day per hectare meter, only one. Now maximum students get confused, I am telling you here. This is recirculation factor. And how can you calculate recirculation factor? 1 plus R upon 1 plus 0.1 R whole square. Ma'am, what is R? R is recirculation ratio. That is QR by Q. Okay, some cases they will directly give you recirculation factor. In some case they will give you recirculation ratio. So check it out. Now you will say, ma'am, why haven't you used here F? Because if you use it also, see, R is what? QR by Q0. Here is any recirculation taking place? No. So if you will substitute F 1 plus r upon 1 plus 0.1 r whole square. So this recirculation factor will come out to be what? 1. So there is no use of writing u divided by 1. That's why we haven't taken it. But in high rate trickling filter, f will not be 0, and that is the reason we have, f will not be 1. So that is the reason we have included it here. Got it? Other than that, the whole formula is same. Fine. Now, here we have two-stage trickling filters. That means you are doing recirculation twice. So you will call it as two-stage. Okay, you will call it as two-stage. So let us suppose this is S. That's S not जा रहा था. The one which comes out is S dash. S dash will go here. The one which comes out from here is S, and that S goes here. Okay. So here actually, abhi tak they haven't asked ever till now two-stage trickling filter. But if in future they do so, so right now I'm telling you that here IST stands for intermediate sedimentation tank. Here one trickling filter is there and then another trickling filter is there. So what you are doing it, you are doing recirculation twice. You are doing recirculation. This is one, this is second. Ma'am, recirculation amount of discharge can be same. It may be not. That's why I've written QR1, QR2. They can be equal also. They can be different also. Here you have to calculate the overall efficiency. So the overall efficiency will be efficiency of first stage plus 1 minus efficiency of first stage into efficiency of second stage. This is the overall efficiency. Now, if you want to calculate efficiency, again same formula, but guys beware, you'll make mistake. Now check it out. It will be 100 upon 1 plus 0.0044 U by F1. Why F1? Because here it will be F1 will be 1 plus R1 upon 1 plus 0.1 R1 whole square. And what will be R1? QR1 by Q0. Correct? Now what is Q? What is U? U is how much sewage is entering. So how much sewage was entering? Q0 into S0 divided by the volume of this trickling filter is V1. So V1 in kg per day per hectare meter. Correct? This one. Now when you, I'll take it as U1. Now if you talk about the efficiency of second stage, this will be 100 1 plus 0.0044 U2 by F2. Will this be the formula? Now, ab galtiyan hongi. Now you will make mistake. Now check it out. R2 1 plus 0.1 R2 whole square. R2 QR2 by Q0. Okay. F2 U2. Now can you tell me what will be U2? Of course from here you can say to me that इसको तो यहाँ पर मैंने S लिया था ना, so amount of trickling filter what is getting S0 है, S0. This will be, यहाँ पे मैं इसको SI इसको S0 ले लेती हूँ because in the previous case also I've taken S0 ना, so I'll take this as S0, Q0 S0. Now can anybody tell me that what is U2? Can anybody tell me what is U2? ये important है. Can anybody tell me what is U2? What is U2? बस U2 बता दो, बाकी कुछ नहीं है इस क्वेश्चन में. Just you have to tell me what is U2. अब आएगा मजा. Maximum people will not know U2. Nobody is telling what is U2, guys. पहले 1 minus efficiency of 1. This also you will do. U2 दो तरीके कैलकुलेट करने के. First tell me, I want the answer. Can anybody tell me? चलो. U2 is किसी का भी नहीं है. U1 minus 1 minus V2 भी होगा ना, एक kg per day per hectare meter. So V will be there, V2, because the volume of this trickling filter is V2. ऊपर का बताओ kg per day में क्या आएगा? kg per day में क्या आएगा? चलो, किसी का भी नहीं है. is U2? अब मैं बता देती हूँ what is this U2. This is, let us suppose this is W1 by V1. W1 मैं यहाँ पे QS not लिखती तो और it will become lengthy, that's why I have written as a W1. W1 is the amount of BOD which is going into the first trickling filter. Q0, S0 was going, but was entire BOD or organic matter removed? Of course not. So what was going minus the efficiency, that much is removed. So W1 was going, out of that eta times of W1 is removed. So the remaining one will be how much? W1 minus eta times W1. So this will be going into the second trickling filter. So this is U2. Got it? This is U2, which you should know. Clear? So this you should know. So never asked till now, but if they do so, that's why you should know this. Clear? अब मैं actually I take kg per day per hectare meter as U. Some people take only kg per day as organic loading rate. So different people have different denotions, that you cannot do anything for that. Okay. Now guys, let's solve one question for this, because this was the things with trickling filter, first stage trickling filter, first stage, two stage trickling filter and standard rate trickling filter. Now, just I'll do the question. Just tell me one thing, what it is asking you in the question. Tell me the, you can say denotion. A single stage filter is there. It is used to treat 3.79 mld of raw sewage. BOD of the sewage is given to you 240 mg per liter. Now BOD loading rate is given to you 11086 kg per day per hectare meter. Recirculation ratio, that means R is given to you 1. What will be strength of the effluent? Can you tell me what it is asking? Can you tell me what it is asking? Can you tell me what it is asking? Very good, Divya. It is asking me S. Strength of effluent means what is the, see, S0 was going here. What is the effluent which is coming out? It is asking me that. Okay. Now, here for calculating S, first I need efficiency to be calculated. So, efficiency formula which I will take it here is 100. 1 plus 0.0044 U by F. Efficiency I need to calculate 100. 1 plus 0.0044. This will be 11086 divided by 1.6. How much it will come? You will get the efficiency in percentage. S पूछ रहा है S. How much you will get? Quickly solve कर लो. मुझको time लग रहा तो मैं ही solve कर लेती हूँ. $73.4937. 49%. Now you know there is one more formula for efficiency, influent minus effluent divided by influent into 100. Okay, you already know that the efficiency is 73.49. You just calculate it, divided by 100. Influent is given to you as how much? 240. Just calculate the effluent. That which is asking you. So into 240. $63.615. This will be the value which you will be getting. Correct? Okay. Such questions can be asked. Till now, they haven't asked two stage in your gate. Okay. Now, next talking about rotating biological contractor, which is again an aerobic attached growth process. Exactly like trickling filter. Mechanism is somewhat same, but here the filter media which you have provided is disc. Okay, here you have provided disc, which you can check it out here. So you have provided disc here. So multiple disc will be there. Multiple disc will be there, which will be there just like you can see it here. So they will be arranged in series. Generally, what you do, you 40% of the disc, like 40% of the dia, you kept it immersed in wastewater. And why in wastewater? Because in wastewater, organic matter is there. Okay, so initially same, a few days, a week and two, you give time for the attachment of biomass layer for the microorganisms. So now what will happen here? The biomass layer has been formed. Here, the biomass layer has been formed. Now what will be happening? Initially, this biomass layer will be dipped, 40% will be dipped, and now 60% is open to the atmosphere. So what they do, this microorganisms, this biomass layer first takes oxygen from the atmosphere, and when you bring them down, with the help of that oxygen, whatever organic matter is there in water, they carry out the decomposition of it. Again, you rotate them, that will go up. So again, they will consume oxygen from the atmosphere, and again they will go down and they will carry out the decomposition. So this process goes on, and what will happen? The decomposition of organic matter will take place. Again, when decomposition will take place, the dead bodies will be there. So thickness of the biomass will increase. Then oxygen limitation ever. Availability of oxygen is limited only in the upper part. When you speak a lot, now I'm speaking from more than how many hours? 8 hours. So now it will happen like this. Okay. So the oxygen availability will be limited only to the upper parts, and it will not be penetrating to the lower parts. So what will happen? The ones which will not get the oxygen, they will go for endogenous respiration, and then they will be removed off, which is known as slogging, and they will go to the SST. Okay, so this is also a process. Phenomena is same, but here you haven't used filter media. Rather, you have used a rotating disc for the attachment of biomass layer. But the process is same, and therefore you call it also as an aerobic attached growth process. Thank you, Sonu Kumar. Can be 100% degradation हो ही नहीं सकता. कोई भी चीज लाइफ में 100% हो ही नहीं सकती. कुछ ना कुछ कमी रह ही जाती है. It can never be 100%. A person cannot be 100% happy. Maximum people, कुछ भी लाइफ में 100% नहीं हो पाता. So similarly, 100% removal of organic matter will take infinite time. If 100% हो जाता, then why would we have taken BOD 5 days at 20 degrees Celsius? We would have waited for 100%. Not possible. हो ही नहीं सकता. Got it, Anwar? So this is your rotating biological contract. Now let's talk about oxidation bond. I've solved one question. And I'll ask you that question. मैंने solve कराया था. I made solve this question in pre class. Algal bacteria symbiotic relationship takes place in which type of lakes? अभी पहले मैं आपको I'll give you few things about oxidation bond, and then you can answer this. Algal bacteria symbiotic relationship. Symbiotic relationship means mutual relationship. You give something to me, I'll give something to you. Like I'm giving you knowledge, you give me rank. So that's like your profit also and my profit also. We are mutually giving each other something. That is symbiotic relationship, mutual relationship. So that takes place in oxidation bond. Here, this itself acts as a complete treatment unit. Why? It removes suspended solids also, organic suspended solids. It removes dissolved solids also, and it carries out the digestion of sludge also. So it itself acts as a complete treatment unit. Now, if I talk about oxidation bond, this is basically flow basins which is taking place, which you can check it out here also. Now, here two things are happening. Two symbiotic relationship is happening. What are they? Algae in the presence of oxygen. Basically, algae will make food under the action of sunlight, and during the process of photosynthesis, it will liberate oxygen. This oxygen will be utilized by biodegradable organic matter, or to be precise, firstly, it will be utilized. मुझे बड़ा चाहिए यार, नेक्स्ट पेज में लिखती हूँ, छोटा छोटा बनाना पड़ेगा. This is the river flowing. Two types of symbiotic relationship takes place. What are they? Algae under the action of photosynthesis will liberate oxygen. This oxygen will be consumed by whom? This oxygen will be consumed by aerobic microorganisms, and they will carry out the decomposition of organic matter. And during aerobic decomposition, which you get carbonates, you get sulfates, you get nitrates. Okay, this carbonate, sulfates and nitrates acts as nutrient. So this is one. Algae gave oxygen, aerobic microorganisms gave carbon, sulfur, nitrogen. So you also got benefited and I also got benefited. That is aerobic microorganisms and algae both got benefited. One more thing is there, this carbonate sulfates is also used by anaerobic microorganisms, and this anaerobic microorganisms will liberate carbon dioxide and all, and this carbon is utilized by aerobic microorganisms. So one more symbiotic relationship exists between aerobic microorganisms and anaerobic microorganisms. Now, if you talk about the ponds, you have basically three types of ponds which takes place. One is aerobic ponds, one is anaerobic pond, one is facultative pond. Now, you will ask, ma'am, which is the pond which is more, you can say on more prevalent basis, prominent basis, that is facultative pond. Aerobic pond is that in which oxygen is available entire through the depth. So, generally, you know, as the depth becomes more, restriction of oxygen goes because sunlight cannot penetrate. So, generally, the depth is 0.5 meter to 1 meter. Anaerobic pond, obviously the depth can be more up to 3 meter, 4 meter, because here mainly the decomposition is being carried out by anaerobic microorganisms. Facultative is on the top surface oxygen is available, so aerobic decomposition. On the bottom surface oxygen availability is limited or restricted, so anaerobic decomposition. Correct. Now I'll ask you one question, you answer me. Algae bacteria symbiotic relationship takes place in which type of pond? Three options: aerobic pond, anaerobic pond, facultative pond. Now answer. Come on. Algal bacterial symbiotic relationship. Which type of pond? Aerobic pond, anaerobic pond, facultative pond. भाई algal, एक बात बताओ. वेरी गुड शुभम, वेरी गुड अनवर, वेरी गुड. ऑक्सीजन, हु यूटिलाइजेस ऑक्सीजन? एनारोबिक थोड़ी ना यूटिलाइज करता है. हु यूटिलाइजेस ऑक्सीजन? Algae, I asked. Algae bacteria symbiotic relationship. So this takes place in which type of pond? Who will utilize oxygen? Aerobic microorganisms. So this is known as aerobic. This is known as aerobic pond. Got it? Sure. Now, one more thing I'll tell you, one formula if they ask you, generally the detention time should be minimum 14 days. If it is less than 14 days, that means you need to redesign the oxidation pond. Oxidation pond designing means to calculate length, width and depth. The formula for detention time is given by, or you can use this denotation, 1 upon Kd log L upon L minus Y. Now what is L? L is the BOD of the effluent. Generally maximum people get confused in Y. Y is not the BOD of the effluent. It is BOD removed. Now example, if 300 mg per liter is the BOD which was coming and 30 is the one which is going and this was coming, can you tell me what will be Y? It was influent. This is influent and 30 is effluent. So can you tell me what is Y? Can you tell me what is Y? Quick. Very good. How much? 300 was coming, 30 is going. How much is removed? 270 is removed. So this will be 300 minus 30. For this case, 270. Got it? This you should. Fine. Now we have reached to activated sludge process, which is aerobic suspended growth process. Now sludge digestion tank, septic tank, hemorrhage tank भी है. चलो by 7:30 or 8 we will complete this. Let's see. ASP, very very important. This year also means 2023 4 moon session 1 marks. They have asked activated sludge process. Now this is an aerobic process, but this will not be open to the atmosphere. You will be supplying oxygen in the aeration tank. चलो अभी सबको first of all let me ask you guys, it is clear now? Trickling filter, rotating biological contractor and oxidation pond. All three are clear? Clear everybody? चलो मैंने इसे पोस्ट भी कर दिया. क्लियर क्लियर क्लियर. चलो okay. Now we will start activated sludge process, which is aerobic suspended growth process. Aerobic because it is basically here we will be supplying oxygen, okay, basically with the help of aeration tank. Suspended growth because in water microorganisms and organic matter will both be suspended. So what will happen? Organic matter, microorganisms will search organic matter and carry out the decomposition. When I say that microorganisms will search organic matter, by default you have to apply brain. Then I am talking about biodegradable organic matter. That is simple. Now, in any process, if you don't use SST, it will not create any impact or hardly any impact. But if in case of in the case of activated sludge process, if SST, that is secondary sedimentation tank, is not there, activated sludge process will not at all happen. It will not function only. Got it? It will not function only. So in other cases, if you were not having a SST, it will somehow manage. But here it will not function only. It will not function at all. Guys, so this is what activated sludge process. Now what happens here? Let's talk it about. Here what will be happening? Raw water will be there. First it will go to the PST and then it goes to the aeration tank. Here let us suppose Q0 is the discharge or Q whatever you want to take and S0 is the BOD which is coming. Now here the God, just a minute, the bottle fell down. Sorry. Okay, so now what will happen? The BOD will be coming. Along with that, organic matter will be there. BOD means organic matter will be there. Along with that, microorganisms will be there. The microorganisms which comes from raw water or from PST is very less. If it is not given in the question, you can take it as 0 also. Okay, so now here what will happen? Microorganisms will search for organic matter and carry out the decomposition of it. You will be the one who will be supplying oxygen. So here aeration tank will be there. Okay, when you have supplied oxygen, microorganisms will consume that oxygen and carry out the decomposition of organic matter. After that, it will form a biomass and that will get deposited in the secondary sedimentation tank. A part of this which is deposited, you call it as QU, useful sludge concentration, and the microorganisms you call it as XU. So a part of it you will recirculate it and a part of it you will take it to the sludge digestion tank. Okay, now this is very important recirculation because the microorganisms coming is very less. So if you want the decomposition to happen, you need more amount of microorganisms and that will come when you will recirculate. Okay, so XU is the amount of microorganisms which will be present in the recirculated sludge and that is the reason SST is required. So when you talk about activated sludge process, this is the whole system. Not the excess sludge is not the system. This is the whole system. So you call it as a system. This is the whole process. In trickling filter, 1 unit was there. In rotating biological contractor, 1 unit was there. Here, no unit is there. Here, combine both of them, you will call it as system. Got it? You call it as system. Now, here you have various things which we have to talk it about. Here, first of all, you will be recirculating. I'll tell you Q0 is the discharge which is coming. S0 is the influent BOD. The discharge which goes out from here is Q0 plus QRS. You will assume that no BOD removals takes place in SST. In actual, it does, but for simplicity of the calculation, we assume that no removal of BOD takes place. Out of from here, what will happen? Q is the one, Q0 minus QW. This is the one which will be going out, means you will dispose them, and the microorganisms in it will be XE and the effluent BOD will be S. Okay. Now, other BOD, I said that no BOD removal take place in SST. So, here also S, here also S, here also S. And when the BOD which will be recirculated, here also S and here also it will be S. Correct? Because you assumed no BOD removal in SST. So that's why whatever BOD was coming from the aeration tank, you just took it there everywhere the same. Correct? Now, here few things are there, few parameters are there which you need to know. First is hydraulic retention time. So for how much time we are talking about? Basically, here aeration tank is there by which you will be supplying oxygen, in which you will be supplying oxygen. So if you want to calculate the time for which you are supplying oxygen, that will be volume by discharge. Volume of the tank divided by the discharge which is coming into the aeration tank. So V by Q naught, or you can write V by Q. Next is organic loading rate. As I told you, how much organic matter is getting loaded. If in 1 liters, S naught is the BOD. So in Q naught liters, how much will be the BOD? Q naught into S naught divided by the volume of the tank. This is known as what? Organic loading rate. Okay, now they have denoted U for something else. It depends upon you. You can use anything. Now this is a new thing they haven't asked till now, but they can ask you this parameter, organic loading rate, hydraulic retention time. They have already done. Now specific food, this they haven't asked you ever till now. Specific food, substrate utilization rate, BODR utilization rate. Basically BOD remaining utilization rate. Now it is basically how much organic matter is removed. So how much organic matter is removed? Check it out. Q naught S naught was the organic. In 1 liters, if S naught is the BOD, in Q naught liters, how much it will be? Q naught into S naught. So this is the BOD which is going into the tank. Okay. After this, how much is going out? QWS and Q naught minus QW. So how much is removed? Q naught S naught was going in, and this is going out. So in minus out will give you the remaining which is removed. That much organic matter is removed. Divided by mass of biomass. That means mass of microorganisms present in the system. So if in 1 liter X, that is MLSS, mixed liquid solid concentration is present. So in whole volume V, how much will be present? So it will be V into X. Got it? So this is the specific food or substrate utilization rate. Is it clear? Is it clear? No, because minus QWS plus QWS will get cancelled out. So you will get this formula. Okay. Now, if in the question MLSS is given mixed liquor means sewage sample. Technically, the most you can say prominent one which we should use is MLVSS, that is mixed liquor volatile suspended solids, because in that inert matter is not there. But actually for calculating volatile suspended solids, it is tedious and time consuming. That's why we go for MLSS. Technically, we should go for MLVSS, but since it is time consuming and tedious, we take everywhere MLSS. Okay, now sludges. This has been asked in examination, so it is important. Sludge age is the time for which the microorganisms is there in the system. So if in 1 liter X is the microorganisms, in V volume, how much will be the microorganisms? V into S. Divided by how much microorganisms is going. How much microorganisms is going? This QE into XC microorganisms is going, and QW into XU microorganisms is going. So this was you have done it here. XC plus QW into XU. Maximum cases, they don't give you XC. So if XC is neglected, you will get the sludgeage as Vx into QWXU. But kindly remember this formula. Don't remember this, because if in the question they will give you XC, you will mark it wrong. So kindly remember this formula rather than remembering this. Correct? Last, you should know, second last, that is recirculation ratio. This topic question has been asked, concept from this has been asked in 2023 ESC conventional. Okay, so if they ask you how much is the sludge which is recirculated, because SST will be there, then you will recirculate the sludge. This is QR XU, this was Q naught X naught, this was Q naught plus QR X. This was aeration time. So if you apply what conservation of mass here, Q naught X naught is going plus QR XU is going, and how much is coming out? Q naught plus QR X is coming out. So when you solve this, this is the recirculation ratio which you will get. This is the recirculation ratio. So if you want to remember it, or it will hardly take a minute maximum to derive it. So if you want to derive, if you are clear with the diagram, you can derive it also, or you can remember this. This is the recirculation ratio. That is recirculated discharge to the original discharge. Got it? So this is recirculation ratio. Fine. Now, Last one is sludge volume index. What is sludge volume index? Volume occupied in ml by 1 gram of suspended solids when allowed to settle for 30 minutes. Now, technically, if they don't mention you also, by default, it should go into your head that sludge volume index is calculated in ml per gram. So, for converting mg into gram, you will write 10 raised to power minus 3, which will go up and it will become 10 raised to power 3 plus. Okay, so this is the formula. Ma'am, if they directly give you in grams, then don't multiply by 10 raised to power 3. If they don't give you, generally they give you in mg per liter. That's why you multiply by 10 raised to power 3. Now, what happens? What you do is, you take, now how you find it out, I'm telling you that. You take a jar and you put sewage. Okay, leave it for 30 minutes without disturbing it. How much volume is occupied by the solids, you will calculate that. Okay, you will just see it. Calibrated cylinder is there. So here what will happen, you will just put the sewage. Okay, you will just put the sewage and you will leave it for 30 minutes. So whatever solids will be there, that will settle. So we'll just measure the volume of it. Okay, after this you will just basically what you will do, you just stir it and make that solids dissolve, again soluble, or just make that solids in suspension, whatever. Now take that same sewage and do the suspended solids test. Okay, or do basically the gravimetric test. So total solids test. So what you will do is, that sample, vaporize it, and at 104 degrees Celsius 24 hours you will get the solids weight. So volume occupied in ml by 1 gram of suspended solids. So first you will measure how much space is occupied by that solids. After that what you will do is, you will do what? You will do is, you will basically stir it, make it again in suspension by 1 gram of suspended solids. Then you will pass it through the filter paper, 104 degrees Celsius 24 hours. That same thing, 104 degrees Celsius 24 hours, and then whatever you will get will be suspended solids, that is XOP. So volume occupied in ml by 1 gram of suspended solids when allowed to settle for 30 minutes. So if you talk about the procedure, this is the procedure which is being done. Got it? Now, डेड सेल मास मतलब क्या? इनऑर्गेनिक मैटर, इनर्ट ऑर्गेनिक मैटर की बात कर रहे हो. इनर्ट ऑर्गेनिक मैटर बेसिकली इट्स प्रेजेंट, नॉट प्रेजेंट इन MLVS. चलो, now this one question you have to calculate multiple things, but इससे पहले just let me tell you the question which was asked in GATE 2023 forum session. Food by microorganisms ratio. Food is what? BOD, that is organic matter, Q into S naught. In 1 liter, if S naught is the BOD, in Q liters, Q upon S naught will be the BOD. M is mass of microorganisms. If X is the mg per liter is the mass of microorganisms, so in total volume, how much it will be? V into X. Got it? Now, let's talk it about the question. Wastewater flow, that means what is given to you? Q naught is given to. Volume of aeration tank. Influent BOD, effluent BOD, MLSS. Effluent suspended solids means XC. Correct? Suspended solids means microorganisms. Wasted sludge suspended solids. Basically XU. जो wasted होता है उसमें भी XU present होता है. Quantity of wasted sludge flow rate QW. First you should know to basically denote them. Now it is asking you hydraulic retention time. Hydraulic retention time is what? Volume by discharge. Come on guys, calculate. How much it is coming? It will come less, so 1 day is equal to 24 hours. Come on, calculate fast. Come on guys. Divya, Prince, everybody. 74 नहीं आएगा भाई. इतनी देर थोड़ी ना एरिएशन करोगे तो कितना कॉस्ट आएगा? 7.474 hours. Okay. Food by microorganisms ratio. Q S naught upon Vx. Q, always write the units, 35,000 meter cube per day. 250 mg per liter. Volume is 10,900 meter cube, and this is 2,500 mg per liter. Solve it. Quick, जल्दी बताओ, I'm waiting. .32 per day. BOD removal efficiency. Efficiency तो you can calculate. Influent minus effluent divided by influent. Both is given to you. 250 minus 20 upon 250 into 100. How much it is coming? 92%. Okay, what is given? One is BOD removal efficiency, F by M ratio, sludge age. Last is sludge age. The time for which microorganisms remain in the system. Vx, Q naught minus QWXC plus QWXU. XC given as quotient. It is not 0. So don't take it 0. That's why I'm telling you to remember the first formula. Q naught 30, V कितना दिया था? 10,900. X is given to you as how much? 2500 mg per liter. $35,000 minus 220. XC is given to you 30 mg per liter. And how much is XU? 9700. Chalo. You will get the sludges in days. Come on, solve it. Come on, solve it. 10,900. मैं ही क्यों सॉल्व करूं? तुम लोग सॉल्व करो. कितना? .576. और किसी का? अच्छा. Got it? So one equation, one question I made you solve each and everything. Any doubts? So now we will move towards sludge digestion tank. Whatever sludge which is generated from primary sedimentation tank or whatever is generated from secondary sedimentation tank, we will digest it, because in that again organic matter is present and we cannot just dispose it directly. First we need to treat it. So sludge digestion, basically here sludge digester will be there in which you will be carrying out the digestion of sludge. Basically here three components will be generated during digestion. Gas like methane, which is known for its explosive tendency, but you can collect it and you can sell it, or you can use that energy for running the plant. You get supernatant liquor, which has a high BOD concentration of 1500 to 3000 ppm. So you will send it back again to the PST. And the third one is the digested sludge, which you will take it to the sludge drying pits. Okay, now let's talk about it one by one. Now in the stages of sludge digestion, basically three stages takes place prominently. First is acid fermentation, then acid regression, and then alkaline fermentation. They will ask you to basically arrange them also. So that is the reason you should know about it. Acid fermentation, there are two types of microorganisms which will be carrying out the decomposition. One is acid formers, which are highly competitive. Give it to them, they will eat it. Methane formers are pH sensitive. So they work only a pH of 6.5 to 7.5. Ma'am, if pH is slightly more than 7.5, it will not function. Ma'am, if pH is slightly less than 6.5, methane formers will not function. They are very sensitive. Okay, acid formers are competitive. Give it whatever to them, they will just use it, eat it. But methane formers are pH sensitive. Okay, so they work in a narrow pH of 6.5 to 7.5. Now in acid fermentation stage or the production state, what happens is, firstly you bring the sewage. fresh sewage is there, generally it is attacked by acid formers. Acid formers are facultative as well as they can be anaerobic. They will convert it into acids and alcohols. Basically, they will solubilize it through hydrolysis. Now, this acids and alcohols which are being there, they will reduce the pH and it will bring it to 6. Second stage, what will happen is acid regression will happen. These volatile organic acids which are formed in the first stage, they will be reduced to carbonates and ammonia compounds. So now the pH will rise from 6 to 6.8. Now in the third stage, methane formers will come into action, and because 6.8 pH, methane formers can function, it works in a pH range of 6.5 to 7.5. So now what will happen, methane formers will come and this ammonia compounds and all, it will convert it into methane. Last stage is methane. If the methane is produced, that means your decomposition is complete. Okay, and this time the pH is slightly greater than 7, so it's okay. No issue. Okay, so last stage is the one in which methane is produced in a higher quantity. Ma'am, how much? Generally 65% up to that methane is being produced, 65 to 70%. So this is the chronologies. It's not all the things happen simultaneously. No. First, acid fermentation will happen, then acid degradation will happen, and then alkaline fermentation will happen. This is the chronology which you have to follow. Now, talking about the gases produced, this is very important. They can ask you. Now, whatever is the solids which comes from the PST, out of this, see, 70% of the solids are volatile solids. So, the remaining non-volatile are 30%. Non-volatile solids, you also call it as fixed solids. Now, out of 75% solids, how much will be reduced to gases? 65% will be reduced to gases. So how much will remain? 65% is reduced to gases. So how much will remain in the tank? 35% will remain in the tank. So if they ask you to calculate the volume of the tank, 30% non-volatile solids will remain plus 35% of 70% volatile solids will remain, because this 35% will not be reduced to gases. Got it? And if they ask you to calculate the volume, so it is in two ways you can calculate. 0.6 meter cube per kg of volatile solids present. This 70% of volatile solids is present. Or 0.9 meter cube per kg of volatile solids reduced to gases. Which one is reduced to gases? 0.70 ka 0.65 is reduced to gases. Slightly there is a difference, but approximately both of them are equal. You can use any one, but if in the question it is telling you to use 0.9 meter cube per kg, use that. If it is telling you to use 0.6 meter cube per kg formula, use that. Okay, till now they haven't asked question from this topic. It has been asked in ESE conventional but not in GATE. So they can ask you this. And if you ask me that how much is methane, as I told you, 65 to 70% is methane, 30% is carbon dioxide and traces of other gases. And methane calorific value is 8600 kilocalorie per meter cube. Got it? Now, if I talk further, ma'am, how does anaerobic digestion takes place? In the sludge digestion tank, you have sludge digesters. So this is the sludge digester. So what will happen? You will feed the sludge from PST into this tank. Okay, primary sedimentation tank, whatever sludge is there, you will feed it here. So now what will happen? Obviously, acid formers will act, acid fermentation, regression, acid, this one. Acid formers, acid fermentation, acid regression, alkaline fermentation, all will take place. And what will be happening? Three things will be produced. First, solids. Solids are heavier in weight, so they will settle down. Gases are higher in weight, so they will try to move up. See, when they try to move up, they try to carry the organic matter also with it. But organic matter is heavier, so they lift, the gases lift them, but they deposit in this zone. That is supernatant liquor. They will deposit in supernatant liquor. Okay, the suspended solids or the organic matter which the gases has taken, and these gases will move up. So you have floating and fixed cover by which you just measure the gases, or you just take out the gases at a constant rate. Okay, and whatever supernatant liquor is there in here, gases have taken what they have just with them, they have taken organic matter BOD also. So this BOD is being here. So that is the reason in supernatant liquor you have high BOD of 150 to 300 ppm, and that is the reason you will send it to again PST. You will send this supernatant liquid to PST. Why? Because from the active zone, when gases was being liberated, it was carrying it upwards, but it cannot carry the organic matter high enough, so it left it in the supernatant liquid. So now the BOD is very high, so you cannot dispose it, so you have to take it back to the PST, primary sedimentation tank. So this is standard rate sludge digester. Now talking about high rate sludge digester, exactly same, only difference is here active zone, you were doing no mixing. So what happens? Microorganisms has to search organic matter and carry out the decomposition. While in high rate sludge digester, high rate is what? In lesser time you are carrying out the decomposition. So in high rate sludge digester, what you do is you first do mixing. 10 to 15 days generally you do mixing, so that opportunity of microorganisms to search and carry out the decomposition of organic matter increases. Correct? So now what will happen? You are bringing the PST. From PST you are bringing the raw sludge, 1 degree sludge, primary sludge, all means the same. So I'll write it. 1 degree sludge, primary sludge, all means the same. Okay, so you do the mixing 10 to 12 days, 15 days, you do the mixing so that opportunity of contact of microorganisms with the organic matter increases. Once it is done, you will feed it here. Now here you don't have to do nothing. According to their densities, again solids will settle bottom, then supernatant, and then gases. Exactly same, but in the previous one, standard one, you were not doing mixing. In the high rate one, you are doing the mixing. So here if they ask you to calculate the volume, it is given by C. Here also that same case, linear and parabolic. If they ask you to calculate the volume, this is, I'm talking about standard rate sludge digester. It is V1 plus V2 by 2. How much volume is coming of sludge per day and how much is getting digested into T. And T is the digestion period. Correct? Now, if they are telling you the variation is parabolic, so this is the formula. V1 is again incoming minus 2 by 3, V1 minus V2. Now let us suppose if monsoon is there, rainy season is there. So whatsoever is the sludge digested, you cannot take it, you cannot dispose it to sludge drying beds. Okay, you cannot take it to sludge drying beds. You have to keep it there only. So in the case of monsoons, you cannot dispose it and you have to keep it in the tank only. So you have to provide additional volume for that. Ma'am, how can we know? In the question it will mention you. If it is giving you the monsoon period and it is not telling you to neglect, that means you have to take into account that volume as well. So V2T, that means whatever is the digested sludge, you have to keep it for T time. T is the time till which rainfall is taking place, till the time monsoon is happening. Okay. Now, next is linear variation, same. But if it is telling you to take into consideration basically the volume during the monsoon time, so whatever digested sludge is there, that will remain till the time the rainfall is going on, monsoon is going on. So if they're telling you, giving you the monsoon period, take this thing. If they're not telling you, then ignore it. Got it? Now, this was for standard rate sludge digester. Okay, high rate, first stage volume will be different because here different equipment is there, here different equipment is there. So here if I'll talk it about V1 into TD1, because here you are keeping it for different time. V2 will be, you're feeding this here. So it will be like a V1, whatever is going out here, plus V2 into 2 into TD2. Okay, volume which is coming here V1, that same volume will be going here V1. Okay, and this volume which goes out, that is V2. But the time here is different for this one and the time here is different for this one. So that's why two different. And don't make this mistake. I'm telling you, I'm warning you. If they ask you, don't do V1 plus V2. Why? Because these two are different. This is different, this is different. So you don't try to add it. Okay, this is a different active zone you are provided for mixing. This is the sludge digester we are provided differently. So don't add it. These two are separate volumes. Got it? अब देखो sludge digestion tank चल रहा है और आप ASP बोल रहे हो अनवर. Sludge digestion tank चल रहा है. Clear? चलो. One question from this, then we will move towards septic tank. चलो. This question, digestion period is given to you TD days, discharge Q, suspended solids S0, moisture content, specific gravity. बता दो क्या बताओ, डिजाइन करना. Means you have to calculate the dia. वैसे मयंक अनवर ने भी बोला था, उसको भी थैंक यू बोलो. चलो, you have to calculate the dia. Come on guys. For calculating the dia, you need volume because volume पता होगा, so pi by 4 d square h, you will get the dia. Okay, height is given to you 6 meter. So how will you calculate the volume? पर बोला तो था ना यार. चलो, calculate करो. You need to calculate the volume. क्या होगा भाई? Volume will be volume of raw sludge minus, मैं parabolic लेके चल रही हूँ. Nothing is mentioned. अभी मेरी मर्जी. I have taken parabolic. Okay. Now, just you need to calculate. Digestion period is given. Just V1 और V2 calculate कर लो. V1 और V2 calculate कर दो. कितना sludge आ रहा है और कितना sludge digest हो रहा है. How much sludge is coming and how much sludge is getting digested. That's it. That's it guys. Come on. कैसे कैलकुलेट करोगे? हाउ मच स्लज इज कमिंग एंड हाउ मच स्लज इज गेटिंग डाइजेस्टेड, यही बताना है मुझे और कुछ नहीं करना. बता दो मुझे. V और V भी कैलकुलेट कर दो. जब मैं बोलती हूँ कैलकुलेट कर लो तो सब भाग जाते हैं, क्योंकि मैं ही तो कैलकुलेट करूंगी और कौन कैलकुलेट करेगा, है ना. In 1 liters, if 300 mg is the suspended solids, so in 20 mld, how much will be the suspended solids? Now, out of this 60% is removed, so 0.60. Convert mg into kg, that means 10 raised to power minus 6 kg. कितना आएगा? 6 cancel, 3 2 so 6.60. 3600 kg per day आ रहा है. 3600 kg per day. This is the sludge which is coming. Basically solids आ रहा है. Solids पानी के साथ मिलके sludge बनाता है. अब now I am giving you a one important formula. अब देखो, सबका वही आया ना. चलो, अब मुझे मॉइस्चर कंटेंट डाइजेस्टेड स्लज का दिया है. अब इसमें से एक चीज मिसिंग कर दी है जो उसको देनी चाहिए थी. मैं अभी बता रही हूँ उसको एक चीज मिसिंग है जो उसको देनी चाहिए थी, क्योंकि अदरवाइज यू वोंट बी एबल टू सॉल्व दिस क्वेश्चन. वॉल्यूम ऑफ डाइजेस्टेड स्लज, क्योंकि ये ना कन्वेंशनल क्वेश्चन है, सो यू अज्यूम इट, बट इन गेट यू कैन विल नॉट अज्यूम इट. इज 1/3 वॉल्यूम ऑफ अनडाइजेस्टेड और रॉ स्लज. So I'll take this while digested, I take V2. This is V1/3. Okay, now you know one formula is there. V1 100 minus P1 is equal to V2 100 minus P2. You know this? इसी में आता है sludge digestion tank में. So V1 you don't know. Moisture also you don't know. Moisture means pani. Pani what was present in raw sludge. You don't know that. V2 you know it is V1/3. And the moisture content of the digested sludge, you know it is 85%. 100 minus 85. So from here, V1 will get cancelled out. How much will P1 come? 50. कितना आ रहा P1? चलो यार जल्दी करो. 95% is P1. That means in the raw sludge, the moisture content is 95%. In the digested sludge, the moisture content is 85%. Now 95% का मतलब होता है 5 kg solid plus 95 kg water will make 100 kg sludge. Correct? This is the meaning of it. You can also take it as 100 minus P1 kg solid plus P1 kg water will make 100 kg sludge. ठीक. So W1 kg कितना sludge बनाएगा? How much sludge will be produced? 100 into W1 upon 100 minus P1. This much sludge will be produced. Correct? So this I will use it. मैंने derive करके भी बता दिया. I have derived it also for you. So what will happen? So now here 3600 kg per day will generate how much amount of sludge? So 3600 per day, that means 100 into 3600 kg per day. And what was the moisture content? 95%. This will generate how much amount of sludge? Come on, solve it. हाँ, तो weight आएगा. This will come the weight. Weight of sludge. 95 आया. हाँ तो अच्छा वो तो पुराना बता रहे हो. 100 into 3600 divided by 5. This will give me the weight 72,000 kg per day. But if I need volume, मैं क्या करूंगी? Weight divided by volume चाहिए ना? Weight divided by specific gravity, unit weight given है 1.02. If in the question, now listen to me very carefully, if in the question for raw sludge and digested sludge for both different specific gravity is not given, take both of them as same. If they are giving you different values, it's okay. If they are giving you same values, take both of them as same. So how much it will come? 1.02 into 10 raised to power 3. Why? Specific gravity is gamma of sewage upon gamma W. So gamma of sewage will be GS gamma W. So solve it. 70.588 meter cube. V2 already बोल दिया था, it is V1 by 3. So 70.588 divided by 3, that is 23.529 meter cube. Just substitute it here in this formula. 70.588 minus 2 by 3, 70.588 minus 23.529 है, चलो 529 into detention period. How much is the detention period? That is 30 days. So here you will take it as 30 days. Chalo, solve karo and tell me the value. This will give me the volume. How much volume is coming? Tell me. Pi by 4 d square h. Dia you need to calculate. Depth is given, I guess, 6 meter, right? 6 meter. So depth of digester is 6 meter. Solve it. You will get the dia. How much is the dia coming? 15.8 आएगा. If they will tell you that round off to the nearest integer, you will take it as 16. एक क्वेश्चन मैंने करा दिया. Clear? Is it clear? Clear है सबको भाई? चलो. Now we will talk about septic tank. अब बस कुछ नहीं बचा. Septic tank और Hemop tank ही बचा था. Okay. Now septic tank, if you talk it about, this is a anaerobic suspended growth process. Now in hospitals and all, generally they used to be located, you can say, in the outskirts of the city. Now they came inside the city, but when they were made, they were located outside of the city. So there were no sewer pipelines and all there. So that time there, the people used this institution, schools, hospital, use septic tank. This is anaerobic suspended growth mechanism. That means what will be happening? Treatment will be done by anaerobic microorganisms, and here basically in the absence of oxygen, and here organic matter and microorganisms both will be suspended in nature. So now what will happen? Microorganisms will search for the organic matter and carry out the decomposition. Correct? Now what will happen here? The sewage which is there, you will check it out here, that microorganisms will search and carry out the decomposition. So first, the tank is there. So what will happen? Removal of organic suspended solids will take place. They will settle down under the action of its weight. So they will form sludge here. Okay. Then microorganisms is carrying out the decomposition. So removal of dissolved organic solids will take place. Second thing. After that, whatever sludge is being formed, digestion of sludge will take place. So again, septic tank in itself acts as a complete treatment unit. Why? Firstly, it is removing organic suspended solids. It is doing the function of PST. Then it is removing dissolved organic solids. It is doing the function of biological treatment. Then it is carrying out the digestion of sludge. It is doing the function of what? Sludge digestion tank. So that is why in it itself acts as a complete treatment unit. Now obviously the sewage will be decomposed, and thus effluent you can dispose it in dispersion trenches are there, and soak pits are there in which you can dispose it. Okay. So this is aerobic बिल्कुल नहीं है, because it is there inside the ground, so it is anaerobic. Here you don't do any mixing and all, so here decomposition will take place by the action of microorganisms suspended in water. So this is the septic tank. But you can say, ma'am, there can be chances no, that sludge can be also carried away with the water. Yes, there are chances, the sewage effluent. That is the reason we have hem-off tank. There you have two different chambers. One chamber is sedimentation chamber and one chamber is digestion chamber. So you have two different chambers in hem-off tank, because to basically Carl Hemhoff was the one who made the hem-off tank. So he found that yeah, there are chances that mixing can take place. So he just made two different chambers in a single tank. But the problem was it was more than 13 meter, 14 meter. And right now the room in which you are sitting, the elevation is 3 to 3.5 meters. And imagine 12 meter, 14 meter height. So you require a large height space also if you want hem-off tank to be there. So here sedimentation used to happen in the upper chamber and digestion used to happen in the lower chamber. To avoid the mixing of sludge or getting of sludge to go out with the effluent treated sludge, he made two different chambers, sedimentation and digestion. Apart from that, he made vents and all so that the gases could escape, and so it was a proper systematic one so that mixing doesn't take place. It was developed by a German scientist, that was Carl Hemhoff. Got it? So with this, we have completed the entire treatment of water. Any doubts? Any doubts? So guys, Geotech Marathon tomorrow at 10, and now we will talk about air pollution. Now just two chapters remaining, just two chapters. मयंक, एक तो तुम लेट आए हो, ऊपर से तुम पीडीएफ कर रहे हो. अब बताओ, मुझे तुम्हें पीडीएफ देनी चाहिए? तुमने तो मेरा साथ ही नहीं दिया. मैं सुबह 10 बजे से बैठी हूँ और तुमने मेरा साथ नहीं दिया, और अब तुमको पीडीएफ पे ये इसका टेलीग्राम पे पीडीएफ चाहिए. बहुत नाइंसाफी है. बताओ. लेट आए हो तुम, सजा तो मिलेगी. चलो, नाउ एयर पोल्यूशन. रेडी एवरीवन? रेडी? जल्दी जल्दी बताओ यार. अब बस 2 चैप्टर बच्चे छोटे छोटे, इसमें ज्यादा टाइम नहीं लगेगा, मैं पक्का बता रही हूँ. देखो 8 बोला था, 7:45 पे कंप्लीट कर दिया, 7:48 पर. ठीक है, 7:48 पर. क्लियर? तो देखो अनवर, अब अनवर नहीं बोलेगा कि मैम जल्दी कर दिया, 8 बजे बोला था. अभी मैंने अगर 8:15 कर दिया होता तो अनवर बोलता. चलो, okay. Air pollution means when air pollutants, one or more, if they are present in such amount and for such duration that life in biosphere, जिसमें हम रह रहे हैं, ये affect हो जाए. See, pollution was there before also, but it was not in such concentration that it used to harm us. But right now, it is present in such a manner that it harms us. Okay, if you breathe on this, you will get bronchitis, asthma, headache, whatnot. Okay, so this is termed as air pollution. Now life is getting affected. Okay, we are getting in a smaller age, we are getting, I'm allergic to dust, I'm having asthma, I'm having this. Why? Due to this pollution. You are getting skin cancer due to this pollution. Okay, so the life in biosphere is getting affected. Now here, before moving to this, there is a patent thing, types of pollutant. This question, I think every year if the paper happens now all over the world, all over India, for all the examinations of civil, this is the patent question which is being asked. Okay. Now here, secondary pollutants. Primary air pollutants are one like oxides of carbon, oxides of nitrogen, oxides like carbon dioxide, carbon monoxide, sulfur oxide, sulfur dioxide, and nitrogen oxide, nitrogen dioxide. These are the primary air pollutants. Apart from that, suspended particulate matter. This is also a primary air pollutant. Secondary air pollutants are when two or more primary pollutants combine, or when primary pollutants combine in the presence of sunlight and water vapor, it leads to the formation of secondary pollutants like peroxyl acetyl nitrite, like ozone. These are what? Secondary pollutants. Okay, these are secondary pollutants. Now they ask you which of the following is a primary air pollutant, which of the following is a secondary air pollutant. They ask like this. Got it? So that's why I've told you. Generally, people think suspended particulate matter is primary air pollutant and ozone is a suspended particulate matter is a secondary air pollutant, which is wrong. It is a primary air pollutant. People think O3 chota hi sa to hai. This is primary. No, it is secondary. So just make sure that you don't make mistake. Now we will talk about the types of environment. But before that, I have to talk to you a few things. So next slide add kar do. I have to tell you, na, adiabatic lapse rate, environmental lapse rate directly. How can I tell you about environments? So I have to tell you that. Just a minute, let me add a slide. And guys, quiz related to today's class. I'm sharing the QR code again. It is available on the app. You guys can download it and check it out. This one is the QR code. You guys can check it out. Formaldehyde is also a वो भी लिख देती हूँ. Formaldehyde is also a primary air pollutant. कि secondary air pollutant होता है. Primary होता है कि secondary होता है अनवर. So this is the QR code. Okay. Now let's talk. My jaws are paining now. Sure. Let's start. First is environmental lapse rate. In short, we call it as ELR. Environmental lapse rate. मुझे बताया नहीं formaldehyde is primary air pollutant or secondary air pollutant, guys? सिर्फ अनवर बोल रहा है. What about सोफिया, मयंक? चलो बताओ. रत्ना दी, प्राइमरी एयर पोल्यूटेंट और सेकेंडरी एयर पोल्यूटेंट आ जाएगा पेपर में. मरकैप्टन, फॉर्मेल्डिहाइड, प्राइमरी एयर पोल्यूटेंट. मैं तो नहीं बताऊंगी अब. प्राइमरी एयर पोल्यूटेंट और सेकेंडरी एयर पोल्यूटेंट. सब सो रहे हैं. हाइड्रोकार्बन्स, प्राइमरी एयर पोल्यूटेंट, सेकेंडरी एयर पोल्यूटेंट. हाइड्रोकार्बन्स, फॉर्मेल्डिहाइड, मरकैप्टन, क्या है ये? URF93 जो भी है आप. थैंक यू सो मच. चलिए, अब नहीं बताओगे तो मैं भी नहीं बताऊंगी, लास्ट में बताऊंगी. हाइड्रोकार्बन, मरकैप्टन, फॉर्मेल्डिहाइड, ये क्या होते हैं? प्राइमरी एयर पोल्यूटेंट होते हैं कि सेकेंडरी एयर पोल्यूटेंट होते हैं? तो बताओ. अब किसी का मुंह नहीं खुल रहा है. मयंक बताओ बेटा, प्राइमरी एयर पोल्यूटेंट की सेकेंडरी एयर पोल्यूटेंट? आएगा तो पेपर में. इफ यू चेक इट आउट, दे हैव आस्क्ड सच पैटर्न ऑफ क्वेश्चंस एन नंबर ऑफ टाइम्स इन योर गेट. सेकेंडरी, चलो मैंने तो सिर्फ लिख के रखा है. अभी प्राइमरी है कि सेकेंडरी मैंने बोला नहीं है. किसी ने अभी तक मुझे बोला भी नहीं है. चलो मैं आखिरी में बताऊंगी. ओके, एनवायरमेंटल लैप्स रेट. नाउ व्हाट हैपेंस? See, environmental lapse rate, or you also call it as ambient lapse rate. What happens first, before discussing this environmental or adiabatic or anything, let me tell you what do you mean by lapse rate. What happens with as you go up, as the height increases, you call it as altitude also. अब इसके ऊपर क्वेश्चन कराऊंगी, so guys just understand it properly. As the height increases or altitude increases, the temperature decreases. So the increase with the increase in altitude, the rate at which the temperature decreases, that is known as lapse rate. So the rate at which temperature decreases with the increase in altitude, that is known as what? That is known as lapse rate. So the decrease in temperature with increase in altitude, that is known as lapse rate. Now you have two types of lapse rate, basically three: environmental, adiabatic and negative lapse rate. Now what is lapse rate? Lapse rate, I told you, temperature will decrease with increase in altitude. Now if you talk it about environmental lapse rate or ambient lapse rate, what will happen here? The temperature of the surrounding air decreases. Temperature of surrounding air decreases with increase in altitude. आज पता नहीं इसकी टिप इतनी मोटी हो गई, इतना तब चल रहा है पेन. With increase in altitude. So the rate at which the temperature of surrounding air decreases with increase in altitude, that is known as environmental lapse rate. That is known as what? Environmental lapse rate. How can you measure it? Just in a balloon which is there, put a thermometer. Okay, and a self-recording mechanism is there. So you will be here, the balloon will go up, the thermometer will also go up. What will be the temperature at various height? It will measure it. So if you want to measure the temperature of the surrounding air, you can measure with the help of environmental lapse rate. So when the temperature of the surrounding air is decreasing with increase in altitude, you call it as environmental lapse rate. Got it? चलो गूगल कर लिया, सेकेंडरी है, ठीक है, फॉर्मेल्डिहाइड को सेकेंडरी में ले आया. अब दो और गूगल करो, मरकैप्टन और एक और क्या बताया था यार मैंने, हाइड्रोकार्बन्स. और बताओ हाइड्रोकार्बन्स प्राइमरी एयर पोल्यूटेंट है कि सेकेंडरी, एंड मरकैप्टन ऑल्सो. बस यही गूगल करो. एग्जाम में भी ओपन बुक टेस्ट हो रहा है, गूगल करने मिलेगा. मयंक नहीं ना, पढ़ना पड़ेगा बेटा. चलो, environmental lapse rate, ambient lapse rate. Now, it has been seen the next type of lapse rate is adiabatic lapse rate. Adiabatic lapse rate. So, what will be happening generally? ये मेरी गाड़ी है, कोई हंसेगा नहीं. Nobody will laugh at my drawing. This is the vehicle, this is the door, this is the exhaust pipe, and from here gases will be coming out from this exhaust pipe. Okay, so the gases will be coming out. टेलीग्राम पर भी है. ओके, घूमो घूमो, पता है प्राइमरी हाइड्रोकार्बन. दिव्या, आई टॉट यू दिस बेटा, यू डोंट नीड टू गूगल इट. I taught you hydrocarbon is primary air pollutant. Now what will happen is the pollutants will be released into the atmosphere. You will see that these pollutants don't exchange heat from the atmosphere. So that's why the name adiabatic is there. Adiabatic means there will be no exchange of heat. But it has been seen that this pollutants also when it rises upwards, this is pollutants or you call it as air parcel. Okay. So what will happen? This pollutants or air parcel also decreases. The temperature also decreases with increase in altitude. So the rate at which the temperature of this air parcel or pollutants decreases with increase in altitude, you call it as adiabatic lapse rate. Clear हुआ? तो जब surrounding air temperature decreases, you call it as ELR. When the temperature of the pollutants decreases, you call it as ALR. Now, ALR is standard. Generally, adiabatic lapse rate, you have two types of adiabatic lapse rate. Dry adiabatic lapse rate and wet adiabatic lapse rate. Generally, that which is present above the clouds, you call it as wet adiabatic lapse rate. Which is present below the clouds, so you call it as dry adiabatic lapse rate. If nothing is given, you will take it as 9.8 degrees Celsius per kilometer is dry adiabatic lapse rate. That means with 1 kilometer rise upwards, 9.8 degrees Celsius temperature will decrease. Wet adiabatic lapse rate is 6 degrees Celsius per kilometer. That means for 1 degree rise, 6 degrees Celsius will temperature be decreasing. Correct? Generally, which one we took? Unless and until nothing is mentioned, we will take dry adiabatic lapse rate. If it is mentioning in the question, we will take 6 degrees Celsius. Okay? So, hydrocarbon. Fine. Now, last one is, last type of lapse rate is negative lapse rate or you call it as inversion. See, right now you said that when the temperature decreases with increase in altitude, you call it as positive. Positive and negative are relative terms. So, decreasing, when you call it as positive, so increasing, you will call it as negative. So, with the increase in, this is temperature, altitude. You can denote it by Z or you can denote it by H. So, with increase in altitude, the temperature is also increasing. This you will call it as negative lapse rate or you will call it as inversion. You will call it as negative lapse rate or you will call it as inversion. So, with the increase in altitude, the temperature is also increasing. Okay. Now, based on this, depending upon ALR and ELR, you have different types of environment. First is unstable environment or you call it as super adiabatic environment. Now, what happens in this case? ELR is more than ALR. Now, what will be happening is, you know that both the air and the pollutants temperature decreases with increase in altitude. But the rate at which decrease in temperature of surrounding air is there, it is more as compared to that of pollutants. Now, डिक्रीज जल्दी करेगा, टेम्परेचर जल्दी कम होगा मीन्स व्हाट, टेम्परेचर विल बी लेस, टेम्परेचर ऑफ एयर, okay, air I'll do not will be less. If temperature is less, what will happen? Temperature is less, that means it is cooler. If it is cooler means its density will be more. If density is more, what will happen? It is heavier, it will settle down. Adiabatic lapse rate also, the pollutant temperature is decreasing, but comparatively it is decreasing at a lesser rate. So comparative to temperature of air, temperature of pollutant is more. If temperature is more, density will be less. If density is less, that means what it is? Density is less, that means what? It will rise up. So what happens? This tries to rise up, this tries to move up. So here what happens? Rapid mixing of pollutants takes place in this condition. That's why you call this as unstable environment, because rapid mixing of pollutants takes place. This takes place when ELR is more than ALR. Since ELR is more than adiabatic lapse rate, ऊपर है, that is more. So ELR you also call it as super adiabatic lapse rate. So in books you will find they write it as SALR also. So that means super adiabatic lapse rate. And if you check it out, here the temperature is there in degrees Celsius and here the height is there in kilometers. Okay, so if you check it out, guys, don't get confused. Here if you check out the slope, ulta slope le rahe, y by x nahi le rahe, you are taking x by y. So when you will check it out, the denominator will come out to be more for air. Denominator will come out to be what? Denominator will come out to be more for ALR. So ALR will come less. Okay, so here if you check it out, don't say ma'am you plotted the wrong graph. No, here you are not measuring slope y by x, you are measuring x by y. That is degrees Celsius per kilometer. So ELR will come more than ALR. ELR will come more than ALR. So what will happen here? Here you will get unstable environment because rapid mixing of pollutants takes place. Now you will be talking about stable environment. Here ALR will be more than ELR. So if I plot it, here this will be ALR, this will be ELR. Okay. So now what will happen? Again, as the altitude increases, surrounding air and pollutants, both temperature will decrease. But the rate at which the temperature of the pollutant decrease will be more. That means pollutant temperature will be less. Okay. So what will happen? Density will be more. So it will be there at down. Temperature of air will be more. Okay. So the density of air will be less. So it will be above. So pollutants down, air upwards. So no mixing takes place. So this is a stable condition which happens. So you call it as stable environment. Pollutant is down and because it is heavier, it is down. Temperature of air is up. So no mixing takes place. So you call it as stable environment. In unstable environment, mixing was taking place. Okay, here mixing doesn't take place. Since ELR is less than ALR, kam hai. So you call it ELR as sub-adiabatic lapse rate. So यहाँ पे you call it as sub-adiabatic. There also SALR, but this time it was super-adiabatic lapse rate. Okay. And this ELR you call it as sub-adiabatic lapse rate. Remember, adiabatic lapse rate is constant, but environmental lapse rate varies. For my place it will be different. For your place it will be different. So it varies from place to place. But ALR will remain constant. Got it? Now, neutral, when both are decreasing but the rate at which they are decreasing is same. Pollutant is also decreasing, surrounding air is also decreasing, but the rate at which it is decreasing is same. That is known as neutral environment. Now, ये मैंने क्वेश्चन रखा था, नहीं दिख रहा क्या? एक मिनट. Sure. Now first answer this question. आपको बताना at what temperature air parcel, basically pollutants or surrounding air will have same temperature. I'll give you 1 minute to solve it and I'll be back in a minute. So come on, solve it. सॉल्व? नो. अब आ जाएगा गेट में क्वेश्चन, देन हु विल सॉल्व इट? मी. एनालिसिस में सॉल्व करूंगी मैं तो. ओके. Now what is given? Environmental lab state is given to you. Z is equal to minus 0.T plus C. That means plus C nahi hai, plus 7. Okay. So from here if I want to calculate degree Celsius per kilometer, how much it will come? कैसे निकालूंगी? How can I get it? कुछ तो बोलो. छोड़ देते हैं क्वेश्चन, नहीं सॉल्व करते. कुछ तो बोलो. You will solve it or me will? I'll be the one who will be solving it. This is Earth's surface. Okay. Environmental lapse rate is given to you. Okay. It is asking at what height? Z मान लेते हैं. Z is the height at which temperature of air and the temperature of pollutant becomes same. Okay. If let us suppose temperature of ground level 50 degrees Celsius, it is given. You know, if nothing is mentioned, what we take it as dry adiabatic lapse rate. So at Z altitude, what will be the temperature? 50 degrees Celsius होना चाहिए था, but it will decrease. How much? 9.8 degrees Celsius per kilometer. Now this Z is in kilometer. It is already, इसको भी मैंने Z किलोमीटर में माना. Okay, so this will be 50 degrees Celsius minus 9.8 Z. Okay, this is the temperature here. If you want to calculate temperature here, कितना आएगा? Z minus 7 upon minus 0.2. Both the temperature of the surrounding air and the pollutant is same. So kindly equate both of them. Z minus 7 minus 0.2 is equal to 50 minus 9.8 Z. How much it is coming? Solve तो कर ही सकते हो. Z minus 7, 10. 19.6 Z. How much it will come? अभी यहाँ पर एक गलती भी हुई है, पता नहीं कौन बताएगा. How much it is coming? Come on guys, how much it is coming? कितना आ रहा आंसर? Because with increase in temperature, with increase in altitude, temperature decrease होता by 9.8 degrees Celsius per kilometer for adiabatic lapse rate. So the final temperature which you will get will be 50 minus 9.8 into the distance which it has travelled. So Z distance it has travelled, so I have multiplied by Z. Got it? ये -10 होगा. चलो. So Z minus 19.6 Z is equal to minus 10 plus 7. From here, what is the value of Z coming? मैंने सही किया ना पूरा यहाँ पे Z minus 10. तो यहाँ पर आ जाएगा minus minus cancel out. कितना आ रहा है? सॉल्व करो. मैंने कोई कैलकुलेशन में मिस्टेक तो नहीं की ना? बस just check it out. How much it is coming? जल्दी कैलकुलेट करके Z की वैल्यू बता दो. How much it is coming? Nobody is solving. चलो. किसी ने सॉल्व भी नहीं किया. मैंने दोनों टेम्परेचर को आई मेड इट इक्वल, यही तो किया, z माइनस 7 माइनस 10 प्लस 19.6 z ये आ रहा है. तो z मैंने इसको डिवाइड कर दिया था, ये मल्टीप्लाई कर दिया था, दिस विल गो हियर, z माइनस 19.6z माइनस 10 और ये हो जाएगा प्लस 7. कैलकुलेट करके जस्ट आई एम आस्किंग यू टू कैलकुलेट द वैल्यू ऑफ z या h, जो भी आप बोलो वो निकाल लो आप, और क्या करना है, और तो कुछ भी नहीं करना है. और मैंने बस एक मिस्टेक कर दी है और वो है 9.8 इंटू ये 1.96 होता है z. बस एक मिस्टेक कर दी है, 1.96 z. और तुम लोग पेपर में बस कुछ मत करना, मेरे भरोसे बैठ के आना है ना. माइनस 0.96 z और ये होगा माइनस 3. So z will come out to be 3 divided by 0.96, that is यहां से ये आ गया 3.125 किलोमीटर. इतना आ रहा है. Is it coming this much? अब चेक कर लो, इतना तो कर ही सकते हो. This is the height which is coming. This is the height which is coming. ठीक, तो ये बहुत अच्छा क्वेश्चन है एंड डेफिनेटली दे कैन आस्क यू. गेट में ऐसा क्वेश्चन नहीं पूछा गया है. सो हियर दे विल टेल यू अज्यूम DLR, ड्राई एडियाबेटिक लैब स्टेट एट 9.8 डिग्री सेल्सियस. सो दैट इज द रीजन यू नीड टू नो दिस. क्लियर? बाकी कुछ नहीं था क्वेश्चन में, बट ये बहुत अच्छा क्वेश्चन. दिस इज वन ऑफ द गुड क्वेश्चंस व्हिच इट कैन आस्क. इसके लिए लॉफ्टिंग प्लूम, लूपिंग प्लूम चाहिए. चलो नाउ कमिंग बैक अगेन. क्लियर हुआ कि नहीं? एटलीस्ट येस और नो तो बोलो गाइस, से येस और नो. Okay, fine. Now we will talk about how inversion, negative lab state. I have told you adiabatic lab state will always decrease with increase in altitude, but if the environmental or the surrounding air temperature increases with increase in altitude, you call it as environmental lab state. Inversion, two types of inversion are there, radiation inversions and subsidence inversion is there. Radiation inversion, during a long winter nights and all, the surface of the earth is cooler in nature, so the temperature is less. Temperature of air is less as compared to the temperature present above the earth's surface. So here the temperature is more. So what is happening? As the altitude increases, the temperature is increasing. So if the temperature increases with increase in altitude, you call it as negative lab state, and that's why here it is taking place. You call it as radiation inversion. It happens on long winter nights. It happens on polar regions. As the morning will come, this radiation will be destroyed. Next type of inversion is subsidence inversions. You know, air travels from higher pressure to lower pressure, but if in higher pressure the cyclones are formed, you call it as anticyclones. If the cyclones are formed on the lower pressure regions, you call it as cyclones. Okay, so if it is formed on high pressure region, you call it as anticyclones. When it is formed on low pressure region, you call it as cyclones. High pressure region, when cyclones are there, their fair weather is being there. Okay, anticyclones, there will be no destruction, fair weather is there. So what will happen is in subsidence inversion, actually the temperature was decreasing with increase in altitude. But if due to some reason high pressure comes, if pressure is more, PV is equal to nRT, temperature will be more. So here the temperature was decreasing, but due to the creation of high pressure area, when the temperature starts to increase with increase in altitude, you call it as inversion. And here this type of inversion, you will call it as subsidence inversion. Got it? So this will be the one. And here, based on ELR, ALR and negative lab state, you have different types of plumes. Now, what is plume? The gas which is released into the atmosphere, you will call it as plume, and the source of their origin is termed as stack. Now, if you talk it about, you have various types of plumes. Now, one by one, you will quickly discuss about it. First is looping plume. Here, basically, loops will be formed, and whatever houses, buildings are there, it will just, you can say the pollutants will go to their places. So, here, when you are designing the chimney height, you have to be very, very cautious about it. Here what will be happening? First of all, it will be generated in unstable environment. Unstable means ELR will be more than ALR. Here, you know, when ELR is more than ALR, what happens? Rapid mixing of pollutants takes place. So make sure you design the height of stack, that is chimney, in such a manner that the pollutants doesn't go to the people living nearby to it. So here actually loops of plume are formed. That's why you call it as looping plume. So ELR is greater than ALR. Next case is coning plume. This will happen when the wind velocity is more than 32 km per hour. Okay, then you will get basically like cone structure it is being produced. It is stable in nature. Stable means what? ALR will be more than ELR. Okay, so it will be stable in nature. That means the velocity will be greater than 32 km per hour. Now here mixing of pollutants will not take place. Next case which you will get is neutral plume. Neutral plume. Here what will happen? ELR and ALR will be same. So vertically the pollutants will rise. So if chimney is there, vertical upwards the rise of the plume will take place. In which case? In the case of neutral plume. Next, if I talk it about, that is fanning plume. This takes place in extreme inversion conditions. That means what will happen? ALR will always decrease with the increase in temperature. By default, here it is kilometer and here the temperature is degree Celsius. And ELR will increase because it is inversion. So here what will happen? If you look at the chimney and from there, this spread horizontally. Check it out. So it's spread like this, fan, horizontally. So that's why the name or the basis, if it produces cone like, you call it coning plume. If it produces in loop wise, the gases involved, you call it as looping plume. If it is producing spreading horizontally, you will call it as fanning plume. Next one is lofting plume. This is the best plume. Out of the 7 types of plume, this is the most ideal plume which you take it. Here inversion will happen and then unstable will be happening. See, initially, the temperature will increase with the increase in altitude. This is the inversion layer. And after that, what will happen? Temperature here, ELR will become more than ALR. So what happens? Whatever pollutants are there that is present above, that means it will not come to the ground. Ma'am, why can't they come to the ground? Because here inversion layer is there. Inversion layer is there. So what will be happening here? What will be happening here is, because of the inversion layer, the pollutants cannot cross that layer. So the pollutants will be at the top. They will not disturb us. So this is the most effective way of discharging the pollutants. Okay. Okay. Now, opposite to it, the worst plume is fumigating plume. Worst. Ma'am, why worst? Just the opposite of it will happen. Opposite means what, ma'am? Here, whatever discharge will be there in the, this will take place above. So it will not come to us. In this case, what will happen? ALR will always decrease. Now here inversion was there first. Here first, opposite. Inversion takes place just the opposite. Inversion was taking place first here. Inversion will take place afterwards here. So first ELR is greater than ALR and then inversion is taking place. And this is the inversion layer. So I told you in inversion layer what will happen? Here the mixing of pollutants has taken place downwards near to the earth. So it will not be able to rise upwards because for rising upwards it need to cross the inversion layer. But it will not be able to cross the inversion layer. So this is the worst condition, that is fumigating plume. Okay, trapping plume, this is also worst only, but the maximum worst is fumigating. Here, first inversion will be there, then again this aisa hoga. Okay, then one first inversion, then unstable, then inversion. So here what will happen is the plume will be trapped in between two layers. This is also inversion layer. This is also inversion layer. So the plume, whatever gas is released, that is trapped between these two layers. So you call this as what? Trapping plume. Got it? So the best out of this is lofting, worst is fumigating. And if they haven't asked till now, but if in the future they ask you to calculate the height of the chimney, that is 74 QP. QP is, if particulate matter is given in the question, convert it into tons per hour. I made you solve this question in app free class also. Particulate matter in tons per hour. QS is the sulfur dioxide. If it is given in the question, you will use this formula. Now, if you will say, ma'am, both particulate matter and sulfur dioxide is given and we calculated the height. So, which height we will use? Whichever is maximum. So, you will use the height whichever is maximum. Got it? So, this is the height which you will use it. Now, till here any doubts? Now, the last part of it. Gaseous pollutants removal. Any doubt till here? Quickly tell me, otherwise we'll move. Okay. Now we will talk about how to remove the pollutants. So we have various manners by which we can control the pollutants. Now first is gravity settling chambers. Control of pollutants. ये अपने आप कैसे आगे बढ़ जाता है यार? First is gravity settling chambers. That means here the whatever pollutants are there. See, pollutants are disposed in the air also. Liquids are also dispersed in the air. So whether it is solids or whether like dust. Dust is what? Particles which is spread in that spread in the smoke, or basically you can say spread in the air. Dust particles, smoke particles. Correct. So these are what I need to remove them. So the nothing you have to apply your brain. Just bring the dirty gas. Okay. Whatever bigger particles are there, they will settle down in this hopper. You will, and whatever clean gas is there, we will go out. Okay, so what will happen is dirty gas coming in, clean gas going out, and whatever is the suspended solids, you will take it out. The drawback is, first of all, it requires large space, efficiency is less than 50%, and only you can use it for higher size of particles. Okay, so if any pollutants are there which is liberated in which the size of the particles is more, that time what you can do for is, you can provide gravity settling chambers. Here you are not doing anything, they are settling down under the action of its own weight. Next is centrifugal collectors. Now you have seen the washing machine vortex motion takes place. Exactly that was happening in this case. What will happen in the centrifugal collector? You are putting the gas in which dust is there. Okay, dirty gas, you are putting it from here. So again, the vortex motion will happen. So whatever solid particles, dust particles are there, they will be just getting attached to the walls of it. Okay, and whatever the dust is there, now they will settle down. So spinning takes place, with the help of which whatever particles are there, they will settle down and the clean gas will be out. So now if you'll ask me, ma'am, how much force can we apply? So this is the formula. MP squared by R. So the radius, this is the mass of the particle, and this is the velocity. This is the formula which you apply for calculating the force. Now, simple, less area, it's inexpensive. That is the advantage of it. But the thing is, it cannot remove finest impurities. Now, spray towers, wet cyclonic scrubbers, Venturi scrubbers. All three function is same. Efficiency depends for each and everybody. Like for Venturi scrubber, you have a higher efficiency as compared to spray tower and wet cyclone scrubber. Now, what happens? Let's talk about it. देखो, एक चीज होती है something takes place naturally and that is the thing which you are replicating it artificially. Example, in atmosphere, pollutants are there. When rainfall happens, you call it as rain out also. What happens is absorption principle also naturally takes place. In the atmosphere, what is there? Pollutants are there. Okay, it is dispersed. Now, when the rainfall happens, these pollutants will get absorbed in the rain and it will go down. So means which was there suspended in the atmosphere, they will be absorbed in water and they will go down. So that is absorption principle, or you call it as rain out. Similar thing which we are doing it, but there in natural process the efficiency was less. Here I'll increase the efficiency. What I will do is, process is same but mechanism I'll change it. Here that time natural rainwater was taking place. Here I'll be the one who will be providing water. Dirty gas will come. Gas is obviously density is less, so it will rise. It will rise upwards on its own. Now here I have spread sprays from which water will be coming out. So the gas, when it is rising, from the spray water will be coming. So whatever particles are there in the gas, they will be along with the water will be absorbed and go out, and the clean air will be present at the top. Phenomena is same, but you are doing it artificially. Same thing by wet cyclonic scrubber. Here also you are providing water, but the thing is here spray was there. Here you have a pipe in which perforations are there. Empty spaces are there. ये देखो मैं छू भी नहीं रही हूँ अपने आप हो रहा. Okay, so what will happen? It will move in this forms. From the perforations, empty spaces, holes, that is moving in this radial directions. Okay, it is moving in radial directions. So again, whatever dirty gas you have made it to fall here, made it to pass here, gas will rise. Water is also moving in n number of directions. So the water in that, whatever dirty particles, dust particles are there, it will just absorb them. It will go out and the clean gas will be up. So this is wet cyclonic scrubber. Okay. Now, last in this category is Venturi scrubber. In Venturi scrubber, Same function is there. If you do the same thing 2 times, efficiency increases. That is the logic which you have applied. Dirty gas is coming. You have put here a spray. You have put it here a spray so that water comes. And again, dirty gas is coming. So water in the gas, whatever dust particles are there, it will be absorbed, and the water will, with dirty water will come out. Now the gas, you will not dispose it out. This gas, you will not discharge it out. You will pass it through a second chamber. So here 2 chambers are there. In the case of cyclonic one or spray towers, you just had 1 chamber. And here in this Venturi scrubber, you have 2 chambers. Okay. So in this Venturi scrubber, what will happen is settling chamber is being provided so that even a particle is there who has a higher weight can settle down. So here 2 times you are allowing it to settle down the dust particles. So that is the reason here the allowing to settlement of the particulate particles or gaseous pollutants. So here the efficiency comes out to be more. That is Venturi scrubber. Now, apart from this, if you talk about fabric filters, these are the best. It can give you efficiency up to 99%, but the waste should be dry in nature. So here you have fabric cloth. What will happen? Dirty air will go here. Fabric will absorb it on the surface of it. The pollutants, the gaseous pollutants, particulate matters will release, and the clean air will go out. So here you can see multiple number of filter bags are there which comes, and this is known as fabric filter unit. Now patent question 2 to 3 times they have asked in the examinations, like how many filter bags are required. Exactly same. Discharge is equal to area into velocity. From here you get total area. And area of one filter bag is pi dl. So number of bags will come out to be total area upon area of one filter bag. Okay, so this is the concept which is being used in n number of questions in your previous years. Got it? Now, last one, again I told you efficiency up to 99% and even smallest sizes of the particle it can remove. Okay, now electrostatic precipitator. In all the thermal power plants, it is very mandatory to have electrostatic precipitators. In short, the official denotion of it is ESPS. Don't expect they will write the full form. If they are writing it as ESPS also, that means electrostatic precipitator. What will happen? You will pass the dirty gas through a highly ionized plate, so that whatever particles are there in that dirty gas, they becomes charged. Once they become charged, you pass it through the electrodes. So what will be happening? That charged particles will go into the electrodes and they will settle down. Okay, and the gas which comes out from it is clean gas. So first what you did was you pass that gas into the highly ionized plates and all electrodes, so that they will gain the charges. Okay, high voltage you gave it so that they gain charges. The moment they gain charges, you pass it through a discharge electrode so that those charged particles opposites attract. So whatever is the negatively charged particle will get to attach to positive. Positively charged particle will get attached to negative, and they will settle down, and you will get the clean gas. This is the concept of electrostatic precipitator. Yeah, you will require a high voltage, you will require energy will be required. Maintenance cost is less, but initial installation cost is costly. Except bioremaining are efficient in wet, dry, dirty air, ma'am. Yeah, you can use it. Prerequisite fabric के लिए जरूरी है, not for others. Yes, Divya. Okay, got it. So particles, wet or dry, high efficiency, even smallest particles can be removed. Correct? And this is the formula based on this question has been asked in your examination. Very important. So this formula is there, Dutch-Anderson equation. This is Dutch-Anderson equation. If you want to calculate efficiency of electrostatic precipitator, 1 minus e to the power minus WA by Q. A is the efficiency, A is the area of the collector plate, Q is the discharge, and W is the velocity. Correct? So if you'll ask in the examination, you guys can substitute this formula. Already they have asked twice. Okay. Now, chalo. Ye last question, and this is MSQ. Solve it, then we will move towards solid waste management. Last question. Come on, guys. Last question. Quick, quick, quick. This is an MCQ. More than one answers are correct. And you know, in environment from 2021 to 2023, whatever MSQ are asked are statement wise in question. Come on, guys. Quick. निकालो. Calculate कौन करेगा? With increase in height, temperature of ambient air means surrounding air. The rate at which the temperature decreases with increase in height is known as environmental lapse rate. Correct. Ambient air means surrounding air. Environmental lapse rate is constant and it won't change from place to place. I told you adiabatic lapse rate is constant. ELR is not constant. Looping plume occurs during a super adiabatic condition. Yes. When ELR is greater than ALR. Okay. Lofting plume occurs when above the surface inversion a strong super adiabatic rate exists. Yes, I told you. First inversion will happen and then ELR will become more than ALR. So this is also correct. Correct, Anwar. Very good. A, C, D are the correct statements. Fine. Now, with this we have done all the questions. One pattern of questions is there. I'll tell you both of them and then we will move towards solid waste management. Last topic, last chapter. डी सही है क्या? हाँ सही है ना. लूपिंग प्लूम बोल रहा है ना. लूपिंग ऑकर्स इन सुपर एडियाबेटिक कंडीशंस. ELR इन मोर देन ALR. तो सुपर एडियाबेटिक तो है. Correct. Okay. Now one pattern of question more is there which has been asked. Height is given to you and temperature is given to you. Okay, two temperatures, two height is given to you and it is asking you whether it is ELR, ALR, stable, what it is. So you just calculate delta D by delta Z. This will give you ELR. I told you ALR is constant 9.8 degrees Celsius. Unless and until it is say anything, you take 9.8 degrees Celsius. So you calculate ELR. If it is coming more than ALR, take it as unstable. If it is coming less than ALR, take it as stable. And if it is coming equal, take it as neutral. This is the question which comes. Clear? Okay. Now, एक और टाइप का क्वेश्चन है वो भी बता देती हूँ. Just a minute, I'll add one slide. एक मिनट. One more type question is there. I'll add a slide and just tell you that. Then we'll start with solid waste management. Slide add करूँ. Thank you so much, Arpit. Thank you so much. Chalo. Last type of question. This is the formula. If you want to get the value of total suspended particulate matter in microgram per meter cube, substitute the value in ppm. That is molecular weight. They write it as gram per mole and students get confused. That's why I write it as molecular weight into 10 raised to power 3 divided by volume of gas. That is in liters per mole. So this is the formula. If sometimes they ask you in microgram per meter cube, sometimes they ask you in ppm. At standard temperature pressure condition, standard temperature is 0 degrees Celsius, pressure is 273 Kelvin and this is 760 mm of temperature is 270. 0 degree Celsius मतलब 273 होता है. 760 mm of mercury. Okay, standard temperature pressure conditions means when temperature is 0 degrees Celsius, that is 273 Kelvin. Kelvin को if degree Celsius you converted into Kelvin, that is 273. Pressure is 760 mm of mercury. That times the volume occupied. चाहे कोई भी gas हो, any gas is there. At standard temperature pressure condition, 1 mole of any gas, it occupies how much? It occupies how much? कितना occupy करता है? It occupies how much volume? It occupies how much volume? बताओ जरा. ये याद रखना तो जरूरी है भाई. वेट में नहीं देगा आपको. 22 पॉइंट. चलो गलत. 0.1 एक्स्ट्रा बोल दिया. 22.4 लीटर्स एज एसटीपी. क्या बोल रहे हो मैम, पहली बार गेट देने जा रहा हूँ, आशीर्वाद दो. मेरा आशीर्वाद तुम्हारे साथ है. फाउंडेशन बैच रिप्लाई कर दिया मैंने. ठीक है. दिव्या इतना लेट क्यों आंसर किया? ओके, आई वॉज एक्सपेक्टिंग दिव्या अनवर प्रिंस टू आंसर. लेट कर दिया. अर्पित ने थोड़ा सा गलत दे दिया. At standard temperature pressure condition, that means at 273 Kelvin and at 760 mm of mercury, the volume of any gas, sulfur dioxide, carbon dioxide, nitrogen dioxide, any gas, 1 mole of it will occupy 22.4 liters. But in the examination, आपके साथ खेल करेंगे. Either they will change the temperature, either they will change the pressure, or they will change both, and they will ask you the suspended particulate matter or the in microgram per meter, or they ask you in ppm. So remember, there is one formula, P1 V1 by T1 is equal to P2 V2 by T2. This you know, 760 mm of mercury, volume is 22.4 liters and temperature is 273 Kelvin. If they give you that, let us suppose the temperature is 10 degrees Celsius. That means it is how much? 273 plus 10. It is 283 Kelvin. And if they give you pressure is, let us suppose 780 mm of mercury. So here 780 into V2. So from here, calculate V2, substitute it here, then you will get the answer. Got it? This is the funda you will apply. So I have told you the whole thing. Clear? Clear hua? Everything is clear? Now I'll move to the, so all pattern of question which comes in gate, formula based, I have told you. Clear? Mayank, Divya, Sophia, everybody. थैंक यू सोफिया, थैंक यू सबको, थैंक यू. अब बता दो, इज दिस क्लियर? अब लास्ट चैप्टर मूव करना है यार. चलो, जियोटेक मैराथन टुमारो एंड सॉलिड वेस्ट मैनेजमेंट टुडे. लास्ट चैप्टर, खुशी. ओके, this is a small chapter, so we will finish it early. Now what is, right now we were talking about liquid, then we talked about air, and the last one which we'll be talking about right now is the solid waste. Now what is solid waste? Either it is solid or it is semi-solid, which is generated due to different activities, domestic activities, industrial activities. That is known as what? Solid waste. Now generally we classify them into 3 categories. पर हम अभी यहाँ पे पढ़ रहे हैं 2, डोमेस्टिक सॉलिड वेस्ट, इंडस्ट्रियल सॉलिड वेस्ट. अभी तो हम लोग 2 ही पढ़ रहे हैं, फर्दर बाइफर्केशन से, बेसिकली ब्रॉडर सेंस 2. Domestic solid waste, industrial solid waste. Domestic solid waste you denoted by one more name, that is municipal solid waste. Okay. Now domestic solid waste is divided into 3 categories: garbage, rubbish, ashes. Garbage, fruit peelings, food waste, vegetables, these all are garbage which are biodegradable in nature. Okay, here the density comes out from 450 to 900 kg per meter cube. Rubbish, if I talk it about, non-biodegradable, glass, crockery, metals, these are generally non-biodegradable and they can't be burnt also. Okay, so these are rubbish. जैसे फालतू बातें करते हैं उसको बोलते हैं ना, you talk rubbish. जैसे this is rubbish. Okay, metals, crockery, broken glass, these are rubbish. Ashes, if I talk it about, this is incombustible in nature. Okay, it is incombustible in nature. जैसे आपने तो चूल्हा से जब burn होता है, जब चूल्हे में आप burn करते हो तो you get ashes. So when you burn it in hearth, what you get, that is ashes. Okay, it is incombustible in nature, and if you talk about the range of it, it is 700 to 850 kg per meter. Okay, so garbage is biodegradable, rubbish is non-biodegradable, ashes are incombustible. They haven't asked in GATE, but in other examinations they have asked regarding the densities and all. So just keep in mind roundabout. I'm not telling you to mug it up, but just remember that for garbage it is 450 to 900, for rubbish it is 50 to 400, and for ashes it is 700 to 850 kg per meter cube. Okay, now this I have told you here also. Ye kya hai? Rubbish, and this is ashes. Correct? Now we will talk about the types of method which is being used for basically carrying out the disposal of solid waste. Okay. Now the first method here is sanitary landfilling method. इसको सबसे आखिरी में करेंगे because उससे पहले सब methods होते हैं. Before that we study every methods, and if you cannot use any method, go for sanitary landfilling. चलो बता ही देती हूँ. What you do it here. सबसे पहले here 3 things are there. If you cannot do composting, if you cannot do incineration, अगर कुछ भी नहीं कर सकते to any waste, if you can't do nothing, go for sanitary landfilling. You don't need to do anything. What you have to do is just you have to take the waste, just first 0.5 meter of the waste, compact it. 0.5 meter of the waste, compacted. 0.5 meter of the waste, compacted. It will become how much? 1.5 meters. After that, spread a daily cover of 15 to 30 centimeters. Okay, daily cover. Now leave it for 7 days. Reason? If you leave it for 7 days, maximum decomposition will happen. But practically not even one day they leave it and they start to dispose the second layer. Okay, but in the books it is written. So I'm telling you what is written in the books. So here what will happen? 0.5 meter, then again 0.5 meter, then again. After every 0.5 meters, what you are doing is you are compressing it. It becomes 1.5 meters. Then you put a layer of daily cover, leave it for 7 days, and then you put second layer. Then leave it for 7 days, then put a next layer after 7 days. Here, who will function first? Initially, oxygen will be available. So first, aerobic microorganisms will carry out the decomposition. After that, oxygen will be utilized or very slight oxygen will be there. So acid formers will come. You know, acid formers are competitive in nature. So they are either facultative or anaerobic. So they will reduce it to acids and alcohols of lower molecular weight. Then acids means pH will be lower. It will go to methane formers. Methane formers are pH sensitive. They work in the pH range of 6.5 to 7.5. So after methane formers acts, carbon dioxide and methane will be released. Methane is heavier, so there are chances that nearby to the sanitary landfilling disposal site, if any buildings is there, 20-25 years, methane will keep on depositing and a sudden blast will happen. So you have to be very, very sure where you are using the sanitary landfill dumping site. Okay, chalo. Now, if you talk it about here, when you decomposition, now after 20 years, 25 years, decomposition keeps on happening. After that, you will see the volume will reduce. But ma'am, you will say, how can I see that the volume is reduced? Volume is reduced basically in terms of height. So the height will become 20 to 40% of it will reduce by 20 to 40% of the original height. So the new height will be 60% approximately of the original height. So that means decomposition has taken place. So when no function, final cover, जो आखिरी में good earth soil, if you provide about final cover, you provide it 60 centimeter. Intermediate 15 centimeter करीब you can say daily cover which you provide it is 15 centimeter around, and final cover जो good earth soil, cover means good earth soil, अच्छी soil जो आप provide करते हो, final cover last में when you are keeping it for decomposition, that is 60 centimeter. Got it? चलिए, economical, simple, biological. आप कुछ नहीं कर रहे हो, no chemical, microorganisms will carry out everything. Okay, so if nothing works out, go for this. Then incineration and thermal pyrolysis. Incineration is this question has been asked in your GATE examination. Incineration is an exothermic process, while pyrolysis is an endothermic process. In exothermic, heat is being released. In endothermic, heat is not released. Okay, incineration, you burn those solid waste which are high calorific value. Like by burning them, you will get energy. If something is there which cannot burn, which is non-biodegradable in nature, incombustible, then why to waste energy? So in incineration, you provide a large temperature, and what will happen? It will get converted to steam. So you will collect that steam, and that steam you can use it for running the plant. Okay, so here heat is released, you call it as exothermic process. In thermal pyrolysis, either you limit the supply of oxygen or it works in the unavailability of oxygen. So here what will happen? Three things will be produced. Solid will be produced to you like charcoal, which you can, this is a byproduct, you can sell it. Tar and oil will be produced, and here gases like methane will be produced. So which you can sell it also, or you can use it for running the plant. So you get three things in thermal pyrolysis, while in the case of incineration, you get only one thing, that is steam. Okay, and thermal pyrolysis comparatively requires lesser degree of temperature, 400 around degrees Celsius, while incineration requires a higher temperature. Okay, for conversion of the combustible waste into steam. Got it? So in thermal pyrolysis, three things: charcoal, tar and oil, and gases. Now, next one is shredding and pulverization. Now, shredding and pulverization, again, it is technically not a method of solid waste disposal. What it does is exactly like you had in wastewater, macerator and communators. Here, exactly what shredding and pulverization does. by converting it into powdered form and all, by pulverizing, basically grinding it and converting it into powdered form, they will reduce the solid waste. They will reduce the solid waste. So that is known as shredding and pulverization. So technically it is not a method of treatment, but you are just converting it into a smaller form of it. Okay, that is the shredding and pulverization. Next is disposal by composting. Now here you have two methods. Aerobic method of composting, which you call it as Indore method, and anaerobic method of composting, Bangalore method. I told you initially also, if in examinations you get confused, what you can do is here AN is there, here AN is there. So AN means Bangalore is for anaerobic. In case if you just forget it, I have told you this. Now, the main difference between aerobic method and anaerobic is, and generally the ones which we prefer is anaerobic, because here human exposure is less. What happens? Anaerobic, you are just piling the compost. Now here in this method of composting, generally you take that waste which is biodegradable in nature. So it's not used for all the types of waste. You will use the waste which is biodegradable in nature, firstly. Okay, so here you will use that waste, biodegradable in nature, and just you will dispose it. You will pile it and you will just dispose it. So here microorganisms will carry out the decomposition. In aerobic method, what happens? After 15 days, you will turn the mixer upside down so that oxygen availability is there. Then after next 15 days, and then after 30 days. Okay, so here you just pile up, you just turn it upside down so that aerobic condition is being maintained. So this you call it as aerobic method of composting. Both will give you the reduction in volume in terms of height. So the height will reduce in both of them. That means decomposition is completed. But here one takes place by aerobic mechanism, one takes place by anaerobic mechanism. Aerobic method was developed in Indore, so Indore method. Anaerobic method was developed in Bangalore, so Bangalore method. Last one is disposal in sea and barging into sea, which is nowadays obsolete, because you know that disposal in seas, again you have to dispose it away from the banks, then deep, then during low tides. This is followed for solid waste also. Otherwise, you know that sea doesn't keep anything little, so it will splash onto you only. So first you have to go away from the shore, then you have to go deeper. So that is the reason nowadays disposal in sea is obsolete. One more thing is there, that is autoclaving. This generally you use it for biomedical waste. So what you do is you pass steam. So whatever treatment of the solid waste you are doing, you pass steam on it at a high temperature, so that here what will happen here, the disposal of it, or basically the sterilization of it takes place. So that is autoclaving. Clear? Now, last thing which they have asked in your examination, energy content in kilojoule per kg on as discarded basis. Now guys, this there are various questions. See, I'll give you now, we have done with the theoretical part. Now just based on numerical, I'm telling you. If they ask questions from solid waste, stoichiometry questions if they ask you, then you have to balance the reactions. फिर को आप कुछ नहीं कर सकते, because in GATE 2022 afternoon session, if I'm not wrong, they have asked question from solid waste management 2 works, and that was a balancing question. C100 at something, that was question was there, and it was a big question. Got it? So if questions like that will come, so you need to do the balancing. Nothing can save you. You need to do the balancing. Okay, how much oxygen is released, or basically they don't ask oxygen, they ask how much is the volume of air. So first you calculate oxygen, and then you divide it. They will say 23% air is present. So you divide it by 0.23. 23% oxygen is present in air. They will write like this. So first you will calculate oxygen, then you will divide it by 0.23, then you will get air. Like this the question comes. So in thus that question comes, so you need to do the balancing. Next is they ask you questions like different types of solid waste will be given, moisture content and all will be given. So if they ask questions from those topics, first check it out whether the percentage is coming 100. If it is coming 100, take 100 kg. It becomes easy for analysis. They ask you temperature, they ask you energy, you can calculate it. Now if they ask you the energy content on moisture free basis, so moisture should not be required. So whatever energy you are getting into 100 upon 100 minus moisture content in percentage. If they're telling you moisture free and ash free, then minus ash percentage. This is the only single formula which is there in your solid waste. No more formula is there. Now one more thing. They have asked questions from landfill. Okay, they'll ask you how much volume of landfill is required. So whenever they ask you volume of landfill, it is asking you the volume of the soil plus volume of the cover. Now sometimes you will be like, ma'am, it has asked uncompacted one or compacted one. If they're giving you compaction ratio, if they're giving you a whole number value, obviously you know before you have compacted, the volume will be much. After you have compacted the landfill, the volume will be less. So if they have given you, let us suppose 4, so you have to apply your brain. They will not say, they will say only compaction ratio. That is volume before compaction to volume after compaction. Okay, like this. So just things are there. Solve questions from this topic. PYQ simples were there, so I haven't taken into account. Solve questions, and if you find any difficulty, do let me know. So with this, we have completed our whole environment. Any doubt anybody is having can ask to me. Come on. Anwar, Sophia, Divya. I remember Sophia, Anwar, I guess Prince is there or not, Divya. These 3-4 people are there right from the starting. At 10 I started. 10 by 9, oh my god, 11 hours. I told you, Richa Gupta, whatever she says, she stands on the words. I was knowing it will be 9. But I don't want to be like away from my commitment. So that's why I told you 9:30. But I was knowing it will get completed at 9. But if I would have said it and if I wouldn't have done it. So that's why. Correct. What is ppm? ppm is technically in the case of water, ppm and this one mg per liter was same. But in the case of gases, it is not the case. ppm means 1 part of anything. In the case of gas, I am talking about 10 raised to power 6 part of any other thing. See, the way I told you, now I'll make you revise the whole environment. Okay. Now, most probably, guys, I'll be taking hydrology and irrigation on Saturday. If in case any, oh, Sagata is there. Dollar Pallavi. Okay, you were not replying in between, so I thought that you are not there. Okay. Sagata was there initially. In between, you were not replying, so I thought you were not there. Okay. So I'll share my Telegram group so that I'll let you know hydrology and irrigation we'll try to cover in one day. But alag-alag nahi lenge. Hydrology and irrigation we'll cover in one day. Chalo. Okay. Any doubts? चलो अब कुछ भी बात करनी है बोलो मुझे. I'll talk. एक क्वेश्चन था, बता तो दिया. Like example, they will tell you that 1 ppm of NO2. That means 1 part of NO2 will be present and 10 raised to power 6 part of gas will be present. This is the meaning of 1 ppm of NO2. Got it? I gave you the example. Okay. और मैं एक चीज बताने वाली थी यार. Which I have told you. Like, I was telling you, एक क्वेश्चन आया था. Like, I'll tell you, density of uncompacted solid waste is mass upon volume of uncompacted solid waste. Density of compacted solid waste is equal to mass upon volume of compacted solid waste. Now, there was one question, अब मुझे exact question तो नहीं याद आ रहा, but उससे मिलता जुलता बताती हूँ. The density increased from 130 kg per meter cube to 300 kg per meter cube. Tell the percentage volume. ऐसी क्वेश्चन था. Solve it. चलो. Thank you अनवर, thank you. अच्छा, मेरे को डिस्टर्ब नहीं करते हो, बीच में आके पीडीएफ मांग रहे हो. मयंक पीडीएफ दे दो और डिस्टर्ब नहीं करते हो. मुंह मत खुलवाओ मेरा. चलो, सॉल्व इट. अब मैंने नहीं सॉल्व करना, कुछ क्वेश्चन खुद भी कर लो. जाओ, मैं सब क्वेश्चन सॉल्व करके दे रही हूँ, तुम लोग की आदत खराब हो गई. सॉल्व करो ये क्वेश्चन, लास्ट क्वेश्चन है, फिर नहीं बोलूंगी कोई क्वेश्चन. चेंज इन वॉल्यूम निकालना है, डेंसिटी इंक्रीज कर रही है. देखो तुम लोग परसेंटेज चेंज इन वॉल्यूम नहीं निकाल रहे हो. अच्छा दिव्या बस का आया है परसेंटेज चेंज इन वॉल्यूम. गाइस स्लाइड ऐड करने दो मेरे को एक. अब आ जाएगा ना गेट में क्वेश्चन, फिर आओगे मेरे पास. परसेंटेज चेंज इन वॉल्यूम, डेल्टा वी परसेंट, that is volume of uncompacted minus volume of compacted upon volume of uncompacted into 100. You will say ma'am volume is not given, mass is constant. Mass ऊपर नीचे from numerator and denominator it will get cancel out. 1 upon density of uncompacted upon 1 upon density of compacted 1 upon density of uncompacted into 100. 1 upon निकाल लिया यार, एक मिनट यार, ये अपडेट आ रहा है बार बार. 1 upon density of uncompacted minus 1 upon density of compacted divided by 1 upon 130 into 100. अब जितना आप बोल रहे हो मैंने खुद से बनाया है क्वेश्चन, तो मुझे नहीं पता इसका आंसर. कैन बी आस्क्ड इन 1 मार्क्स. क्लियर? चलो विजन गेट 2024 क्रैश कोर्स और इसके साथ फुल सिलेबस कोर्स फॉर गेट 25 एंड 26 बोथ इन इंग्लिश एंड हिंदी लैंग्वेज. सो इफ यू गाइज आर टारगेटिंग फॉर दैट, यू गाइज कैन स्टार्ट योर प्रिपरेशन जर्नी विद अस. मैं क्या कर रही थी, मैं टेलीग्राम ग्रुप का लिंक देने वाली थी ना. सो चलो, एंड शेयर दिस मैराथन विथ मैक्सिमम ऑफ योर फ्रेंड्स. एंड रुको, आई वाज गिविंग यू द लिंक ऑफ टेलीग्राम. मैंने दिया था शायद अभी ना. कमेंट्स पढ़ने के चक्कर में मोबाइल भी जिंदा नहीं बचा है. ओके, oh Giri is also there. Okay, fine. So this we have completed. Kindly share this PDF, will be much helpful. I'll provide it in the app. Bitly link is there in the description box. Download it from there. Then I'll think कि मैं app में provide करूंगी कि नहीं. अभी मेरा mood में mini mock test PDF. अच्छा हाँ दिव्या, कौन सी डेट पे हुआ था एक बार मुझे मैसेज कर देना प्लीज. इतनी सारी पीडीएफ हो गई ना, माई लैपटॉप इज गेटिंग हैंग. अब मैं नहीं दूंगी, मयंक को तो बिल्कुल नहीं दूंगी मैं पीडीएफ. इसने बीच की 2 घंटे की क्लास छोड़ी है, इसकी सजा है, इसको पीडीएफ नहीं मिलेगा. Okay, any more doubts guys? Now let me tell you one thing. If any question comes highly calculative in nature, don't attempt that question. Up if any question comes from stoichiometry, don't waste your time in starting. मैं कुछ quick tips दे रही हूँ. हाँ हाँ अनवर, I'll do that. Wait, पहले मुझे सेव करना. आखिरी में अगर मैंने सेव नहीं किया ना, पूरा उड़ जाएगा. Okay, now भुला देते हो यार तुम लोग. हाँ, if any questions from stoichiometry and all comes, so in that case guys, kindly first of all what you will do is kindly leave it. उस क्वेश्चन को पहले मत करना, because stoichiometry balancing and all will require time. So stoichiometry questions comes, tabular format question comes, leave it, do it at the last. Okay, questions related to sedimentation tank, filtration वगैरह आता है, कर लो. MSQs questions आता है, be sure about it. If even your नहीं भी बन रहा है, mark it. Okay, तुक्का मार दो, because negative marking is not there. Because MSQ पिछले from the last 3 years they're asking questions from MSQ, so it's like higher probability is there that this year also they will ask MSQ from that. Okay, like I'll tell you one thing, in forenoon session मिस नहीं किया कुछ, but without chatting for you. Thank you रितेश, दे दूंगी, I'll give you, but अभी नहीं. Okay, now जो हाइड्रोलॉजी इरिगेशन की क्लास आएगा उसी को एनवायरमेंट का मैराथन का मिलेगा. अरे यार मेरे को भुला देते हो यार तुम लोग बीच में बोल के. मैं कुछ इंपॉर्टेंट बताने वाली थी, अब दिमाग से निकल गया मेरे. क्या बता रही थी मैं? व्हाट आई वाज टेलिंग? नो आई फॉरगॉट व्हाट आई वाज टेलिंग. कुछ तो बता रही थी. हाँ, आई वाज टेलिंग that this year forenoon session there was a question related to diseases. ठीक है, 1 marks question MSQ was asked that polio is there and one more disease was there. 4 options were there, and generally everybody knows that virus polio is caused due to virus. Everybody marks to virus as the answer, but that was wrong. Virus था तो polio answer mark किया था. Due to virus what takes place, what type of disease takes place. So everybody marked forenoon session का था One option was polio, another option was, I guess, hepatitis. One more option was there. Okay, so everybody marked one option because everybody know that virus will be there due to polio. But that was an MSQ question. So even if you marked one answer as correct, it is not true. So that I'm telling you, kindly read it. Don't be in excitement. You thought it is an MCQ, but it was an MSQ. So kindly don't do this mistake. If such question comes, 1 marks or 2 marks, see, it was a ready-made question. You would have got 1 marks. Even one marks, even half a marks matter. Clear? So if such question comes, kindly read the question paper properly while answering. Don't be overwhelmed that the paper is easy. If it is easy for you, it is easy for others also, and cutoff will go up. I'm not threatening you, but I'm telling you the fact. Got it? चलो फाइन. हाँ जॉइंडिस था, करेक्ट. ऐसी कुछ तो था. चलो. Now, we'll see you soon. Most probably Saturday ko yoga, but if anything else happens, I'll let you know. And thank you everybody for specifically to those students. I'll thank everybody, but specifically to those students. Apart from me, yeah, for me it's like I'm from the morning I'm there and I'm the one who is speaking. But you guys also, you were the one because of whom I got the energy. Basically, it's the you can say audience which is there, which gives you the energy. If audience is not there, you are like in a hurry to complete it. So that's what I'm saying, that thank you each and every one of you for so much of patience and being with me. And that too, I was thinking that I have to stop it and we have to take it next day for environment. In between, it came into my mind in the first half, but अब ये अनवर चैलेंज कर रहा. हाँ 10 ही बजेगा अनवर, 10 ही बजेगा, उसमें तो बजेगा. चलो. So we'll meet you soon, and thank you so very much everybody. I'm highly grateful and I wish that you continue with your journey with us in BYJU'S exam prep, and we'll meet you for 2 more marathons, hydrology and irrigation and open channel. Okay, thank you everybody. God bless each and everybody of you. Take care of yourself. Bye bye. Good night and steady heart. Thank you everyone.